Hey, this is Andrew Brown bringing you another free certification course, and this time it's the Google Cloud Associate Engineer, also known as the ACE. And the way we're going to get certified is, as always, going through lecture content, hands-on labs, and as always, I provide you a free practice exam so that you can do your best in the exam, pass that exam, get that certification, put it on your resume, get that job you've been looking for. I do want to just remind you that if you want to support more of these free courses, you can purchase the additional paid materials, which includes cheat sheets, downloadable lecture slides, flashcards, and more, which will just help you have a better chance of passing in the end. And again, supports this kind of content here. If you don't know me, I've taught a lot of courses here. I've taught AWS, Azure, GCP, Kubernetes, Terraform, security, DevOps, everything, you name it, I've taught it in the cloud. So you're in good hands, and let's go jump into it, okay? Hey, it's Andrew Brown, and we're taking a look here at the Google Cloud Associate Cloud Engineer, which is a concept-based certification, meaning it's more focused on the conceptuals than the practical. You're going to need to know the 4 core services, so storage, database, computing, networking. Cloud native workloads has a large emphasis in this course. I think it's just because Kubernetes comes from Google. Google has a very good offering for running Kubernetes workloads through GKE, and so they want you to know it. We have automation, configuration, patching, securing workloads, so everything that you'd expect from DevOps. Governance, security, identity, observability. I wouldn't say it's security heavy, but you need to know the general best practices for security. And so, that is good there. Google does not have course codes, but often this course is called the GCP ACE. So if you hear Google ACE or GCP ACE, they're talking about the certification. I would not say this certification is hard, but I would just say that it requires a significant amount of study time because you are basically setting yourself up with all the fundamentals that you're going to need to do all of the other certifications. And this is a core path. You really cannot skip this certification. But a lot of folks kind of do in the sense that they do study for the ACE, but they end up going for the Pro, as some folks don't care about getting the ACE, they want to get the Pro certification. But we'll talk about that as we work through this, okay? So who's the certification for? Well, if you are going to be working in Google, so that means, utilizing it as your primary workload, then you absolutely want this certification along with the digital leader. It's must-have certifications. If you enjoy working with architectures and trying to understand how multiple services need to work together, you're going to like the certification. Or if you're going for the Pro. So basically 80% of the content that's in the certification is going to be needed for the Pro. The Pro focuses on refining that knowledge through business case studies and going deeper in certain areas. But the bulk of the knowledge that you need is in the certification. That's why I say some folks skip the ACE. I don't think you should. You should sit the exam. But some folks skip the ACE because they have to get their Pro, and they know that there's so much overlap, and they might score the Pros a bit higher. But I'm going to just tell you right now, you should really make sure you get your associate because it's going to make the Pro certification a lot easier to do. I really don't recommend skipping it. And absolutely, you should get your fundamentals, Cloud Digital Leader, prior to the associate, because there's just content in there that builds off of into the associate level, into the professional. Do note that there are other, I said earlier, there's only basically one associate level, and there basically is. It's just this cloud engineer, but they have introduced the Google Workspace Admin, Data Practitioner. Those are kind of like specialized associates. They're not really the core path, but you can do them if you need to. Generative AI is also new, and it's okay. And I believe that security operations is a new one, which is a little bit different from the cloud security one, which I think is, this one is basically general security. Maybe security operations is like DevSecOps, I'm not sure. But the point is that they have a lot of professionals. One thing about Google certifications is the professionals aren't as hard as other providers. They feel very well-sized in terms of the work, so that is one good thing. I do need to tell you that certifications do not validate programming, technical diagramming, code management, and many other technical skills that are required for obtaining technical roles. So understand that you need to gain those skills, and you will not be tested on them on the certifications, but I will fill that information in as best I can throughout this course for you, okay? How long does it take to pass? the certification? Well, I would probably put it at 30 hours, maybe even 40 hours if you're a beginner. If you have your GCP CDL, and you really should have that before you attempt the GCPAs or study for it. It's still going to take you 30 hours if you're experienced and you have knowledge of GCP or with another provider, and you just have a strong background in technology. You can clear this in 12 hours. I would set the study time for 15 hours, a little bit higher than my other courses, just because this associate is packed, where other providers will break them up into 3 or 4 courses. It's literally they just have the one course. So there's definitely more time, lecture and lab side. So I would put more time into that than practice exams. But it is recommended that you study 1 to 2 hours a day for 14 days. That's basically the most optimal way to study. So what is it going to take to pass? So you're going to watch the lecture videos. You're going to do the hands-on labs and follow along with your own account. Do the paid online practice exams. And if you sign up at Exam Pro, we do have a full free practice exam, no credit card required, to get you started. We're the only provider that does full free practice exams. We're super generous that way. But it is very hard to pass the GCPAs without practice exams, so make sure that you do acquire them, whether they're with us or with somebody else. One thing I do need to emphasize is that you really want to try the hands-on labs as much as you can. With Google, their documentation is, I would say, very incomplete and out of date. And this makes it very challenging to know what actually works. And throughout this course, I had to stumble through and figure things out. Even though I've used Google before, you just have to stumble through and validate things. So it's extremely important that you do the hands-on, and I gave you a bunch of hands-on in this course. Where do you take the exam? Well, in person or at the convenience of your own home. Most people doing it online these days, and Google uses Criterion. And so Web Assessor is the tool that Criterion uses. So if you see Web Assessor, it's basically Criterion or vice versa. I'm not exactly sure I understand the relationship, but I just know that when you look at Web Assessor, it links back to Criterion. Google said prior that they were going to switch out and use something other than Criterion, but they've not done so. So I guess they're staying with them as a provider, where other folks use Pearson VUE. Pearson VUE has been very popular, but Google sticks with Criterion, which is totally fine. These exams are proctored. That means there's a supervisor, a person who monitors students during the examination. So when you're there, make sure you have a nice clean desk and no noises in the background, etc. Be ready to have your identification and maybe even to show what your room looks like to make sure you can sit the exam. Okay. Let's take a look at the content outline. So we have 23% setting up a cloud solution environment, which is just basically governance, like how do you set up projects and folders and organizational policies and billing. A lot of this stuff I covered in the GCP CDL, the Cloud Digital Leader. So if it feels a bit light here, it's because my expectation is that you went and did that one first. If you didn't, then go look at that content, because I didn't carry it all over into this course because I didn't want to make it bloated, okay? So just consider that. Planning and implementing a cloud solution. So this is understanding the core services. We're ensuring successful operation of cloud solutions, configuring access and security. But this doesn't really help you understand what's inside the course. So there are sub-domains under this stuff. But I would say, which it really doesn't show from this list, this summary here, but Kubernetes is definitely something that you're going to want to have a base knowledge in, like a primer on it. And so we are going to include a primer of Kubernetes here, just because, again, Google really wants to promote cloud native workloads here. Each domain has its own weighting that determines how many questions are in that domain that show up. But let's continue on here. To pass, it's 70%. They don't necessarily say that anywhere in the FAQs, but if you take the exam, it's 70%. We say around because you technically could fail with a 70%, so try to always aim a bit higher. This just has to do with how many questions you get, because there could be an odd number and how they scale and score things. So, make sure that you're aiming for 80% at the very least, but you can get exactly 70% and technically fail. There are 50 to 60 questions. This is what I mean when I say there's a range of questions, but there's 50 to 60 questions. You can get about 18 wrong. There's no penalty for wrong questions. Format of questions, multiple choice, multiple answer. So, pretty straightforward. The duration is 2 hours. You get a lot of time on this exam, considerable amount compared to other ones. And this is why I say it's easy, because you got 2 minutes per question. So, it's not like you're super rushed. So 2 hours is 120 minutes. Your seat time is 150 minutes. Seat time is the time you need to allocate for time to review the instructions, show the online proctor your workspace, read and accept the NDAs, complete the exam, provide feedback at the end. It is stressful checking in, especially for online exams, checking in. So make sure 30 minutes to 45 minutes early, just so that you don't have any problems and you don't, waste your money. Okay. This exam guide or the exam is valid for 3 years before recertification. So recertification is a bit different. It seems like they have a separate exam, and the scope of the materials is less, but you can still technically use this course to brush up on it, but the process is a little bit different. I do want to point out that cloud certifications expect you to already have foundational knowledge and technical skills like programming, scripting, SQL, IT networking, Linux and Windows, project management, developer tools, app dev skills, comp sci algorithms, and more. If you do not have that knowledge and you feel that you're lacking it, check out freeCodeCamp, their large catalog. Or you can get a subscription on Exam Pro, because I do make other materials that go along with it. I do need to point out GCP itself does not care about certifications for hiring. For their own technical role, certifications serve as a structured way of learning from a goalpost. But one thing that's really interesting is that if you do work at Google, I can't say this with other providers, but if you do work with Google, they really want you to get the pro. Okay, so not during the hiring process, but after you're hired, they're going to want you to go for your pro. But just consider during the hiring process, they're not going to care if you already have it. Okay. Understand there's about 250 to 500 hours of additional work outside of certifications that you need to have. So that's why my courses are very long, is because I'm always cramming in all these additional things on the side to help you have practical knowledge. But that's our general overview for the GCP, and there you go. All right, let's take a look here at the exam guide so we have a good idea what's going on. And as I said over here, the renewal exam information is a little bit different, and they have a different exam guide for that. But you can pretty much use the same materials and you'll be in good shape. But let's zoom in here and take a look. So they don't tell you a whole lot on the top here, but that's fine. We can work our way through here. And I just want to show you that the interior of these things, some of these make sense and some of these don't align, so you have to be careful and look at what you need to study for. So setting up a cloud environment, creating resource hierarchies, organizational policies, IAM roles, cloud identity, enabling APIs with projects. So we got a lot of stuff here. I'm not sure if we did Gemini Cloud Assist with analyzing resources. To be honest, at least at this time when I'm recording it, I'm not finding Gemini Cloud to be working very well. I did try it in a few videos, and you'll see that it spectacularly fails in multiple areas, but I think that has to do with the lack of documentation that Google currently has. I know they have a platform called Skill Builder or something, or Skill Boost, where they have a lot of labs, and that's for learning. And so I feel like a lot of the knowledge is locked up there, which is bizarre because they really should push it out to their documentation, but that's just how it is. Going over to managing building configuration, so we have this stuff here. I did all this in the Digital Leader, and if you do not find that content in this course, and it's over there, but we'll do our best to carry it over as long as we're not bloating up the course here. Planning and implementing a cloud solution. So this is where you need to know how to use basically everything. So Compute Engine, GKE, Cloud Run functions, Knative serving, Compute Engine, which we said over there already, but all the storage methods, yep, auto scaling, OS log, and VM manager, basically a huge collection of stuff. So there's that. Then over here, basically something very similar. We're saying planning, implementing storage solutions. So now they're just talking about data and storage, right? And then we have networking. So again, this is all the 4 core stuff under planning, implementing a cloud solution. And yeah, there's more stuff here. So yeah, we do include that. Let's go over to ensuring successful operation. And so here you'll notice a lot of talk about containers and Kubernetes. So this is where I had to bring in our Kubernetes content. We already had some content for it, and so I rolled it into this course, but I chose just the right amount, so we're not going fully into Kubernetes, but just enough that you'll know what is going on here, okay? Then we have managing storage data solutions, so a bit of a repeat up here, but just talking again about possible storage solutions that we can utilize in Google Cloud. And then again, repeat of networking. I don't know why they made these 2 separate sections, because there's so much overlap between the two, but that's totally fine. Then we have configuring access and security. So IAM policies, IAM roles, and very basic stuff. So security here is very, very light. And I think the reason why is they have specialized certifications for those too. We probably do more hands-on than we actually have to do for this course. But I think it's important because, again, the documentation is a bit lacking, and a lot of things did not match up, or they were out of date, or sometimes I would do things once and it would work and not a second time. And so I want you to get comfortable. I want you to get hands-on for the ACE, okay? But there you go. Let's take a look at what is a resource within Google Cloud Platform. So a resource is an entity that you can create, manage, or use within your cloud environment. And there are two main types of resources. The first being service level resources. This is what you think of when you think of resources in any other provider. It's the actual things that you're launching, such as the virtual machines, your storage, or your databases. And the other one are account level resources. Now, I put an asterisk on it because I don't like calling these resources, but that is just the name that Google defines them as. And so I'm being very explicit to give you Google's language. But other providers, I don't think we would call those resources. It would just be ways of logically grouping your actual resources together. But let's make it clear what they are. So this is where we have your organization, your folders, your projects, and these are logical grouping, a way of logically grouping your service level resources so that you can organize them. Okay, so hopefully that's really clear. But when you think of a resource, I just want you to think of service level resources, and that's how I'm going to treat the language throughout this course. Is when I say resources, I'm just talking about service level resources, and I'm not going to call account level resources. Okay. All right, let's take a look here at resource hierarchy. So here on the right-hand side, I've pulled this graphic from the documentation, and this is a general representation, a generic representation of how you could organize your resources using those account level resources. But let's go through and define the most top level stuff that we're going to care about here. It's not going to include everything, but it's going to include 99% of the things we need to know about resource hierarchy. So the first thing is a resource. And when we say resource, I'm going to just refer to anything that's a service level resource as a resource through this course. These are the things that are used to process your workloads. So the things that you're deploying, again, servers, databases, cloud storage, whatever. Anything you're pressing a button to launch, it's likely going to be a service level resource. Let's make sure we understand resource management. So this is how you should configure and grant access to cloud resources for your team to set up your organization for utilizing account level resources. The top level thing is your domain. This is a primary identity for your organization. If you notice on the right-hand side here, it doesn't show the domain in that representation graphic, but it absolutely is there. But we'll continue to work through here. So it defines which users should be associated with your org. Universally administered policies for your users and devices linked to either a Google Workspace or Cloud Identity account. A Google Workspace or Cloud Identity can only have one org, okay? Then we have our organization. So this is the root node of your Google Cloud hierarchy of resources. It defines settings, permissions, and policies for all projects, folders, resources, cloud building accounts for it at its parents. Organizations is associated with exactly one domain, right? So there's a very strong coupling between a domain and an organization. Using the organization, you can essentially manage your Google Cloud resources and your users' access with proactive and reactive management. Then we have folders. So folders are, they're exactly what you think they are, but depending on how you structure them, you can have better or worse kind of posture in terms of the way you organize your resources. And Google is very prescriptive in terms of ways that you can organize them. But the one on the right-hand side looks pretty generic here, so I'm not really sure if it represents any of the three that Google suggests. But we'll look at those here in a moment. But anyway, so yeah, folders are logical groupings of projects or other folders. Folders can be used to group resources that share common IAM policies. Then you have projects themselves. This is logical grouping of service level resources. This is basically always where you're launching your stuff into. And you're going to find, projects are okay. I think I like Azure resource groups better, but there is a limit. I don't know what the limit is, but there is a limit of how many projects you can have. And I always kind of find that, at least at my account level, kind of frustrating. They do take a little bit of time to spin up initially. But anyway, we'll see that as we work through the course here. Projects can represent teams, environments, org units, business departments. So between folders and projects, you have a lot of ways of isolating things. Basis for enabling services, APIs, and IAM permissions. A service level resource can only belong to a single project. And there is something here where it talks about APIs. So when you make a new project, and let's say you use something like Vertex AI, you have to turn that API on every single time when you go to a new project. If you're from the AWS world, basically you can think of projects as like being accounts, right? Literally being accounts. Whereas in something like Azure, if you enable something, it's across everything. And so it's just a different way of isolation. So again, if you're coming from those other clouds, you're going to notice the difference here. We have labels. These are used to categorize and filter your resources with key and values. They're great for tracking costs at a granular level. There are 3 suggested hierarchy architectures that you can use. They might have more now, but again, these are just whatever. You just have to decide what you want. But we have environmental-oriented, function-oriented, and granular access-oriented. We'll look at those separately in the next video, but there you go. I think there's a few things we didn't cover here, like organizational policies, but we'll cover those in separate slides, okay? All right, so I said that Google has 3, or maybe more now, but 3 architectural hierarchies that you can use to organize your resources using folders and projects. So let's take a look at these 3. And whatever you're doing, you can do whatever you want. Again, this is just something that they suggest, but I find that in terms of real application, you got to do what works for your team. So again, just take this stuff with a grain of salt, but whatever you learn from this, adapt it in your organization. Let's take a look at environment-oriented hierarchy. So here we have our diagram below, and let's look at some of the points and then try to make sense of it. So you have one organization that contains one folder per environment, simple to implement, right? Pretty straightforward. This can pose challenges if you have to deploy services that are shared by multiple environments. So yeah, let's take a look here. So yeah, we have a single organization. Underneath we have production, quality assurance, development. I might call mine like production, staging. Staging to me would be Q&A, and then we'd have development, and we have resources underneath. How could you expand this further? Well, I mean, down below, you see like we have projects, and they actually have projects isolated per, I'm gonna get my pen out here, but it looks like they have projects per per workload. So here it says NetHost, app, and things like here. And so it's suggesting that these are all, well, these are resources, but it's not really suggesting if this is a single project or if this is multiple projects, right? Because, I could see here that you could have production, and then maybe you have this workload. Let's just represent this as a project, but this is a workload, like this is workload 1, workload 2, and workload 3. And you could repeat that across the board here. And I think that would work out pretty well for small to medium-sized organizations. So I don't really see an issue with that there. But the other thing is that you can have folders inside of folders. So yeah, I think this is fine starting out. So I think it's pretty straightforward here. And the drawbacks are pretty clear. Let's look at function-oriented hierarchy. So here on the right-hand side, we have a little bit more structure. So one organization that contains one folder per business function. Each business function folder can contain multiple environments folders. Multiple business functions, apps management and information technology. More flexible compared to environment-oriented, gives you the same environment separation, allows you to deploy similar services. Function-oriented hierarchy is more complex to manage than an environment-oriented, separated access by business. And again, it depends on how granular you go with the projects. Here, it looks like these are the projects. Like if we go back to this one, this is NetHost, my app, whatever. Like if these are the projects under here, let's start over here. All right, let's take a look at how we can organize our hierarchies with folders and projects and how we get different outcomes. These are the 3 that are recommended by Google, but I'm going to provide my own opinion as we're working through this. First one is environment-oriented hierarchy. So here it is down below. The idea here is you have one org that contains one folder per environment And the idea is it's just simple to implement. And Google's saying that it can pose challenges if you have to deploy services that are shared by multiple environments. What I think Google should be doing is saying like, okay, you have this organizational structure, and how do you change it over time? Which is, I don't know why they don't do this, but like this is what they really should be doing, is saying like start here, go, and then you can go from here or there or there. Kind of like your Tamagotchi or your Pokemon, you have like your upgrade path, but they don't do that. They just show you 3 here. Is this okay? I think it's fine. Like we go down below here. It's a little bit unusual because here, this looks like a resource. These all look like app engines, but I guess these are all projects. And so we have our main org, we have prod, Q&A, I'll call that staging, and then dev. And then down below, we have our isolate projects. So we have NetHost, app1, app2. And I think that's fine. Like here, we're seeing the app repeated once, twice, thrice, right? So the idea is that you have that app across the board. Like, I don't know why they just wouldn't suggest in this case, like this would make sense if you had one project for your entire organization, like you're a really, really small company, but why wouldn't they just put another folder up here? Like just put a folder here, like app1, and then you could isolate these into the 3 folders. But even if you had this folder here, like the app folder up here, like you can use labels to isolate things as well, kind of. So why wouldn't you just have a folder that is app1, or simply just have a project that is a project that is your logical isolation for your app workload, and then use labels underneath? So I kind of feel like they could have gone a bit simpler here. And I mean, like this is fine. Like this is still okay if you want to have a bunch of folders. But I don't think that this is the starting point for most folks. I think that they should be starting with projects and labels, and then introducing, like bubbling up and having a folder here. And then if they really need 3 folders underneath for their different environments, then have a folder there. But why they did this way, I don't know. Let's take a look at function-oriented hierarchy. So here on the right-hand side, the idea is that one org that contains 1 folder per business function. So what are they saying here? So on the right-hand side, we have apps management and infrastructure technology. So we have a generic business function. And then down below, they have their environments. And then they have their projects. Again, this is okay, but I don't know why. This is their suggestion. This is the other thing, is like, you can't understand as to, like, they say like that you should use this, but they don't really justify it in terms of an org. But let's take a look here. Each business function folder can contain multiple environments. Multiple business functions and apps managed in information technology. Gives you the same environment separation, allows you to deploy shared services. Separate access by business. It's fine, but again, I don't understand. Like, I don't see how apps management and information technology is the best way to go. But I guess, like, I suppose, like, if you had your apps and then there was, you had like large data workloads that you wanted to keep separate, maybe for like analytics or something, I could see that. Maybe that's information. That's not IT. So maybe they're suggesting this for like more large organizations that aren't just deploying apps, but are utilizing Google Cloud for many things. So that might make sense. Like I could see a school maybe separating apps management, IT, but I'm not completely sold on function-oriented hierarchy, but whatever. We have granular access oriented hierarchy. So this is just where we get a ton of folders. So one org that contains 1 folder per business unit. Each business unit folder can contain 1 folder per business function. Each business function folder can contain 1 per environment. It's most flexible. You need to spend a great effort to manage the structure, roles, and permissions. Network topology is more complex. And so, yeah, I mean, this is like endgame, where you have your divisions of your, at the top there. And then the second level is your functions, and then your environments, and your projects. Again, it's fine. I would probably try to use labels to separate environments and just kind of try to keep things a little bit flat, unless you have a very specific reason to separate them out into separate projects, because it's like governance reasons and you need to really restrict things in a particular way, which you can still, again, do at a project level. I would just try to keep things a little bit simpler than this. It's not like it's defining the divisions as like the organizational units of your business. It says business unit. And so I guess it is. Like it says retail, risk management, financial, commercial. Yeah, I don't know. It just feels a little bit off to me. But anyway, it's just what they suggest. And again, if you come up with something different, it's totally fine. The question more is like, can you, like, once you put a project in a folder, can you move it? Right? Because, what happens if you don't like it? So just a second here. Yeah, so I just wanted to double check that my knowledge is up to date. And I mean, like, you can move projects to other folders. So I don't feel like you're really locked into any of this mess. I think the hard part is probably setting up the permissions and things like that. But again, I would start small, right? Start with a single project, use labels, and then bubble up to a folder. You could do that based on environments. And then if you have more than one workload, then bubble that up into separate the scope on the projects. Yeah, so it's fine, but I do think there are some improvements that could be made with these resource hierarchy graphs here. Okay. Let's talk about projects within Google Cloud. So a project in Google Cloud is a logical grouping of resources, and a cloud resource must belong to a project. So here in the top right corner, you see Exam Pro. That is a name of a project that I have. Though in this course, you'll notice I call it GCP Playground, or I might have a few different names. A project is made up of settings, permissions, other metadata. A project can't access another project's resources unless you use shared VPC or VPC networking peering, and that stuff is going to be related specifically to virtual machines, okay? Resources within a single project can work together easily, for example, by communicating through an internal network subject to the regions and zones rules. Each Google Cloud project has the following: a project name, which you provide, a project ID, which you or Google Cloud can provide for you, a project number, which Google Cloud provides. As you work with Google Cloud, you'll use these identifiers in certain command lines and API calls. Once you give it a project ID, you cannot change it. So be very careful that you get your project ID right, because a good project ID is going to make things a lot easier for you. Each project ID is unique across Google Cloud. Once you have created a project, you can delete the project, but its ID can never be used again. When billing is enabled, each project is associated with one billing account. Multiple projects can have their resource usage billed to the same account. A project serves as a namespace. This means that every resource within each project must have a unique name, but you can usually reuse resource names if they are separate projects. Folders allow you to logically group multiple projects that share common IAM permissions. So that is obviously a huge benefit. Folders are commonly used to isolate projects from different departments or for different environments. Though I do feel like you could utilize tags to get a little bit more, or labels to get more flexibility within a project for permissions. But there you go. Hey folks, it's Andrew Brown. Let's take a look at where the resource hierarchy is and what we can do with it. So right now I'm in my Google Cloud account. If you do not have a Google Workspaces account, you'll have to make one first, because you need to be an organization in order to manage your resource hierarchy. But you can see here I already have an existing project. But if you click here, what you can do is go to the three ellipses and manage resources. If for whatever reason this path is not working for you, you can go on the left-hand side here to the three pancakes. And I like to think of those pancakes instead of hamburgers, but it's pancakes for me. If you go to IAM and admin under manage resources, it will get us to the same place. So our organization is at the top level. You can see we have folders underneath, and then we have our projects, and then resources are within the projects. So it's pretty straightforward at this step here. But if we wanted to create some things like a folder or project, we can do that. So I'll make a new one, and I'm going to call this one learning. Okay. And you can see I'm putting this organization in this location. We'll go ahead and create that. Sometimes there's a bit of a delay here, so you need to be a little bit patient dealing with this here. And so, yeah, notice like right away I do not see my folder, so we'll go ahead and give that a refresh. Right, so I'm like, where did it go? And so that's generally what my experience is trying to find some of these resources. Now we can go up to, I believe it's up in our notifications. And so we can see that it has been created, but just notice that we do not see it. So what I'm going to do is I'm just going to wait a little bit here, maybe 5 minutes, 3 minutes, and give it a refresh and see if it appears, okay? You have to have confidence when working with the Google Cloud Management Console, because sometimes things just don't show up immediately, okay? All right, so I was doom scrolling for a bit. Now I'm back. Let's give it a refresh and see if it appears. And so now it appears. So yeah, again, have patience for these resources being created. I'm gonna go here on the right-hand side, see if we can directly create. We can move them, and there are very little settings for us to do. You see you have application APIs here if you want to have that feature on. It's still in preview, so there's not much to talk about there. But let's say we want to create a new project under here. I'm gonna checkbox this here. Let's go ahead and do that. And there is a limit to how many projects you can have in your repo. or sorry, your organization. I can't remember what the number is, but I'm going to make a new one here, and this will just be called, I just want to have a generic one that I'm going to keep using here again and again. So this will just be GCP Playground. Okay. And if you want to make sure you have a nice name, that one's fine. I might want a number I can remember, 1212. We'll do that if I'm allowed to take that. And I'm going to go ahead and create that. There we go. Okay. And, again, these things take time, but, managing resources is pretty straightforward. You can move things around, right? You can create folders. And this structure is obviously going to be valuable when you want to apply organizational policies, which we'll look at pretty soon. But again, we're just waiting for that resource. As we're waiting, let's just take a look here. So yeah, you can apply tags, but I'm not really interested in doing that here today. So I'm going to wait, and once that's created, then we will we'll continue on here. Yeah, and again, notice you have to wait a little while, so we'll wait a little while, okay? All right, again, back, and we'll give this a refresh, see if that resource is there. It is, but it's not where I want it to be. I want it to be in this folder here, which is fine. So we'll go ahead and move it. And we'll go ahead and say move. And there we go. Now it's been moved. So now it is over here. Okay. So again, we can apply tags if we want to. Edit tags for the resources. So we could do this and apply tag if we want to. So I guess I don't really care. One second. I was thinking about it. We can go ahead and do some tags. So if we were going to want to have tags, we'll have to make some first. So I'm going to go ahead and open a new link here. We'll type in tags at the top, and that should bring us over to IAM-admin. Again, if you need to find it another way, it's probably here. And so we'll go ahead and create ourselves a new tag. What do I want to call this tag? Learning, maybe. Well, it depends. There's a key and a value, right? So yeah, I'll go ahead and type in learning for fun here. For use of network firewalls, no, we're just doing that. Add one or more tag values that can be enforced for the policy categorization. So we can go ahead here. Maybe I'm typing in ACE for its value. And we can give it a descriptor. I'm not going to go ahead and give it a descriptor. We'll go ahead and create that tag. So that tag is creating. Again, this is not a very useful tag, but it is a tag so that we at least learn that little bit there. And if we go back over to here, I want to see if I can actually apply that tag. Select current project. And this is the thing, it's propagation. You got to wait. So we'll give it, again, another few minutes, and maybe we can apply that tag, okay? All right, again, quite a bit of waiting here. And so we're going to give this a nice hard refresh. Hard refresh up here just in case. Give them lots of hard refreshes. And what we're going to do here, if these pop-ups get out of the way, there we go. We'll go ahead and checkbox that. See if we can apply tags again. We'll scope the tags. Cannot contain tags. Okay. But why not? Okay, that's fine. We'll say select current project. I mean, that's just another way to do it. And learning. So yeah, I'm not sure why I can't select my tags right now, but that's totally fine. So I'm going to go ahead. But my point is we'll come back to tagging when we need it. Right now, we do not need it. And I really just want to focus on managing hierarchies. But yeah, there you go. Okay. We're taking a look here at organizational policies, and they allow you to apply constraints across your entire resource hierarchy. If you know org policies from AWS, it's very, very similar. I can't remember what Azure has. But one thing I want to make clear is that when you are distinguishing these from your IAM roles, IAM lets you focus on who has access. Org policies lets you focus on what has access. Now, the interesting part is that they don't call org policies policies, they call them constraints, which is confusing. But the idea is that when you want to create an organizational policy, you're going to create a constraint. And organizational policies is really the organizational policy service that allows you to create constraints. Whoever named this stuff over Google, I wonder if you're still there, because it is really confusing. But the idea here is that when you create a constraint, you need to apply an enforcement. So within your constraint, you are now creating enforcement within it. Again, I don't know why they just didn't not have this level of enforcement. It's called a constraint. But within that, you'll need to have the following. You need to define the resource type. So that's going to be what resource you can apply to the constraint. I believe you can choose multiple resource types, but I've only ever chosen one. You have the enforcement method. So this is when it should be applied on create or update. There are some other ones like based on tags, but usually on create and update are the options that you can choose. Not necessarily both, but one or the other. Then we need to create a condition using CEL expression. I really dislike CEL, but it's something that you do have to learn when utilizing Google. But it's its own little logical language that you can write in YAML or I guess JSON, but I've only ever used it in YAML. Then you need to choose whether you want to allow or deny the action. And there are two types of constraints. We have managed, created by GCP, and then custom created by you. And here's an example of me creating a constraint. In fact, I actually failed at creating this correctly because I'm going to tell you it's just really hard to make organizational policies and be very clear on what you can do. You can apparently do dry runs and there's ways to evaluate them, but honestly, I find org policies very difficult to set in GCP. So if you do find it confusing or frustrating, understand that that is normal for these, but they are very powerful if you can get them to work. And so the example down below is I wanted to create a constraint only for VM in Canada. You can see right now its enforcement state is inactive, meaning it's not being applied. Let's take a look at an example. So I pulled this from the docs because, again, my examples, don't always work correctly. But here we can see that there's the name. We have that resource type, and here you can see it's for node pool. We have the method type. So apparently you can include both create and update. Though in the console, it makes it seem like you only select one or the other. So I suppose you can select more there. Then your condition itself. So this you do have to do quite a bit of research to try to find it out. In the documentation, they don't really make it easy to figure out like what you can apply to different resources. Each resource is a little bit different in terms of what is being set there. And it's very hard. You have to play around with G-Cloud and try to find it out or find existing examples. LLMs are going to lie to you. They're just going to tell you nonsensical things because, again, if there's no docs, then LLMs are just going to make things up, and it's hard to find. So you can see the action type is allow. There's a display name, a description. Pretty straightforward, but understand that creating those conditions can be a bit of a headache. You will see CEL appear in other places, so it's not just in org policies, but we will be touching CEL throughout this course. Let's talk about how you change the hierarchy evaluation by setting the policy source. So here's a diagram, and they kind of try to explain in the docs based on like different colors and here from different things. But really, changing the hierarchy evaluation is called policy source. They don't mention this in the docs, but it's definitely there in the UI, and it's clearly tied to this specific thing. But there are three options we can choose. We have inherent parent policy, so follow the policy that the folder or org above it is using, or Google defined default if no parent exists. We have Google managed default, so follow the default policy set by Google. Override parent policy, so policy includes rules from the parent folder or replaces the parent policy entirely, okay? Now, once you create your policy, it doesn't necessarily take effect until you create a rule. So now you have rules, and basically rule is it on or is it off? Why don't they put this under the enforcement section? I don't know. You can add a condition, but for the most part, you'll do that. And again, these are frustrating. It's hard to tell when they're working. So, just understand the nature of them. But if you know AWS organization policies, then you have an idea what these are. But there you go. Okay. Hey, this is Andrew Brown. In this video, we're going to see if we can apply an organizational policy. I find these very hard to set, and my last attempt I failed. So hopefully I'll learn from my mistake and we'll get it working this time. But let's make our way over to organizational policies. So I'll go ahead and type that in here, organizational policies. And I remember there being two options here at the top, now just this custom constraints, so maybe they changed something. But down below we have constraints, and actually I have the one that I made here before. I'm gonna go ahead and take a look and see if I can find it. So over here, if we scroll to the right, we have constraint type managed, and there's gonna be custom ones. Those are the ones that you create. So I'm gonna go ahead and try to find mine. So I'm gonna go constraint type and type custom. You're not gonna see this here. This is what I created before. And so I have one here called only VM Canada, right? So I created this one before. And I told it to restrict on this information. I'm going to copy that out. It's really, really hard to figure out these conditions. So I'm just going to copy this over here. But what I'm going to do is I'm going to go ahead and see if I can delete this policy. If there is even a way to do that. It's so hard to figure this stuff out. Just a moment here. Let me see. Okay, I'm back at top level here. We have edit the policy. right? And so I'm looking for that delete, cancel. And then we have manage the policy. So like I can't even figure out how to delete this thing. It's so darn hard. So constraints can only be deleted at the organizational level. So switch to parent organization. Maybe that's the reason why I can't delete it. There we go. Now I can delete it. So you can see how it can be a little bit of a challenge to getting rid of that. But let's go ahead and create ourselves a new custom constraint. And I believe I'm at the organizational level. I am right up here. Okay. And so let's go ahead and create a new custom constraint. I'm going to try this again, say Canada VM only, right? So what I want to do is I want to restrict this VM to be only in Canada. So Canada VM only. So only VMs in Canada should be launched and nowhere else should they work. We're going to enforce this on our instance for compute. There we go. And so we have an enforce method. So enforce on create. I'm going to do create or end update so that we're catching all conditions when this is happening. And then we need to define our conditions. So we expand this. We can go over here. We can try to figure out where it is. But again, I said that this is just talking about the common expression language. This is not necessarily talking about the resource underneath, right? Its properties. And it's kind of hard to find that. So let's go ahead. I just want to show you like how great these LLMs are with trying to help. By great, I mean they're not. And don't even rely on Google Gemini to help you because it's not great. I'm going to say I need to write a CL expression for organizational policies for a resource to restrict to apply a constraint. Okay, so like how constraint. How can I apply one for an compute engine instance, right? And my expectation is this is not going to give us a good answer, or if it is, it's it's going to be hard. But I'd expect through the docs I'd be able to find this pretty darn easy, but it isn't. Okay, restricting resource locations. I mean, that's literally what I want to do. So here we might be able to find it here. The physical location of your resources constraint. You can use the location property to resource identify. I mean, this is probably one way we can do it. Maybe this is the way that I should be doing it. But let's go over to here and see what we have. So here, and I kept did we keep that? Yeah, we kept it up here, the original one. But here we have resource match tag, whatever. So it says user define here to write the CL expressions. Okay, but like the question is like, okay, but how? Useful CEL functions. Okay, so here we have some here. Let's go back over to CEL. And let's see if we can find it. Because if we can't find it, like, it can be a bit of a headache. And you really want to know how to do that. So here, I'm wondering, on the left-hand side, can we find some functions here? So I know there's also a page like CEL, Google, and there's going to be like a GitHub page here. But maybe it's in the spec. Right, so going down here, and what I'm looking for, like this just defines the specification of the language. It doesn't necessarily define the functions. So go here and say Google, like functions, Google. Right, so again, where where is this stuff? I can't find it to save my life. You know what I mean? So I have one here. Go back over here. So I have obviously this one here, which is resource zone starts whatever. We go down below here, it says resource match tag. Testing your CL expression, okay. Okay, but but how do you know what you can access on a resource? E.g. resource.zone. I just want to show you like how hard it is to find this information. Okay. Maybe the API. Maybe we can find it via the API. Right? If I already knew the answer, I wouldn't be walking through this like this here. But here we are in instances on Compute Engine. And so maybe we do have zone here. Oh, okay. All right. I think we figured it out. So basically, it seems like all the CEL is doing is it's just basically evaluating that YAML. Okay. So I'm just going to go ahead and just ask this question here. Let's grab this representation. So we have, we have this JSON representation. Okay, and so I'm going to just ask, is CEL just matching against, is matching against this? Is that all it's doing? Yes. Oh, okay. I see. All right, so that should make it a lot easier. So then here, for our zone, then we have this. Do we get an example of what we get for that data? So here I'm looking for, yeah, zone. Actually, it's perfect. So output only, URL of the zone where the instance resides. You must specify the field as part of the HTTP request. And, again, I wish we had examples here. I'm not sure if we do. Do we? No. But without examples, I can't exactly see that format. But I would assume, based on this, it'd be like something that's like starts with whatever. So we go back over to our CEL expression here. And so we might want to match on a string. Let's go here to take a look at string. So here we can do exactly this, or matches. So string value is exactly this, or string value matches the regular expression. I think what I would rather do, we have starts with whatever. I'm going to try something a bit different. I'm going to do an explicit match on this one. So I'm going to go back to wherever my tab was, where I had it. Here it was. Instead of doing this, I'm just going to say equals, and it's going to be very specific, right? We're going to launch in a very specific one. So before I fill that out, I'm just going to open this tab and another one here. I want to pretend that I'm launching an instance, a model. So we'll go over to instance here. And I need to go into my project because we right now are at the org top level here. I'm not going to make one just yet, but what I want to do is I want to go here and just fill that in so I can just grab this name here. So I'm assuming the name is going to be like this. Okay, so hopefully it is. But I'm going to grab this here. We're going to go back over to here, and we're going to place this in here. And it has a problem because there are a couple things here. We'll go ahead and try this. We'll save that. And so now we have it. So when it's this, we want to allow this to happen, right? So as long as this is possible, we can go ahead and create it. So we'll go ahead and create our constraint. I don't know how tests work, so I don't even bother with it. But now we have our constraint set up. Now this constraint is not necessarily on. Let's go over to our organizational policy. We will go and we'll filter based on constraint type. We'll type in custom. And here we can see it's inactive. So we'll click into it and we'll manage the policy. And I mean, that's fine. That's not what we need. Edit constraint. Nope. Manage policy again. Inherent parents policy. So the org will follow the policy of the folder or the org above it. The Google default's fine, so I don't think that's a problem, but we want to turn that on. But every time I'm trying to find this, it's so hard to figure out. Let's go over to here. Maybe view the policy. No. We will edit the policy. No. It's somewhere here. Not enforced. Oh my goodness. Give me a moment because we need to set a rule. And that's what I'm looking for is like manage policy. No. Oh, I think, yeah. Okay. So here we have it here, inherit the parent policy. But if we drop it down to override parent policy, this is where we can set a rule. Okay, great. And so we'll go ahead and say enforce. I really don't understand. Like I tried reading the docs, but I really can't make sense of it. But I think if we set this one here, you can choose whether the policy includes rules from the parent or replaces the parent policy entirely. I mean, we want to override the policy. Why would we want to inherit the parent policy? Like, if we have this here, like, it's not taking effect, right? So we're going to go over here, we're going to override, and I'm going to tell it to enforce it, okay? So we'll go ahead and we will test our changes. Yeah, like, oh, it succeeded. Great. I don't know what that means. So go ahead here and we'll try this again. And I'll say done, and we will, I guess, set policy. Well, we're testing it right now. So it's now enforced, right? So the idea is that we should not be able to launch a VM outside of Northeast 2. So I'm going to try US Central 1. And we'll try this. If this fails, I'm not going to do this video again. I'm just going to show you as it is. But We have our E2. We'll go here. We'll choose our E2 micro. We'll go ahead and create that. We'll give it a moment to create. And I want it to fail, right? Let's see what happens, okay? All right, let's take a look here. And, well, that's not very good because we were able to launch it and that's the wrong region. Let's go make our way back over to the policies, the org policies. And so this one when we click here, we're now in the scope of this. And so I thought we were applying to the entire organization, but maybe we weren't. Let's go take a look here and see if we have a custom one here. So we'll type in custom. And you'll notice here we do have it. It's active. It inherits the parent's policy. So what gives, right? Like, because we told it to restrict resource zone equals this. So it could be that there's something wrong with the way that we wrote this, but it says allow it, right? So if it matches this allow, like what if we go back over to our compute, right? And look, even if I can't get it working, at the very least, I'm getting you a little bit farther and then you can fiddle around with it yourself. But I'm gonna go ahead here and we're going to go ahead and delete this. I don't care, let's go ahead and I'm gonna try to actually launch this in the region we want. I'm gonna go down here, E2, the micro, we'll create it. We'll try this again. This is not, no, that's not the region I want. Sorry, folks, I messed this one up. We'll try that one more time. And I'm gonna drop this down. Toronto, I thought I chose Toronto, E2, micro, create. Oh, this one denied it. This one was denied. What? But it was green. Okay, maybe it did work. Okay. But the UI, you all saw that, right? The UI was green. That's okay. But my question is like, can we make this one? Because last time I did it, now it's saying US Central C1. I'm really confused here. Let's go back here. Retry. Click off. Click here. But how is this one here then? Refresh. Nope, there's nothing here. Dismiss, dismiss. Okay, let's try this again, right? So I'm going here. Right, I'm choosing this one, right? And I'm gonna go here and drop micro. I'm gonna go back to the top here. It's set, North America, Northeast 2. Region is permanent. I'm not crazy. We're gonna say Canada VM, right? We wanna make sure we know what we're creating here. We'll go ahead and do that. And so now this one should launch right away. It says policy denied. So it doesn't like our policy for some reason. I'm gonna go here and take a look here. And I'll go here. And so for some reason, when I set this policy and yet when I launch my instance in this region, it fails. Could the string be wrong? Because that's the only thing that could be happening here, right? And unless I have a way to test it. Oh, zone, right. Okay, so let's go ahead. Let's go ahead and try to fix this here. So I'm gonna go ahead, and before, like I would set like starts with, but I even had problems with that. So I'm gonna go ahead and change this out. Right, we'll do this here. And so now this is 2A. We'll try this again, we'll save it. The only question is like, how soon does it take effect? Yes, this is fine. We'll go back over to here. We'll create a new instance. And we want to launch this one in A, right? So this will be Canada VMA. The question is like, does this policy take effect immediately or does it take time to propagate? I don't know. We'll go ahead and we'll create it. And maybe this time, see, it says it failed, right? So we updated that. Match the specific zone. Really? Do we really have to do that? And here it says contain. So maybe we try this instead. Let's try this again. We'll go edit the constraint. That actually would make sense. Like if I tried to do it with starts with before, that could explain why it didn't work if it had that big long thing here. Undefined field data. Yeah, because it's just zone, right? Like that. So we'll try this again. We'll save it again. Okay, it's enforced. We'll try this again. So this will be here. We'll say Canada VM 2A. It's 2, right? Let's refresh this. It just has to be in Northeast 2. Okay. So now, like, it shouldn't matter where we put it. It should be in any of those zones. We'll try this again. Please, 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 please. Please, 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 please. No. So, you know, like, the thing that I can't see is, like, the API calls, right? So I just can't see what I'm doing. So, you know, it's still failing. Is there any way I can get API output so I know exactly what I need to match for the string? Because they don't provide any examples, right? And without that, I can't see what I'm doing. Exactly what CLC. So it says this here, right? So we go here and I mean, but the problem is like we don't have a resource, right? So how do you use this when you are launching a new resource, right? For existing resources, yes. Policy similar, best for other ones here. So here we have another one. But would that work for orgs? I don't know. So create a test instance first, yeah, and then run this. That's pretty much what it feels like we need to do here. So I'm going to edit the constraint here. I'm going to, where it was manage policy, here it was. So I'm going to take this rule off here. Set this back to inherit. We will set the policy, we'll set the policy. I'm going to go ahead, I'm going to launch a new instance. We'll just say, you know, my instance. We'll keep it nice and simple. I don't care where it is. We'll go ahead and do E2. We'll choose E2 micro. I'm going to create this here. We're going to launch that up. And then we'll see if we can actually, you know, do this. All right, so that resource should be deployed. Let's go take a look here and see if we can refresh here and see that resource. I mean, it should be deployed, right? Nope. Nope, nope, nope. So anyway, again, this is multiple attempts of me trying to figure it out, but like I would think that I gotta make sure that policy is off, but I think it takes time to like see it's not enforced right now. So why is it complaining? Let's go at the this level here. Make sure that one is off. But you can see that this stuff is really, really tricky to debug. So I don't want to make this video longer than it has to be. We're 20 minutes in. You have a general idea on how these are going to get set. But what I would say is like, if you want to try to figure it out, I think that the problem with this one is that we would have to get the API calls. And so we would have to do something like debug the instance and then see the API information, apply it. But even right now, like I have it disabled and I can't launch it. I can't launch an instance. So what I'm going to do is I'm just going to delete this policy so I'm not having any problems going forward here. And so I'm just trying to figure out how to delete it. Again, it's so hard to figure this out. We'll go back here for a second. Where was it? And despite how many times I do this, it's just impossible. So we'll go here, view policy, delete, yeah, pinch to parent, delete. There we go. But anyway, that was my best attempt at organizational policies. I do apologize, but you know, if it doesn't work, it doesn't work. Okay, ciao, ciao. Let's take a look at the concept of principle of least privilege. So this is a security practice granting users, programs, processes the minimum permissions. When we say like users, programs, and processes, and I didn't mean to get my highlighter out. Let's get out our pen here. When we talk about these three things, we're really talking about principles, things that like is a term, it's like the thing that you are giving or granting access to. So you can think of user programs as processes as principles, and we're talking about GCP. But you know, here's an example of something that is very overly permissive. So of course, I'm teaching you GCP, and as an instructor, I just want things to be really easy and for the learner to be really easy. So normally when we learn cloud, we have a lot of permissions, right? And so the owner account you can see here, it has full permissions to everything. And so this would be the opposite of the principal least privilege. So maybe you might want to have a separate account that specifically has ownership, and then you create an additional account and then lock that one down to exactly what you need. But again, if it's your personal account, you might not want to do that because you're just playing around within GCP. But you can even see here from Security Insights that it's saying that there's a concern because this principal over here, which is a user, which is me, has a lot of access, okay? So one thing I want to point out is that in GCP, you're going to often see within the console these shorter names, but you need to also know their pragmatic names. And so over here, we have roles im.organization role admin. I don't know why there's a space here. There's not supposed to be a space, but it's not easy to get the pragmatic name when you're within the GCP console, but you have to use like gcloud to get the pragmatic names. But when we work with GCP via the console, you're going to notice that variant there, okay? So how can you get principal least privilege? Well, just choose roles that have fewer permissions, or you can create yourself a custom role. And so here's an example of me creating a custom role where I'm just making it this role where you can do create, delete, and get. That's it, right? And there you go. Let's take a look at Cloud IAM. So this lets you control who has specific permissions to access Google Cloud resources. IAM standing for Identity Access Management. Every cloud provider has an IAM solution, but each one works slightly different. So let's talk about the three major components, and then we will go deeper in future videos. So the first one is the principal identifier. This will just be called principal when you are in the Google console. But this is either individuals or systems accessing resources. This could be a user, a service account, a group. So just understand the word principal is going to be something that identifies something that is going to get permissions. Then you have roles. So this defines what action or permissions a member can perform. And so this example roles could be things like viewers, editor, or custom roles. You can make your own. And we'll talk about some of the most popular roles in GCP so you have an idea. Then within roles, you actually have your policy. So these are the rules that connect members for who with the roles with permissions for specific resources. So this could be a policy that might allow a group to view project details but not make changes. But anyway, this is an overview, and then we will jump deeper into this, okay? Let us take a look here at principals for Cloud IAM. So a principal in Cloud IAM identifies who gets access. And there are many types of principals, and I'll list them all here, but we're not going to look at all of them in detail. We'll look at the most important ones. So we have Google accounts, service accounts, Google groups, Google Workspace accounts, cloud identity domains, all authenticated users, all users, one or more federated identities in a workforce identity pool, then for a workload identity pool, then for Google Kubernetes Engine pods, resource manager principal sets, okay? So let's go take a look at the four that I'm really interested in. Now, there is Google Groups. I could have included that there, but it's pretty straightforward. It's just a group of accounts, right? So Google accounts, these are individual users with an email associated with Google accounts. And so there on the right-hand side, you can see we have Andrew and my co-founder, Bako. It can be any email. So you enter an email in, and it's pretty straightforward. What you should take note of here, and I mean, I didn't put it here in the docs, but notice here it has like user colon. This is the principal identity. And so when you're pragmatically entering this in, or like in a box, you might have to prefix the username with this so that it can identify what kind of principal you're using. So you'll see that when we are in the console or whatever. Then you have service accounts. So a Google service is a Google service instead of an individual user. And so again, its identifier will have a service account in front of it. You're going to give it a name. And notice that the service account can be scoped different ways. This one's, but anyway, this is IMG service account, okay? And so here are some examples on the right-hand side. So here, notice they all end with G service account, but this one says developer, this one says IAM. Notice here, like I gave them my own names, and they have different permissions here, that there, okay? We have authenticated users. This is a special identifier that represents all users and service accounts for users that are authenticated. And then you have all users, which is a special identifier for representing anyone from anywhere. These two come into play when you are doing things maybe like with a CDN or a bucket or Google Cloud Run, where you are trying to provide access to users to use, something that's like web appy or website, right? So you'll see those come up there. Let's just make sure we understand how easy it is to create both a Google account and a service account. Every time I've been away from using Google for a little while, Google GCP, I forget this and I get a bit confused, but it is pretty simple. So here we're going to add a new principal. So I put in my other email. That was my old business. I still have the email. So Andrew at monsterboxpro.com. Originally I made that because I was going to make video games. This is like when I was 20. But then it became my company. And then I obviously changed to Exam Pro, but that email's around. Notice I signed the role as Cloud Run Developer. You can sign whatever you want. When you create Google accounts, you're adding them at the org level. So that's pretty straightforward. For service accounts, you're going to name it. You give it a service account ID. Notice that is adding it to the email here. Okay. And then you are going to apply permissions. So service accounts can optionally provide access to principals, such as other users. Service accounts all allow you to generate keys to allow applications to authenticate using service accounts. You're going to be doing this a lot, unless there's a case where you're just creating a service account for a service to use, right? I think like with Compute Engine or Vertex AI, you will end up doing that, where you never generate keys. It's just you have to create a service account associated with the service in general, so you can say exactly what permissions it's allowed to access. Service accounts are assigned at the project level, not at the org level. So, that's how it is there. And so here you can see I created a key, right? There are two types of key. I think it's like JSON or P11. I can't remember. It's not that important, but it has a creation date, an expiration date. But there you go. Okay. Let's take a look here at roles. So these are used to group permissions to define what actions users and services can perform in Google Cloud. Permissions cannot be assigned to users directly. Instead, roles are assigned to users, granting them all the permissions contained in the role. If you come from AWS, you'll find that this is a lot simpler and more straightforward. If you're coming from Azure, you really use predefined roles, and you have to pay extra to be able to have additional functionality. So you'll be happy to hear custom roles here are free to utilize. But an example role might be, we want to just make a custom role where it only has access to buckets and objects, or this might be a managed role for Google Cloud buckets. But yeah, on the right-hand side are example of managed roles. So here I'm just searching for Cloud Run, and you see we have ones like Cloud Run admin, builder, developer, invoker. So the managed roles are pretty granular, more granular than something like AWS or even Azure. So you can really use these effectively, but you can also create your own custom roles and get exactly what you want. So neither is bad or good. It just depends on how you want to compose your roles. There are three main types of roles in IAM. We have basic. So these are legacy roles historically used in Google Cloud. They would be things like giving you full access. So we'd have owner, which would give you full control, editor, which can read and modify resources, and viewer, which is read only. A lot of people still use owner and viewer, but they generally say if you can, don't use these anymore. But I still think there's use with owner and viewer. And then we have predefined, so fine-grained roles managed by Google designed for specific job functions. So compute admin would allow you to manage compute engine resources, just like the last one we saw. The example that might have been something like Google Cloud bucket developer. I don't know, but that's an example. So here's another one: storage object viewer. So real-time access to cloud storage. Then you have custom, so custom roles created by users, and you just choose what permissions you need. Pretty straightforward. Ideal when prefix defined roles don't meet your exact requirements. Avoid using basic roles. That is GCP's recommendation, but in practice, owner and viewer, not editor, but owner and viewer are still often used by companies because they're obviously really easy to use. There is also this thing called role launch stages. And all this is metadata. So it doesn't change anything with the role. It's just more an indicator to your team how you want to think about this role. Like this role is alpha, beta, general availability, or disabled. I don't know why they have this. It doesn't really make sense to me. Like, I mean, I feel like you could just put in a description if you want to do that. But I guess at some point, Google, maybe it was Google's workflow. This is how they wanted to work. And so, now we all have this addition here. But you can basically just always choose generally available and proceed forward on that. Okay. Let us take a look here at permissions. So these specify what actions users or services can perform on a resource. So here on the left-hand side, we have a role, and see the one that's highlighted in red? That is a single permission that you could apply. Permissions correspond one-to-one with REST API methods most of the time, meaning permissions directly map to actions you can perform using REST API requests for Google Cloud Services. I don't think this is much different than maybe AWS. I think that theirs is the same, but I would say Google has a much better naming convention for their stuff because it generally follows CRUD, as you see get, list, create, delete, get. So for example, storage buckets.get will allow reading buckets from information using get. Create would use a post or a put, obviously. And here you can see there's a pattern store or service, resource, verb. So very straightforward. Roles are assigned to grant one or more permissions, which obviously that makes sense. But yeah, permissions, pretty straightforward. Let's take a look at conditions. So a condition is a rule that specifies when access to a resource is granted based on a logical expression. So it adds a specific rule or limit to the binding. Conditions enable fine-grained attribute-based access control for Google Cloud resources. It grants access only if certain attributes, such as request time, IP address, resource tags, match the defined criteria. If you come from AWS world, you've seen conditions before. It's basically the same thing. An example might be restrict access to resource during specific hours for a certain IP range. The way it works is it's specified in a role binding via the IAM policy. Access is granted only if the condition expression evaluates to be true. Okay, and we will contextualize like permissions, conditions, metadata, and stuff in the policy architecture, but we're going over it and then we'll go over it again to make sure we absolutely understand this stuff. Okay. Let's take a look at metadata. So metadata in IAM policies provides information for versioning, concurrency control, and auditing. So on the left-hand side, you can see we have metadata for e-tags, concurrency control, or versioning such as schema versions. It includes e-tags for consistent updates, versions for schema specification, or optional audit logs for logging. Same thing as we're saying on the left-hand side. So for e-tags, it enables concurrency controls for consistent policy updates. E-tags is, I think, electronic tag. It's a standard format, not specific to Google, but often used as metadata for bucket storage. It prevents race conditions during policy updates. For version, defines the schema version to ensure consistency, compatibility across updates. I'm sorry, I know it's very repetitive. Like, obviously, it's very straightforward, but again, we'll just repeat it 3 times to make sure you understand what is the metadata we can attach. Let's take a look at audit config. This specifies which permission types are logged and identifies any exemptions for certain identities and IAM policies. So we have audit log types, and under this we have admin activity log, so records administrative actions like creating or deleting resources. We have data access logs. This tracks access to resource data such as read and write operations. We have policy denied logs. This captures attempts to access resources that were blocked by policies. It is an audit log or audit config, as you understand here, okay? Hey, this is Andrew Brown. In this video, I want to show you how to add a principal, specifically an IAM user, to your organization. So I'm going to go here to click the Google Cloud. I'm at my organizational level, and we're going to go over and type in IAM. And so from here, we'll click on IAM. On the left-hand side, we'll be under IAM. I'm going to go ahead and click the it's grant access. Yeah, grant access. There we go. Yep. Sorry, the wording is a bit confusing. I don't know. They just don't say add. And I'm going to go ahead and add my other email. This is Andrew at monsterboxpro.com. That's my old business, so that's why it's called what it is. And so I'm going to drop down here, and we're going to assign a role. So what I'm thinking here is we can do something like Google Cloud Run. So I'm looking for something like Google Cloud Run developer. And I personally do not like the search here. I always find it very confusing. So I usually just, or like I would just say it's not useful, right? So I always have to scroll and then find exactly what I want. So I'm looking for Cloud Run. So do we see it here? We have Cloud Build. Cloud Run, Cloud Run, Cloud Run, Cloud Run, Cloud Run. There it is, Cloud Run. And then we might say Cloud Run Developer. Whoops. Cloud Run Developer. And so now we'll go ahead and save. And so now that user is added. Something else that we should know how to do is set a custom role. So what we'll do here is we'll make our way over to roles. I don't know where it is on the left-hand side, but if you type in roles, like you think it'd be here. Let me see here. Like I don't, oh, there it is. Okay. So you can go to roles here on the left-hand side. Normally I just search for it. And let's say we wanted to create ourselves a new custom role. We'll go here and create a custom role. We'll give it a moment here to load. Takes a little bit of time. Well, normally not, but today it is. And let's just say like launch, just say like launch VMs role. I'm going to call it that. And this is a custom role. I mean, we want to give it a better ID than that. So let's just say only launch VMs. Notice that we have a few different role launch stages. So it really depends on what you want. I'm going to say general availability as our launch stage here. Let's go ahead and add our permissions. And for this, I want to find compute. So in here, I'm going to type in compute. I mean, that's filtering for existing roles, which is not exactly what I want. We can try here, compute instance sys.launch or .start. I'm just going to be honest with you, it is very hard to navigate these UIs. They're not the best. We'll go ahead and add it. So now they have only permissions to launch the instance. We'll go and take a look here. Nothing else I need here. We'll go ahead and create this role. And so that role should now exist. Here it is, launch VM roles. Probably not the best name. Let's see if I can adjust that name. So I'll go here and only launch VMs. That will be a lot more clear if we do it that way. I'm going to go back over to my IAM user, and we're going to go into this user here, and I want to grant them access. I wonder if I can just edit them over here. There we go. We'll go ahead and add a role, and so this will be our custom. There we go, and we will go ahead and save it. And so we've created a user, and we've added a custom role. So there you go. Hey folks, this is Andrew Brown. In this video, what I want to do is get some practice here with the gcloud IAM commands. So I actually have this. You might have created a user or not. I'm just going to go ahead and remove this one as I want to try to start this from scratch. Actually, I think I would actually need one to start with. So maybe maybe that's what I'll do first. So there is a command to copy between projects, but that's a little bit too complicated. What I want to do is I want to go over here into Active Cloud Shell, and we're going to authorize here. Okay, and let's go ahead and see if we can create ourselves our own custom role. Actually, before that we do that, we could also just list roles that we have. That might be fun to do. So we're just giving it a moment here to connect. Sometimes it's fast, sometimes it's slow. I'll pause here and make the wait faster. All right, we are back. And so, one that we should know is gcloud IAM roles list. So let's go ahead and try that. Oh, sorry, we got to spell gcloud correctly if we want it to work. Now just remember that these things are highly conventional, so it's very easy for us to find the stuff that we need. Now we're getting a lot of output back. That is a little bit too much that I would like to have. So I'm just going to hit Control-C to stop that. And there is a way that we can get help with a command. And so I just typed in the -- help flag, and it tells us a bit more about this specific command that we're running. And so obviously there's too many there. I would probably want to sort by project. I think it's picking up. Is it picking up that project? I'm not sure. But I might want to just filter out some custom roles. So I'm going to go ahead here and try this again. And there's a filter flag. So in the filter flag, I would like to filter just custom. So I'm scrolling down here. I'm just taking a look here. Filter. Can I get an example of filter? I don't have one, but we'll try this. We'll say gcloud IAM roles list filter. And I'm going to just say custom and see if that helps. And again, you have to spell gcloud correctly if you want it to work. I'm dyslexic, so you'll see me do that quite often. And it is filtering, but it's not really doing what I want to do. So I'm going to stop there. Let's take a look here at the filter flag for gcloud command. Let's see if we can figure that out here really quickly. So here we have, I'm trying to look for an example. Format. I mean, YAML's fine. I actually like YAML quite a bit, but maybe not the way that that's working there. And so what I'm looking for, here we have zone, whatever. Okay, so we're starting to see some expressions here to do this. And so, I mean, we have description, tag, role, stage. What I really want to do is like say filter based on custom. So let's see if we can find this. Let's say I am roles list API gcloud and see if we can find that information here, because this will tell us what data gets returned. Right, so this is the roles method here, and that's the API call. And so what I'm looking for here is what does the data look like? And I don't have an example, but maybe we can just go ahead and attempt this. Just say execute, and I'll connect here. Say continue. And yes, continue, let me in. And so we have an error call, that's totally fine. We'll try again. Again. There we go. And so now we're getting back an API call. And so we can see the data that we're getting returned back. And I'm not seeing in here the means to filter based on that. Because filter, I believe, is like post data filter. So if I want to filter that specific information, that's going to be a little bit hard. Looking at the properties within this API call, I don't see anything that would allow me to filter it. So I really would have to filter this based on name. So let's say I want to find exactly policy admin. Maybe we could try this. So I'll go back over to here, and we have this, but there is obviously a syntax language. I'm going to put double quotes here, and I'm going to say policy admin. And so let's go take a look and see how we might do that. So I'm just carefully looking at this here. Does not equals. Contains. Yeah, I thought that's what it was. So I'm going to go ahead here and we'll try this. So what do we want to filter on? It's going to be the name. And I'm going to do a squiggly like this and see if that works. And so now we're only getting back policy admin. Okay, so we're getting comfortable with working with gcloud here. Maybe one other thing that we should try to do is try to create a custom role here. So we do need a role file in order to do that. So I'm not exactly sure what the content should be. What I'm going to do is go over to Claude. You can use Gemini if you want, but I'm going to say, can you create me a JSON file for a custom role for GCP, right? We could also probably look that up. So like custom role GCP JSON. And probably in here, when creating the custom role, they probably give us that information. So we have one here. Again, I might not use this one, but I just want to see what we get. And I'm just clicking through the documentation here. We'll give it a moment to load. Sometimes the docs are slow because it's not because the page itself is slow, but it might like authenticate your account because you are connecting here. And so that's one of the reasons why. But what I'm looking for here is one where we have, custom role here. gcloud. Create a custom role using a YAML file. To be honest, I prefer YAML. So if we can provide YAML, I'd rather do that. So we have a template here. We have title, description, stage, include permissions 1, permissions 2. So I'm going to go back over to here, and I believe we have an editor here. So I'm going to open the editor. And we'll just create ourselves a quick, we'll say allow, a quick YAML file. So let's say new, give it a moment to load. New, it'll say custom role. .yaml. We'll do YAML because YAML is so much nicer. And I mean, we can kind of follow with what we have here. I'm just going to grab some of this here. Like you can do that as well, but it's not like it's that hard. And we'll paste it in. Some people don't like YAML because I'm going to turn it on Vim mode. You don't have to do this. Actually, don't do this if you don't know how to use Vim. But if I don't turn it on, I just can't seem to get around easily. I want this one here. There we go. Install. Yeah, so what I want to do here, just format this a little bit here. And I don't need these. You can see if you like Vim, you'll really like it. Or sorry, if you like YAML, you really like it. If you don't, yeah, you don't, I understand. But again, I'm very good at precisely typing, so it's less of an issue for me. And so I'm just going to format this so that it is good for this here. We don't need any of those. There we go. And so now I have myself a custom role. So I want to go ahead and create that. I'm going to go ahead and try this. So this will be gcloud IAM roles create. And then we got to give it a role ID. So this will be my custom role example. And I'm not going to give it a project ID. I think it'll pick up the existing project or it'll go somewhere. And so I'm going to go ahead and type in custom-role.yaml because this should be the same directory as this. Let's go ahead. If it doesn't, it'll tell us in 2 seconds. I'm going to do ls-la to see if we have that file there. Yeah, we do have custom role. Let's try that one more time. Let's take a look here. So I'm not exactly sure what's wrong. So I'm going to go ahead and do a help. And that will tell us a little bit more about what it's expecting us to do. So here it says gcloud IAM roles create. So you provide the role ID. We did that. We have a file. You can also provide permissions inline, which is nice. So here we have an example. They do have an equals in there. We don't have that there. Notice that they're using title case. So I'm going to go back over to here. I'm going to hit up. And so I didn't do this. And I believe it's double hyphen, right? Take this out like this. Yeah, it is double hyphen. Oh, we have to specify the project, sorry. So we can do this or the organization. I'm going to do it at the organization level. I might have said earlier that these roles are not project specific, but I could be wrong. Be honest, like it's not that big of a deal whether you know or not. It's just you're paying attention. So we're trying the organization here. If it doesn't work, we'll switch over to the project. Request contains invalid argument. I'm not sure as to why. We'll switch out to project, I suppose. Oh, maybe we're not giving the org ID. Let me go take a look here. Maybe it's org ID. I don't usually specify organization, so I'm not really sure what it is. So we'll just try this. I mean, it's hanging, so that probably means it's creating the role. I'm going to wait a little bit. Oh, there we go. And so it's created the custom role. So there you go. Yeah, it's really up to you, like whether you want to use gcloud or the console for, mostly for this course, you'll probably see me using the console because it's one of the providers where the console's super easy to use. But, you know, we hop in when we need to into the gcloud here. But there you go. All right, let's take a look at the policy architecture. You'll notice that it's made up of the components we talked about earlier for IAM. So policy is a collection of statements that define who has what type of access. It is attached to a resource and enforces access controls when the resource is accessed. A binding connects one or more members to a specific role. So it's pretty straightforward and not very complicated, but we will continue on here and just reinforce what policies are, okay? Let us take a look at policy statement. So it defines access control rules, specifying roles, members, and conditions for resource access. On the left-hand side, we have a representation JSON. On the right, YAML. JSON is really great for automated systems because applications are really good at writing out JSON, whereas humans, we don't want to see as much, so YAML makes it so much easier to read and also write manually. So it's really up to you. As you can see on the interior there, we define our bindings. Remember, we saw that in the policy statement that or policy architecture, we need to define a binding. And so here we're saying this is the role and this is the member. Again, I call these principals, but here it's called members. So the members that have it. Then we have another role with another member and the conditions to when they can have it. We have etag and version. So we'll continue on there. The example shows a project level IAM policy retrieved with gcloud projects IAM policy. So if you ran this command, this would be a way for you to view this data yourself. There are a few commands that we might want to talk about. So there is the gcloud projects get IAM policy. There's the resource manager folders, and there's the org IAM policy as a means for you to see the stuff. Some limitations you need to know about policies is each resource can only have one IAM policy. Policies support up to 1,500 members or 250 Google groups. Policy changes take up to 7 minutes to propagate, up to 100 conditional role bindings per policy. Conditional roles allow up to 12 logic operators for fine-grained access. Let's talk about conditions specifically for policy statements. These are condition attributes, defined rules based on resource properties or request details such as timestamps, IP addresses, or other contextual data. We already covered this before, but we didn't show it in a policy statement. But here you can see when you look, I'm gonna get my pen tool out here. When you look here, we have our condition, right? Here's our expression. So the request time, if it is less than this thing, then if it's true, then, you know, access expires after January 1st, right? So hopefully that makes sense. So for time-based conditions, this will allow you to control access by specifying when a policy is valid. Okay, so here we're specifying a range. Down below, but up here we have the same one basically, but we're saying restrict access to a user until January 1st. So as long as the time is less than this date, they will have access to it. Here we have the off hours access. So only during the day. So here we're looking, we only want them to be able to access it between 8 p.m. and 6 a.m. Access allowed only during off hours. That's really interesting. You think only on hours would be the case, but here we're specifying the time zone and the hours in 24 hours. The request time ensures access aligns with set times or expiration dates. We also have resource-based conditions. So these restrict access based on specific resources. So here we're taking a look, we can see resource name starts with this, and that is going to be the restriction we have there. The resource.name attribute ensures access applies to only resources matching the specified name prefix, as we just saw there. What are some condition limitations of conditions? Only supported for specific services. Primitive roles are not supported. Cannot use all users or all authenticated users as members. Up to 100 conditional role bindings per policy. A max of 20 bindings for the same role and member. And there you go. Hey, it's Andrew Brown, and what we're going to do here is take a look at how do we enable APIs for specific resources or services within a project. So right now, I'm going to make sure I'm in my GCP playground. This is a new one that I created. Some APIs I've activated, some I haven't. We'll go to the top here. We'll just type in API, and we'll go to APIs and services. So the idea is that if you want to utilize a service, you have to turn on its API. So if we go enable APIs, you see we have a large library, and one that I already know that I've activated is Compute Engine, but we'll go ahead and type in Compute Engine, and here we'll click through to it, and you can see it says manager try this API. So it's already enabled. So there's something else that I wanted to utilize. Let's say buckets. We'll go ahead and type that in. And so we're trying to discern like what uses cloud storage buckets. So I could say cloud storage as well. Cloud storage. Cloud storage. So there's a little bit of a guesswork here, but for the most part, when you go and utilize something, it will generally try to help you to turn it on. So I can go here and I can, oh, it's already enabled. So maybe when I turned on compute engines or something else, it was already turned on. But if I go over to here, we could disable it. So I'm going to go ahead and disable it just as an example. So it says Google APIs, Google, So if you disable this, the APIs will also be disabled because they depend on it. So I'm going to go ahead and just confirm it. Even though I don't really want to turn it off, I'm just going to turn it off, for example, here. And so sometimes it takes effect for things to happen. But now imagine that I want to go ahead and use buckets. So say buckets. Okay, that's under cloud storage. I'm going to go ahead and hit create. And I think it should take effect. Sometimes it's a bit slow to propagate. We'll go ahead, my cool bucket. I'm going to put some numbers here so I have no conflicts. And we'll go ahead and hit continue. And I don't care. Yes, it can be multi-region. I'm not really going to use this bucket. This bucket is sent to prevent exposure of data on the public internet. That's totally fine. We'll go ahead and create that bucket. And it looks like it created the bucket. So, my expectation was that bucket wasn't going to work because we have disabled cloud storage APIs. So if we take a look here, Google Cloud Storage is RESTful service, accessing, etc. I really thought that wasn't going to work. Okay, so let's go ahead. Let's ask Gemini Assistant. So we'll go ahead. I'll just say enable at no cost. It doesn't really work that well at this point. I think it's just because of lack of Google documentation. If there's no documentation, there's nothing for Gemini to work with. But let's see if we can pose this question to Gemini whenever it decides to turn on and see if it can determine what's happening here, because we did turn it off. So if Google Cloud Storage API is disabled, would we be able to create a Google Cloud Storage bucket? Let's see what it says. Because I would assume that it wouldn't work. But for the most part, when you're working with Google Cloud, if something doesn't work, it just tells you. No, if Google Cloud Storage API is disabled for your project, you'll not be able to create a Google Cloud Storage bucket. The API needs to be enabled to allow interactions. So that's what I would have thought. You need to enable it. Okay. Now, if you disable an API in Google Cloud, does it take effect immediately? Instantly? Or does it take time? Disabling the API takes effect almost immediately. However, there are a few important things. Okay, so this is where I'm confused. Like, it says one thing and then there's another. But really, you just have to kind of observe these things and see what you're able to do and not able to do. I'm going to go ahead and delete this bucket. So we'll say delete. I'm going to try to make it again and see what happens. Okay, because it's been a little bit of time. So let's say my really cool bucket. Okay, and we'll go ahead and hit create. And we'll see if it makes it this time. And again, we're not seeing any resistance here in terms of this being able to be created. So maybe it's at the API level. So here I just click this button. This is going to open up Cloud Shell. Okay. And what I might be able to do is maybe if I try to use the API to put something in that bucket, that's where I'll run into some friction. Okay. We're trying to figure out why, like if we disable it, it should not work, right? So now what I need some kind of command. So I'm going to go back over to here. I am in Google Cloud Shell. I want to move a text file into my bucket. Please provide me the Google CLI command. Okay. Takes me a little bit of time to start remembering the Google CLI, but it's not too hard. Yeah, gcloud storage and then the path. So what I'm going to do is I'm just going to touch a new file here. We'll call it index or hello.txt. Okay, I'm going to edit this file. You don't have to, but if you want, you can just, I'm doing vi. So here I'm in vi. I'm going to hit I for insert mode. I'm going to type in hello world. I'm going to hit escape to get out of insert mode. And I'm going to hit colon WQ, right, and quit the file. So now I have this file here. Let's see if we are prevented from moving this file into our bucket. So we have this bucket here. Okay. I'm going to try this. gcloud storage, CP, and then the path to the file. So it's hello.txt. And then we need the path to our bucket. So we will bring this on over. It's not really moving over, but that's fine. And then we could have copied it here to our clipboard into our shell, but I'd rather just type it out. It's not that big of a deal. // and we have my really cool bucket -12313. I'm not sure why I named it that, but that's what it is. So I'm hoping that moves it there. And it does. So a failed example of the API being disabled, but what I'm going to do is I'm going to go ahead here. And if that doesn't work, we'll try something else. Again, this is really important to try these things out because no matter what the LM says, no matter what the docs say, what actually works is always different. So we'll go back to APIs because I don't really want to turn off cloud storage. It's something that I probably want to use. So we'll go back over to here. We'll type in cloud storage. Okay. And it was, we have cloud storage here and then cloud storage API. Okay. Google Cloud Storage is RESTful service storing. So this is the API, which is enabled apparently. Let me click this one. This one's disabled. So that's a little bit confusing because what's this one then? Right? What's this one if we have this one? Ready for enterprise use? Okay. So we have a bit of redundancy. So maybe if I turn this one off, disable the API. If any resources were created, they may be deleted soon after cloud storage API is disabled. So that's probably something worth to note. If you're turning it off, the resources might vanish. Okay. So now that's disabled. Let's make our way back over to buckets. Everything in Google Cloud is, does it do what it says on the tin? I'm constantly trying to figure stuff out. So say my super cool bucket. Put some different numbers in here. We'll go all the way down. And so I'm hoping that this doesn't work. What's it going to take to make it so I cannot create a bucket? We can open up this command again. So I'll just copy this here. We'll open up our shell. Now it should still have that same file. If we do ls, there it is. I'm going to hit up on the keyboard. I'm just going to paste in this link and see if that works. Still copies. It's just like I can't for the life of me get rid of it. We'll go ahead and we'll delete that. We'll say delete. And we'll go back over to here and we'll click back. API services. What if we try bucket? So transfers data from external data sources to Google Cloud Storage bucket or between there. Okay. Go back over to here. To a cloud storage bucket or between storage buckets. So there's also this API. So we've turned off Google Cloud Storage API. We've turned off Google Cloud Storage, and then there's Storage Transfer API. But that's not even enabled, okay? So I don't think we're going to figure that out, which is totally fine. But I'm just trying to show you what the experience is with Google Cloud. And, even for myself, that's, again, worked for I don't know how many years with all these cloud services and being an expert in all of them that, I get confused myself. So we'll go back over to here and type in cloud storage. And I believe we enabled this one and this one. We're not going to figure out this bucket thing. I'm just going to re-enable that stuff. Now, it made it sound like it also disabled something else, which I'm not exactly sure, but I guess we'll find out. Now, I definitely know if we disable Compute Engine, it better stop working because I had to turn this on to be able to use Compute Engine. So go to here, and if it's already on, turn it off. Or if it's not on, don't worry about it. So I'm going to go ahead and disable it. They depend on the OS config API. Yes, confirm it. Okay, and those ones are turning on, which is fine. We'll give it a moment here to turn off, okay? Oh, wait, there we go. So it's turned off. So now what I want to do is I want to make my way over to Compute Engine. And we're going to spin up a virtual machine. So we'll create a new instance. And we will see right away, I have to enable. I'm not allowed to use this without enabling it, okay? So we could also try this here and just say, can you provide me a command? Can you provide me a command to launch a virtual machine via gcloud for an E2? And hopefully it will provide all that information, but we'll see what happens. I just want to try to show, like via the API, that it should return something funny. So we go over to here. Okay, and can you just fill them in for me, just so I don't have to guess. There we go. Now that seems pretty darn light, but I don't want a medium. I guess a medium's fine. We're only going to spin up for a second. Again, if you're worried about cost, don't spin things up or look into it. But for the most part, I'm going to spin. Well, again, this is not supposed to even work, so it's not even going to matter. So I'm going to go ahead. I'm going to copy this, and we'll paste it in here. I don't know if that's enough for the command to work, but let's find out. That seems like too little. Would you like to enable and retry? So right away it says not enabled. So, you know, even if you do it here, I guess we can hit Y for yes. Sure, why not? And we have a little bit of a problem. The service is currently deactivated, and deactivated must complete before activation can occur. So I'm going to try this again. Yes. No. Okay, that's fine. So what we'll do is we'll enable it here. Sure there was. Sure there was. Okay. We'll try this again. All right, so we're going to have to hang out here for a bit. So I'm going to just wait and turn this on. I'm going to wait 5 minutes and be back. Okay. Now, I didn't really wait, but some folks suggest that maybe you might want to disable and then re-enable manually. And then if one of these comments fails, please run by placing the correct operation ID obtained. Sure. So let's go ahead and go over to here. Let's see if we can just run this command here. And hit enter. Well, I didn't want to disable, I want to enable it actually, so that's fine. Let's see if we can enable it. And I will come back here when it shows something. Now I'd say that took about 4 or 5 minutes, and now it says it's successfully enabled. Let's go over here and give it a refresh. And see if it's now enabled. There we go. So, you know, we can kind of work around our problems there. But it is a bit unusual. Actually, we'll go back over to here as we were originally trying to run that command. This one here. See if it works. Again, I expected it to want more information, but if that's all it needs to launch, that's really nice. So we're just going to hang tight until it returns a response, okay? That was really fast. Literally 1 or 2 minutes later, we can see our information, the internal, external IP, and it's in a running state. Let's go back over to here. We can go ahead and delete that. So we just type in compute engine. Technically VM instances is what we want. So there it is. I'm going to go ahead and delete it. And we'll hit delete. Okay. So you can see it's a bit finicky, but you know, we can enable, disable. It should prompt, and if you run into issues, I guess just do what I did there in the in Cloud Shell. I'll see you in the next one. Ciao, ciao. Let's learn about quota limits. So the idea is that you have all these services, but there are guardrails, so to speak, in here to prevent you from launching too many resources. This could be so that you're not exhausting resources for other customers, or let's say a malicious actor gets in your account. They can't spin up really expensive things, or they have a limit to how much they're utilizing. So you do get some defaults, but if you need to increase them, you can do a service quota increase. But I can just type in quota up here and try to spell it correctly. I'm dyslexic, so I often get it wrong. I'm going to go to all quotas. And on the left-hand side, we're under IAM and admin. And you can see over here, we have some limits. Now, I actually don't have a virtual machine spun up, but right now, it seems to think that I do, or it's just suggesting that this is the general usage of current usage patterns. So what would happen if we spun up more? So maybe we can launch five virtual machines and see what that looks like. So what I'm going to do is I'm going to go over to virtual machines. I'm going to create a new virtual machine. And you know what? This might be a little bit faster if we use Cloud Shell. Okay, because it's a lot of work to type all this stuff through here. And so I'm looking here, and yeah, I do want E2, but I might want it to be the smallest one. So we have, I don't know why they don't do this in order, but E2 micro. So what I'm going to do is go here, and actually we're doing this earlier. You can type this out if you don't have it. But here we have G Cloud Compute instances, and I'm just going to reduce the font a little bit so it's a little bit easier to work with. Now, obviously it could be harder for you to see, but hopefully it's not too bad. So what I'm going to do is say, we'll just say VM1, okay? And then here we're going to swap this out from E2 medium to E2, I think they said it was micro. Scroll down there and take a look. It is. And then you can choose whatever zone you want. I've used Central 1A from before. I'm going to go ahead and hit enter. Okay. So that is going to, or should, initially create a VM called 1. It doesn't take too long, so we'll just wait a little bit here, okay? And that was really, really fast, so that was less than a minute. I'm going to go ahead and hit up, and we're going to switch this out to 2. Okay. So now we are creating our second virtual machine. And we'll give that a moment to create. So that is now created, and what I want to do is go back to my quotas and service limits, or whatever you want to call them. We're going to give us a nice hard refresh. Let's see if that value updates. So here it says, Compute Engine API, current usage 1. Okay. And so I was hoping that this would be based on amount of compute engines launched. But also there's region-specific stuff here too, right? So maybe it is in here. I just got to go find it. Just give me a moment, okay? Also, sorry, something I should have been paying attention to. This says networks up here, right? So it's the type of thing that's, I don't know why I wasn't paying attention to that. So let's try to find the instance. And this actually kind of makes sense because we obviously have a network set up. So that makes sense there. Just give me a moment, okay? All right, so what we can do is we can go to here on the filter, and then we have name. I'm just going to start typing instances and see if we can find something that resembles what we're looking for. And so somewhere in here, here it is, VM instances. And so here it shows the current usage 2. And so if we wanted to exceed that amount, we'd have to launch 24. It'd be interesting to see what happens if we try to exceed that. So I might be interested in trying to make a Terraform template that we can launch here. So maybe that's what I'm going to do. So what I'm going to do is I'm going to go over to GitHub. And I'm going to make a new, you don't have to do this, but you can get the code from here. That's what I'm doing. I'm setting up a new code base for us folks here, unless I already have one. And I'm just going to check and see if I already have one or not, because I might. I do not. So let's go ahead and make our new GCP examples repo. So this is where I'm going to be putting all the code examples. So if you, again, you want to follow along, it'll make life a lot easier. I'm going to go ahead and add the README, and we're going to go ahead and create the repo. You're not doing this. I'm doing this so that you have access to these files. I'm going to go ahead and hit a period on the keyboard here. Okay. And so I want to launch up 24 instances. You might not want to do this, but I'm going to go ahead and just say quotas. And in here, I want to have a Terraform script that will launch 24 instances. So I'm going to go over to anything. We can go over to Claude. Use whatever you like. I'm going to use Claude here today. I'm going to say I am using GCP and using Terraform. I would like to deploy 24 instances of E2 micros in US Central 1 E or A or whatever it was. And we'll go ahead and see if it can write that up for us. Because I want to see what happens if we hit the limit. Like, what are we going to see? Okay, and so we are getting some code here. Good. The GCP project ID, yep. Number of instances. And again, just carefully looking at the configuration here. I think this is fine. And here it has the account. We don't even need that, but it's nice that it's doing that if it wants to do a startup script here. If you enable external IPs, We don't really care about external IPs. We just want this to work. But I'm going to go ahead and copy the contents of this. Okay, we'll go over to here, and I'm going to make a new file called main.tf. We're going to paste that in. We don't actually have any compute attached here, so this is going to be a bit of a problem. I'm just going to commit this. So work in progress of quota example. And what I'm going to do, and it's up to you. You can clone this repo locally. You can use Gitpod, GitHub Codespaces. I'm going to use GitHub Codespaces because it's right here. And I'm going to create a new code space. You got to get your developer environment working however you want. Okay. And just to be cool, because we're the cool kids, we're going to switch this over to dark mode whenever it decides to let us choose our modes. And yeah, I don't know, just for writing code, I have to use dark mode. But we'll go over to here, and so we have our main TF, and so we're going to need to get Terraform installed on here. So let's go take a look here. Install Terraform Ubuntu, because that's what we're using right now. And it should be pretty easy. Linux. I don't know if we need all of these commands, but it seems to think that we do. Security systems up to date. Well, we're using a cloud environment, so I don't think that's necessary. We do need to use the HashiCorp GPG, so we'll definitely grab that. Okay. And I'm gonna, while I'm doing this, I'll make the instructions, because you never know when you have to come back and do this stuff again. So this will be the first thing we do. And you don't have to turn on Vim keys, but if I don't turn on Vim, my life is miserable. Okay. If you don't know what Vim is and you don't know how to use Vim keys, do not turn that on. This just makes it so it's easier for me to type. So this will be install Terraform. Okay. And I will go back over to here, and yeah, we're going to run these step by step. So hopefully it works. I'll paste that in down below. There probably is a way to install this like really quickly in GitHub Codespaces, but I want to show you the general way of doing it, so I don't want to add any kind of complications to it. Okay, we'll paste that in. Okay, I can also grab this page just in case you folks do not know where it is. And yeah, so we have the fingerprint, add the official repository here. Good. I don't remember it being so many commands before, but I guess it depends on what you're using, right? Like if you're using a Mac, it's probably just brew install or something. And then we will do an update. It's not too bad. Sudo apt update. And then we'll run this line here. The repository does not have a release file. Cannot be done securely by default. I'm not sure if this will be a problem, but we'll find out in just a moment. As long as it installs, I don't care. It says it's installed. We'll type in Terraform. Or TF, sorry. Or Terraform. It says it installed it, unable to locate the package. So we do have a little bit of a problem. And again, this is 90% cloud, just figuring out problems. So what is our problem here? We have this step here. Yeah, it does not have a release file. Okay. So, I mean, that's not very helpful. Just a moment. So yeah, as I said, there is another way that we can probably install it, and that's using dev container. Now I've installed on GitHub Codespaces and Gitpod many times. I'm surprised it's not working right now. There's a problem from people from 2022 that's really old. But to solve it is not clear. Just found out the solution works for me. Try installing Debian releases called Trixie. Yeah, I'm not going to do that. So maybe what we'll do is use this way of doing it. If it's installed for you, then you're in good shape, but for me, it's not. So here, what's being suggested is open up the dev container configuration. So we'll go over to, back to our repo here in Codespaces. And they make it look like I can change my dev config here. Sure doesn't look that way though. If we go up to here, here it is. Okay, and so here they're suggesting we add in this code, I believe, under features. I know it's really small, that's why I'm saying it out loud as I do it. And yeah. And the question is like, how old is this one? Because see, it says Terraform 1, and then over here, when was this article made? Last year, so it probably is fine. I really like the idea of GitHub Codespaces as a cloud-based environment, et cetera, et cetera. So they're suggesting that this might work. Okay, so what I'm going to do, because we haven't really done anything in this environment, I'm going to, well, this is the github.dev. By the way, you got to be logged in to use all this stuff if you don't already know that. So I'm over here, and we have this. We'll go ahead and add that. So update instructions. I'm gonna need to rebuild this environment. So I believe we go to command palette. I don't know what it is. Rebuild. Rebuild container. Sounds good to me. So we'll have it rebuild. I'm doing a slow rebuild, and then we'll see if Terraform is already installed. We'll be back in just a moment, okay? All right, so I believe it's restarted. Let's go take a look here and see if we have Terraform now. Of course we don't. Of course we don't. Why would we get what we want, right? I actually didn't even sync these changes. So what I'm gonna do, just to really make sure this actually gets installed, and the other question, did I even save this? No, I didn't. So how's it gonna, what was the point of that rebuild if I didn't do that? So I'll try this one more time. We'll rebuild the container one more time. Took forever. But maybe this time. Oh, don't tell me it's that fast. Because last time I was waiting forever. Oh, okay. It's fast, I guess, now. And so I'm doing this. I'm not seeing that there. So I don't trust this. I'm going to go back to the repo here. And this is now the dev container over here. And just because I don't trust GitHub Codespaces, I'm going to go ahead and delete it. And we'll make a new one. I used to love Gitpod, but Gitpod, they've been retiring their original service. And so I've been kind of staying away from there just in case, so people don't get comfortable with a really good service that they decided not to do anymore. So, I mean, they have a new way of working, but I haven't tried it yet. So this is going to spin up, and then we'll check if Terraform is installed. All right, we're back. Says the code space is currently running in recovery mode due to configuration error. What's wrong with my configuration error? Or my configuration? It's pretty darn straightforward, right? So we'll go back over to here, and I guess it didn't like what I did. I'm going to just click back to get back to it quickly. Or not, I suppose we can just edit the file manually here. And what could be wrong here? We have a comma here. We have the feature here. It looks fine. So dev containers. GitHub Codespaces. Doesn't matter what we do. We're going to have trouble no matter what we do. But once we get that set up, we'll be in good shape because I'm sure we will end up using Terraform more. See, here they have all the steps. So this is the way they did it. I mean, we could also just do it that way. You know, there's another thing that we can do. It's been a while, but we do use, let's see here, free GenAI Bootcamp. No, not the GenAI Bootcamp. If we go into here, and I should have a repo because I've done this so many times, but we have the AWS Bootcamp from 2023. I should have in here an installation script for Terraform. Okay. And so, yeah, we have dev container. Let's check this one. And this one specifies the AWS CLI as a tool. And so that one looks correct. But I might also have in here the instructions. Maybe not. I was hoping maybe I have the instructions here to install. I do have a Gitpod YAML. So I do have one for Gitpod, but we're not using Gitpod, right? So yeah, this might still not work. So we really do need to figure out how to get that features there. Let's go over to here, see features, dev container, because there is a way to install them directly in here. But since it's in this debug mode, this is github.dev. That's not the same thing. That's not going to help us. Let's see if we can find it this way. We'll type in Terraform. And yeah, we have this one here. Let's go back over to here. Let's make sure that is correct. It's totally fine. Oh, you know what it is? We have doubles of these. This is our problem. So we have some extra copy going on here that's not supposed to be here. So we'll go ahead and take that out. And so that will probably fix our problem. Okay, let's go ahead and commit that. So now I'm hoping that that will fix our problem here. I know, again, huge detour. And I'll just close that tab out. We'll go back over to here. And if there is one running, we will stop it. We'll go ahead and delete it. And this time we'll create a new code space. But once we have Terraform set up, I'm sure we'll come back to it and use it again. So I don't think this is a waste of time. Okay. We'll give that a moment to spin up, okay? There we go. Supposedly it's activated. Let's go type in Terraform. If it ever decides, there we go. TF, Terraform. I don't know. I don't know what it wants to work. One second. So I know there's another way to install these, which is through the command palette. So modify your active permissions. That might be one we might want to do here. I'm doing Command P, by the way, to bring that up. It's just this command palette. I'm actually hitting Command. Yeah, there we go. So modify. Say dev container feature dev container. Sure. Modify. And so now we have checkboxes. So now I can go here and just type in Terraform. Right? And it's checkboxed, right? So what else would it need for this to work? It clearly is installed. So we'll go ahead and type this again, Terraform. All right, 1 second. I really don't think I should have to do this, but I'm going to do a rebuild, which seems excessive, but I'm hitting Control-Shift-P, by the way, when I do that. So we'll try this again. We'll do a rebuild. And I'm going to do a full rebuild. And let's hope that Terraform shows up now. All right, let's take a look now. Terraform. There we go. Okay, so I know that was a lot of work, but we are close to getting something set up here. So we have our main.tf. There's a little bit more work that we need to do, as we need a way of actually connecting to our account. So obviously there are some configurations that we'll need to do. I'm going to just make this a bit larger, and I'm going to go back and get my Vim command here. Again, don't install this unless you know what you're doing and you want Vim. We'll go over our themes. We'll change our color. We'll go to dark mode. And what I'm going to do here is I need a way of storing the variables. So it's been a while. I mean, it's vars.tf or something. Variables vars tf Terraform. Yeah, it is variables tf. Well, no, there's variables tf. Tf vars is what I'm thinking. There, tf vars actually stores the values. So we will go back over to, well, where did we go? Allow. And so here we have these variables here, right? So normally these would be separated out into a separate file. So this would be variables tf, I believe. Okay, and then we'll place that there. So we have the number here, and that there. So now we actually need to load this up with a value. So I think maybe like, was it main.tf vars? It's been a while. Let's go take a look here. Just a moment. Oh, we actually already have it over here. Okay, so yeah, here. Oh yeah, it's Terraform TFRs. I don't think that the name here matters. I can't remember if it does or not, but I was going to name it main. So we'll just make sure that we name it correctly here. There we go. And so now we can provide our values. So we'll go back over to here. Yeah, it's just project ID like that. So do that. And then the next thing I need is the name of this. So this is GCP Playground. But that's not its ID, as this is actual its ID, right? So we'll go ahead and copy that. We'll make our way back over to here. We're going to select this. We're going to paste this in here. And there we go. So now that should be set up. We'll do Terraform init. It says the directory has no, well, we got to cd into the correct directory. There we go. We'll say Terraform init again. Terraform has been successfully initialized, so that is good. What is next? I don't think we could do a Terraform apply, but let's try it anyway, because we don't have any credentials set up, right? So how is it going to know how to deploy? There we go. Attempted to load, but there are no credentials. And so there are a few different ways of getting credentials in. At least that's what I recall. Let's take a look here, over here, and see what it says. Okay, so how do I load Terraform credentials for GCP? We'll see what it comes up with. Actually, Terraform, getting information for that is the worst for Terraform, just because, again, it's documentation, lack of documentation, and this is due to GCP's fault for not providing it. But we'll go over to here, because generally what you can do is go check the provider information. Not over here, but we'll say Terraform provider GCP. We'll try this again. And we'll go over to here. And so it should be providers. And we go to GCP. And we go to documentation. And here it should tell us how to do it. Sometimes it's in the top part of this guide. And usually it's in this part here. But we're looking for that information for credentials. So where are you? It used to be right here. Or here. They do not. I just want to show you I'm not crazy. Like if you go over to other providers like AWS and documentation, the first thing they normally tell you is authentication configuration, right? Same thing with Azure. But we go over to GCP, you'd expect that to be there, but it's not. Which is fine. So we will try to leverage Claude to get help here today. So create a service account. Yes. Grant permissions. Download the key. Set the environment. Yeah, it is really that involved. Method 2, application default credentials recommended for local development. I mean, we're developing in a cloud environment. So maybe we can do this Google Auth login. It's usually hard to log in when you're in a cloud environment. We can try it. We don't have gcloud installed, so we might have to get that installed. Let's go over to here and see if we can even do that. Control-Shift-P, and it was dev containers. Okay, modify, gcloud. And so here we have gcloud CLI. What's the difference between these two? I don't know. So I guess I'll go with this one. It'd be nice if there was an official one. So we'll go ahead and hit OK. And I'm just going to go ahead and just, I don't want to really save all this stuff in here, so I need a git ignore for Terraform. So say git ignore Terraform. Usually GitHub will have one for us. Not exactly. So we'll take this one from Spacelift, they're okay. And we will go back over to here. I'll make a new git ignore just in this directory here, okay? Because I just want to say this before I do a rebuild. And, okay, we want to add that first. Update git ignore. Okay. And now if it wants to add any of these files, then it's fine, right? So, but I mean, TFRs is, I mean, that's not sensitive information, but it could be sensitive information. I don't want 1Password here. Let's close that out there. And so I'm going to go ahead and just say update. I think that's fine what we have in here. If it's not, we'll figure it out as we go. Let's go ahead and try this again. So Control-Shift-P. We want to, add to there, modify to there. We'll type in GCP or gcloud. CLI, install it. We'll hit OK. Keep defaults. and it's rebuild now. So we're going to rebuild that, and yep. So we'll have to do a full rebuild, I think. We'll be back in just a moment, okay? All right, we are back, and we should now have G-Cloud. Let's see if it's here. It is. Okay, so let's try a G-Cloud login. I think it's G-Cloud auth login. It's been a little while, but... And so here it's suggesting to follow a link. Once you finish this, we'll bring in the browser. So I'm going to just hold Control and click. It will say open, and maybe this will be really easy to connect. Sometimes it's not. Sometimes it's easy. And so here, yeah, it says we should have done that, right? We'll go ahead and copy this. It's totally fine. And I'm just going to paste that in there and hit enter. You are now logged in. So now we are in good shape. Your current project is none, so we can set it, but technically we have set it over here in our in this file here, so I'm not really worried about it. And this is not really a secret, so I'm not worried about that either. So let's go ahead and see if we can now deploy. It's defaulted to 24, so we should be in good shape here. So I'm going to type in Terraform apply. And it says no configuration found. Applies require configuration to be present. Applying without configuration would mark everything for destruction, which is normally not what you want to desire. If you would like to destroy everything, well, I'm not trying to destroy anything, but I'm not sure why. Oh, you know what? I'm not in the right folder. And we'll do Terraform init because we need to do this. Oh, Terraform should be here. Oh, you know what? You got to type it right for it to work. There we go. Terraform apply. I usually will abbreviate Terraform to TFs so I don't get it wrong. And here it's worried about credentials. We'll go over to here, take a look. Could not find default credentials. So we'll go ahead and grab this link here. See if this helps at all. Local developer environment. If you're using local shell, use your credentials. So I'm just trying to decide what's the easiest way to do this. I guess we could do G-Cloud init and see what happens. But I thought we're logged in, so I figured it would just work at this point. Let's go ahead and try this. No, see, we don't need... I'll hit 1. Yeah, because we're logged in, so I don't feel like we need to reinitialize any of this. Pick your project to use, so we'll do number 2 here. No, I don't care what zone it is. Okay, let's try this again. Okay. 1 second. Let's go take a look here. So I know sometimes we end up having to download a key to verify stuff, but it says the credentials field in the provider config expects a path to service account key, not the account credentials. If you want to authenticate with your user account, try omitting credentials and running G-Cloud application default login if Terraform doesn't find your credentials. I suppose we could try that. Explicitly advised against using application default login. This approach isn't recommended. Some APIs are not compatible with credentials obtained through G-Cloud. For almost all cases, whether you're deploying locally or in production applications, you should use service accounts rather than accounts or API keys. So they're insisting that we use service accounts, which is fine. I always forget how to do this in GCP, but we will stumble our way through it. And we'll just reject this. We don't care about that. And I think I've been running machines in the background here because we're going to launch up 24. So I want to get the ones that we have here out of the way. So I'm going to go ahead and we're just going to go and delete these, which is fine. And so what I'm going to do here is I'm going to make my way over to, what am I making my way over to? Service accounts. Service accounts, there we go. And so we have this developer one here for Compute Engine, but we'll go ahead and make a new service account. And again, I always forget how these work, so 1 second, let's look it up. Well, we did have the steps up here, right? Service account file key recommended. So here, description, display name. This is probably the easier way to do it, I suppose. So maybe we'll just completely skip this interface here and just go over to Cloud Shell. authorize, and let's see if that works. Once it decides to connect. So create service account. Yeah, that's what we want. So we'll go ahead. And it's set as this default project. Make sure you check what projects you're in as this is working. So we'll go ahead and hit enter. And so now we have a service account created. Let's go over to service account, see what it looks like. Is it in here? Well, at least we know we've created one, but where it is another question. Let's give this a hard refresh. Sometimes giving a hard refresh might help. There it is. Okay, great. So you can see it named it. So probably description display name. So we type, let's look down here, let's type in Terraform. Yeah, so it would have been whatever's in the prereq here. And so if we go back, yeah, so we would just put in Terraform SA and that would have done that. So now what's the next step? Probably to get the keys, grant it permissions, service account, instance admin, account user. Sure, I suppose we can do that. Is this too permissive? I don't know, seems fine to me. I mean, we do want to get access to compute, so that makes sense. And we probably do need access to IAM, so that also makes sense. So that is probably fine. So I'm going to grab these here because obviously you might not have these, as you might not want to have to copy and paste them in. So I'm going to go over to here into our README here. And we'll go ahead and we'll just do this. We'll bring that over. And I think these are fine. The only thing that's kind of annoying is that we have to replace our project ID here. So there's probably a environment variable set up, env grep project. So here they have Google Cloud Project ID like this. Right, so that is definitely a more convenient way to grab it. So I'm going to go ahead and grab that here. And I'm going to go back over to here. And I'm just going to swap this out because, again, I'm just trying to make this easier. Google Cloud Project. Okay, so in theory, this should, I don't like how long that name is, but I'm going to go ahead and copy this. I'm going to export it this one time. And we've already done this one, so let's see if we can run this one next. Hopefully it just works. Paste. Well, we're doing this in, hold on. We're not doing it here, we're doing it over here, right? Paste. It is not being cooperative here today. Right-click copy. Sometimes you got to do a lot of right-clicking. There we go. And that worked. Okay, good. Or it looks like it worked. We'll go ahead and copy this. We'll paste that in next. We'll hit enter. Okay, we have that. The next thing we need is our key. So we'll go and grab this. Okay. Now we actually need to download this into this machine here. We should be able to do it. So here, good thing I actually set that env here earlier. I'm not sure if I actually set that that one there. I think I just picked up the project inherently. Let's go ahead and see if we can just download in here because we are authorized over here, so it should just work. Please, please, please. It did or it didn't? Let's go refresh this. I can't tell. Let's go over to here. I don't see anything committed in here, so it makes me think. Maybe it did. Oh yeah, it went right here. So home code spaces Terraform key JSON. So it actually did download it. Is that where we want it to be? I don't know. So now that we have the key downloaded, Oh, yeah. Okay, and then we set it this way. That makes sense. Yep. So then it doesn't really matter where it goes as long as it goes to the place that we want. So download it to the home directory, which is fine. This is not obviously, well, actually will persist if we restart this machine, but this should, in theory, get us over that hump. So I'm going to go ahead and just say update. Okay, we'll sync those changes. Let's now go ahead. Whoops. Let's go now ahead and see if we can do a Terraform apply. All this work to get Terraform working. And has no file or directory. So it's suggesting that's not working. I'm going to see if I can cat this out. So it is there, right? But it might want the full path. So I'm going to do pwd. And, well, I'll do pwd on this here like that. That's not going to work. I thought that would expand it. Okay, so we'll do that. So it's home code spaces. So what I'm going to do, I'm just going to get rid of that. I don't know if this is the problem, but we'll go ahead and just take that out like this. And then we will paste it in like this. We will go back to our workspace directory. What a hard, all the other videos are not going to be this hard. It's just, this task just happens to be hard. Okay. We'll go ahead and hit enter here. And so now it's saying like, okay, yeah, we're going to set this up and these are all the instances that we're going to make. All right. And where are they going to deploy this? 24. So again, if you're not comfortable deploying 24, that's totally fine. I'm comfortable doing this. And the reason I'm doing this is because I want to see us hit that quota limit, all that roundabout stuff to do that. You might ask like, Andrew, why don't you go back and edit your videos and make it more straightforward? Because I think this is part of the learning process, showing this stuff. Some of them I actually do, but some of them I'm not going to go back and edit because, some of these things I see and I think that they should be included. So this is going to go ahead and deploy 24 instances, which is totally in our quota to do so. And we're going to find out here shortly, once it's done, if that's working there. But now we have Terraform set up because the way you deploy to GCP is with Terraform. There is a native solution for GCP, but nobody uses it. They use Terraform. So we'll give that a moment to finish, okay? All right, so it didn't take really long for that to spin up. Let's go take a look now over here in our quotas, which we've been keeping this diligently open this entire time. Let's give it a hard refresh. And let's see if we are at our max quota. They're at 100% utilization. So what would happen if we tipped that over just by 1? So I'm going to go back over to here, and I'm going to go into our, I think it's TFRs, and we want to change the number in here so it's a little bit larger. So I cannot remember, what is the variable name, but we will go find it here in just a moment. It is called, it's under variables. What am I doing? It's over here. So we have instance count. So we're going to go ahead and change this now to 25. And let's see how that takes. So we'll go ahead, we'll type in Terraform apply. Our expectation is this is going to fail, right? Because it can't add another instance. And we just want to see what kind of error we get. We could also do it through the console and find out. And we can do that for fun too. So it says error waiting, for instance, quota CPUs exceeded. So now we're seeing that information there. And that's totally fine. Let's go over to EC2 Compute Engine. Sorry, too many clouds for me. We'll go over to Compute Engine here, and we'll go ahead and launch a new instance. And my expectation is this is not going to work. So we'll go here, and I will just choose the micro as we're just trying to be cost effective. And my expectation is this will not launch. But again, we want to observe, we want to see what this looks like. This is how we get our experience by actually doing. And there we go. So we hover over and it says, no, you're not allowed to do this. So we've learned that if we want to increase that, there should be a quota increase somewhere. So let's go back to quotas. Okay. And so increase requests. So that has to obviously go somewhere. Increase request. Some things are at the organizational level. So now we're at our org level here. Okay, so give me a moment to find it. So here it's saying, in most cases, increased adjustments must be made at the project level. Limited number of products support organizational level quota changes. Okay, I thought it had been the organizational level. So go here. Okay, maybe we have to just click into it. All right, so wherever that was before, we're going to go back into name. We'll say instances. Instance. VM instances, maybe? Nope. And I think it's because now we're at the organizational level. Let's go back to our project level. And this one's now on top because I guess it's exacerbated. So we'll go into here. And so we're in here. Where do we increase the limit? Sure, checkbox it. Okay, well, we've hit the limit. Can we increase it? Maybe over here. Edit quota. And let's see if we can do. So it says here, enter new value. Above 24 will require approval for your service provider. Okay, so we'll go ahead and do 25. I am teaching GCP to students, and I'm showing them how to make a quota increase. Okay. Done. I guess we have summary there next. I'm not putting my phone number in. We'll go ahead and do that. And so here you can see whether they will take that increase or not. If they don't, I don't care. That's obviously for demonstrations. Let's make our way back over to here. We want to get rid of all these instances here. So I'm going to say Terraform destroy. You got to type it right if you want it to work. We'll give that a moment. So now it is working to destroy those. We're going to wait a little bit. But yeah, a long video for such a short thing, but I think it was worth our time. Here we just need a confirmation. Say yes. There it goes. We'll wait for those to destroy. All right, there we go. Our resources are destroyed, and I don't think there's anything sensitive in here. Do I want to be storing? No, TF state file. Like, do we want to store TF state files? I always forget. Do TF state files go in repo? I don't think they do. Yeah, because it can have sensitive information. You generally do not want to commit them. Yeah, and so what I'm going to do, just because this really shouldn't be in here, we'll go ahead and... The thing is that as long as we don't get rid of this environment, it's fine, but we should be managing our state somewhere, and we're simply not right now. And so I'm going to just ignore both these files here. There's nothing like sensitive in here that would cause any problems, but I'm going to go ahead just to git remove. I don't think I've committed them, but in case I have, we'll go ahead and just say git remove Terraform TF state. Okay, so maybe it hasn't been added, so that's fine. Okay, great. And so yeah, if you want to follow along there, but obviously that was very roundabout, but we will come back and use Terraform at some other point. So having this set up early on is going to be great for us. Ciao, ciao. Okay, so Google Cloud obviously has a lot of services, but how do you know what is available for your region or area? Well, one of the easiest ways to find out is going to cloud.google.com about/locations. If you scroll on down here, it's going to tell you products available by location. So, you know, if you're looking for something in particular, you can use this grid. I don't find this to be the easiest to work with, but I mean, like I'm in Canada, right? So I might go here and say, okay, well, I guess App Engine is not available here in Toronto, but it is available in Montreal. So if I want to utilize it, we can. They also have up here this region picker tool. So if you go over to here, it's really originally, I think, for carbon footprint. But if you're just trying to find, you know, a specific location, so maybe we see it, say Canada, right? it's telling you the next one that you should recommend it to. So if I'm in Canada, then it's saying, it'd be more efficient to use it here. I'm not sure why Montreal and Toronto would be third. It seems like that should be on top. But clicking through here, like if it's just not in the list, like we saw, what was it? App Engine's not available. So we click on this, and so we can see that there is no Toronto location. So that is another way to determine it. And sometimes the docs will tell you what locations it runs in. But this is not always a reliable way to do this. So if we were to switch to another product, so we go here and we go to Compute Engine, I'm not sure if it would have, the same option. So we go back over to here. So here we see locations under resources. Okay, so we'll go over to here in the docs. And notice like the UI, it's not even consistent. So you have to just kind of fish for it. But for the most part, if you need to find something, it's right here. Okay. But there you go. Let's take a look here at service counts. So service counts enable apps or virtual machines to secure access to Google Cloud resources without user involvement. So used by apps or virtual machines to authenticate with GCP services, acts as identity of a service with permissions controlling resource access, identified by a unique email address, not necessarily yours, but one that is created within Google Cloud. It eliminates direct user involvement in authentication. If you come from AWS, the way you do it over there, well, I guess for the most part, a lot of times AWS passes the permissions implicitly to a compute machine, right? But the closest equivalent would be creating a new user that doesn't have console access, that only has credentials like access keys, and you treat it as a machine user, right? But for whatever reason, Google likes to separate out as a separate service. Totally fine. But let's just walk through the three types of services, three types of service accounts. You have user managed. These are created manually by the user for custom apps or workloads. You control the naming and permissions. And what is key to remember here is the ending. So again, we said that they have unique emails, and this one's going to be .im. I've also seen developer. I'm not sure if it's for user managed ones, but it's going to vary based on use case. Then you have Google managed ones. These automatically are created by Google, and they're obviously for Google services. Some are visible for specific use cases. Others are hidden for backend system tasks. The names typically include service agent or service account. So here you will see system. Okay. So there'll be some variation here, but notice here it says service agent, right? So then you have the default ones created by GCP when you enable specific services like Compute Engine, App Engine, automatically granted project-wide editor role unless modified. And so here we can tell that it is for AppSpot as it is suggested there in the name. The whole purpose of service accounts is to generate out two keys for you. You have Google managed ones and user managed ones. If they're managed by Google, then they're fully handled by Google. The keys are rotated automatically. The private keys are secure and never accessible. And you use IAM APIs to perform signing operations. For user-managed service account keys, you, the user, are creating the key. You control the private key and are responsible for the security rotation, preventing loss of the private key. Public keys are stored by Google. Private keys are not retrievable by Google. If lost, the service account stops functioning. It stores these keys in Cloud KMS for enhanced security. Let's talk about permissions for service accounts. The service account permissions define who can use a service account and access resources via IAM policies. So this is where you're going to have service accounts that have IAM policies just like any other resource. So you have roles, and this is going to provide control access to your service account. Service account user role grants access at the project or service account level. Again, this is pretty straightforward. But users can impersonate service accounts to access resources. And I don't know if I have a slide for this, but that last part is that you can grant a user access to a service account, and that is what we talk about when we're saying impersonation, okay? Default service accounts get editor roles for basic tasks, and I think you can change that if you don't like that, okay? Then we have access scopes. These are the legacy methods for defining permissions for service accounts on Google Cloud. I don't think I really come across this very often. if ever now, but we'll mention it anyway. So you can assign a service account such as the default compute engine default service account to a VM and resource. Here you can see the access scope options. So we have all allow default access, allow full access to cloud APIs, set access for APIs. And again, it's the current best practice to use custom service accounts with IAM roles. Again, I do it the modern way, so I can't even remember if I ever see this. Let's talk about use of service accounts. Service accounts authenticate and authorize apps or services to access Google Cloud resources securely, either by attachment or impersonation. Let's take a look at the first example. So attached to resource. The service account is bound to a resource to allow the resource to act with permissions granted to the service account, similar to like how AWS will pass on permissions to virtual machines. And so that's reattached to resource. Then you have impersonation. So a user or another service impersonates the service account to perform actions on its behalf. This avoids the need to manage external keys. Similar to, again, AWS, temporary STS, service token, whatever. So same thing where you assume a role of another thing. This is just assuming a role if, again, you come from the AWS world. So let's talk about a few best practices. Use service account keys.list or logvira to audit service accounts and keys. Delete unused external keys. Grant only the minimum permissions needed for the service account. Create separate service accounts for each service with specific permissions. Use the IAM service account API for key rotation. So there you go. I mean, really all you got to remember is that service accounts creates keys, and that's how you're going to allow your apps to interact with GCP, but there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Cloud Billings Account, which is used to define who pays for a given set of Google Cloud resources and is connected to a Google Payments profile. So over here on the right-hand side, you can see that link. So projects are going to be going to your billing account, and then your billing account is linked to a payment profile. If you want to see that you can create multiple under a payment profile, you create multiple billing accounts. So here is just a single one, but it's very easy to create multiples. So billing account includes one or more billing contacts predefined in a payments profile. Billings can have sub-accounts for resellers, so you can bill resources to be paid by your customer. So let's compare the two so that we fully understand these two offerings, okay? So for Cloud Billing Account, it is a cloud-level resource managed in the Google Cloud Console, tracks all of the costs, charges, and usage credits incurred by the Google Cloud usage. A Cloud Billing Account can be linked to one or more projects. Projects usage is charged to the linked billing account, results in a single invoice per cloud billing account, operates in a single currency, defines who pays for a given set of resources, is connected to a Google Payments profile, which includes payment instructions defining how you pay for charges, has billing-specific roles and permissions to control accessing and modifying billing-related functions, so establish IAM. So on the payments profile side, we're over here now, it is a Google-level resource managed at payments.google.com, connects to all of your Google services such as Google Ads, Google Cloud, Phone service, processes payments for all Google services, not just Google Cloud, stores information like names, address, tax ID when required legally, or who is responsible for the profile, stores your various payment instruments, so credit cards, debit cards, bank accounts, other payment methods you'll be used to buy through Google in the past, functions as a document center where you can view invoices, payment history, and so on, controls who you can view and receive invoices of various cloud billing accounts and products. So hopefully that is clear. On the exam, they're not going to ask you to choose out of these at a lineup, so I wouldn't worry about that. It's just more for your benefit, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at billing account types. So there are two types of cloud billing accounts. We got self-serve or online accounts. Payment instrument is a credit or debit card, ACH direct debit. Depending on the availability in each country or region, costs are charged automatically to the payment instrument connected to the cloud billing account. You can sign up for self-serve accounts online. The documents generated for the self-serve account include statements, payment receipts, tax invoices that are accessible to Google Cloud Console. Then you have invoice or offline accounts. So payment instrument can be a check or wire transfer. Invoices are sent by mail or electronically. Invoices are also accessible in the Cloud Console. as are payment receipts. You must be eligible for invoice billing, and you can learn more about it somewhere in the documentation. So that's kind of interesting. I don't know. I don't remember seeing whether AWS or Azure had that, but it's cool that you can do that kind of offline method. For payment profile types, there's two as well. We got individual. So you're using your account for your own personal payments. If you register your payment profile as an individual, then you can only manage the profile. You won't be able to add or remove users or change permissions on the profile. And then we have business. You're paying on behalf of a business, organization, partnership, or educational institution. You use Google Payment Center to pay for Play apps, games, Google services like Google Ads, Google Cloud, Phone service. A business profile allows you to add other users to a Google Payment profile you manage so that more than one person can access or manage payment profiles. All users added to a business profile can see the payment information on that profile. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at charging cycles. So for self-serve cloud billing accounts, your Google Cloud costs are automatically charged in one of two ways. So you either have monthly billing, so costs are charged on a regular monthly cycle, or threshold billing. Costs are charged when your account has accrued a specific amount. For self-serve cloud billing accounts, your charging cycle is automatically assigned when you create the account. You do not get to choose your charging cycle, and you cannot change the charging cycle. For invoice cloud billing accounts, your typical receive one invoice per month, and the amount of time you have to pay your invoice. So your payment terms is determined by the agreement you made with Google. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at cloud billing IAM roles. So cloud billing lets you control which users have administrative and cost viewing permissions for specified resources by setting identity and access management, so IAM policies, on the resources. So to grant or limit access to cloud billing, you can set an IAM policy at the organizational level, the cloud billing account level, or the project level. Cloud billing roles in IAM include billing account creator. So this creates a new self-serve online billing accounts. Billing account administrator, manage billing accounts, but not be able to create them. Billing account user, so link projects to billing accounts. Billing account viewer, so view billing account cost information and transactions. Project billing manager, so link and unlink the project to and from a billing account. Billing account cost manager, so can view and export cost information of billing. In the documentation here, I've just pulled up one. This is for billings admin, and just shows you all the permissions that are possible. Okay, so this is basically a condensed list of all this information, all these descriptions and stuff. But if you want to have an idea of exactly what you have access to, you can see that there. Okay. Hey, this is Andrew Brown from Exam Pro, and we are looking at billing health checks and also budget alerts. So billing health checks are recommendations to avoid common billing issues. So within your billings overview, you'll see this billing health checks, and it'll either be red, like saying, look at these things, here are some ideas, and things that are good. And so if you click into that, you can see a full kind of checklist. The first recommendation is to go ahead and create a budget alert. So this allows you to make multiple alert thresholds to reduce spending, surprises, and unexpected cost overruns. Lots of great suggestions here, but let's take a look more detail at budget alerts. So you can narrow down the budget scope to specific projects or specific resources. You're going to go ahead and provide a value. So here I say $100. Notice that it draws a trend line, so you can see where your spend is currently at. And you can set multiple thresholds that preemptively warn you when you approach your budget limit. So here I'm saying $50, $90, $100. This is really nice because other cloud service providers, what they'll do is you'll just set a threshold to say a single threshold, which is like 20%. And if you wanted these incremented stuff, you'd have to make multiple budget alerts or plans or whatever you want to call them, the other CSPs, but it would cost you more money. Whereas this one, you can just do it all in one go, which is really nice. So notification options, so email alerts to billing admin users, link monitoring email notification channels to the budget, connect a pub subtopic to this account, this budget. So there you go. Hey, this is Andrew Brown from Exam Pro, and I just want to show you how would you get to all the cool billing features in Google Cloud Console. Well, you just go to Billing, in the drop down, and from there you're going to have a lot of options. But the ones that Google wants you to know, and you definitely need to know these for the exam, are the built-in billing reports. There's 4 that they have in mind. So there's billing reports, so an interactive pricing explorer including graph visualization, cost table reports, a tabular breakdown of the cost to analyze details of invoices, cost breakdown report, so at a glance waterfall overview of monthly charges and credit, pricing report, so access SKU prices for Google Cloud Services. Here they are. Just notice that they're not one-to-one in terms of naming, so that's why I highlighted these in black, so you could just see like cost table report is just called cost table, pricing report is just called pricing, things like that, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at the billing reports in greater detail here. So billing report is to view and analyze your Google Cloud usage costs using many selectable settings and filters. So configuring various views of cloud billing reports can help you answer questions like these. How is my current month's Google Cloud spending trending? What Google Cloud project cost the most last month? What Google Cloud service costs me the most? What are my forecasted future costs based on historical trends? How much am I spending by the region? What was the cost of resources with label X? And you can also have customized report views that are savable and shareable. So on the exam, they actually might ask you, like, okay, you want to do this, right? Which built-in report will let you do that? So you need to remember these, okay, and which they apply to, all right? Hey, this is Andrew Brown from Exam Pro, and we are looking at cost table reports. And a cost table report is to access and analyze the details of your invoices and statements. I know this image is really small, but down below it actually shows like kind of like a summary of costs, just like an invoice. So you can filter that out to understand those totals and things like that. So because your generated invoices and statement PDF only contains simplified summarized views of your costs, the cost table report is available to provide invoice or statement cost details such as the following, including project level cost details from your invoices and statements, including tax costs broken down out by project. Includes additional details you might need such as IDs, SKU IDs, project numbers. The report view is customizable and downloadable to a CSV. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at cost breakdown reports. So a cost breakdown report is an at-a-glance waterfall overview of your monthly costs and savings. So this report shows the following summarized view of monthly charges and credits, the combined cost of your monthly Google Cloud usage, on-demand rate calculated using non-discounted list prices, savings realized on your invoice due to negotiated price, if applicable for your Google Cloud billing account, savings earned on your invoice with usage-based credits broken down by credit type. Your invoice level charges such as tax and adjustments. So they call it a waterfall because it looks like a waterfall, but the idea is like this is just a much clearer view than using billing reports. Of course, you can get the same visualization with billing reports. It's just an easier visualization, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at pricing reports. So use the pricing table report to access SKU prices for Google Cloud services, including Google Cloud, Google Maps Platform, Google Workspace, as of the date the report is viewed. The report shows the following pricing information: displays SKU prices specific to the selected cloud billing account. If your cloud billing account has negotiated contract pricing, each SKU displays the list price, your contract price, and your effective discount. If an SKU is subject to tiered pricing, each pricing tier for an SKU is listed as a separate row. All the prices are shown in the currency of the selected billing account, and the report view is customizable and downloadable to the CSV for offline analysis. Hey, this is Andrew Brown from Exam Pro, and we are looking at what the Google Cloud Console is. And this is a portal that is a web-based unified console that provides an alternative to the command line tools. It allows you to build, manage, and monitor everything from simple web apps to complex cloud deployments. And so this is generally the main way you're going to be interacting with Google Cloud because it's the easiest way to do it. So the idea is that you have this hamburger menu. You can drop down and see all the possible services. You can also search for them. You can can organize different projects here and switch between them. And in the background here, what you can see me doing is I'm actually trying to launch a new compute engine virtual machine instance. You can also get notifications and things like that. But basically, everything you want to do is via the console, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look here at Cloud SDK. So SDK stands for Software Development Kit, and it is a collection of software development tools in one installable package. So you can use the Cloud SDK to pragmatically create, modify, delete, or interact with Google Cloud resources. And the SDK is offered in a variety of programming languages. So we got Java, Python, Node.js, Ruby, which is my favorite, Go, .NET, PHP. And so here's an example of us using the SDK with Ruby code. So we've installed the package as a Ruby gem. That's how we did it. And we're accessing BigQuery, and we're just iterating out that table. Okay. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Cloud CLI. So CLI stands for Command Line Interface, and what it allows you to do is process commands to a computer program in the form of lines of text. And operating systems implement a command line interface in a shell or a terminal. That's how you're going to interact with one. And so this is what it looks like to use the CLI. So once it's installed, what you'll do is write gcloud, and then whatever it is that you want to do. So in this case, we are you want to work with a compute engine. So we write compute for SSH into our instance. And so it's just as simple as that, okay? Hey, this is Andrew Brown from Exam Pro, and we're taking a look here at Cloud Shell, and this is a free online environment with a command line access for managing your infrastructure and an online code editor for cloud development. So the idea here is these are the two interfaces. They're very pretty similar, but the idea is you'll press this little button here. It will launch generally a shell, and if you want to switch over to the editor, you just press that. And here you can see this is basically a bash terminal. And this one here is a VS Code environment. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a deeper look here at App Engine. So App Engine is a platform as a service for your applications. You can quickly deploy and scale web applications without having to worry about the underlying infrastructure. And a great way of thinking of this is if you know Heroku, it's basically the Heroku of GCP. So the idea here is you can use your favorite programming language, whether it's Node.js, Java, Ruby, C#, Go, Python, or PHP. You can also bring your own language runtime, and you do that by creating a custom Docker container. So there is all our familiar logos just to kind of put home as to what you can use. It has powerful application diagnostics. You have cloud monitoring, cloud logging to monitor the health of your performance, cloud debugger and error reporting to diagnose and fix bugs quickly, application versioning, so easily create development, test, staging, and production environments, traffic splitting, so route incoming requests to different app versions, A to B tests, and do incremental feature rollouts. You have application security, so defining access rules with App Engine Firewall, and you can leverage managed SSL TLS certificates by default. So the idea is that you have all this infrastructure, and this is not even the full list, but all this stuff around your application that you would generally have to do yourself, but they do it all for you, okay? Now, there are two types of environments that you can launch with App Engine. You got flexible and standard. It's very, very, very important that you know the difference for the exam because they will have scenarios where you have to pick one or the other, okay? So you can simultaneously use both environments for your application. So it's not you have to use one or the other. It just depends on what kind of workload you're running. An App Engine is well suited to applications that are designed using microservice architecture. So splitting it down the line, let's talk about standard, and then we'll talk about flexible. So standard, I would describe as being serverless compute. So it starts in seconds. It's going to run in a sandbox, meaning that there's a like you don't have like you're not deploying a container. It's just you're uploading your code. Okay. It's designed for rapid scaling, so it can handle sudden spikes of traffic. It supports specific language versions, but it's not a custom runtime. So if you've ever deployed a serverless function where you're just like choose Ruby, that's the language you get of a particular version. Okay, you're not going to get that much flexibility around that. It can scale to 0 instances, so that's another characteristic of serverless compute. Its pricing is based on hours. You cannot use SSH to debug it, which is very common for serverless apps. There are no background processes. When we're looking at flexible, these are fully managed containers, so it starts in minutes. Runs with Docker containers on Compute Engine VMs, so that's what it's doing underneath. It's designed for predictable and consistent traffic. It supports generally any language version, or you can run a custom runtime. Must have at least one instance running. The pricing is based on vCPUs, memory, and disk. You can SSH to debug it, and you can have background processes. So just understand those two, and you'll be good for the exam, okay? Hey, this is Andrew Brown. In this video, we're going to learn how to use Cloud Run. So I'm going to go ahead to the top here and type in Cloud Run. Cloud Run allows you to deploy containers. Also, Serverless Functions version 2, because that uses Cloud Run. So it depends on what we want to do here. And I mean, obviously we want to deploy a container. Now, you could also connect a repository, and that actually might be probably the easiest way to do it. And you could set up Cloud Build to go ahead and build stuff, but we'll go ahead and try to deploy something maybe from Docker Hub. So here we can use a test sample container, and that's exactly what I'm looking for. This is the Hello World container, and well, this one specifically is for a Cloud Run, so I'm not exactly sure its contents, but I guess we'll find out as we run it. Let's choose a region, ideally Toronto, something near me. So we'll go ahead and drop that down. And we're going to have this endpoint that will be what we're able to access the app with. Here we have use IAM to authenticate incoming requests. We can do that. I just want to make this super easy. So I'm going to say allow unauthenticated invocations, which may disallow. I guess we could leave it alone, I suppose. Yeah, we'll leave it on required. I thought it'd be less work if we made it unauthenticated, but there might be more there. We could turn on identity aware proxy, which is not a bad idea if we had IAP enabled. That's where it would detect where you're connecting from and take into account HTTP data like your IP address, your location, your browser stuff, determine whether you should have access or not. We have billing down here, so we have request space or instance space. You know, so basically one sounds more serverless than the other, right? So I'm going to do with request based. So to do with that, we can set to auto scaling with a minimum amount of number of instances. I'd probably want to have one, right? So, for the minimum here. Then down below here, we have ingress. So allow traffic from your project, share VPCs or VPC control perimeter. That might be interesting to have if you want to do internal. But we're going to allow direct access from anywhere. Then down below here, we have our container configuration. So here we can see it's starting on port 8080. I think with Cloud Functions, it's very prescriptive of what port you have to be on. We're not going to worry about that. Over here, we could attach volumes. We have some network configuration. We have a little bit of security configuration. But you can see that, you know, there's some stuff that you can change here. I think that it already has, it has a built-in container command. So I'm going to let it do whatever it wants to do there. Then down below here, request timeout if it takes too long. Execution time will leave as default. So that seems fine to me, but obviously there are two options here that we can utilize. We're going to go ahead and create that. Obviously you can add SQL connections as well. And so we'll deploy this and see what happens. All right, so this is deployed. Let's go take a look and see if we can see our hello world. So here we have, your client does not have permission to get the URL. So that is going to be our challenge here, is the fact that we're trying to access it, but we technically are authenticated, so I'm not sure why that would be an issue because I'm logged in here. We do have a test up here, but so we want to send a payload to our workload. So that's not exactly that useful. Okay. Go over our security. Just a moment. All right, so since it requires authentication, what I'm thinking here is if we go to test, look down below here that it's putting the authorization header for us, because that was the trick that I'm trying to have here. And technically it's just generating out the command. Oh, if it can test in Cloud Shell, that would be really awesome. So we'll go ahead and do this and open that in Cloud Shell, as we will already have access to do what we need to do here. So we'll give it a moment here to open. Okay, and so let's paste it in. We'll go ahead and hit enter. And we get back Yeah, we get a backup page. So clearly it is working. So now my question is, can we update the permissions or security after the fact so that we can get in here? So here we have use IAM to authenticate incoming requests. So if we uncheck that, then there is no authentication. So Cloud Run services have stable and secure connections by default. So let's say you need to enable the API to use that. That's fine. So we'll go ahead and hit save here. And so now we don't have any authentication on. So it would make me think that anyone should have access now. So we give a refresh here. We're going to test that theory. We'll go ahead to this page, give it a refresh. So now anyone's able to see it, okay? So congratulations, you successfully deployed a container image to Cloud Run. This creates whatever. You can deploy any container to Cloud Run that listens to HTTP. And if we look up here, the protocol is HTTPS. What's next? Build and deploy quick start. Not necessarily want to do that, but we'll just go over here. And so there are other options here. So deploy a pre-built container. This might be useful if like there's a specific type of app we want to deploy. I really like Ruby. So if there's like a Ruby service one, that might work really well for me. So build and deploy a Ruby web app to Cloud Run. Yeah, this might be might be up my alley here. But I'm going to go back over to here, and we're going to go ahead and just tear down this. Okay, so yeah, not too hard to get that up and running. Okay, I believe that it is deleting. We deleted it, right? Yeah, it's gone, and I'll see you in the next one. Okay. Okay, now that we tested the or deployed the Hello World container application, I'm more interested in deploying a Ruby one. I know Ruby really well, so I could probably carry us through this here. Let's take a look at the instructions and what they're suggesting here. So gcloud init. So get your gcloud set up. Imagine we already have it set up and we are saying, okay, let's get access to cloud build. Cloud build would be for building out the image, which is fine. So here they're making a new directory. They're going to deploy a simple Sinatra app. This seems like something that is very doable for us to do. So what I'm going to do is I'm going to go over to GitHub here, and let's go deploy Sinatra app because I'm really good at Ruby, so this should be super easy for me. So go ahead and say GCP examples, and I got to put examproco in front of that, examproco. And here, what I'm going to do is press, go down here and launch this here. So I already have one set up. We do this earlier in the course. If you don't know how, go do that. Or just copy my dev container out here when you launch it, and then you'll get the same configurations, which will have Terraform installed and the Google Cloud. It's just a file over here, this one here. So if you bring that into your folder, you'll be in good shape here. Or you can just launch this repo too, right? And you'll be in good shape. So sometimes I find that you have to do a rebuild though. So if you type in gcloud and it's not there, you might need to just go up here and do a rebuild up here. But let's get authenticated. So we'll do gcloud auth login. I'm supposed to always say like no browser here or something, no device. This will be the first time I actually wrote it in for quite a while. And so you're authorizing the CLI without an access to web browser. Run the following command on a machine with a web browser, which is fine. Run the following command on a machine with a web browser. What? I don't understand. So I'm going to, I thought that would make more sense. I'm going to go ahead and just do this. Okay, and then I'm just going to right click and open here. And I'm going to authenticate. We'll say continue. And we'll say allow. And yeah, no launch browser. That's what I meant to get, not no browser. So I'm going to go ahead and copy that. I'm going to paste this in. I just right click to paste it in. And so now I'm authenticated. I'm going to add my project ID here, just so my life is a little bit easier. So we'll go over to here. We'll grab our project ID. We'll go back over to here. We'll paste that in. And so now that is set. Okay. We'll give it a moment here. So that is now set. What do we want to do? I was trying to do something earlier here, which was with Terraform. And get rid of this here. Just so that we're not making a mess of stuff. But I'm going to go over to here and we're going to make a new one. This will just be Google Cloud. Or sorry, Cloud Run. And we'll make a new folder in here. This will be Ruby app. And I'm going to cd into that directory. Okay, and I'm going to go ahead and make that file. So it'll just be main.rb. Could be called server.rb, depends on what they want it to be called. But if we go here, we'll copy the contents here like this. And we will go back over to here and paste it in. That's the gem file, so that's not actually right. So I'm going to go here and type in bundle init. I thought I was copying the Ruby code. This is actually the gem code. And so it actually goes into here. And that looks fine. I don't know if that's the latest or oldest, but it should be fine using Sinatra 3.1. And so this was actually the Ruby code. Go ahead and paste that in. So very simple Sinatra app. All it does is print hello world. We'll go over to here, and it's telling us to make a directory called hello world. I don't think that really matters. We will need to do a bundle install. So we'll go ahead and do bundle install. Let's make sure our application works. Right, while I'm working on this, let's do readme.md. So we have bundle install. And then we install deps. Start app. Probably the way to start the app. There's a few ways we can do it, but the way I'm probably going to do is just bundle exec main.rb or ruby.main.rb, and that should start it up. You have to put bundle exec in front of it so it knows to use those gems in those contexts. And so now it's started on port 8080. It's binding to 000. You need to bind to 000 if you want this to work. If it's not binding to 000, you're not going to see anything here. So I'm opening this up, making sure that it displays. And so our app works. You should check to make sure your apps work before you try to deploy them. Probably a good idea, right? So those steps are there. We're going to need a Docker file. 3.2 is fine. And so we're going to go back over to here. I'm going to make myself a new file called a Docker file. And we're going to go ahead and paste the contents in here. Now, it's going to be very specific about what it wants to bring over. Now, it's installing the user source app directory. I don't know if it matters, but we'll just follow with what it's saying. And it's just copying the app.rb. So it wants this to be an app.rb. So we'll go ahead and rename this to app.rb just to make our lives easier. I want to see if this Docker file works. So in here, I should be able to right click and launch the Docker file. If I can't, here we have a couple of these. We'll go ahead and grab the Docker extension. All right, we can also build it the slow and boring way, but if there's a way that we can just right click and do it, that'd be a lot nicer. So down below here, we have containers, but I want to right click this and build the image. So here we have build image. And here it's calling GCP examples latest to figure out a name. I'm actually going to call this like hello world. We'll just call it Ruby app. Ruby app. Okay, and that's going to build it. All it's doing here is running like Docker build. So the command is docker build. Docker build -t Ruby latest is all we would have to really write. So I'm going to go back over to my README here. This could be like build container. That'd be docker build -t Ruby app latest. I don't know if it needs the parentheses around it, but because there's a hyphen in there, maybe it does. So I'm going to do that just in case. It should pick up the Docker file here. See where they're specifying the file with -f, but if you run it in the current directory, it should build. And it's just going ahead and building this thing, and then we'll try to run it in just a moment. So let that build, okay? All right, so that image should be built now. If we go over to here, we now have that image over here. If we want to, well, we don't want to remove it, but we probably want to go ahead and run it. So the command is going to be like docker run. I don't, oops, sorry, it's noon. It always rings at noon, but I don't always remember the commands, but we will figure it out here in 2 seconds. It's not hard. So I'm going to cd into the Ruby app directory. 1 second here. The cloud run, Ruby app directory. We'll do docker run -t Ruby app latest. Let's see if that works. No, maybe run. We got to type the word run for it to work. And so we're just making sure that it still works. And now it's on port 8080. We go to our ports and we can see that port 8080 is open. Let's go ahead and open that up to the internet. So I'm going to hold control to right click. And so it's working, and now it's in a container. So not only do you want to make sure your app works, you want to make sure that it works within a container. Otherwise, you're going to have a bad time, right? So we're starting to get there. Let's go back over to here, and I'm just going to stop this from running. So we're going to need to place this container somewhere for it to work, right? So if we go back up to here for a moment, here it's suggesting we're going to use enable Cloud Run Admin API and Cloudmin Run Build API. So here it's suggesting for us to enable Cloud Build, and that's not a bad idea. So we'll go ahead and do that. Cloud Build will be used to build our images whenever we make changes, probably from that repo. So I'm going to go and try to find, here it is, try to find this here. And I think we're already authenticated into GCP. So I'm going to go ahead here and just do this. And so this should enable this. We can also just go through the APIs and type it in here and then find it, but we're just going to do it this way. And quick view required rules for Cloud Build service account. So hopefully I don't have to do anything additional. Cloud Build automatically uses the Compute Engine default account. By default, Cloud Build service account to build your source code. Unless you override this behavior for code build to build sources, whatever. So I think it's okay. So we wrote our code here. We didn't make a Docker file. That's not a bad idea. So we'll go ahead and do that. That just tells it what not to include. Let's go back over to here. We need a period in the front of it. We'll grab that contents. We'll dump it in here. We'll go back over to, I'm going to close this tab. It's driving me crazy. And we'll go to the next step here. So here we have gcloud run deploy source. So the idea is it's going to pick up the source there. When you're prompted for the service name, enter to accept the default name. Okay, so we'll go ahead and do this. If that just works, that'd be awesome. We'll go ahead and we'll make sure we're in the correct directory first. We probably go to another tab. We have so many tabs open here. Okay, and I'm going to go ahead and try this. Make sure you're in the Ruby app. We'll hit enter. And so the idea is that you pick it up. So it'll have the service name as that. That seems fine to me. And here it's asking us where we want to deploy. I'm in Canada, so I'm going to go with 30, which is Toronto. And here we could set that as our default, but that's fine. Deploying from a source requires an artifact to store the container. And do you want to name it this and have it there? Yes. If it does all the work, that's really nice because it's a headache pushing things to the artifact register on GCP. Allow unauthenticated? Yes, please. And so now it's going to go ahead and do the rest of the work for us. So let's see how this goes, okay? All right, so this is now deployed, and it'd be interesting to see if that just works. It does give us a URL right off the bat. I'm going to hold Control to click and open. If that works, yes, there we go. So we've deployed our own Ruby application. Now, something that would be really in production would be something that is hooked up to a database. So, I mean, we're kind of getting there to something really impressive. If I wanted to take this a bit farther, I would probably go ahead and, I would try to add the support for SQL. I'm just going to go click here. I just want to take a look at where that option is. I think it was down here where it says Cloud SQL connection. So here we could add connection. Allow this Cloud Run revision to connect to specific Cloud SQL instances. That would be a really cool thing to do. Now, what do I want to do with this? I don't know if I want to get rid of this. Let me decide 1 second. The reason I'm thinking about this is just because I might want to connect SQL to this. But maybe we'll leave that alone for some other time. I don't want to overcomplicate things here. So what I'm going to do is go back over to here, and we're just going to tear this down. We'll hit delete. And so that is going to tear that down. But yeah, we were able to deploy that pretty easily. What was the command we ran? It was just that, yeah. Wow. That was easy. So go ahead over to here. We'll update our README. Right, and so now we have that for another time. So Ruby app for gcloud. And if you want, you can delete the artifact out of the artifact registry. You just have to look for it in there, like artifact registry. Maybe registry, they have two. They have the container registry and the artifact registry. I can't remember which one's older or newer. I always forget, but here you can see that is there. So if you want to, you can delete that out there. I'm not going to because I might want to come back to this application and I'm going to leave it alone and I'll see you in the next one. Okay, ciao. All right, folks, we're continuing on with Cloud Run, but specifically with Cloud Functions. So I'm going to go to the Google Cloud page here. I'm going to type in Cloud Functions. And here we notice it says Cloud Run Functions, Cloud Run. It's basically the same thing, but we're going to write a function. I don't remember what options we have for functions here, but maybe like for languages, if there's Ruby, I'd love to do that. But let's go take a look here and see if they have some basic instructions for that, because that would be really, really nice. So here, this is for deploying a simple web service. Let's do a sample function. Because the console can be a lot of work to click through all that stuff. And so what I'm looking for, yeah, I'd rather do it via G-Cloud. But we'll take a look and we'll see how much work it is. So yeah, we do have one for Ruby. Excellent. So folks, you're using Ruby today. It's my favorite language. So let's go ahead and do that. I already have this open from last time. So we're going to go ahead and I'm going to go here and just say new folder. And this will be Ruby function. At this point, you should be familiar with this repo here at, this is at github.com/examproco GCP examples. And we're going to need to make a new file here. So we'll go ahead and make a new file. Whoops, not in there. But it was so darn easy to use Google Cloud Run. I don't even know why we would need functions, but you know, I guess there's less to manage. We'll go ahead and copy this. We'll paste this in here. Whoops. We'll paste this in here. And so what do we have? We are defining the functions framework. We're having to bring it in here. And notice the last thing is it's returning what you want to display. Okay. In Ruby, you don't need returns, but technically there's a return happening here. And we'll go ahead and paste it in. We'll take a look at some of the other ones, if just in case you are not familiar with Ruby. Let's take a look at what Python looks like. It looks very similar, but here they have the function there. For JavaScript, again, similar. Oh, they even have PHP. That's pretty cool. But let's go back over to Ruby. And I guess we're defining the route up here. But I guess we'll find out as we go through this. Or maybe I guess it's just the handler. So we're going to need a new gem file. We'll go back over to here. And I'm going to cd out of here. We'll cd into the Ruby function. And I'm going to do bundle init just to create that initial file. And you don't have to, but you could just make the file manually. But that's what I'm used to doing. We'll go ahead and paste that in. We'll do a bundle install. Okay, we'll make a readme.md here. So people have a little bit of information here. So the first step we want is just that bundle install. And notice that gem is called Functions Framework. Why doesn't they call it Google? I don't know, but that's totally fine. I mean, it is a Google project, right? So we go over here, we'll just say GitHub. It's most likely hosted on GitHub. Yep, I don't know, they don't put Google in the name. So down below here, we have our settings here. Ruby 3.4 is pretty new. I want to switch my region over here to North America. I don't know how to spell it, so what we'll do is maybe in here we can choose and find the exact value. We'll do this and we'll type in North America. Or, yeah, so it's North America, Northeast 2. I just don't want to type it wrong. I'm notorious for typing things wrong, so we'll go over to here and I'll edit that. And so we have this command. I'm going to copy this over. If it's that easy, I'm going to be pretty happy. Deploy function. Let's just say other providers require a little bit more work to get going. So we have allow unauthenticated. We're going to use Ruby 3.4 as the base image. And yeah, that's the handler saying what function should it call and its source. We'll go ahead and do this. Now, I already did gcloud auth login. We've done that so many times. You should know how to do that by now. We'll go ahead and hit enter here. And I'm hoping that this will just go deploy and work. We'll give it a moment here. Okay. Well, let's take a look here. We have an error. So it says is not ready and cannot serve traffic. The user provision container failed to start and listen on port defined provided by port 8080. Environment variable with the allocated timeout. This can happen when the container port is misconfigured. We didn't configure much, right? So I'm not sure what it's talking about, but we'll go take a look here and see what happened. It was almost super easy, but not quite. Run query, okay. So no information here. Did it even deploy? Let's go ahead and go to Cloud Run and take a look. We do have this here. It's not ready and cannot serve traffic. User provided container. The user provided container. Well, sure, but the container provided was the container that's a base image, right? Maybe it's out of date and the base image that it's suggesting is no longer available. I don't know. But we'll look at Google Cloud Run base images Ruby. Let's see if we can find that there. If we go over to here, I mean, 3.4 is not old, that's for certain. It's definitely newer. But here it says the base image is Google 22, Ruby 34. So, but here it just says 34, right? And then here is function endpoint. Let's go back over to here. Function is called hello get. The source is here. Yeah, what's wrong with this? I don't know. So we'll click back. You can't just follow instructions, eh? I'm gonna look into this 1 second, okay? So one thing I'm thinking is that it's using the base image of, well, it's using containers, right? Obviously. And so we are specifying the base image, which is Ruby 34. And I would think that would come from Docker Hub, right? And we could probably specify specifically that version if we wanted to, Ruby base image over here. We shouldn't have to do it this way, but we could be very specific and just say, hey, make sure you are absolutely using the Google Ruby one here. I'm not sure if that would help, right? Because this would probably go to Docker Hub, I would think. Like if we go to Docker Hub, like this. Because there's also an official one, right? So I'm not sure which one it's pulling. I'm going to delete this function and try deploying it again, okay? So we'll go back here, and I'm going to go delete this function. And we'll just try this one more time. Type in clear here. And we're going to copy this command, copy, and paste it in, and then hit enter. So it found the source, it's uploading the source. I don't know if it's putting in our container artifacts, but we can take a look here. So I would think it would just pull, right? So we'll go to artifact registry. Yeah, it's just the one there. Let's just check the container registry. I always get these two mixed up. One's newer than the other. I don't know which one's newer. I can't remember anymore. Here it says Cloud Run Source Deploy. That was 7 minutes ago. Okay. Ruby app, Ruby function. Ooh, that's confusing. But it looks like we have one here. Yeah, just now. So clearly it is using one. All the sizes are the same. It makes me think it's the same. We'll go back over to here and just wait, I guess, to see if it deploys. All right, so I wasn't able to figure out what the problem was, but you know, one thing we could do is we could try to download that container, because if that container is the problem, this one here, then maybe that would, by running it locally, we could find out if there's a problem. So what I'm going to do is I'm going to go ahead and try to download this, and this might fail, but we'll try anyway. So I'll do docker pull, and we'll pull that image. It says access deny to pull that image. Okay, so then how do I get this image? Can we pull these? Here it says full base image. The default and the full. Let's go over to here. So the images are here. And what's interesting, we're seeing a bunch of deprecations here, but it seems like this is the latest one. It says latest public current image. So let's click into here and see if we can get the name of wherever it is. So somewhere there should be Yeah, wait for us to pull it. Okay, so we have instructions here. So we would have to do this one first for sure. Okay. We'll say yes. And then I'll go back over to here and we will pull this next. Paste, enter. So now the idea is that we're pulling down this image, okay? The only thing is I don't know is that, like, even if we get this container running locally, is there any other sticking points that it needs in order to run this? Because I didn't really think about that. We'll go here. Can you test? Like, how would you run these locally? That's a good question. You know, Google Cloud run base images. Can you run them locally? Because that's what I would do. I download the container. I try to run it. Yes, you can run them base images. Okay, but you are an LLM. You do never tell me things that are right. So here it says Docker file, etc., etc. Test a Cloud Run service locally. That's what we want to do, right? So here we have port 8080 and then the image URL. So it's just saying that's all we have to do it. So that's, there's that. So that should be pretty darn easy. That's all we should need to do that. I'm going to go back over to here. And so now that image is downloaded. So we'll go over to our images here. Let's take a look at what we have. So we have this one here, which is a really long name. So hopefully, we'll do this here. We'll grab this here. And we have port 8080, which is fine. We can just go ahead and change this to port 8080. That's just mapping the port over. I don't know if we're running anything else. We could technically just map it 8080 to 8080, but we'll leave it alone. It seems like it wants us to have that in there. I'll just go back here because it's specifying quite a few things here, but we need to put the image here in the end. So I'll just do Docker images. And so this is the big long name. I'm going to copy the big long name here, and we're going to go ahead and paste it in like this. Though I'm not running US Central 1, but I don't think it really matters because the image should more or less be the same anywhere, unless the image is not available in certain places. And so we'll go ahead and we'll hit enter and we'll see if we can do that. No command specified. Okay, let's go back over to here. I suppose so. Docker run -e. Replace image URL with a reference to the container image, for example. I mean, I guess that makes sense if you're downloading an existing one, but I'm talking about like for functions, right? So that's actually not going to help us. Google Cloud Functions test locally containers. We'll say Google run functions. That's Firebase. That's not going to help us. So here we have somebody where they're trying to do this locally. And so we're just trying to find command for it. The Poetry, I believe, is for PHP. Is it not? Poetry? Give me a moment. So over here, I just clicked this one here. This is local functions development. So this might be useful. Cloud Functions supports several methods for running your applications outside of it. For Ruby, we already have that added, so that's less of an issue. Before running a function, you first need to specify both the type and the name of the function you want to run. We already have that done. Per language instruction, so we have that information here. The Ruby function framework lets you do this, okay. Bundle exec functions framework, Ruby, target. We can do that, but again, it's an issue with the actual container, right? Not necessarily this. So this is not going to help us. We'll go back over to here and we'll change this over to hello get. Right? Normally we specify your function name. Yeah, it's hello get. We'll go over to here. This just says app. So I'm going to assume that it just assumes that it's app. And we'll go up here and we'll take a look. So we have a bunch of stuff spitting about back at us. Logger was loaded for the standard library. You can add logger base64. Cannot load such file base64. Okay, I mean, we could add base64. I'm not sure why we need to add that there, but we'll go ahead and do that. Because at the very least, if we can get it working here, then that should maybe mitigate some of our problems. And I just added it there. I actually didn't do a rebundle install, but maybe that's fine. We'll go ahead and open that. And it works here, so maybe we were just missing this. Again, I'm not sure why that would be an issue here. So what I'm going to do is I guess I'll just go ahead and try to deploy this one more time. So what we'll do is go back over to our function. It would be nice if there was a way to, maybe there is, and I just don't know what I'm doing, but it would have been nice if there's a way to check the logs for that. So we go here, and I mean, there's logs right here. There is an error up here, maybe. Let's, can we pull this up? 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 We can open that up like that. And yeah, that's kind of a pain. So we'll go back over to here where we can actually see our logs. Not sure I can't see them elsewhere there. But maybe somewhere here is the answer. So let me just crawl through this very carefully and see if it matches to what we're looking at. Yeah, so carefully crawling through this, I'm not getting anything that's really helping me to determine the problem. So what I'm going to do is go ahead and delete this function, and we'll deploy it again. I mean, we added that to our gem file. Our gem file should be part of our deployment. And so I would assume that that script took that into account when we deployed this, that's something that we would need. So we'll go ahead and we'll try this again. And we will do that again. I'm assuming the other one has finished. I'm not sure if that copied correctly. We'll try that one more time. Copy. And we'll paste that in again here. We'll hit enter. And we'll try to deploy one more time. If this doesn't work, we'll give up. But at the very least, you can see that we are debugging the logs. We're trying to figure it out. If Google's tutorial does not work, then it's not worth our time, at least not in the Ruby version. But it really should work everywhere, right? But here, you know, like, I don't know, like, does that framework actually use the underlying environments, or is it just using the local environment? Because that's another factor. But we will try this again and see what happens, okay? Okay, and we're not getting any error now, so this makes me think that it's deployed, and really adding that one single thing to that file made it work. So there you go. That's really bizarre, but you know, Google not having up-to-date tutorials is nothing new to me here. I wonder if there's a way that I could send feedback here. Yeah, I'll go ahead and do that. So we'll go here, this page, documentation feedback, Cloud Run, documentation feedback, this page. For the Ruby example, you need to include gem base64. Otherwise, it will error out. Okay. So go ahead. Good. And I hope they fix that, but there you go. We were able to deploy a function. I'm going to go here and just tear that down now that I'm done with it. So yeah, it's easy when the instructions are right. Anyway, ciao, ciao. Cloud SQL is a relational managed database service for MySQL, Postgres, and SQL Server with replication support. It has automatic failover with read replicas. It has point-in-time recovery for restores, automatic scaling storage for up to 30 terabytes with SSD or HDD. We have data encryption at rest and in transit. It has simple pricing for CPU, memory, storage, and traffic. This one requires the most level of management out of all the providers, such as Spanner and AlloDB, but it is very cost effective. A Cloud SQL instance is a virtual machine on Google Cloud that runs your database. You can connect to the database using a static IP address. It provides a consistent endpoint for the application to access the Cloud SQL instance. A high availability standby virtual machine in another zone to take over if the original VM fails can be added, I suppose. The database is the core service, so that could be MySQL, Postgres, or SQL servers. We have it can store the database with durability and scalability via a persistent disk, or I suppose a hyperdisk, as hyperdisk is preferred these days. It has logging and monitoring built in, so you can track its performance, and it supports operational tasks. So there you Hey, this is Andrew. In this video, let's take a look at Cloud SQL. So Cloud SQL is a way of deploying managed SQL databases. There's also Spanner, which is SQL-like or SQL compatible, and that's fully managed. But Cloud SQL is just your usual databases here. There are different ones that we can deploy. We have MySQL, Postgres, etc. I personally like Postgres, so that is normally what I would like to deploy here. And you can see right away that we have some options where we can go here and just start spinning one up here. Let's go ahead and walk through the steps ourselves so that we know what we're doing. Very simple choices here. Down below we have AlloyDB for Postgres. And this is also a really good option. But we are going to take a look at Postgres first and ignore MySQL. No one who's using MySQL anymore. So we have a couple options here. We have Enterprise Plus or Enterprise. It should tell us the cost here down below. And it doesn't because we don't have everything chosen. So I'm not trying to spend a lot of money. So let's just do normal enterprise. We are going to use the development preset, and we have 30 total without usage discount, 30 cents. I don't think it's that cheap, but whatever, that's fine. As long as it's not costing me a lot of money. And so the latest version is Postgres SQL 17. We're going to call this my PSQL server. The password, it's going to be pretty finicky. So I suppose we'll let it generate a new one here. I'm going to copy it out and just dump it here. Nope, didn't copy. Let's go back over to here and show it. I'm going to go right click copy. And I'm just pasting here, right click paste. So we're just holding on to that password for a little bit so we don't have to figure it out. I don't like complex passwords when showing stuff here, but they do have the generate button, so why not? There's obviously a password policy that you can enforce here. I'm going to go to Toronto, as that's where I like to deploy things, assuming it's available. It's all about availability. We are looking for North America, Northeast 2. Single zone is fine for me. If you want more availability, you can go ahead and do that yourself. Customize your instance. So let's go down below here and take a look. So here we could choose our machine image. I will use shared. I want this to be cheap. I think that these presets were already set here, and so maybe the cost might have gone up. But I just want to go through here and show you how to make it really cheap if you're not using the presets there. So we're going shared core. We're going really small here. For our storage options here, HDD is even cheaper. I don't need a lot. We'll do 10 gigabytes. For connections, we have public and private. I'm going to want to connect to this publicly, so we'll have that as an IP address here. You can specify CIDR ranges. That's fine as well. We're going to leave that alone. Google Cloud Service Authorization allow Google Cloud Services like BigQuery to access data. We might want to do that later on. For security, we're going to leave it so that Google manages it. For data protection, I'm turning off backups. Again, we're doing this just for to demo, right? I don't want it to prevent instance deletion. That might get annoying. I don't want to retain anything right now. Let's go to maintenance. We'll just say any. It doesn't really matter because we're going to just connect to this and delete it afterwards. Query insights. Helps you detect and diagnose performance issues. That can be really useful, but I'm not turning that on here today. And we'll go ahead and take a look. And so we really have this, this is hourly cost estimator, so it's not showing us the monthly cost. Okay, and we'll go ahead and create that instance. And so instantly we're over here, and it's saying the instance is being updated. So I don't believe that it is ready. If we go over to SQL here for instances, we have the status here, and it says instance is being updated. So we're going to wait till I think that this icon changes, and it's just a solid green one. Could be wrong, but we'll wait here a little bit, okay? All right, our Postgres server is apparently ready. We'll want to go ahead and connect to it. Just to make it really clear where to find that, I'm going to go here to SQL. All right, so I'm just kind of backing out and making this a little bit easier. We're going to click into here. On the left-hand side, we have connections. And so we're starting to get connection information. So this looks like a connection. It's just a connection. Yeah, it's just a connection name. It kind of looked like a connection endpoint, but I wasn't exactly sure there, but now I am. So it has a public IP address, so technically it should be accessible. Just taking a look here. Yeah, so I think it should work. So we're going to need some way to connect to this, and I do have this environment here, but I'm not sure if I have that set up. An easy way to connect to a database is using Table Plus. This is one piece of software you can use. It has a free tier. I've been using it for years, and it's fine. So we'll go ahead and open that up. And if I don't have it installed, do I not have Table Plus installed? Well, look at that. I don't have it installed. So we're going to go ahead and install Table Plus. There's probably like free ones also within extensions, but this one just happens to work easily. So we'll go ahead and do that. And hopefully that works without problems for us. So I'm just going to go ahead and get this set up here. Okay. I'll be back in just a moment. All right, so let's go ahead and launch Table Plus. And so now we are here in Table Plus. It can take a connection URL, but I think it depends if you're on Mac or Windows. So we're going to make a connection here, and I want to make a connection to a Postgres database. So you can see it supports quite a few things. And so this will just be my, or like SQL Cloud GCP. And so we're going to need to start grabbing information and putting it in here. So obviously one thing is the password. So I'm going to go grab that before I lose it. As I place it in a very precarious location, we're going to put the password right there. The next thing is the name of our connection name. So here, so really that's the whole name. I keep thinking that this is the host, but we'll go ahead and copy this. And I'm going to paste that here. I'm trying to think, what did we set as the username? I mean, I don't remember setting any username, so over here, I guess we'd have to set up users, right? So here we have Postgres, and there is no password set to it. Well, wouldn't the password be the password we set for the database? It would be, right? So I'm going to go ahead here and copy the Postgres user. You're normally supposed to create an additional user and log in, but it's totally fine if we don't do that. We'll go to databases because you can have multiple databases within here. The only database that's in here is the default database. I like how we have the options to create stuff here, and we can try that in a moment. And so we're basically logging in as the most permissive user that we can here. And so we'll go ahead and test this connection. So this driver error, unknown error. Well, that doesn't really help me too much. And we'll give it the port 5432. We'll test it again. So I'm not exactly sure as to why. It's not really giving us a whole lot of information. So if that doesn't work, let's go ahead over here. Normally it's easier than that. We'll go over to connections and we'll go to test connectivity. And I don't know if this is too much work. No, I think it's connectivity to the database, so it's not really what we want. But we have a public IP address. Connection name. There is also a public IP address. I'm going to go ahead here and provide that there. That might actually make more sense. And we'll test that. I'm so used to there being a host name, and so maybe I just was a little bit too eager to do that there. And so I don't see anything coming back from our test, so I'm not sure if it worked or not. We'll go ahead and maybe save this, because maybe it did work. Here it's specifying that this is local. It's technically not local. It's unknown driver error. We'll just ignore that for a second. We're going to go to production here. We'll test that again. 5432, that standard port, passwords in here, database is in here, Postgres is our user. We'll go ahead and hit connect. Did this connect? It didn't error out. And we don't see anything here. So what I'll do, unknown driver error. I'm not sure about that. But what we'll do is we'll go ahead and make a new database. We'll just call this tasks. Okay. You cannot create a database since there's a pending operation. Oh yeah, okay. So now we have our tasks. And I'm going to go back over to here and let's see if we can refresh or see more information here. So I'll just close that out. I'm going to edit this. We're going to choose the database as tasks. And we'll now connect to that. Okay. And yeah, it looks like it's not really establishing connection. So I don't think that is, I don't think that's working. So just give me a second here. I'm going to try to figure out how we can get connected to this. So if our external connection is not working for whatever reason, I know on the overview page, we also have this option here. I think it populates this so we can actually log in. Let's see if we can get in this way. The other thing is, like, does our firewall rules allow folks to connect to it, and do firewall rules apply there? I'm not sure. So we have gcloud SQL connect MySQL server, Postgres quiet. We'll go ahead and hit enter. And here it says the SQL admin API is not being used before or it is disabled. So that could be maybe part of the reason as to why we're not able to access it. So here, what I'm going to do is we'll type in, let's see if we can get the API this way. We'll try this. Okay, so we'll go ahead and activate that. Okay, so that's now activated. You could, obviously, there's lots of ways to enable permissions, and that's just the way we did it here. So we'll go ahead and we'll try this again. And so now say allowing your IP for incoming connection for 5 minutes, working. And it's thinking. We'll give it a moment there to think. It is progressing now, connecting database with the SQL password. Oh, so we need to provide the password, which is a bit of a headache, but we'll go ahead and copy this. We'll go back over to here, and I'm going to go ahead and paste it in. I'm going to hit, oops. I'm going to go ahead and hit enter here. It should have been pasted in, and so now we're connected to the database. And if we list all databases here, or was it LS? DLS? That was LS for list databases. It's been a while, so list all databases, Postgres. It's a \L, right? Yeah, it's \L. But the point is that we are connected to this database here. But maybe we can connect to the other database. So we'll do \C and then just say tasks. And so this one needs a password. Okay. We'll go back over to here. Good thing I kept my stuff over here. We'll paste and hit enter. So now we're on the task database. I'm just copying and pasting that password each time. So if we wanted to, let's say, create a table in here, I'm just going to go to Claude here and just say, like, create me SQL to create a tasks table and 3 records for Postgres. We'll go ahead and do that. We just get some quick SQL here, so we don't have to write it. There we go. I don't know if we need indexes and all that other stuff, but I guess we'll go ahead and just paste it in. I'm not sure if it'll take all of them in one go, but we'll find out here in just a moment. Okay, you obviously have to find this stuff yourself. So now I'll just say describe. So now we have a task table. We say select all from tasks. And so we can see inside of it. I would like to externally connect, but there's obviously some other thing going on here that's going to allow us permissions. I want to go take a look at our firewall rules. I'm not sure if firewall rules apply here to our VPCs, or sorry, our SQL databases, because I don't see anything open here. So let's go back over to SQL Cloud. And let's just take a look at our networking settings, because maybe something had to be open. So what I'm looking for here is something to do with networking. You can also read the docs here if we want to find another way to connect. And whoop, I didn't even know about this. Log into your database. Oh, wow. Okay. Well, that would be fun. Built-in database. Sure. Let's try this. This is wasn't what I was looking for, but it looks like this is an easier interface to interact with it. I don't think I've actually ever used this before. Oh, cool. There we go. Well, why were we doing it the hard way when we could just access our database this way the entire time? Gemini Code Assist can help us write code. That sounds fun. So here I can say like, create 20 more records for me to insert into the tasks table. And we'll generate that out. Cool. SQL is a query language and not a data generation tool. Well, yeah, you can. That's not very useful. Okay, but sure you can. Create me. So that's kind of annoying. Let's go here and just like, can you create me 20 records of data, not in SQL, just in text. Let's go ahead and see that. Because what I want to see is if that tool will actually write it for us. Okay, I don't know if I can take all of it, so I'll just take the first 4. And we'll go back over to here. And we'll say, turn this into inserts for tasks. Can it do this? I mean, it definitely did that. So fix login page to resolve. We'll go back over to here. See if any of that maps up. It does, so we'll go ahead and try that and run it. There we go, so we just inserted, that's cool. And I mean, all that really is just an editor. I'm not sure if they have a preview mode. That'd be really, really nice. I don't think it does. Maybe we can go here, let's see. No, but it'd be nice to be able to see the data, right? So like here we can go in and we can see that structure. At least I don't know how to do it, so that's totally fine. But anyway, my goal really was how do we externally connect to it? Because if we're working with an application, you're gonna need to know how to do that, right? Now, maybe this is less of an issue. Maybe when you're on the internal network, it's easier, but the idea that it has a public-facing IP address made me think that it would be able to handle that there. So just give me a second, okay? All right, for those who don't know, I've actually recorded this before in the Digital Cloud Leader. So it shows it's been a little while since I've done it. And so it looks like the way I did it last time is I went and I edited it because there were settings under the network. This interface is a little bit different, but under security, there was a way to authorize networks. Maybe it was under connections here. So it says, you can specify a CIDR range to allow IP addresses in those ranges to access it. And so what I'm doing here is I'm adding a network and I just say my home network. Or here we could say from anywhere. So I could say 0.0.0.0/32. That's obviously not what you want to do. You probably look up your own IP address and we could do that. Say, what's my IP address? Here. And waiting for the IPv4. There we go. So I'm going to grab this IPv4 address. We'll go back over to here. And I'll just do this and say /32. It wouldn't be 0.0.0/32. That makes no sense. To be 0.0.0/0 for everywhere. For everywhere, we'll say my home network. And so this will allow us to establish that connection. And we'll go ahead and save that. And then we'll go and try Table Plus again once it's updating. Notice that we have this symbol here, so it can look like it's ready, but it's not. And so if you go to connections here, it's showing you that it's still updating. So we'll wait for that to finish updating, okay? All right, our server is updated. And so now we've added that to the network. We're gonna go back over to Table Plus. And I think we already have most of our connection information in there. And now we're able to connect instantly, no problem there. So yeah, it's interesting. The last time I did it, exact same problem, forgot that setting. But yeah, there you go. So we are done here. So we'll go ahead and tear down the server. Okay, and we'll say my PSQL server. I don't need a backup. We'll go ahead and delete that. And I'll see you in the next one, okay? Ciao. Let's take a look at Spanner. So Cloud Spanner is a fully managed relational database service that is both strongly consistent and horizontally scalable. Its key features is that it ensures data is instantly replicated across all regions using Google's atomic clock system called TrueTime. Supports globally consistent reads and distributed transactions across regions, automatically manages replication, sharding, and performance optimizations based on data size and load, provides synchronous data replication across independent zones for fault tolerance. When I first used Spanner, there was only one flavor of SQL. It was some SQL, like Google's own SQL flavor. Now they have Postgres support or Postgres compatible support, which seems very similar to AlloyDB, except AlloyDB literally works perfectly with Postgres, whereas this one's Postgres-esque, but doesn't always work as expected. So I was very frustrated using Postgres utilizing with Spanner. But again, Spanner is what it is. It's pretty good. Let's take a look at its architecture. So data is in a regional instance. It is distributed across multiple zones for fault tolerance. For each zone has compute nodes for query processing and data management. Compute handles queries, ensures strong consistency using Google's TrueTime, stores data in a distributed way and durable way replicated across zones. Spanner synchronously replicates data across zones while automatically scaling compute and storage based on demand. Okay. Hey, this is Andrew. In this video, we're going to take a look at Spanner. Spanner is a relational database. Well, technically it's NoSQL, but it allows you to use SQL Google flavor or Postgres. And underneath it can do graphing, vector, full text search, but it really depends on what kind of version you start up here. Your screen might look a little bit different. I can't set mine back to the original screen where it says like 90 days to whatever. So it'll look a little bit different, but just proceed to fill in the two items and hit enter next. Here, I'm going to choose standard. If you compare the additions, if you are in Enterprise or Enterprise Plus, you're getting additional functionality. I'm trying to keep this cost effective, so we're staying with standard, and we're not really using that additional functionality. We'll go here to the next one. I'm going to say my instance, and here this will be, we'll leave it as the same. That's totally fine. I'm choosing regional. I'm going to launch mine here in Toronto. I'm going to go to the next thing here, continue. I'm choosing one node. I'm turning off backups here. And notice the cost is $1 an hour. If you're not comfortable running this, totally just watch here. But it's not a cheap service because it is a fully managed service. So we're going to need to create our database. We have a couple options where we have Postgres and Google SQL. Every time I use Postgres, it doesn't actually work. And then Google SQL is a big pain in the butt. So just understand that this might be a bit of a struggle. We'll probably use Claude to help us write it and work through this here, but we'll do our best that we can here. Let's say we're making a to-do app. I'm going to go over to here to Claude. And before we do that, we'll just actually create our table. So if we go here, we can create a table, right? And I just want a to-do table. So I'll go over here and say, using, what is it called? Google Standard SQL. Create me a table for a to-do app. So so we'll see what it does. And hopefully it just works. That's a lot of data. Okay, it just never seems to listen. Keep it simple. Always overdoes it here, but we'll try to get something really, really easy here. Because we can fill this out, but it'd be a little bit nicer if it just does that. Excellent. I don't know if the timestamp's going to work, but I guess we'll find out as we work through this here. So I'm going to go ahead and copy this and hit enter. And hopefully it just works. And it's having a problem with the timestamp one. So I think it's because it can't handle the timestamp. So we'll go ahead and we'll just remove this one here. Okay, and then we'll just try this. And so we're having some issues here. We'll go back over here. Again, it's really not worth your time to try to learn this unless you're going to do it for real. And I'd rather just kind of fiddle with this until it works. Okay, no created at timestamp. Just get that out of there. We'll keep it nice and simple. There we go. And we'll try this one more time. But yeah, working with this programmatically is a headache, but it scales and it works really, really well beyond that. So you have to make your trade-off there. Here it says the update failed. That might be just old failures. Let's go over here and see if we have a table. We do. Great. So we'll say, give me inserts now for the data. 10 records. And there is Google Gemini here, but it's notoriously bad. So there's no point in even trying to use it. This is the 6th time I've done this lab. So I'm telling you for certain, I'm not even going to bother trying to use Gemini there to generate it out. It's nice. It's like a nice idea, but if it doesn't work, it doesn't work, right? So we'll go ahead and do this. And so now we have 10 rows inserted. So the question is, how are we going to connect to our database? This is a little bit different because, with SQL, like a Postgres database or something, you establish a connection. With this, we actually have to use the API or SDK. What I'm going to do is go over to GitHub here. And I'm going to see if we can establish a connection. Well, here's a question, is that if we use Spanner, can we connect to something that is... Can we connect to something that is not within our VPC? Because I feel like, because it's such a robust service, it probably have some restrictions on how we can connect to it. But just give me a moment, okay? So I just found the Spanner client libraries. I really like Ruby, so I probably would utilize that to get it working. The question still is that even if we do get it working, is that going to be enough, right? So if I want to see how this works, I'm going to have to look up this gem because they're not really providing a whole lot of it. Well, here it is. There's the information. Okay, so require Spanner, project ID, information here, and there's the connection. So that does look really straightforward, but I still don't know if we're going to be able to establish a connection. I just kind of expect something else to go wrong here. But we'll go ahead to our repository that we've been working with, the GCP examples. I believe here I already have one running here. If you don't know how this works, go check our earlier videos in the course. I mentioned it multiple times, so we're going to go ahead and open up. Oops, I don't want this opening in Visual Studio. I opened up the wrong tab here. I meant to open this up in the browser. And so this is going to open up GitHub Codespaces. We will connect to Google using gcloud auth login once this is here. Give this just a moment here. gcloud auth login. gcloud auth login. This is already installed because I have a dev container here. Okay, so if you don't know, watch earlier videos. So here I'm going to hold control and click here to open this up in another tab. And then I'll go ahead and authenticate here. I'm going to assume that we need to do this to connect. So if we need additional permissions, we'll figure it out as we go here. So we can go ahead and paste that in there. And I'm going to go ahead and set the project while I'm here. So we'll go over to here, and I'm going to set this to my GCP playground. And I'll paste that in here like that. There we go. So now our project is set. I'm going to go over here and make a new folder for Spanner. And this is just because we're creating an app. So I'm going to go here and just call it main.rb. Ruby's already installed on here, so it'll make our lives really, really easy. I'm going to initialize a bundler file or a gem file. And that will allow us to import that information. So if we go up to here, we'll take a look and grab that. Just so you know, these instructions that are on here don't always work. So if it doesn't work, that's totally fine. We'll just work around it. But I'm a really good developer, so I think we'll be able to resolve any issues that we have here. If it's networking, then it'll be a bit more of a pain, but if it's development side, it should be fine. So we'll scroll on down back to, this is old stuff here. We'll go down here. I'm going to grab all of this here. I don't think we need to do application default login, but we'll see what happens. I'm going to go ahead and copy this over here. And we're going to paste it in here as such. So here, it's not connecting to a specific, well, it's interesting because I called it my instance. Our database is called to-do. And we probably would want to select all from tasks. We say select all from tasks. And if that works, that'd be really, really nice. We have a project ID already set here, but I guess we'll grab it again. So we'll just grab that value one more time. We're going to go back over to here. I'm just going to hard code it in. If you can, don't try to hard code these values. It's not going to hurt anything, but we have that set up. And so now I want to see if this code works. If it just works, that'd be really, really great. So we have bundle exec Ruby main. And we're going to scroll up here and see what we get. So it says your credentials were not found. So to set up, use application default. So we did have to do that. Okay. So we'll go back over to here and we will do gcloud auth application default login. So we'll go ahead and paste that in. I'm going to click through here again, continue, and we'll copy that. I think if I right click, it'll just put it in there. We'll hit enter. So now it says was added to ADC, which can be used with Google Client Libraries building quota. Excellent. Okay. So now what we'll do is go ahead and run this and see what happens. And hopefully it just works. No, what is our problem? So here, table not found called tasks. Let's go back over there and make sure we even have a table called that. So we'll just click out of here. We go to Spanner. Oh, our table's called to-dos. Well, then what's our database called? Is our table called to-dos and our table's called to-dos as well? Oh, it is. Okay, that's fine. It's not a big deal. I thought it was called tasks. So we'll go here. First of all, the database is called to-dos. And I think, well, hold on. We'll go back one more time and check. To-dos. Yep, to-dos. Okay, fine. I apologize for that mistake. Okay, so we'll go, whoops, that's not it. We'll go do this and we'll try this again. We have a new error. Now what is our problem? Database not found. So instances, my instance, etc. Let's go back and take a look to our overview. Our database is called to-dos. Our instance is called my instance. Oh, the database name is to-do. Okay, so the table is to-dos and the database is to-do. That's so darn confusing. That's my fault though, of course. We'll go ahead and try this one more time. And there we go. So now we're able to interact with our Spanner database. So there's more to Spanner, of course, but that's the easiest way to get started with it. I'm going to go spin down this instance, and if we need to do more with it, of course, we will just make a new instance, okay? So we'll click into here, and we will delete this instance. Good. I'll go ahead and commit this code. And I'll see you in the next one. Ciao. Hey, it's Andrew Brown. In this video, we're going to take a look at Firestore, not to be confused with Firebase. So Firestore is a MongoDB compatible database, and I don't know, it's really good for real-time stuff. I know that for certain. Let's go ahead and create ourselves a new Firestore database. And so we have standard or enterprise edition. Of course, we want to keep things cost effective, so we're going to stick with standard edition. It says database ID is default here, and it's a permanent choice. I guess I don't care, but I probably want to change that. So we'll just call this to-dos. And then down below we have Firestore native or Firestore with data store compatibility. Today I just want to use Firestore native, which seems fine. Enables Firestore native server-side web and SDK. That sounds good to me. Allow anyone to view, edit, delete all data for the next 30 days. Deny all reads and writes by default. These rules apply for access controls. It sounds like restrictive is better. I mean, open sounds really easy and fun, but we'll stick with restrictive for now. And I don't need multi-region, so we'll just do a region, and we'll launch this in North America, Toronto. We'll go ahead and create the database. And we'll give that a moment to create, okay? All right, so what we're going to do is go ahead and create a collection. This is pretty standard for MongoDB, right? So here we're calling it tasks, and we can insert our first document. And I don't know where that came from. I guess it's just auto-assigned, assigned automatically. Hold on here. We'll try that again. Yeah, do we add another one? Does it just automatically do that? Okay, sure, why not? And so I'm going to have our name. It'll be like, create Firestore database. And we'll have completed. Do we have a Boolean? We do. And I'll just set this to false. We'll go ahead and save that. And so now we have our first record. We'll go ahead and add another one. And again, it's just autofilling it. So this will be our next task. Because it's MongoDB or MongoDB-like, the idea is you can add as many fields as you want, and they don't have to be the same, right? So here, this will be completed again, right? This will be populating database, populating documents into table. Maybe we'll set that as true. And down below here, we could add another one and say amount. And we're just being abstract about these values, right? Because they're documents. So now we have some data inserted here, and we're going to want to actually interact with this database, right? So I'm going to imagine, we do have a query builder as well, which is nice over here, but I'm going to imagine that we're going to probably use an SDK for that. So we'll go look up Firestore SDK, and we'll see what we have here. So there's like web, iOS, Android, Flutter. I want to do this server side. I don't want to do this via mobile applications. And so we have the SDKs here. We'll take a look here. They call them admin SDKs. I wish they had Ruby. I don't know why they have everything else, but they don't have Ruby. But I guess it depends on what you're doing. So these ones here, well, this is for Firebase, right? So let's say Google Cloud Firestore SDKs. Not Firebase, Firestore. Like technically Firestore is within Firebase. I just want to make sure I don't get confused there and choose the wrong one. Do they have one for Ruby? Maybe there's a third-party one. I don't know. Apparently they do. So Cloud Firestore is a NoSQL document database built automatically scaling. I keep using Ruby because A, it's my favorite language, and B, it's really easy to use and learn. So it seems like there is one. But you can see sometimes documentation is a little bit hard to find stuff. So here it says Cloud Store, document database. I just don't know what gem to install. So we'll go ahead and I'll go use Cloud as a search. What gem am I installing to use this? Okay, maybe it is that. That'd be really nice if it is. We'll make our way over to GitHub here. And as per usual, we'll go over here and to our GCP examples. I've showed this many times. I actually still have it running here, but I have a code spaces, so use whatever you want. I show you how to set this up earlier in the course. If you were skipping videos ahead of time, go back and find those videos. I repeat it multiple times over and over again. We'll go ahead and make a new folder here. This will be for Firestore. So we are here. I'm just going to make a new one here. This would be like basic Ruby. And we will CD our way into there. So I'm going to make a new gem file. So we'll say bundle init. And that will create us a new gem file. From here, we'll go back over to here, and we're going to grab this. And so now we have that there. We'll do a bundle install, and we'll see if that actually works. It looks like it is, so that's good. I'm going to make a main.rb here. And let's go take a look at the code that they've provided. This code might not work. Sometimes the docs are just wrong, but that's fine. If it is, we'll work our way through it, okay? So we'll go ahead and paste this here. So here we're creating a new Firestore instance, get a document reference. So I feel like there's more to configure than that, right? That's not going to make any sense. So what I'm looking for here is I'm trying to figure like, okay, how do we establish our connection, right? So in general, Cloud Store, library, service account, credentials to the Google Cloud account. Okay, and so there's some environment variables. We have the project. But again, that's not what I'm looking for. I'm looking for, how does it know what what database to use, right? Because we're not seeing that option. So I'm going to go over here and say, all right, now how do I connect to a specific database for Firestore? using this API. Let's see if this can find it for me. But I like to find things in the docs directly, but you can see that there's a lack of documentation. So here we're seeing project ID, database ID. That could be it. I'm not really certain if that's true or not. And it is bringing that credentials file in. I'm not sure if we need that either. But we'll go ahead and we'll copy this over and we'll see if we can work through this. I'm very hesitant with code that comes from LLMs. They don't always work properly. But we'll go ahead and do our best. So here I'm going to drop this down. We'll grab this ID over here. And we will paste it in here like that. The database is called to-dos. And all I want to do is just kind of like read out the contents of them. So I'm not worried about credential files yet. How can I print out all documents in a collection? There we go. So we will see if that works. And we'll go ahead and paste that in like that. Let's go take a look at what our collection was called. I already forgot what it was called, so we'll have to go check. It's called tasks. So we'll go over to here and we'll change this to tasks. Okay, and that looks pretty good. I don't know if we have to do any establishing connections. I didn't have this up. I had already had this up, so this might already be connected, but I did gcloud auth, login auth. And then I also did like application default or gcloud auth login, but I'll run through this again just in case. Right? But I'm already logged in, but I'll just do it again. We'll copy this one here. Okay. And I'm already set for this project. If you're not, you can set it manually, but we are setting it here as well, so it's less of an issue. I also did, but this was for when we were doing, I think, Spanner. I did this. I don't know if we actually need to do it for this, but I kind of feel like we do. So I'm going to do it anyway. If that doesn't work, we'll figure it out. Okay. And let's go ahead and see if this works. So I'm going to go ahead and run this. I'll do bundle exec Ruby main. That's just how you run it in the context of that. And it'll work or it won't work. And so here we have it. It worked. So as simple as that. We didn't have to do anything special. I do think we probably had to do that application default for it to work. But there we go. We've integrated Firestore. There is a lot of cool features with Firestore, especially with streaming. But it is there, you know, if you want to use Firestore. I'm going to go ahead and delete this database because we are now done. There you go. I'll see you in the next one. Ciao. AlloyDB is a fully managed Postgres-compatible database service built for high performance and scalability in demanding applications. A single AlloyDB deployment in Google Cloud region organizes resources into a cluster. A cluster consists of nodes, so these are virtual machines running the Postgres engine, grouped into instances with private static IPs. Apps connect to the instance using Postgres protocols, which forward SQL queries to nodes. AlloyDB has two kinds of instances: a primary instance, which we will say, which could be either a high availability primary, which includes two nodes, an active and a standby, which with automatic failover ensuring high availability, and then basic instance, a single node for non-production use with no standby. Again, just depends on if you're just trying it out or if you're utilizing this for production use case, right? There's also a read pool instance. So this is an optional read-only instance up to 20 nodes per cluster with automatic load balancing. So let's take a look at this diagram, which shows a bit about how these things are connected. I mean, it's pretty straightforward, but the idea here is that you have your primary instance, and then here we have our read pool, and then down below we have a storage layer, which is shared, which is going to give us consistent and durable data across the cluster. Okay, let's take a look at some of the key features. So it's 4 times faster transactions and 100 times faster analytics than Postgres, lightning fast Well, let's call it Scan. Scan powered queries for Vertex AI, 100 times faster insights with Columnar Engine, natural language SQL with smart recommendations. Its use cases here would be fast response times for e-commerce, finance, and gaming, simplified Postgres migration, real-time BI, so business intelligence, fraud detection, AI-driven vector search. For pricing, that's its cost per vCPU. For memory, that's its cost. For storage, that's its cost. For networking, you have free intra-region data transfer there. So hopefully that gives you an idea. But the key thing to remember is AlloDB is basically like enterprise. If you've ever used AWS Aurora, that's kind of the equivalent over here for AlloDB. But yeah, it's very, very much Postgres or Postgres compatible, which is really, really nice. Okay. Hey, this is Andrew. In this video, let's take a look at AlloDB. So AlloDB is a fully managed enterprise-grade Postgres instance, which I love Postgres, and if we can use one that is cost-effective, that would be good. Here we have a sandbox-free cluster, a free environment to experience AlloDB's superior performance. That sounds really nice. Over here, we can see starting $14 a day. Wow, what a great price. If you are not comfortable with these costs, that's totally understandable. You don't have to do that. I'm going to try the free trial. And we'll create new. We'll see what we can actually do in the trial. I'm not sure what limits there are on it. We'll go ahead and do that. And it looks like it's actually spinning up a development cluster. So we'll call this my alloy. Why not? Or my cluster. We'll call it my cluster. And here we'll generate out a password. I'm going to show it. I'm going to copy it. I'm going to place it in another tab. And I hope I do not lose it. So here we only have up to 16. I think 17's out. So at least at this time. So that's one thing. Over here on the right-hand side, we can see the costs. Again, we're just trying to get this up, make sure we connect to it, and experience a basic database. We're looking here for Toronto, so here we go. And here we have private IP connectivity, enable private IPs, always enable. Public IPs, yes, please. And we actually have to add our authorized network. So very similar to Cloud SQL. So let's say, what's my IP? We'll go here. We'll wait just a moment. We're going to grab that IP address here. Give it, yeah, there it is. So we'll grab that, go back over to here. We'll drop this in, and we'll put a /32. We'll scroll on down, and we can see we have N2, 64, whatever. Sounds great. I mean, normally this would probably be really expensive. But again, I don't want to keep it up for very long. So we'll go ahead and start a free trial. And so that's going to spin up, and we're going to wait for that to be provisioned, okay? And while this is provisioning, it's telling us some things we might want to do. So it says create a cloud storage bucket in the project where your Allo database is located. Upload the SQL file in the storage bucket. Okay, so I mean, we can do that. Click the import data to navigate to the import form. Provide the GCS path to the SQL file. Okay, so yeah, I'm going to go ahead here, and I suppose we can create a new bucket to get prepared here. I thought it'd be a little bit easier than that, but we'll see. So we'll go ahead here, and we'll make our ways over to buckets. And this will just be I still have that migrate bucket. You know what? I'll just use migrate bucket. You can use whatever you want. This is the bucket that I have kicking around here. And I'm going to go ahead and just say, like, I need an import script for AlloDB. Create me one. Okay, so we'll go over to here. I'm not sure if it'll do a good job here, but prepare the SQL file for the bucket. Let's go see if there's any particulars that we have to consider. And so we have CSV, DMB, and SQL file. I think SQL sounds a bit better. So I'm looking here. Let me just see what we need to do, okay? So it doesn't really tell us much about the format of it, so that's a little bit confusing. I don't really care if we use those import operations, but let's just pretend that we did. Navigate to the import data and import with the GCP, create the database. Okay. If we go back to the step, it's up here. So we'll just keep waiting here, and I guess what we can do, I just need SQL. Like, what is it doing here? Okay, you're not listening. Only Postgres. Holy smokes. There we go. No, 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 no. Only write SQL. We are creating an SQL file with mock data. Okay? I don't know what it's doing here today. There we go. Okay. The only thing I don't know is like, can we set up tables? And like, it doesn't tell us that, right? There's obviously the import statements. We say like alloy DB, try not to lose that. Alloy DB SQL import example. Like it tells us we should import one, but it doesn't tell us how, which is kind of annoying. A CSV file could work as well. If you're migrating an entire database, etc., before you begin doing so, prevent issues. It doesn't talk about like the table rows or anything like that. So how would it? Yeah, a table already has to exist. So I would think that you'd have to create the table, and then it would just be import statements, right? So let's go back over to here. Is it still creating? It's still creating, right? So there's not a whole lot that we can do until it's ready. I mean, if we can connect to the database this way, I don't see why that even matters because we can just query there. But we can try the import statement, but we'll see what happens, okay? We're just going to hang tight. All right, so our instance is ready. Let's go over into the Alloy DB Studio, which is just like Spanner Studio or the SQL one, apparently. And we're going to go use Postgres, and we kept that password around. Please, please, please. There it is. Let's not lose that tab. And we'll go ahead and authenticate, okay? So we're going to authenticate. This is just a Postgres database, so I assume Postgres queries are going to work here. And I think that mass import thing is really, if you have an SQL file that's really, really, really large, or there's obviously another way to migrate it. We'll go ahead and open up a new SQL tab. I want to create this table, so we'll go all the way to the top here. And I mean, I guess we could just take these here. I don't care. Let's go grab all of this and see if it goes. So we'll go ahead and paste it in here. We'll hit run, and hopefully those tables just create. Excellent. So we have those tables. So this is definitely Postgres. Whereas with Spanner, even when I didn't do it in the video because I had so much trouble in the Postgres compatible mode, but like it couldn't handle timestamps and other things, so it wasn't truly. I might use the Postgres syntax, but we couldn't use all the features of Postgres, which was frustrating. So now we have those tables. We could import the data here, but why not use that import thing? Because they made a big stink about like, hey, you can use it. So if we click on this import, here it wants to be in a bucket. We have SQL, a plain text file with a sequence of SQL commands, like the output of a PG dump. I don't know if this is an output of a PG dump. I mean, probably looks similar, but it's probably just going to run this sequentially, right? So I'm just going to grab all of this here. Not everything, but I'll grab this stuff here. And let's just try to make an SQL file. So I need to just make a file really quickly on my local machine. Okay. I'm just trying to do that off screen here. I'm not sure my clicking is, there we go. My clicking wasn't working. So we have that there. We'll go ahead and save that as a file to my desktop. And then this will just be import.sql. Now that I have that, we'll make our way over to a bucket that I have. So we have this bucket. I'm going to drag on over. Once I open up a file explorer window here, I'm going to drag on over that import SQL here. I'm going to drop it plainly in here. Okay, the question is, will it have access to this bucket? I would hope that it could, but I don't know if we have to do some special permissions here. I do not see, oh, there it is. We'll click into it. And I need to get its GS link here. Here it is. So we'll grab that one. I believe that's what it wants. So we'll go back over to here. I'm trying not to lose this tab here. And, oh, we can just browse. Well, that's even better. Let's do that. Migrate bucket, import. There we go. Select. If this doesn't work, I don't care. But if it does, that's great too. How would it know what table to insert into? I guess it's in there where it says to insert because it's the same table, right? We'll go ahead and run that and see if it works. Again, we don't have to do it this way, but because they have it there, we should try it. So it's finished. Let's just confirm that the data is there. So we'll go over into categories. I guess we just have to search any of it. So we'll say select all from orders. We'll run that. There's our data down below. So definitely inserted. I'm going to assume that there is a, well, if this is a Postgres database, this would just have a address, right? Because I don't think we'd use an SDK to connect with this. So where's the connection information? Connectivity. Okay, so it looks a lot like how we would normally connect with a database. Let's bring up Table Plus. I'm going to delete this one. We don't need that anymore. We'll go ahead and create a new connection in here. We installed this in the Cloud SQL, so didn't watch that one. Go watch that one first about installing Table Plus. And so I want to grab some information here. I'm just going to drag that half off screen so I can click back onto it easily. So what do we need? We need the host. So the host is the public IP address, right? And we'll paste that in. The user, I believe, is Postgres. The database is Postgres. Our password is precariously living on that tab, that new tab there. And I'll go back to here and we'll paste in our password. I think that's everything. And this will be like AlloyDB. I'm going to test. Unknown driver error. Let's make sure we put in a port here. Test again. Unknown driver error. This does not look right. Let's do that. Test that again. Connection's okay. We'll save it. Let's go here. Make sure that we can see stuff. We got lots of stuff. We'll go here. Our data. So we have our data. There we go. Great. So yeah, not too hard. Actually, I really like that. That was not too bad. So let's go ahead and get rid of this really, really expensive cluster. But you know, if you're an enterprise and you like Postgres and you just want it to work, I could see why they made this, because Spanner, I'm sure, is good, but if you really like Postgres at scale, then this is even better, right? So now it's deleting the cluster, and we'll just wait for that to go. There's probably more things we could do with AlloyDB, but that's a simple introduction. So there you go. Bigtable is a fully managed, scalable NoSQL database for real-time analytics on massive data sets. It handles petabytes of data with horizontal scaling, provides low latency, high throughput for real-time analytics. It's ideal for large, sparse data sets with wide column NoSQL structures, partitions data effectively across nodes for scalability, integrates seamlessly with Google Cloud Services and the Hadoop ecosystem. The use cases here would be time series data, marketing data, financial data, IoT data, graph data. In terms of its architecture, clients' requests are routed through a front-end server to a big node cluster, and each node manages specific requests and handles tablets, which are shards of Bigtable tables stored in SS table format on Colossus. Adding nodes increases capacity and throughput to handle more requests. Tablets can move between nodes without copying data, as nodes store only metadata. Writes are stored in Colossus for durability. No data is stored directly on nodes. So there. All right, so let's talk about managed file storage. There are no pretty graphics for this one. It's all just text here, but let's make sure we understand what it is. It's an alternative to compute engine disk persistent block storage. And so there are many managed solutions that Google is either partnered with or provide, I think, directly for more volume options, okay, or disk management options. So we have Firestore Basic, Firestore Zonal, Firestore Regional, Google Cloud NetApp Volumes, Google Cloud Managed Lustre for partners. So these managed solutions, I believe, are managed by Google, right? So if you ever heard of NetApp, that would be a means to which you'd get NetApp, and one of the easiest ways there. Let's take a look at partnered solutions. So you can directly work with NetApp and use ONTAP, Nasuni, Cloud File Storage, Syscom Storage fueled by IBM. And so when would you want to use these solutions? When you have lots of storage and you want Google or a partner handling all the storage operations. It provides additional flexibility for storage features and configuration. If you're not really into storage, you might think, okay, I don't really understand, but there's a lot of functionality that you can tweak when you are utilizing these things that go well beyond compute engine disk persistent block storage, okay? BigQuery is a serverless, fully managed data warehouse and analytics engine designed for fast, scalable data processing across clouds. So here is a screenshot of the BigQuery Studio. And I'm just going to tell you that this is the best-in-class data warehouse out of all the cloud service providers. If there's one service really worth using on GCP, it is BigQuery. And so the idea here is that you can run SQL queries in your editor. It's pretty straightforward to use. You can easily connect to various data sources and BI tools for smooth data import. You can quickly browse data sets and tables through the user-friendly interface. You can use the UI, command line, APIs, making it simple for both beginners and experts. In terms of the workflow, it kind of looks like this. So on the left-hand side, you have data ingestion. So you have things coming from BigQuery, cloud storage, Google Sheets, databases, apps, files upload. You're bringing that raw data into BigQuery. It's interesting. You can bring BigQuery into BigQuery. And here we can refine the data, and then we can output it to BigQuery or cloud storage. And then from there, we can analyze the data with BigQuery or BigQuery ML, Looker, which is obviously a BI tool, Google Data Studio, partnered BI services like QLink, or send it to the cloud AI platform. In terms of key features for BigQuery, we have serverless and managed. There's no need for infrastructure. Google handles scaling and updates. And I'm going to tell you, there's other providers that have serverless, I'm doing air quotes right now, serverless data warehouses, but the only one that I consider truly serverless is BigQuery because it's so easy to use. It's real-time and flexible. It supports continuous data streaming and handles structured and unstructured data. It has multi-cloud analytics, so it can analyze data across multiple clouds using open formats like Apache Iceberg, which is becoming a very popular table format. We have efficient storage and querying, so columnar storage for fast queries with built-in analytics and machine learning. Security and governance, so centralized access controls, encryption, and compliance tools. It has flexible pricing, so on-demand or reserved pricing to optimize costs. And when we're talking about data import, it can support a variety of format types, so CSV, JSON, Avro, Parquet, Google Sheets for analysis. But Excel is not supported, which kind of makes sense. It's a Google product. And if you ever tried to parse an XLS file, it is a pain. So I kind of understand that. But a really, really good service. It is worth your time to learn more about it, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at Firebase. So this is Google's fully managed platform for rapidly developing and deploying web and mobile apps. Really, it's a platform as a service utilizing serverless technology. Firebase offers the following services and features. So Cloud Firestore, machine learning, cloud functions, authentication, hosting, cloud storage, real-time database, crash of Linux, performance monitoring, test lab, app distribution, Google Analytics, in-app messaging, predictions, A/B testing, cloud messaging, remote config, dynamic links. So Firebase is basically an alternative to using Google Cloud directly for users who want to focus on building and deploying their applications in a highly opinionated framework. If you ever heard of AWS Amplify, that's the AWS competitor for this. The only thing that I find, like, this service is great, but I find that it's very hard to migrate off of Firebase onto Google Cloud. But the idea is that, if you don't really want to learn all the infrastructure as a service stuff, and you just want all this convenience around you, this thing is really great, okay? Hey, this is Andrew. In this video, we're going to look at PubSub. So in the top here, we'll type in PubSub, and we will find the PubSub product. So it is over here. We'll go ahead and create ourselves a new topic. And we'll just say, my topic, be whatever you want it to be called. We could add a default subscription. We don't need to enforce a schema, but it's not a bad idea to enforce a schema. Do we want to enable streaming data? No, I don't think so. That doesn't really matter. We have enable message retention and a bunch of other options. But for now, I think it's fine if we just have that there. We'll go ahead and hit create. And we'll give that just a moment here. And so now we have our topic and subscription. So probably what I would like to do is I would like it to do something. And so what we probably need to do, so here we have a subscription and topic. I want to push something to our queue. So what I'm going to do here is look up SDK PubSub Google Cloud, and we'll see if we can find something here. As you're finding with a lot of these libraries, we programmatically work with them, and they usually have client libraries. I'm assuming they have a Ruby one. They seem to have Ruby for everything else, and if they do, I'm going to use Ruby because I like Ruby. And they have one, so here it is, Google Cloud Pub Sub. So I'm going to make my way over to GitHub, and we are going to go here and pull up GCP examples, and I'm going to close this out because no, you know what? I'm just going to use it. It's totally fine. I'm going to open this in the browser. And so I've been using the same code space again and again and again. If you want to utilize this stuff, you're going to have to log in. So probably we'll have to do, auth application login, which is fine. I set this up much earlier in the course. So if you want to use GitHub code spaces, you can. If you don't, you can set up your local machine. This one has Terraform and Google Cloud CLI installed. All we need is the CLI. Watch earlier videos for that. I'm going to just clear this out. And I was, I think, attempting here before Bigtable. That didn't work out. But that'll be another video you will see later on. So what we'll do is go to the top directory here. We're going to make sure that we log in with application default login. So go ahead and hit enter. We're going to have that link. I'm going to hold control, click on the open. We'll go here, connect. Okay, we'll give it a moment here, continue. We'll copy this code. We'll go back over to here. We'll hit enter. And so now we should be authenticated. My project's already set here to GCP Playground 12.12. You might want to set that default yourself. Usually they will tell you here how to set a default, but it's up to you. So anyway, what I'm going to do here now is I'm going to make a new folder. This will be for PubSub. And we'll make another folder here. This will be like basic Ruby. And I'm going to cd into that directory. I'm going to initialize a Ruby file. The reason I use Ruby, it's my favorite language, and it's super easy to use, and the code's easy to read. So multiple reasons, but generally these are all basically the same. Like language-wise, but I'm going to use the language that is easiest to use. So we'll go ahead and we'll do a bundle install. So that's going to install that there. We'll go over to here. We'll scroll on down. And here we have a very basic example, which looks good to me. We'll have to create a new file here called main.rb. We'll paste in this contents. And so we need to provide our topic ID. I think we call it my topic. And this is for creating a topic. We don't need to create a topic. We already have one, right? But we could create it via the SDK here, which is fine. So what I'm looking for here is how would we go about pushing something to it. So we'll go down to the Ruby reference library, and we'll scroll on down. So here we have an example, and we can publish an article or a message to the pub sub here. So publish a new message, retrieve a subscription, right? So here we can do this. I'm just reading through it. Create a subscription to listen for available messages. By default, this will block. So you might want one that publishes and one that listens. So what I'm going to do is I'm just going to change this over here. So we have publish. And we'll just do this a bit separately, okay? So we'll take that out. We don't need that. And just in case it wants us to set the project ID, it most likely will want us to do that. So I'm just going to get ahead here and do that. I know that I already have one here in Firestore, so I'll copy that over. Obviously yours is going to be different from mine. And so that will get us set up there. And so this should publish a message. I can just do a puts here and see what happens. We'll type in clear, and we'll do bundle exec Ruby publish. All right, and so it has a problem with topic here. Let's go back over to here. Pubsub.topic, right? So we'll go back up like this. And we'll hit enter. And so that is now published there. Let's see if we can see any information from the UI. We might not be able to. It doesn't really matter, though. And we can do pull from here, maybe. Oh, it's showing whether someone's pulled or not. Sometimes, like at least with AWS and other providers, they give you an interface in order to see those there. I wonder if replay messages will let us do that. There are no snapshots, acknowledged messages. That's fine. Okay. And that's totally fine. I like this pub sub light. I actually don't know what that is. I might have to go and explore that separately. Oh, you have to enable that. Okay. But what I'm going to do here is, I guess, just listen. We'll do that there. So I'll go ahead and make a new file here. We'll call it listen. And I'm going to go over to here. And so we need something that is similar with the code. So I'll go back over to this and we'll grab this to start with. Right? And we'll go over to here. Do we have our subscription? We have our topic. But we're going to need our subscription here. Let's go take a look at what our subscription is called. So we go to subscriptions, my topic sub. Okay, is it already called that? It is, nice. Lazy naming makes it easy for us. So here, create a subscriber to listen. So we'll go ahead and copy this code. We'll probably need an exception handler. That's a good idea. Gracefully shut down. Start background thread that we'll call and sleep. Okay. So what we'll do is we'll go ahead and paste all this stuff in here. So I imagine what we need to do is run this in the background. So we'll probably need two tabs here. And one will listen and one will receive, right? So we'll go here. And I'm going to go ahead. And we have listen. So this is, assuming all the code's fine, it should now be listening. Oh, there we got that message, but it's still probably listening. So if we go over to here and we do, maybe we can split this here. There's a way to do that like this. Not exactly what I wanted. We'll bring this over here and it's not doing exactly what I want, but that's fine. We'll go back over to, well, let's just stop that here. So I'll go on one side here. This will be listen. Bundle exec Ruby listen. And then on this side, it'll be bundle exec Ruby publish. Okay, so you see what's happening here? One listens, one publishes, one receives. Okay, so we've now just set up pub sub. It's that simple. There's more to it, obviously, but that's the most basic thing. I think maybe setting up a schema might be interesting. Okay, so apparently here, yeah, you can enforce a schema. So I don't even think I care about doing that right now, but at least we know that that's possible. We have the most basic hello world. If we want to do another one, I'll do that in a separate video. We'll just say pub sub here. And we'll call that done. I'm going to go ahead and delete out our topic here. I think I saved that here. Yep. And I'll see you in the next one. Okay. Ciao. All right, let's take a look here at durable block storage. And that means we're talking about hyperdisk and persistent disk. So let's make it clear. Why would you want to use hyperdisk over persistent disks? Well, hyperdisk can increase or decrease volume without changing the size. It doesn't depend on provision capacity. It has higher IOPS and throughput limits. So, you know, if you can, always use hyperdisk. There's never a reason to not use hyperdisk unless it's not available. One thing that you need to know about durable block storage is that if you create a disk, you're charged for it, even if it's not in use. So, you know, make sure, you clean up your old durable block storage that you're not utilizing. When you go ahead and create an instance, it will show you what is available. And it really depends on what, again, machine series you're launching. And this list will completely change. It can be really small, really long. So you're just going to have to take a careful look. But for this one, I don't know what I was launching here, but I was getting basically all the types of disk, right? So we have hyper, disk balance, extreme, ML, throughput, a lot of different names there. In the next slide, we'll talk about the comparative of all these different types. Some hyperdisks can be attached to multiple virtual machines at the same time, but that's not always the case. I don't know what the limit is, but I'm just telling you that I noticed that. Now let's go take a look and compare hyperdisk and persistent types that we have. So let's start on the hyperdisk side. So we have balanced and balanced high availability. These are general purpose enterprise. These are good for general purpose enterprise applications. Then you have extreme. These are high-end database workloads. So think of SAP HANA. Then you have ML. So if you want to run AI ML workloads that need access to large amounts of data, then you want to use the hyperdisk ML if it's available. You have hyperdisk throughput. This is cost-sensitive workloads, analytical workloads, and workloads that require less than 600 megabits of throughput. On the persistent side, we have standard. Notice the number there on the side. That's a number I made up to help you quantify how much better the next one is in terms of performance. But really, when you're comparing performance, it's a little bit trickier because it's really hard to boil it down to a single number. So it really depends on reads and writes and what you want. But I just generalize it here so you have an idea how much better these get as they go. But for standard, it's cost sensitive. It's great for throughput optimized non-boot data drives. Now we go to balance, it's 18 times more proficient. These are great for general purpose enterprise apps, best price per gigabyte. Then you have SSD, which would be, I would consider it times 90. So these are performance sensitive business critical apps, best price for IOPS. And you have extreme. These are high-end database workloads such as SAP HANA. Again, the docs, information is very fragmented, so I had to do my best here to, again, quantify it for you. And other providers, we generally will do this. We'll have an idea of sense with this number, but Google doesn't do this here for you, so I had to figure it out myself. But yeah, I think standard and balance, because like obviously we have SSD down here, so these are probably running on HDD hard disk drives up here. That's probably why they are what they are, but there you go. Let us compare the options for persistent disk storage, okay? And we're gonna cover zonal and regional. So for zonal persistent disks, it's a reliable block storage for apps running in a single zone. The idea here is that we get sequential reads and writes. It uses an SSD or extreme PD for high ops when needed. The key features here, it scales up to 64 terabits per disk with 257 terabits per VM. It's predictable performance scaling with capacity and vCPUs. Has built-in redundancy with incremental snapshots for fast backups. Then on the other side, we have regional persistent disks, which is a durable storage replicated across two zones within the same region for high availability. This is ideal for multi-zone apps needing redundancy. Its key features is that it provides 99.9 SLAs with automatic synchronous replication between zones. It's designed for multi-zone failover and high availability workloads. So there you go. Hey, this is Andrew Brown. We're going to focus on virtual machines so we fully understand all the configuration options. We have been launching virtual machines, but we'll just go through it again a little bit more detail so we fully understand it. So I navigated to the hamburger menu to Compute Engine, to VM instances. You can obviously search at the top as well. We're going to create ourselves a new instance. When you're naming these machines, they have to be lowercase hyphen. So I actually like that naming convention. It's quite nice. But yeah, that's how we name it. I'm going to switch over to Toronto because I'm in Canada and that's my closest region. So notice that once you launch, you obviously can't change it. That goes for every single cloud service provider because those machines physically exist in those locations. So obviously it's not as simple as just changing it later on. There has to be some kind of migration, which is creating new machines. Down below, we have our machine types. You can read more about the machine types over here. We, of course, cover them in the course. I believe N1 are the older ones. You'll notice here in the vCPU range that the lowest ones here is E2 and O2596. I think N1 were like, they were like a really, really first generation machines, and E2 is now what's recommended, but they still have those machines here. So we will go with E2. Down below here, we have some presets, and notice here that it says shared core, and then these ones are core. So obviously shared, you're sharing these cores with other folks. So now we've chosen the E2 Micro, which is the smallest options. In our advanced configurations, we can fiddle with this. I believe this has to do with multi-threading. I never touch these, but they are here. And what I like is that as we're working through this, we actually get the code equivalent. So if we wanted this in command line, REST, or Terraform, like look at that, how nice is that? We can copy that over into Terraform, and that might be something we might want to do. I'm not sure if it updates in real time as we're working on it, but we might want to extract that out for fun. So let's continue on. So we'll go to our OS and storage options. So here you notice it's set to Debian, Debian Linux 12. Really depends on what you want to run. I personally like Debian as my Linux web server just because I know it very well. Some folks might like CentOS. I believe CentOS is based off of Red Hat Linux. So those are usually the two that you see, CentOS or Debian. Or if you really want things to be easy, you can go with Ubuntu. It's really up to you. But I think Debian will be fine here, and you obviously have a lot of options. You can bring your own custom images. There's a lot of options for this, but we'll cover that later on. Okay, so Debian is fine for me. We can obviously add additional disks. And then if we want to deploy a container image in this VM, we can do that. It has to do with whether we have a container optimized OS image. This is very similar to AWS's container optimized OS images. I don't know if Azure has one, but this obviously is really nice if you just want to launch a container within a virtual machine, but you'd have to choose one that is compatible. We'll go over to data protection. So back up your data. You can see you have snapshots on a schedule. You can set it to have no backups. I don't want backups because this is just for learning, and I don't have to worry about those later on. We obviously have more options for replicating, so that if something happens in our current zone, we can recover from data that was stored in another zone. Over here, we have our networking options. So if we're launching a web server, we might want to checkbox both of these. They're going to add those network tags, which will open up those ports for us. We could set a custom host name. I would probably not touch that. We can do IP forwarding. I would think that this would be for maybe if you are setting up a bastion or something. Yeah, again, I'm not the best at networking, but IP forwarding is forwarding your IPs as the name implies. Okay, we obviously can't checkbox this because this has to do with different types of machine types. So if you want to enable VM Tier 1 networking performance, you got to pay a little bit more and choose an instance that supports it. Down below, we have our network interface cards, our NICs, and obviously we can attach multiples, but we have one here. We'll continue on to observability. So install Ops Agent for monitoring and logging. Not a bad idea. I don't know why you'd ever want to uncheck that, but it is enabled by default. Enabled to use screen capturing and recording tools. I've actually never used this before, so I'm not exactly sure what this option is, but it's nice to see that option is there. Then over on our security tab, we have our service accounts. That's obviously what's giving it permission to do things. We can allow the default access or change some of the settings as we're working through here. So that is pretty clear as well. Usually you'd want to have secure boot on, so I'm not sure why it's turned off by default. Secure boot helps protect VMs against boot level stuff. I would think we'd want that on, so I would just checkbox that on. I don't think it costs anything additional, so why wouldn't you turn it on? So that is one thing there. We'll go over to, what's down here? Anything else? Oh yeah. We have control VM access through IAM permissions. Not a bad idea, but not really worried about it. Block project-wide SSH keys. That's probably not a bad idea as well. But for now, we'll leave that alone. Add manually generated SSH keys. So we can go ahead and add our own SSH keys. That wouldn't be a bad idea because when you launch a virtual machine in Google Cloud, you can obviously click to connect to it. But if you wanted to connect to an external machine, you probably would want to add your SSH keys. Could you do that afterwards? Yeah, you could log in and set them, but you might want to do it here at that step. And we might do that in a separate video, okay? Then over here, we can manage our tags and labels. I don't know, yeah, there we go. I was gonna say, like, where is it? Because their options weren't there, but yeah, we could add the tags and labels. Why they show like that? Looks like the description's put in there, but that's confusing. So this will be my web server for showing how to start up Apache. That might be there. We can set up an automation script. So I believe this is just user data underneath, which is the Cloud Init standard. All providers initialize Cloud Init. If folks are not familiar with Cloud Init, okay. Almost all providers for virtualization use Cloud Init to set those up. I'm pretty sure that's what it's using. Let's go take a look here. Yeah, it should be Cloud Init. Yeah, we'll go over to here. Yeah, Cloud Init, exactly. And so actually this is perfect. This is exactly what I wanted. It's just coincidental that it was here, but I was going to do something similar. Is that for Debian? That looks like it's for Debian. But yeah, that's basically what I wanted to do. So we kind of lucked out there. We'll put in our script here. And so this is a bash script. I think it can also take a YAML file, but it is not showing us that. But I believe it's Cloud Init underneath. So whatever Cloud Init can take, it can take as well. So we'll give that a try and see if it works. We can obviously pass metadata. We'll talk about that later. We have data encryption. So Google Managed Encryption, Cloud KMS key, that's fine. Provisioning model. We want to stick with standard. So if we want to save some money, right, you could switch over to Spot, which isn't running all the time. And everything else seems fine. So selected machine is not compatible for sole tenancy. So it is obviously a shared tenant, right? Meaning running along other, if you're using a shared core, it can't be sole tenancy, right? That's going to make no sense. Well, over here, we can see our cost is $7.83. We might want to save this code for later. And actually, I think that's a great idea. So I'm going to go ahead and I'm going to copy this code here, because I think this is probably like a better way to launch. This depends if it works, right? So one of the hardest things with Google Cloud is actually having good Terraform code. And not all services have this, but at least this one does. And so we should give it a try to see if it actually does work. So what I'm going to do is I'm going to go open GitHub here. And we're going to make our way over to the examples repo. So that'll be exampro co GCP examples. Okay, and we're going to go ahead and I'm going to open this up in Codespaces because I have set this up in Codespaces prior. So I'm going to go ahead and I'll delete the old one. I think it's always good to create from scratch. You can use this on your local host, whatever you want. You'd have to do some of our prior videos for that to work. So, if you're not doing videos in order, you're going to have a hard time here. We're going to go ahead and add a new code space. Okay. And we will provision it the Terraform way, okay? All right, so this machine is running. And remember that we are using this, and we installed Terraform and Google Cloud here. So we will have to re-authenticate every time we do this. If we're on a local machine, this would be less of an issue. But if we keep doing this, we're going to get good at working with service accounts because it'll become more routine. But luckily, I provided, in this example, the instructions on how to do that. But we're going to make a new folder. Whoops. Say allow. I'm going to change my theme over to something that's a little bit easier to look at. So we'll make our way over to dark. Okay, and we'll just zoom in here. And we'll make a new folder here, and this will be Compute Engine. And we'll go here, we'll make a new one here called Basics. Okay, and we'll go in here, we'll say a main dot Terraform TF. I have to think about what we're doing here. It's Terraform, right? And so we'll go back over to here, and I'm going to go ahead and just copy. Whoops. We'll copy this over here. And my question is, like, does this work? Because my number one thing that I have trouble with is Terraform with Google Cloud, because it's usually hard to get up-to-date code that works. We'll go ahead and we'll install the Terraform extension here. Why they don't just publish examples online, I don't know why. But we'll go here, and so here we can see we have our web server. Okay. And I'm just slowly going through it, seeing if everything makes sense. Everything looks fine. I'm trying to see if anything's like hard-coded. And there are values that we'd probably want to uplift into variables here. So what I'm going to do is go here on the right-hand side, and we'll make a new file. And this will be, variables.tf. And you can use whatever you want to uplift these. But I'm going to go and use Claude, because I like Claude. I mean, I have ChatGPT, I have everything, but I'm going to use what works best for me. And so I'm just going to paste this into here. I'm going to say, can you extract out the hard-coded values and create a variables TF, and this main TF reference the variables. I think if Google Cloud actually made it generate it like that, that would make a lot more sense, because right away, that's what you're going to want to do. So we'll give it a moment there to generate. Of course, if you do not want to do this, you could just copy paste the code out, the final solution. But I'm just showing you how I'm working through this problem. And so here we are getting lots and lots of variables. Okay, so we'll give that a moment there. All right, so here we have the formatted instance. Wow, it looks like it's way smaller. That can't be right, can it? But we'll find out here in just a moment. And yes, this is 87 lines. Now what do we have? No, it's the same amount. Okay. Has everything been extracted out? I'm not sure. Let's take a look here. Yeah, we're seeing some extractions out. I think it's fine. Obviously, you could go very far here and extract out quite a few stuff, but that seems fine to me. We'll go over to our variables here, and we will copy this contents over to here. Okay, and then I'm just going to take a look here. So we have our project ID, our region, our zone, our instance name, image description, machine type, boot image, boot disk size. Again, just carefully looking through what we want. It's on the premium tier. I think that's fine. Service account email. So that makes sense as well. And then what are the scopes? Like what permissions does this machine have? That's fine. Okay, so as far as I can tell, this looks fine. Now the question is, how do we go ahead and deploy this? So we'll go ahead and take a look at, we did this earlier with the quotas. So if I go into my README here, I have my instructions set up. So we should already have Terraform installed and the Google Cloud CLI. We will have to log into the Google Cloud CLI. So that should be pretty easy. We just need to type in gcloud login auth. It's supposed to put like no browser, whatever, but I keep forgetting how to do that. And it's saying that it doesn't see gcloud. Oh, let's try this again. Well, it's definitely the same container. I'm not really sure as to why we don't see it. So we go over here. Yeah, we have gcloud. Where is gcloud? gcloud CLI. It's not that. It's just gcloud login, right? Gcloud auth login. And it's kind of frustrating that sometimes this stuff works, sometimes it doesn't. Yeah, it's just that. Actually, the one I'm looking for is the, no browser one. But what we'll do, just to make sure this works, sometimes what helps is rebuilding. I shouldn't have to rebuild this, but we'll rebuild it anyway. And we'll go ahead and do a full rebuild, okay? All right, so we rebuilt the machine. Let's see if gcloud's there now. Okay. And so now it's back. It's really strange because when it starts up, it's supposed to already be installed, and I shouldn't have to do that extra step, but we'll have to keep that container or that virtual machine around if we're going to keep using this. But the order of videos, I might have to call that out. But anyway, so we'll go ahead and we'll do gcloud. That's fine. We'll just do gcloud auth login, and we'll go ahead and log in. So of course we need to follow that link, and if we had the no browser option, that would probably be better, but I can't ever remember what it is, so it doesn't really matter. We're going to go ahead and continue through here, click all the stuff that it likes. Yeah, see here it says that you're seeing this page because of whatever, that's fine. We'll copy this code, we'll go back over to here, we'll paste it in, and we'll hit enter. And now we are logged in. So I'm going to go ahead and type in clear. And so what do I want to do? I want to deploy this compute engine instance. But before I can do that, I need to make sure I have the permissions to deploy, I believe, right? Because I am logged in, but that might not be enough. But let's find out. Let's see what happens. So we will need to go into our compute engine basics, and we'll do Terraform init, because we have to initialize what we have here. And I know this is going to make a mess. So in here we have a .gitignore, and we're just going to copy the contents of, actually just copy this file here, copy it, and we'll paste it into our basics folder. Okay. And so we've initialized, and so this deploy probably shouldn't work. Okay. It says attempted to load credentials, etc., etc. So we learned in our quotas one, we did the work up front there to find out what we need to do to make this work. So if we go into our README here, and I just scroll on down. So here we created a Terraform SA account. So this one already exists. We already bound permissions specifically for a specific project. So we are doing this all in the same project, the GCP Playground. And here, everything's fine. So basically, we've already done this prior. So if you haven't done this, you'd have to go run all these steps, and you'd run these in Cloud Shell. So you'd open up Cloud Shell, you'd run it in here, right? Okay. But I'm not doing that because I've already done it prior, and these already exist. If we want to make sure those service accounts exist, we can make our way over to service account. Okay. Whoops. Service account. Service accounts, right? And you can see this one already exists. And it should say somewhere in here what permissions it has. Okay. I would have thought we said, so manage service account permissions. Okay, so manage access. Here it is. I'm surprised it doesn't show it here in line, but you can see it has compute instance admin permissions there if we wanted to modify it. So this one already exists. All you need to do is download that key, right? Because I already have that all created, so I don't have to run those other steps. So we'll go back over to here, and I should just be able to run this line here because we're now logged in, right? And that's going to dump this into the correct location. The reason it's complaining is it doesn't know what the Google Cloud Project ID is here. So I think I set in here. Oh, it's not there, I guess. No, it's right here. So I just need to run this one line here, which is, I actually want this to be export. I don't know why I don't have that as export. We'll go fix that quickly. I also notice I don't have Vim. That's driving me crazy. Don't install Vim unless you are a person that likes to use Vim, okay? We will go over to here, and I'm going to copy this. Okay, that's going to set that environment variable. We'll go all the way down to the ground, and we're going to copy this command. That's going to download the key pair. Now, we could just download it manually, but we need it in this machine, right? So if we go over to, not here, but we'll go back to here. You see you have keys, and so you can download the keys, and clearly I just downloaded the key right here, right? And so if there's old keys that you're not using anymore, you can delete them. That was from yesterday, so I can delete that. We're going to go back over to here. I'm going to go ahead and now that I've downloaded the key, it's gone to this location, right? And so I'm going to give it the full hard-coded address. I found out if you don't do that, it just decides not to work. And so we'll go ahead and export that. So now, in theory, we should be able to do Terraform apply. Okay. And so here we get what it's going to change. So we have a bunch of stuff. Looks good. And we'll go ahead and hit yes. The reason I'm doing this, I want to see if that generated Terraform code out from Google Cloud actually works, as I thought that was really curious. Because again, it's really hard to go to like the Terraform documentation and get good GCP code. So if we see it, we should try to use it and test it, because it'll make our lives a lot easier. So we'll wait for this deployment to finish, okay? So here we ran into an issue where it says permission, OS config, OS policy assignments create, denied on resource. So here we're having a permissions issue because we need this permission in order to do whatever we're doing. So who has the permission issue? Is it the web server itself, or is it the permissions that I have to provision these things? And so that's where it's not really clear. But let's take a look here and see if we can clearly read this here. So error creating the OS policy assignment. So I'm thinking that inside of this, somewhere here, there's an OS policy assignment in our main TF, right? So let's take a look here and see what we have. I'm going to just type in policy here, policy. We do have OS agent policy, right? Because we want to attach that there. And so it's saying it doesn't have permissions. Now, this must be at the key that I just downloaded, right? So it needs to have OS policy assignment creation, right? So let's go back over to here into our Terraform service account, and let's see if we can update our permissions to include it. Now, I don't know what permissions it needs, but I'm sure we can try to figure it out here. So we have a role that we've attached, which is good. And we also have the service account role. Let's go here and see if there's something for policies. So I'm just trying to guess here, like policy. And yeah, we have a lot of policies here. So OS policy, let's see if that helps. OS policy assignment. So here we're doing the admin access, because that's basically what it was saying that it needed. We'll go ahead and save that. The question is, like, I just updated that key. Would that be attached to these permissions? I would think so, right? I would think that that would work. And I don't think any of our resources were provisioned because Terraform would just not run any of it. Let's try this again and see if we've resolved our issue. Okay, we'll go ahead and hit yes. So OS policy assignment denied. So I'm not sure if we need to download that key again. I wouldn't think so, but I'm going to go ahead and delete it anyway. And we're going to try to download it again, right? And that will just make a new key. So I'm going to go hit up, 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 up. There we go. Right, so now we have a new one, and I'm hoping that maybe that might make a difference. The other question is, do we have to wait for these to propagate? Is there something we're missing? I don't know. We'll go ahead and hit yes. We're still getting that error, right? So the error creating the OS policy assignment, permission 403 denied. So I'm not sure what's causing this. So I'm going to go and ask Claude, see if it can figure it out. Because we've added the permissions to the key that can do it. Oh, you know what? Maybe we need to enable it. That's actually a good question. Is it enabled? So I'm going to go over to our APIs. Because that would make sense as well. So we'll go ahead, and we probably still had to give it permissions. We'll say OS policy. That's not what I was looking for. Let's go back here and see what they suggested here. OS config, okay. OS config. VM manager, okay, that makes sense. So we'll go here and we will, it says it's already enabled. So it clearly isn't that, right? So we'll go back over to here. Grant required IAM permissions. So here they're adding the OS policy assignment admin. I believe we already did that, right? If we go back over to our service account. Okay, we go back. I don't know why you don't get search everywhere. But we'll go back and back and back. Where's my search? Oh, it is here. Okay. And so I'm looking for service accounts again. And I want to see here, right? This is our Terraform one. And we'll click into here. We'll go to our permissions. We'll manage our roles. OS policy assignment admin. So it definitely is there, at least here on this account, right? So we'll go back over to here. Remove the ops agent module temporary solution. Check the current permissions. We could do that. Required role summary. So OS admin login. Helps monitoring and logging, but your web server will still work without it. You can always come back later. So do we need additional permissions? I don't know. Let's go back and take a look at that error and be very careful at seeing what permissions it needs. It says OS config, OS policy assignment create. So that has to be the assignments, right? It has to be. Okay, so just give me a moment and I will try to troubleshoot this, okay? All right, so I'm not sure exactly what the problem is, but one thing we can do is try commenting out the OS agent policy, because the question is, right now, do we have any permissions to do this, right? Like, is our credentials being set and being loaded and being interpreted? Which is what I don't know. Because if we go back over to our main TF here, what I'm looking for is how does it load that information in, right? So if we go back over to our other one here, we have Terraform provider up here in the top. And I'm just looking here, and where is it? Right, in fact, I don't see it at all. So I wonder if that's part of the problem. Yeah, how's that even working without the provider information? So maybe that's something we might want to do. So I'm just scrolling up and down. Did the original one actually have it? If we go back to, well, I guess we don't know now because we closed it, right? Well, you could find out. You could go back in the video. I can't. I'm recording the video as we speak. So what I'm going to try to do here to help make this work, I'm actually going to copy these two things over because I feel like these should be over here. And I probably can make that a separate file called provider.tf. I'm not sure. I can't remember what the standard is for that. But I suppose, yeah, I'll just put it in its own file. We'll call it provider.tf. The way Terraform works, it'll pick up all the files here. So now I have this in particular, and so I'm hoping that this will work, but I think it said that it works with a very specific version of Terraform. So we go back over to here, and let's pretend that we're going to launch a new VM, okay? So we're just giving it a moment here to load, and we have the code equivalent of Terraform, and notice here it doesn't show at all. It doesn't show at all that information. And it also says this code is compatible with 4.25, and the version that are backwards compatible to 4. So notice that it's not for 5. This is what I mean when I say that Terraform is hard to use with Google Cloud. They're not even providing the latest up-to-date version, which is 5. That doesn't mean that our version 5 won't work. It just means that we could run into problems and we might have to roll this back to version 4. So what I'm going to do is I'm going to go ahead and try this again now that we have the providers in place. And here you can see there's an independency lock. So the following dependencies are inconsistent with the current configuration. So here, locked versions from 6.3.9 does not match the updated constraint of 5, 4, 5, and 7. Okay, so we'll do an Terraform init upgrade. And this version 5 was what we used earlier because it was what was generated out for us. So I guess we never even checked. That was when we did quotas. But if we go to Terraform provider, or actually just go to Terraform GitHub, I bet we could find out the version of the latest one right here. And so if we go to tags, we scroll all the way down. That's going to take too long. Let's go to releases here. No, I guess that doesn't help because each one has their own provider. So we'll say Terraform GCP provider, GitHub maybe. Because these all exist, or they should exist in repos, right? And so, yeah, that's not very clear. So we'll go back to the Terraform registry here, and we will go over to our providers, browse providers, GCP, and does it say what version is? 6.3.9. So interestingly enough, this one's on 6.3.9. It's officially supported. I believe this means that it's official by HashiCorp. So HashiCorp maintains it, but then Google, they're literally 2 versions behind. That is bizarre. But that's, again, Google. I tell you, they don't keep their stuff up to date. Good products, just bad documentation and not great for helping folks around that kind of stuff. So we'll try to run this again. And we're running on, again, at least version 5, where the code's saying it's supposed to be 4.2.5, and the latest version 6. So we could seriously have some breaking stuff, but we'll see what happens here. Because before it didn't have any context, so how would it have known that that was the project ID or that was the region? And now it deploys fine. So it probably did need those permissions, right? Probably needed those things, but clearly it wasn't able to, whatever additional information it needed, it wasn't there, right? So that's going to help us out a lot. And now it's deployed. So let's go take a look at that resource. Okay, over here. And we'll go back over to Compute Engine. Okay. And we'll go into our instances, wherever that is. VM instances. And so there is our web server running. Okay. If we want to get into that, we can SSH into it, right? So we can go ahead in the browser. All right. Now, we said that this is a Apache web server, right? So the idea is that this is supposed to be running. We'll just say authorize here. This will get us into this web server here. And so now we are in this web server, so we can do ls pwd. So in here, there's supposed to be a web server installed. Let's go back over to here, to our Terraform code, because somewhere in here, there should be that user data script, right? That we pasted in. So what I'm looking for here is that user data script. It says startup script. It says metadata. Instances count. This is, I mean, that doesn't look like the one that I'm looking for here. Go over here. This must be, that's quotas. Okay. So we'll just close it. It gets confusing here when you have too many tabs open. I apologize. But we'll go to main TF here. And what I'm looking for here is I'm looking for the user data setup, right? So I'm going through here. Where is it? I don't see it. Startup script right here, var startup script. So then we go to our variables. And do we have our startup script here? Yes, we do. And that's an interesting way that they could do that. I don't know if Terraform supports Terraform multi-line string. Can it do a multi-line string? Because if it can, that'd be a lot nicer, right? So we'll go here. And it can. So now that we know that it can, I'm going to go ahead and copy this. We don't really need to do this, but it's just to make it easier to read. So can we make the default string multi-line for easier readability? Was this HCL? I believe the language is called HCL underneath. I forget. You'd think I know since I made a Terraform course, but we'll give that a moment there to, just the code I gave you. Okay, it's trying to edit this big thing here on the right-hand side. I don't want that. Not really listening to me, but that's fine. Okay, so we'll go ahead and we'll copy that, and that will be a little bit easier for us to see what we're doing, right? So we'll go back over to here, and I'm going to go ahead and paste in this. Sometimes this has to like hug the wall. There's actually, looks like there's 2 EOFs in here, which is interesting. An argument of block is defined or required. Well, what do you want? I just copied what you told me to copy, right? So we go down here, and I don't like how there's 2 of them, so I'm gonna just put a new L here, like L, like that, just to make it not conflict. And so now we're not getting an error, right? So it's probably because they have an EOF inside an EOF, end of file. Why they call it that, I don't know, but you can name this whatever you want. This could be like script and script. I'm not sure about this for cat, so I'll leave it alone, but definitely for the outside one, I believe you can name it whatever you want, right? If we go back over to here, wherever the Terraform, oh, we closed that tab, but I was wondering if we looked at that documentation. So, I mean, this is still the same script, but the idea is that this is installed and it's in the var www html index html directory. So we should be able to find that if we go and pull up this window here, right? And if I go into var www and we go to HTML, there should be a page here, right? So there it is. And it should be serving. Now it says app update. I don't see anything that says sudo system start or stuff like that. When using Linux, it can be either sudo system or sudo system CTL. It's probably sudo system CTL. These are things that manage services, or sorry, sudo service. It can be service or system CTL, but it's probably system CTL. Sudo system CTL Apache 2 status. Sometimes I get the order wrong, so it's like status Apache 2. There we go. And so we can see that it's running and it's enabled. Normally what you want to do is you want to enable it afterwards, because if we were to restart this machine, like start it down, it might not show up later on. The other question, like, is this reachable out to the internet? So this is running on port 80. And so I'm going to close that tab out, and we're going to go back over to our VM, and we have this external IP address that's been assigned here. I'm going to copy it, and it should just serve up a website in theory, right? Because we opened up those ports. If we go back over and we click into our instance, right, we should have information that tells us if those ports are open. So under networking here, it says firewalls, HTTP traffic is off and off. I would think that would mean that's good, because then it's disabled, right? Let me get through of it, because we have these tags here. So if we go back over to, where was I here? Oh, we closed the other window. I was thinking of the thing that I opened, but I'm trying to figure out, like, what's this? Oh, it still gives us, oh, VM, JSON representation is VM. Okay, that's useless. But I'm trying to figure out, okay, we have an IP address here. How do we reach it? How do we get to that address? Because here it should be serving it up. Well, first let's make sure that we are, this is HTTP, because that might be a little bit easier. But what might be preventing this is the network firewall rules. So I'm going to open a new tab, and we'll type in firewall. Okay, and we'll go over to our firewall. And in here, we have different rules that allow us ingress or outgress or things like that. And what I'm trying to figure out is, like, are there any policies to allow us to, or rules to allow us to be able to get out to the internet here? Because I see a bunch of ingress here, and well, that's just not that helpful, right? So what we can do, I mean, I just need a rule. I always get these two mixed up. We'll go ahead and just create a new rule here. And so firewall rules that control. So I'm going to say HTTPS. And actually, we have very specific tags. We'll say web server allowed, right? So this will be a policy that allows web servers to go out to the internet. And so I'm going to go down here, and network will leave alone. Priority, the higher, the more priority it will take. Ingress, so traffic coming in, that's fine. Allow, that's fine. We already have some tags that are applied. So if we go here, we should be able to provide those tags. If we go back over to here, what were the network tags that we had applied? They're somewhere in here. I know we applied them because I saw we checkboxed them. Unless they're not actually there. Oh no, they're here. So HTTP server, right? So these are the network tags that we have. Okay. And so I'm thinking I should be able to paste them in there, but maybe not. That should be network tags, right? Just a moment, okay? So here you can see, I looked it up, and it's like the target tag defines the GCP VM. And so I think it's equating that to network tags, right? But it's weird because we go here and I can't see it. So if I put this here, now it applies. Okay, there we go. So it doesn't autocomplete, which is fine, but at least we now have those network tags there that we want to allow this access to. Now, technically, these are two different rules. So, I mean, basically, if someone's an HTTP server, then you'd probably just want to open that port. So I'll take off that one, and we'll just say HTTP web server allowed. And we'll just have the HTTP one on here, okay? So we have the allow, we have IPv4 ranges. The source, I don't think we have to fiddle with that because we have the tags, right? If we already have that, we wouldn't have to select that, right? Right? Well, anyway, we'll continue on because it'll tell us in a moment if we're wrong, right? And then here, allowed specified port. So we go here, we're going to say port 80 because that is what it's running on. Let's see if we can create it. So we say go to issues. I hate typing in IPv4 ranges. I'm terrible at networking. So the traffic is only allowed from sources within these IP addresses. From sources. Okay, so we're saying from the internet. So we go here. And so we're saying anywhere from the internet will be allowed to come in. And so that will make it a little bit easier. We'll go down below, we'll create that. And so now our port 80 should be open. That doesn't necessarily mean that our Debian machine has access to the internet because there could be firewall rules that we need to configure also on the machine. But for now, this should be technically working. Okay, 1 second. Sorry. And so if we look here at our network rules, we want to make sure this one's on top and we can look at the priority. So the lower the number, the higher priority it has. And so if this one says ingress, it's going to allow everything here. There's nothing underneath here that's going to conflict it with like denies. So this should now be accessible. So we go back to our web server and we are going to look for the IP address. Yeah, we're on our web server. Let's go back one step. Sometimes it's easier to go here and grab it. So we'll go ahead and grab that IP address again. I'm going to paste it in here. And so now it's working. Linux startup script added directly. I guess that's fine. Is that what it actually called it? I wasn't really paying attention when it generated out the code. Yeah. And so not the best message, but it does work. And we now have this machine deployed. So obviously that's some good steps there. You probably might want to, I'm not certain, but you might want to include maybe in the Terraform setting up the firewall rule. But I don't know if that would cause a conflict or not, because you can make like a firewall rule per machine, but it just depends on how you want to manage those rules. I don't honestly have the best idea on how to manage it because most of my infrastructure I run on other clouds, so I don't have strong opinions about it, but we have an idea here. We don't necessarily want to stop this machine over here because that wouldn't make any sense to do. But what I'm going to do is I'm going to go back over to our environment here, and I'm going to go ahead and I'm going to do Terraform destroy. Okay, and the idea now is that we have a base template where we can tweak this and do different things with it, right? So I think it was worth our time setting it up there. I want to make sure that I just add that git ignore file first, so just ignore sensitive files. We do have the Terraform save file, so make sure that you delete before you close your environment, because that save file is the only thing that tells it what to delete. Normally you'd push your state to something, and maybe GCP can do that. Last time I was using GCP, because I'd make these courses every few years, right? But I remember them saying that they now have support for managing Terraform state, but I haven't looked into it. So, maybe we'll do that in this course. I'm not sure, but the point is that we've now turned down that resource. Once it's done, we'll close this video, okay? All right, so the resources are spun down, and we'll go ahead and commit this. So we'll say basics, and we'll just extend this when we need to for showing other things, okay? Ciao, ciao. Hey folks, it's Andrew Brown. In this video, we're going to take a look at instance types under Compute Engine. And so this seems very similar to machine images, but machine images are like a point-in-time snapshot of a virtual machine, whereas instance templates are designed to be configuration to launch multiple new instances and not necessarily a point-in-time snapshot. So we're going to go ahead and create ourselves a new instance type. And here I'm just going to call this, my first instance type or instance template. Doesn't really matter. We have the option to make this regional or global. As per usual, I'm going to launch things in Toronto. Then down below we have our new types. Oh, we have a C4D machine, which sounds great. Leading price performance, advanced features too. I'm not familiar with it just yet, so I'm going to keep sticking with my E2s. And then from here, we're going to go to our E2 micro. So we have something nice and small. We have standard or spot for provisioning. Obviously, we're going to stick with standard. We're going to keep going down here. So let's just see what else we want. Placement policy. I mean, that could be useful, but I'm not really worried about that right now. If we want to deploy a container, obviously, it looks just like setting up a virtual machine, right? But we're not actually launching one. We're just creating a template. Here we have Debian, so that is good. That's normally what I will use. 10 gigabyte size, that is fine. Everything is good. Here we can attach a different service account if we need different permissions, of course, and then we can open up some firewall rules. Often you might want to do something like launch a Apache web server. So that might be something we might want to do. I'm just going to go look here, Apache web server GCP. I know that they have the perfect user data script for that, as we did it earlier in another video. I don't remember where we got it, but I remember I was so surprised how easy it was to find it. Maybe it was under the quick start for virtual machines. What I'm looking for here, I mean, it should be as simple as that. Yeah. So I'm going to go here and just say user data GCP, because I think their primary example, the one that I always use it, is Apache. And so let's see if we can just quickly find it, because it'll just save us some time here if we grab that. If I can find it, startup scripts maybe. Here. Yeah, perfect example. So here it is. So we had to look up startup scripts. And so we'll grab that one here. We might as well have this do something, right? So I do want to set that there. So we're going to have to just look for where it is. So I know we're going to want to open up HTTP. So we'll definitely open that up. Might as well open up HTTPS while we're here at it. That's going to add those network tags. And I mean, they should already be open, but if they're not, it'll tag the machine so that we have those for access. And so what I'm looking for here is to set up the user data. So it's not under network. Networking is fine. It's not going to be under disk. It's going to just make whatever disk it wants. Here, we don't need to affect security. That's fine. Feels like it should be under here, automation. You can choose to specify startup script. Here we go. There it is. Okay, so that will have our startup script. Other providers call them user data, so I was kind of looking for that name. And I think we are good. I don't think there's anything else for us to do here. So let's go ahead and create ourselves this instance template. Okay, and we are just waiting for that instance template to be ready. It is now ready. And if we checkbox it, we should be able to create a VM. We'll look at create an instance group separately here, but let's just make sure that we can launch a single virtual machine with this instance template. So this would be my, my Apache server. Notice that it stuck with the name of that. So it might have been smarter to name this instance template my Apache server. I'm not sure if we can change the name retroactively. I don't think we can. No, we cannot, but that's fine. I don't care. So we'll just go back here, and obviously these are Apache servers, but we'll just leave it the name here so we know exactly what it is. And notice that it's already pre-populated this stuff. And so for the most part, you can just go ahead and hit create, and it'll have all the configuration that you want, right? And so we'll just wait for that to be ready, and then we will check if we can get an Apache page from it, okay? All right, let's take a look and see if our instance is working. Now, I think I already have ports open for this, so it should just have a website. If not, we'll take a look here. Yep, there it is. So Linux startup script added directly. So this is in good working shape. I'm going to go ahead and delete this. We are going to, in the next video, focus on using that instance template to launch an instance group, okay? All right, in this video, we're going to go ahead and create ourselves an instance group. So an instance group allows us to ensure that we have a certain amount of instances running at any given time, and that if instances are, if utilization goes over a certain amount, it will spin up new instances, or it can repair damaged instances if you have health checks attached. And notice we have three. We have stateless, stateful, and unmanaged instance groups. Stateful is going to be for databases because those instances have data on them. So they have to be managed a little bit differently. As you can see, there is different information here for it, but we'll focus on stateless. I'm going to call this stateless here, so we know what we're running here. Then we will make sure we have our instance template, which just has a simple Apache server on it. Down below, notice we have single and multiple zones. I'm going to stick with single zone right now, but multiple zones would make sense if you want multiples of these running. Now, the thing is that you might, depending on what you set here, so like if you have it set to multiple zone, you have 1 to 3, it's going to have one running in every single one because it wants to have at least one in each zone. And so I just want to make sure that I run the least amount. And so I'm going to do single zone for this so that we start with 1. But here we have the maximum number as 3 instances. I'm going to leave the CPU utilization alone, but notice we could scale this based on the queue and other information here. We can turn on predictive auto scaling, but we don't need this here. We have an initialization period of 60 seconds, so 1 minute before it's ready to serve. That seems fine to me. We can tell it how to repair, but I think this would require us to have a health check. We're not going to create a health check in this video. We're going to go and proceed and create this instance group. So what I want to do is I want to see if we can trigger this to spin up other instances. So we want to first confirm that there's only one, right? We want to know where do we monitor CPU utilization. We'll go to the machine, we'll install something like a stress tool, and then we will check that. Now, instance groups will show up here, and they will eventually show up here under the VM instances, but sometimes there's a bit of a delay. So if you don't see them, just go here. So we have 0 to 1, right? And we should see 1. So it's telling you exactly what it's trying to do. I'm just going to open up this other tab here so we can kind of look at some other information while we're here. Right, so I think it's already ready. We'll go back and give this a refresh. There we go. And so we have 1 instance, right? So the idea is that we want to see CPU spike. And over here, because it was spinning up a new instance, right? But we have a, we want to be watching this information, right? Because this is going to determine if new instances are going to spike, right? So what we're going to do, go to overview here, or sorry, back to this tab here. I'll click into the first one, same page. And what I want to do is I want to go in here and SSH in, okay? So we'll SSH in, we'll install a stress tool, and from there we will figure this out. So we'll give that a moment here to connect. We'll hit authorize. We'll type in sudo apt update, sudo apt update. Sudo apt update. You got to type it right if you want it to work. If you don't do this, it might not install in the next step here. Sometimes that happens. I'm in the habit of not doing sudo apt update, but because I had a few labs here where they didn't install, now I'm getting back into a good habit here. So it shouldn't take too long for that to install here. Okay, so let's continue on here. So I want to install sudo apt install stress. I think there's a newer one called like ng, stress ng, but I haven't ever used it. It's supposed to be better. But if the old one's working, I don't see any reason why we need to change that. So we're just giving that a moment to install. I thought it'd be a lot faster than that. I'll just pause here till we're done. Okay, so this is now installed. If we want to see how many CPUs we have, I think it's like LCPU. And if we scroll on up, it should tell us that we have a certain amount. So we have CPUs 2. So that's going to help us when we want to determine how many we should run. So we're going to do stress CPU 2. We're going to time this out for 60 seconds, right? I just want to make sure as we do this is going to go up very quickly. So I want to make sure that I'm monitoring this. So I have this tab open. And oh, I haven't even done anything, and another instance has spun up. Okay, so maybe just by installing that other one, it already triggered one there. So let's go back over to here and take a look. Can we see any information here? Let's give this a nice hard refresh here. See if we get any history. And we'll go back to monitoring. Yeah, so maybe when we were doing that install there, it exceeded, because we are running a very small instance. What I'm going to do is I'm going to go ahead here. I'm just going to delete this one, right? And this, I think this was the original one. If we click into it, we should be able to observe it, assuming this was the first one and not the one we just did, right? And so totally possible that just that install alone, because again, we're using the smallest instance, caused that to spin up. Though here it is trying to spin it back up, because notice the target running size is 2 right now, right? So I'm going to go ahead and see if I can edit that back down to the value. No, I can't, not easily. We'll go back over to here. Okay. And we'll just give that a second, 1 second. And now we literally have too many instances. So we haven't even ran the stress test, but I guess that just was enough. That was enough to do it. So this is not going to really work, this test example we have. And so maybe this is where we should update the instance template. So I'm going to go here. I'm going to edit the instance template. We'll go into here. I guess we can't edit it. We have to create a similar one. So let's go ahead and create a similar one. And all I'm going to do here is choose something with more resources. So that is good. I need something larger. Let's go to standard. And maybe we'll do one here. This is obviously a lot more expensive, but it's still under. I'm going to make it a little bit larger. I'm just watching the mount here. If you're uncomfortable with this, don't do it, but this will be 30 cents. 30 cents an hour. I'll go back to a 4 here, a 4-core one. And so I'm hoping, yeah, 15 cents an hour, that this one will be a lot more predictable. So I'm going to go ahead and create this as the, what size did we use? We used a standard 4. So this is a standard 4. And we'll say Apache Web Server. So obviously a lot larger, but again, I just want to make sure that we can reliably test that out there. So we'll go back over to our instance group, wherever it is here, instance group. I don't think we can swap out the instance template, but we could try. I don't think we can though. Well, let's see what happens. So go here. Yes, we can. Okay, so we'll drop it down. We'll switch to this one. The template applies only to newly created VMs. After saving these settings, recreate the instances using the existing template. Sounds fine to me. I'm going to set this a lot higher. We'll say like 80%. I want to make it so that it's very hard for us to trigger, because obviously the one we set was just way too low. And again, if you are concerned about cost, just don't run this. Just watch me do it. We're going to go ahead and update this instance template or instance group. And I think it's updated. Let's take a look here. It still says 60% here. Did it actually take effect? Let's go ahead and edit it. If you don't trust it, go check. It's at 80%. So again, the UI might just be a little bit dated there, and it's misleading. So what I want to do is I'm going to go ahead and remove these. See, because we can remove them from the group, but I'm going to go ahead and just delete them. Yeah. And let's see if they respin up or not. Yep, so it's being deleted. And so I'm hoping that we're going to only see a single instance spin up here, but we'll find out here in just a moment. But there's no, what's this? Update VMs. What's this? An update modified instance group. Yeah, I mean, I don't want to update the VMs. I just want to see the new ones spin up in place. Okay, so we're going to wait for this to settle. It is bringing in much larger ones than I want them to. But just a moment here. So while we have too many instances, I'm just going to hang tight here because I'm just hoping that they decide after a minute or two to spin down. And so that's what I'm looking for, because obviously we have a lot of um, compute here, and this should just scale down, right? Because we can see our threshold is much larger, right? Mm-hmm. So yeah, I'm just going to hang tight and see what happens, okay? So something that's a bit confusing here is that notice that our auto scaling is at utilization 80%. If we go into here and we go to monitoring, you'll notice that here when we hover over, we are seeing capacity and utilization. So we can see here's this capacity 30%, utilization 20%. And then over here we have 60. So we have 30 because there was only, maybe at that one time there was only one machine. Yeah, so we go here, 60%. Okay, and so we see capacity is 16, utilization is 20%. So we still are really, really low overall, but we are still just waiting, again, waiting for that to spin down, because my assumption here is that it's going to spin down here, but we have to get past that 60-second window, which we have. But yeah, I'm just waiting to see what happens. All right, so after waiting several minutes, there's been a change, and so notice that one of the VMs has been deleted. And so I'm just waiting for this other one to delete as well. We'll give this a nice refresh here. So yeah, you do have to be really, really patient here, but we'll just continue waiting, okay? All right, and now we can see the other one is deleting itself. So yeah, again, patience is key here. And now we only have one. So, you know, now the target running size is this. The status is still updating. I'm just going to wait and see what the status is. And then we will go into this machine, run the stress test, and maybe actually get more predictable results. But obviously those smaller instances are a lot more finicky, eh? And less than 10 seconds, I refreshed and it says it's ready. So now what we can do is we can go back into our instance here. We'll SSH in, right? And we're going to try to run that stress test again. And we're trying to trigger stuff to start. Now this thing I think has 4 CPUs, but we'll take a look here and see what we have. So say sudo apt install stress, or sorry, sudo apt update first. And we will run our update. Once our update is complete, there we go, we can go ahead and do the next step. So we'll be sudo apt install stress -y. Let's give the -y flag so we don't have to deal with anything here, and we'll get that installed. And now I'm going to check how many CPUs we have. So we do ls CPU. I'm going to scroll on up. And here we can see 4. So we have 4 CPUs. So the command should be, I know it's stress. It's stress hyphen CPU 4, and then it's the duration. I can't remember the flag. 1 second. Let me go find it. Right, the flag is timeout. Okay, I was going to say duration, but it's timeout. I guess we could check the man as well. And so we'll set it for 60 seconds. We'll go ahead and hit enter. And so now that is running, and it should be stressing those out. The question is it going to stress them enough? So let's go over to our monitoring and see if we can see what's happening here. So, and it's still not even showing that it's spun down those other instances. You can see like it takes forever to get information here before we can see what's going on here, right? Because obviously we aren't running 3 instances, it's gone down, right? So just be aware that this stuff is a bit, you know, not up to the minute, right? Okay. And yeah, even here, it's hard to see like what is happening, right? But obviously our CPU usage is going up. I mean, it has to be, right? So we're going to go into that actual instance and take a look at the observability here on the CPU and see if we can see that information. So it's showing very little information, but we'll go over to here. And so it ran, and I'm hoping that that might have triggered one to start up. And it did, so we have another instance spun up. So hopefully that is a clear way. I wish I could show you a much more easier way to track the usage there. I think if we could run this in the background, then it would be easier for us to monitor the CPU usage. But right now, that's a little bit difficult. I wonder if there is a way. Can we? I'm going to go ask ChatGPT. Can you run stress in the background? Because maybe there's like a flag for it. Yeah, they just say ampersand, right? So I guess if we did that, we say stress ampersand. I didn't know that you could put an ampersand on the end there, but that kind of makes sense. And we do this. Okay, so I'm assuming it's running in the background. So check current CPU utilization in W. I'm going to see if it can give me a, I'm just doing this off screen. Can we get a command for that? I guess it's just asking for top. That's true. Yeah, we'll just use top. And so we can see that they're running and we're seeing CPU utilization and it's maxing the utilization out. So yeah, it will absolutely make sure that it will spin up another resource. So that is pretty darn clear. I'm going to go ahead and close that out. So yeah, we successfully used a scaling policy. And I'm going to go ahead and just get rid of this instance group. But obviously we can explore other instance groups like the managed or the stateful ones. We could have converted this one, I think, over to stateful. I think I saw an option for that. If I can find our instance group, 1 second here. Right, so if we were to go into here, we can convert this and make it stateful. That's going to allow us to preserve the storage, but we'll worry about that in a separate video. I'm just going to get rid of this instance group. And yeah, just realize that no matter what the provider is, AWS, Azure, GCP, monitoring this stuff in real time is always hard and there's always that delay. So there's always a bit of, did I do it right? And so you just have to have a lot of confidence and patience, or be doing this every day to really keep track of it. It's not unusual to not know what's going on here, okay? But let's go ahead and delete that, and I will see you in the next one, okay? All right, so what I want to do in this video is I want to launch a instance template, or sorry, an instance group from an instance template, and we want to use a health check and see if we can get it to become unhealthy and it to spin a replacement machine. So we have two instance templates here, one with an E2 micro and an E2 standard 4. I'm going to just use the E2 micro, and we're going to go ahead and create a new instance group. So here, this will just be, we'll just say like health check, so we know what we're doing with this one and we don't forget. And this is going to be stateless, which is fine. We will select the first template, not the very expensive one, but this one here. And I'm going to have this a single zone, which is totally fine here today. I will leave this alone. I really only want one instance ever at any given time. So this means the autoscaler cannot add or remove. That is totally what I want. So that is fine. We obviously don't need a signal because it's not going to matter in this case. But what I want is to do something with the VM instance lifecycle. So we do want it to repair, and we're going to set up a health check. So we'll create a health check, and this will be ensure HTTP 80 is okay. Okay, so here you can see we can change the protocol. We have TCP, but I'll switch to HTTP because that's really what we're doing here. And the scope doesn't matter where it's coming from, but you can set if you want to change the scope from another location, like, hey, does it work here? Does it work there? But anyway, it's going to be global. And I suppose, yeah, we're not doing any proxy, so we'll leave it alone. And it will literally just be this endpoint. So that is totally fine. Then down below, we have the health criteria, health check. So we have check intervals of 5 seconds, timeout with 5 seconds, healthy threshold 2. So this stuff can add up really quick. So you have to think like, okay, if the timeout is 5 seconds and the check interval is 5 seconds and there's a health threshold of whatever, then it's like 5-10 seconds. But it's actually pretty fast compared to other providers' defaults. So actually, I'm fine with that. And oh yeah, we can't do that. So we'll say ensure HTTP okay. 80. I'll just say HTTP because HTTP is port 80. So we'll go ahead and save that. Because the health check will replace unhealthy instances, you may want to increase the check interval to at least 10 seconds and the unhealthy threshold at least 3 times so your instances aren't replaced too often. I don't care, but that is an okay suggestion. But if we want something really fast, we can do that. This initial delay means after it's booted up, wait this amount of time because let's say the instance isn't ready, it has to install something like Apache, and that takes a certain amount of time. This is where you might want to increase it. Then here we have on failed health check. What do you want to do? The default action. which is up here, which should replace it, or we could be explicit and just say repair the instance. I'm going to be explicit and say repair the instance. To use auto healing, configure firewall rules. This will allow the health check to connect to the VM instance in the group. Now, we already have port 80 open, so this shouldn't be an issue because it's checking from the internet. It's going to ping it, right? Update during the VM instance repair. Keep the same instance configuration. Recreate the VM with the same instance template or update it. Apply the latest instance template. Generally, you'd want to do the latest instance template, but I didn't see earlier when we made our instance template, I didn't see us having the ability to make iterations, so maybe I missed it. Let's go back and take a look here. Because I went here, right? And I said, clicked into it. I said create similar, right? I didn't see a place to update latest. So unless I'm mistaken and I don't understand what I'm doing here, I'm going to go check the actions here. Yeah, I would assume that you'd have to choose another one. So maybe there is a way. Keep the instance configuration, apply the latest instance template. Okay, so just give me a second here. This is why I'm confused because instance templates are immutable. You cannot make new ones. So if I go here, yeah, I'm not sure what we're doing there, but we'll leave it the same here. To send traffic to instance group through a named port, you can do that. I'm not going to do that here. I'm going to leave that alone. And I'm going to go ahead and I think everything's ready. And I have one instance, so this should be fine. We'll go ahead and create it. Okay, and the question is, how are we going to observe the health checks? Now down below, we have a tab for health checks, right? And notice that it's not in use yet, so we're just waiting for that to show up here. So now it's showing that it's in use. Okay. But what I want to observe is the instance group when the health check is updated that the health check is taking effect. So here it's going from 0 to 1, and so we are just waiting for it to go 0 to 1. It shouldn't take too long. Okay, and when it is there, I'll just pause here. So I've refreshed, and now I have a 1. We'll go into here, and right away we have a status effect problem. So it's saying what? It's 0% healthy right now. The VM is being verified. So not necessarily that it's unhealthy, but it's still verifying the check. Okay. Now, while this is going, I'm going to go ahead here and just open this tab here. I just want to manually verify myself because it should be available, right? The this instance here, it should. Let's go back here. Sorry, I clicked into the instance group. I meant to go here and check the external IP address. And so we want to make sure that here we are getting. Oh, look at that. We can't see our website. Now that I think about it, when we created that instance template, did we put in the metadata for it? I think we did, right? Because otherwise, how? Oh, there it is. Okay, so now it just came up. I think we'll give it another refresh. It's interesting it's not showing the page we created, but at the very least, we're getting that page now, which is fine. And so now it's 100% healthy, okay? So that's good. It's 100% healthy. Let's go ahead and stop Apache. So I'm going to go ahead here, and I'm going to SSH in. I'm going to say authorize. We'll give that a moment as we are connecting. I'm going to go ahead here and stop Apache. So I think it's going to be like sudo system. I'm just guessing. Sudo system ctl Apache. Oh, what happened here? The min replica is equal to the max. This means the autoscaler cannot add or remove instances from the instance group. Make sure the setting is correct. Yeah, that's correct because we don't want we don't ever want it to be 0, so that should be fine. So we'll go ahead and say sudo system Apache sudo system Apache stop. Sudo system L stop Apache 2, there we go. And then I'll just do a status on this. Again, I'm just guessing this. I've done this so many times. I just kind of guess. And another way we can test if it's down here. Oops. I can just do a curl to localhost 80 here. Okay, or we'll just say HTTP colon 0000. Right, and so I believe we should have checked if it was running first before we ran that command, but I believe now it should be become unhealthy. And it says instance by health is now unhealthy, right? Which is good, because that's what we were trying to do. So we'll give this a nice refresh here. And so now it's 0. So what I'm waiting for is I want to see if it's going to replace this instance. Okay, but we'll see what happens because now it's not running. So I'm just going to hang tight, okay? All right, so here you can definitely see now the instance is red and this is 0%. I'm going to give this a nice refresh here. And so what I'm hoping is that it's going to try to replace the instance. But I don't see it doing that. So I'm going to hang tight here and have some patience here. And I'll investigate this. I don't think that's the case because other providers, it doesn't matter if it's 1 because it still has to replace it somehow. But just a moment, okay? All right, so after refreshing and waiting more minutes, now we can see that we have an instance. So despite this message being here, again, this refers to scaling up or down for capacity based on that stuff. And, you know, the rule stands the same. Be patient and observe. And then once you get comfortable with that, then that's fine. But if you do end up having a larger workload, make sure that you test your workloads so that when you do have a problem, you have an idea what it's going to look like. Because this stuff is very hard to get a feel for against new workloads. So I'm going to go ahead and delete this and the instance group. And so we have now successfully used a health check. Will it delete the health check? I don't know. I'm going to go ahead and I don't think it costs anything to have these here because they'll just be out of use here in a moment. I don't think these cost anything, but if you don't like it, you can delete it, but you have to wait for the instance group to vanish, okay? Ciao, ciao. Hey folks, it's Andrew, and we're going to continue on learning about Compute Engine or working with Compute Engine. And I think what I would like to do is set up multiple instances and start using a load balancer. So we want to use an application load balancer. It might be just under the load balancers here. Yeah, it's under the load balancing services. And so we'll make our way over to here. And we can see that we have this. I don't want to get confused with Cloud Load Balancer. Let me just make sure that's the same thing. Yeah, like if we go over to here, I think that just turns on the API for the service. Go over to here. Yeah, it's the same place, okay? So Cloud Load Balancer, load balancing, it's over here under load balancing. So we're going to go ahead and create ourselves a load balancer. We have an application load balancer and a network load balancer. Application load balancer works on the HTTP and HTTPS. Layer 7. Network load balancer is layer 3 and layer 4. When you have things that have higher throughput, UDP and TCP, like maybe a video game server or something like that, you're going to be doing that for your standard web applications. Application load balancer is great, especially if you want to route things based on HTTP metadata or information in the packet. Let's go ahead and hit next. We have public or internal. I'm going to go with public today. We're going to go next here. We have best for global workloads or best for regional workloads. I don't need anything crazy, so I'm just going to go regional here today. And I want to go ahead and configure. To proceed, you must make a selection in every step of the workflow. I thought I did. Next right here, that's why. And we'll go ahead and create our load balancer. So we are creating our load balancer. This will be my Apache web server load balancer. As per usual, we're going to launch this into Toronto, as that is the closest major Canadian city to me, 1,000 kilometers away, more than 1,000 kilometers away. We'll drop down here. We have our different VPCs. We're going to just use the default one, so our life is really easy. Proxy only subnet, it's required, so I guess we'll just reserve one. We'll just add a proxy only subnet for this region, sure. But what IP address do I have to use? That's always the tricky part. So 1 second here. Maybe I will launch this into my new VPC. Before we do that, let's make our way over to here and take a look at our to our VPC. I'm really bad at networking. I'm just going to put that out there. I never can remember stuff. But we'll go here and we'll take a look, because what I'm looking for is our subnets, right? Because we have a heck of a lot of subnets here, and this is just too many. I don't need to have this many, and it's just because I use this as the default. So what I'm going to do here is I'm going to find Toronto in here, which is Northeast 2. I can just keep the Canadian ones. You can have whatever you want, but I'm going to go ahead and just delete these. So my life is super, super easy. Okay. North America, yeah. So we'll go here. That's all I want is that. So we'll go here and just keep deleting. If you did our VPC section, you should have done it earlier. You would have had this. This is when we created my new VPC. If you don't have that, go do that. Or create yourself a new VPC. At this point, you should know how to create your own VPC. And we should be able to delete these. Can we not? What? Oh, can I not just... Let me try this again. Can I delete them? Oh, subnets can't be deleted. To delete the subnet, switch the network subnet creation mode to custom. Okay, well, if that's the case, then what I'm going to do, instead of using this one, I'll use my manual one, because my manual one, this one is going to be less of a problem. I thought maybe we could use the new one, because I don't really use that one that much. We'll go over to subnets, and we have here too. We have 10.0.0.24, 10.0.1.0.24, and so I'm going to go over to here, and this will just be my... I'll go back over here, which is the manual one. Yeah, that's where we were. Yeah, here it is. Okay, so I click here, and I'll call this load balancing ALB application load balancer proxy subnet, and we'll go here. We'll say 10.0.2.0/2024. Okay, all I know how to do is increment the numbers. My math is not very good with this stuff. Even though I got a whole course on it, it just doesn't stay in my head if you don't do it every day. My buddy Tim, who's a network engineer, he knows this stuff off the top of his head, but I don't. So we have that set here. It's creating that proxy-only subnet for us. Specify an IP address, port, and protocol. This IP address is the front-end IP address for your application. That sounds good to me. So a name, so just be like HTTP public. Okay, we are going to do that HTTP. You can do premium or standard. I'm going to stick it premium. Port 80 is correct. Ephemeral means that it's going to only exist for the time of, but we can create a static IP. You ideally would probably want to create a static IP. Just say ALB static. We'll delete that later, but I would definitely create one. Like, no questions about it. And we'll just give that a moment. Let's take a look at some of our advanced features. Don't care about that. We'll hit done. So our front end's configured. It's going to watch on that. Let's go to our back end. Select or create a backend service. So we'll go ahead and we'll create a backend service. So my backend, and notice right away it wants an instance group, right? Okay. We do have other options here, but an instance group is what we're going to need. So I'm going to go over to here and we'll make ourselves an instance group so we aren't getting stuck in the weeds here. We'll go to instance template. I like to always go from instance template. And so we have the E2 micro and the standard one. We're going to make one from here. And I'm going to create an instance group. And this will just be my Apache server. And this is regional, which is fine. And what I'm going to do is choose the first one. So that's the cheap one. I'm going to go multi-zone this time, and we're going to have 3, because if you're going to have a load balancer, you want to be able to distribute things other places. Because it's even, I think it's when it's even. I'm not sure about balance, but the idea is that there are 3 zones. It'll probably spin up 3, okay? So I'm going to go here and say 1 to 3. All right. And everything else is fine. We could put health checks in here. We probably should, because it is a web server. So I already have this one from before. I never deleted it. I created that in the prior video for instance groups with health checks. If you didn't watch that one, go watch that one. Very easy to make one. I'm not going to make a new one here. This one seems fine. Repair the instance if there's a problem with it. We'll go ahead and we'll create this, okay? So we will create this instance group. I'm not sure if we have to fully wait, but we'll go here. Yeah, instance group, HTTP, timeout, and we'll go here and can we see it? What we might be able to do is delete out the backend and re-add it. Add the backend. I'm waiting for this instance group to appear, right? So we'll just wait for this to become available, okay? All right, our instance is, our instance group should be ready here. Let's give it a refresh. It only spun up 1, that's good. I don't know, I keep thinking that it's gonna spin up 3 because we have those, but if it only spins up 1, that's actually perfect. But generally in my experience, every time I do that, I end up with multiple ones, but maybe because of the utilization was set lower, well, that's fine, whatever. So we'll go back over to here, and I'm trying to find it. I really hope I don't have to remake this whole thing. That'd be kind of frustrating. There it is. Okay, good. So now we have my Apache server here, and we could set it single or dual stack. We're obviously using only IPv4 here today. The port numbers is going to be 80 because that's what our stuff is running on. Then we have our balancing mode. So we have utilization, rate, or custom metric. I guess utilization is fine, and yeah, I'm fine with that. So we'll leave it at 80% per instance. Do I have to set that? The target request per second for individuals. Oof, please let me just go forward. And so let me just make sure that we just have this one here. Okay, so we have this one here, good. And so I'll go over to here. And that other health check's already in use. So maybe what I should have done, I'll go back over to this one here, our Apache web server here. I'm going to detach the health check from here, if it'll let me. So I'll go back over to here. And can I detach it? No health check. Okay, so we'll go ahead and save that. I suppose we could have both, but like, let's have the load balancer do it because why have both do them? And so we'll wait for that to become available, okay? All right, let's take a look and see if our health check is available here. I don't see it, so I'll just create a new one. It's not that big of a deal. So we'll just say my new health check. This will be on protocol HTTP. Proxy none, request is fine here, default values are fine. That's going to tell us, well, that's a little bit aggressive, but we're going to leave it as a default. So we want this to occur very quickly. We can enable logging. It's probably not a bad idea, but I'm just going to leave that alone here for now. The default security group is fine. Yep, that is fine. I'm fine with that. Let's take a look at advanced configurations. If we wanted to set a session affinity, we could. Not something that we need to do because we don't need to persist any of this information to our machines. Round robin seems fine to me. Each healthy backend is selected in a round robin order, so that is a good default, I think, there. Setting controlling eviction of unhealthy hosts from the load balancing pool. Now we'll leave that alone. We'll go ahead and hit create. So that is there. So writing rules. So here we can add additional rules, right? So here's the host. Yeah, path. So I guess if we want to set a path, we could do that. These are just simple ones. Probably advanced ones are probably more interesting because here we could use the path matcher language. We'll need some code guidance for that. But the idea is that, you know, if let's say you wanted to route something for something in particular. So like, let's say you needed to reroute a URL, you could do that. Yeah, I guess there's other ones down here below. Right, so we're not going to get anything super advanced right now. I'll hold this out for another video, but we'll just keep it simple. So right now, we're just trying to have a load balancer and have it work for multiple machines. So this looks fine by me. We'll go ahead and create this. And so now we're creating that load balancer. And the idea is that we have that single point of entry. Probably would have been interesting is if we actually deployed each instance and it said its name, and then we could have saw if it would where it would route traffic. But if we can just get a load balancer to go to our instance, I think that's good enough for our basics into application load balancer. And yeah, now notice we have 2 instances. So do we have 3 now? Let me see. Do we have 3? Nope, just 2. Okay. Why do we have 2? I don't know. Maybe the first one was unhealthy. I don't know. I find, well, just in general, I find scaling, and I've been doing this for like 10 years. I just find figuring out scaling to be very, very tricky. So yeah, when I have a workload online, what I will do is I will figure out what the predictable workload is, and I'll try to stress it out in different ways. And then, you know, that way I'll know what I'm working with in production. So it says that it's been created. We'll click into it. And so it has the static IP address, which is here. That's our front end. And so all I want to do, I don't need the 80 in there, but all I want to do is I want to see if I go here, can I see my web application? Is it load balancing to my web application? I guess the other question, is it healthy yet? So yeah, healthy, 2 of 2. So it's saying that they're healthy. And let's just make sure this is using HTTP because it might try to use HTTPS for some weird reason. But this should resolve. Okay. Now, sometimes it gives you a false flag there. So what I'm going to do is open Cloud Shell. And I'm just going to curl it because sometimes I don't trust the DNS resolving here. And so I will use curl definitively to know if it's working or not. So we'll say curl, and then we'll paste in that IP address. And it will already go to port 80. And so what I'm looking for is the HTML page to return back. Now we do have something now. So it did have a stream timeout. Okay, maybe we're just not being patient enough for this to be ready. But this should work. Okay. So capacity 100%, selected ports 80, preference level, max backend, etc. So yeah, stream timeout. Just a moment. I think again we might just have to be patient here, but let me go. So what I'm going to do is I'm just going to wait a few minutes, and I'm just going to revisit this here. So I'm going to pause and give it like I don't know 3-4 minutes because we do have. I mean that's a connection draining timeout. That's when you are getting rid of machines, but we have a 30-second timeout up here. But I'm just going to wait, okay? I'm going to be patient here. I'm going to wait a little bit, and we'll see what happens. All right, so it's still not working. Also, I want to point out that our instance is now back to 1. Why it scaled up that other time, I don't know. So I guess we're going to have to kind of debug this here. So we have a backend here that's set up for this, and we have our front end that's specifically on this port. This, we have a route specifically, all unmatched defaults go to my backend. So it should be pointing here. We do have a health check on this, and we can see that it's healthy, 2 of 2. There aren't 2 anymore. Let's go take a look and give this a refresh. We'll give this here a refresh here. And we'll scroll on down, 1 of 1. Okay, good. So it's clearly saying like the backend's healthy, right? And so that should be a non-issue. And this is on HTTP. So one thing we can do, I mean, like we know the web server is working, but let's just make sure that it is. And I'm going to go to that individual web server here. And we'll just curl that. So let's say curl. And we get the HTML back, right? So our problem really is between this and that. So yeah, I'm still not sure as to why, but give me a moment and I'll figure it out, okay? All right, so I can't seem to figure out why it's doing that, but one thing we might be able to do is turn on logs, and maybe logs will help us see what's going on here. So I'm pretty sure there is an option for logs somewhere. Let's go back over to here. And this, by the way, this proxy is specifically for envoys when you're doing GKE, like with Kubernetes, so I wouldn't worry about that. But I could have swore there was an option for logs, unless I'm crazy here. Let's go back here and let's see if we can see here. Let's go this one here. I'm not going to actually make one. I'm just going through it to see if I missed an option here. And yeah, public facing, regional, next, configure. I thought there was an option for logging. Maybe I'm just mistaken and there is no logging. Okay. Because right now stuff is not reaching. Or it's, we could try it again. Maybe it works now for no reason. Nope, just stream timeout. Okay, so I'm still not sure what's wrong with it. Just give me a moment. I'll try to fix it again. There is also the security group here. And so this is using Cloud Armor. And this allows you to set rules at the application layer. And so there could be something here that's causing it to filter out. I guess there are logs over here. I'm not sure if it would show up under policy logs, but we could take a look. And yeah, I'm not, this query stuff is never very useful to find stuff here. And region USC's 2. So yeah, I'm not sure if that's really doing anything there. Okay. But the point is that it says allow from everywhere. So there's no reason that it shouldn't work, right? Because if it's saying allow, there is a throttle option here, default rate limiting. So I don't think it's the throttling. I could delete it. You really don't want to delete your throttling because that's really, really useful. But I can delete it and see if that resolves our issue. Not like there'd be much hitting this page anyway. Yeah, so that didn't fix anything. So there was really no reason to delete our throttle there. But let me go and see if I can figure out what the problem is, okay? I haven't solved the problem, but I just wanted to point out that that logging thing I was looking for was actually when you set up the backend service over here, and we could turn that on, but I'm not sure if it's even reaching that point. But we could enable it and see if we could find anything whatsoever. So I'm going to go here back to our backend configuration. I'll edit it. We'll go down below and we'll enable logging. The sample rate gets log. You can specify 0 to 1. I would think that we'd want the sample rate to be 1, right? The idea is that you don't always want to include everything. And so 1, I think, is maybe what we'd want it to be. I'm going to go ahead and hit update and we'll update that. Another interesting thing, yes, we want to update that. Another interesting thing is that while I was looking for it, someone's like, yeah, I'm having the same problem. I'm having stream timeout. I don't know why it's happening. And then their solution was, I'm using a regional external application load balancer. When I switched to global external, it was fixed. And I'm like, okay, but why would that matter? It should still work. Another thing that might matter is like, is our workload, is everything in the same region? But it'd have to be, because otherwise how would we do it? So this is Northeast, North America, Northeast 2. I'll go over to instance groups, right? And if we go here, this is North America, Northeast 2, same thing. Is there 3 now for some reason? Nope, just 1, okay. I like how the UI is very, very confusing. Here's this three of 3. I guess it's just saying what locations there are, not how many instances there are, so that's just me. And so if we turn on our load balancer, now there should be logging, but where can we see that logging, right? We'll go back here for a second. And sample rate 1 of 1. So, I would think, if we're hitting these here, this would appear somewhere. But even if we have that logging turned on, it's like, where is it, right? So I'm not sure how much that's going to help us, having that turned on, to be honest. We could go to logs, I suppose, logs. But where and how are we going to find that? So that's great and all. We've turned it on, but I'm not sure I'm going to be able to find it. Another thing that was being suggested, but this is LLMs, and LLMs aren't smart. They're like, well, you're supposed to use standard with regional and premium with global. I'm like, well, then why would they let you set it? That makes no sense, right? So I can't imagine that's the problem, right? So if we go here, and maybe was it the front end or the back end? Yes, it's premium network service. I can't imagine that's the problem, right? Like if we switch this to the standard network, but we can try for fun here. Why not? Like we're at our wit's end, so why not try? So just say HTTP basic. And then here I'm going to switch it to, here. Well, this one says Google's high quality global backbone entering and exiting the Google Edge peering closest peers. And here we have standard. Traffic enters and exits the Google networking at a peer location. I mean, technically it's regional, so that makes more sense. I'm going to go with a ephemeral number. I'm going to ignore the static IP address this time. I'm going to hit done. And so we're going to swap that out and see if that makes any difference. Not sure as to why that would make a difference. But again, just trying to throw things at it, try to figure out how to make it work. I mean, we could try to make it global, which seems really silly. I don't think you can just change it to be, I know it's still updating, but I don't think you can go and just, change it after the fact and make it global. But we will see here. I'm not sure why it's asking us to adjust those, as I haven't changed it. But we're going to wait for this to update, and we'll try with the new IP address that's not a static IP, okay? I think it's actually done now. Let's go back here to this load balancer. And yeah, it has 1 backend supported. If that's the change that makes it work, I'll be really happy. But here we have an IP address here, right? So I'm going to go over the top here. Okay, so it's a different one this time. And again, I'm going to go and try to open up, must have a session open somewhere here. Here it is. Close this out here. Let's close out some of our tabs so we have less confusion going on. And I'll just give this a nice refresh here. I do not have, I do not have it open anywhere else, but it won't let me, it won't let me get to G-Cloud now, which is, it's just great. Google is great sometimes, the UI is just, the experience is just amazing. So we're going to go back over to load balancers here, because I was going to try to ping it from Cloud Shell, but, oh, you know what? It's actually down here. It's just down at the bottom. Open a new window. No, I just want to restore it. There we go. Reconnect. Here we go. And we'll try this again. We'll say curl. Stream timeout. So yeah, I'm not sure as to why it's not working. This is very, very frustrating for me, but you know what I'm going to do? I mean, it's dumb, but we're going to go ahead. We're going to delete. We're going to make a global load balancer. Global load balancer is fine. We'll go ahead and delete these two things. But if that works, that's fine. But I'm just showing you the real experience, what it's like trying to figure this stuff out. We'll go ahead and we'll create a new one. We'll do application load balancer. We'll hit next. We'll have it public facing. We'll say next. We'll choose global. We'll hit next. Best for global workloads. Global external application load balancer. Next, we'll create this load balancer, okay? We'll go here. We'll say my basic HTTP. We'll have it set as that, IPv4. We'll leave it ephemeral this time. We'll go to the backend. We'll drop this down. We'll create a backend service. This will be my backend. This will be an instance group. We will let it be IPv4. We will select our Apache group. We'll leave it to utilization. This is all fine. I don't want to fiddle with that, so I'll let it be whatever it is. Here we have Cloud CDN. I don't really want a Cloud CDN. It's a paid product that accelerates the web content. Yeah, it's fine. I mean, a CDN is a good idea. I guess we could just take a look at the pricing here before we do it. Can we find the pricing? It's all the way down here. It's pretty low, but then we're waiting for that to spin up. Yeah, I don't want Cloud CDN right now. We could always do it later. We'll choose our health check, assuming that one sticks around. I think I had that one from before, whatever. We'll enable logging, why not, right? Though I don't, oh, here it is. No, that's just not it. I thought it would tell us where it is. We have our backend policy, which allows us to work with stuff here. Name already in use, we'll just call it number 2. I don't care. We will go drop this down. Everything else is fine. Everything else is fine. We'll go ahead and click create. Okay, we'll say okay. That looks fine to me. Only backend services created for HTTPS load balancing advanced traffic management will be visible. Backend services created for classic HTTPS load balancer cannot be used. That's fine. I don't care. We'll go to our next step here. Simple host path. Yep, leave it alone. We'll hit create. My global ALB. We'll go ahead and create it. We'll give it a moment here to spin up, okay? All right, here is our load balancer, application global load balancer. We'll like the regional one, but that's fine. We'll go ahead to the top here, grab our IP address, please work. And we'll just go here and say HTTP, make sure that it's using HTTP protocol, can't be reached. Hey, it's better than before where we were getting different information, right? So let's go back and open up Cloud Shell. Because that stream timeout was really annoying. We'll go ahead and we'll do a curl on this. And put the protocol in front of it here, HTTP. Empty reply from the server. So we'll go down below and we have that there. Our backend is HTTP, so it's on port 80, right? So that should work. We do not have Cloud CDN, which is fine. We'll go ahead, curl that. Come on, let's go here. It goes to our backend. It must work, right? We can take a look at our security policy, I suppose. Let's take a look here. Yeah, it's fine. Everything looks fine. Yep. Just a second. All right, so I just waited a few minutes. I went back and refreshed, and now it's working. So just had to have patience there. Again, I'm not sure what the issues were with the regional ALB, but at the very least, you saw some of the debugging processes that I would go through to try and solve that problem. If I really wanted that regional ALB to work, I'd probably go out and reach out to Google support and go, hey, what am I doing? I got everything set correctly, because there's no LLMs, there's no information online to walk you through that particular issue. But hey, at least we got a global load balancer. It really just depends on what your needs are. And I think I'm fully done with this. So we'll go ahead and we'll delete our load balancer. We'll get rid of the backend service, the health checks as that thing is working. Cloud CDN is not a bad idea to attach to it, but I didn't want to overcomplicate that. Maybe when we come back to ALB, we'll launch that with a Cloud CDN if we need to show off Cloud CDN. I want to make sure that I don't have any IP addresses that are just hanging around. So I'm going to go over to VPC Networks here. We're going to go into our IP addresses, and we'll go over to external. And so we do have this one here, and it's not in use. So I'm going to go ahead and make sure that I release it because I just don't want these to, I don't want these to stick around. Okay, so we'll get rid of that one. These ones are obviously going to vanish. And again, just checking, making sure that I don't have any that are not supposed to be around. The other thing is I want to get rid of our instance group. So we'll make our way over to our instance group here. Okay, and from here, I'm going to go ahead and we will get rid of that. We'll click into it. Sometimes they have the 3 dots, sometimes they don't. You got to click in sometimes. Not sure why their UI is so inconsistent, but there you go. So we were able to do a global ALB. Okay, ciao, ciao. VM Manager is a suite of tools for managing OS updates and compliance across virtual machines running on Google Cloud, mainly Windows and Linux on Compute Engine. So the VM Manager suite includes these services. So we have Patch, OS Inventory, and OS Policies. We do a lab, so it becomes very straightforward. I thought this was going to be a lot more complicated than it was, but it's a very simple service. There are 2 ways to enable VM Manager: automatic, project-wide, manual per specific virtual machine or project-wide. And so, you can see VM Manager there as the means for it to work. In terms of configuration, for OS config agents for functions, you have Patch, you have OS Inventory, you have OS Policies. You can also use Terraform to extend VM Manager across multiple projects in your Google Cloud organization. But again, very simple service, and we'll give it a go. Hey folks, it's Andrew. In this video, we're going to be taking a look at VM Manager. So VM Manager is a way to manage your virtual machines by allowing you to patch VMs with security updates, set up policies to make sure things are enforced correctly, take inventory of what is installed on your virtual machines, and being able to run automated scripts against them to do configuration, things like that. So if you've ever used something like, let's say, a simple systems manager, it's something equivalent. So I'm here in Compute Engine. I have never used this before, but I understand the concepts of it. So we're going to kind of stumble our way through it here, and I'm going to make it look like I know what I'm doing. But under here, we have VM Manager, and so we have Patch, and then we have OS Policies. We are going to need to enable the functionality here, and I think it says, enable full manager functionality. So the first 100 VMs are free of cost. Sounds good. We're going to go enable that. And so now it's enabled. All right. And so I'm going to imagine that if we launch some VM instances, we'll be able to see some stuff. And so it looks like I actually am running a server. I'm not sure if I am running a server. Let's go take a look here. I am running a server, and my Apache server, why am I running a server? I don't remember why. So I'm going to go ahead and just delete this. If that's all right. Am I running an instance group that maybe didn't shut down or something? Let me take a look here quickly. Yeah, looks like I am. That's probably why. So that's okay. I mean, as long as we have something running, I'll start another instance for fun here, just so that we have 2. You can just start 1 if you want. I'm going to go over to Toronto here. I'm going to go to E2. I'm going to choose an E2 micro. We're going to go ahead and just go and create that. Not setting anything else on it. We're just going to spin that up. Let's go back here on the left-hand side to VM Manager and see if we can do anything with it. I mean, I think I'd be mostly interested in setting configuration with it, but I'm not exactly sure how to do that. I know that in order to use VM Manager, you have to have some kind of agent installed. I think it's called OS Config Agent, and so that is going to be something that we're going to need. But let's see if we can go figure this out. So one thing I want to know is, like, do I already have the OS config installed? So that's going to be something like how do I install the OS? Actually, you know what? I think when we launch a virtual machine, we might even have an option to select it. So I'm going to go back over here. I know I already launched one, but let's go here and just carefully look and go to observability. So you have ops agent. Maybe that's not what I was thinking of. Advance. And so I'm just looking to see if there's something additional that I'm supposed to checkbox. I don't think so. I don't think so. So give me a second. I want to make sure that we can monitor these things using VM Manager. Okay, so just give me just a moment, all right? All right, so in the docs, we're talking about the OS config agent, and so I guess we can go inside there and take a look if it actually exists. So I've obviously just spinned up a Debian machine. I'm hoping that it just comes pre-installed. That'd be really sweet. And so this server is not supposed to be here. It's not spinning down for some reason, but I'm going to SSH into the new one. I don't mind having the other VM around here. And what we'll do is we'll go here, we'll copy this line, and we'll see if it's already pre-installed. If it is, we're in good shape. If we're not, well. So I'm going to go ahead here and just give this, whoops, a paste. It did not take as I hoped, so I'm going to just try that again. There we go, we'll hit enter. And so it's saying command not found. I mean, sudo systemctl should be there, but I think it's because it pasted in a bunch of other stuff I didn't want, so we'll just make sure that's correct. And it's already active and running, so I guess if we're using some of those base images, we're going to already have that in place. And so we're in good shape because we are seeing that it is available there. But if it wasn't there, it looks like there are steps to install it. And it's as simple as that. Wow, that's really, really easy. For AWS, their agent, not so easy. But that's good. You can either set the instance metadata on each VM. That's another thing that matters. I think that in order for it to track it, it also has to have that metadata there. Or it should have it on there. Let's go take a look at the instance and see if there's any metadata. So yeah, so here it says enable OS config. So I didn't set that, but because it's already installed and the VM manager is on there, that's going to be there. We already had an instance over here. Would this one actually have that tag, or would it just not be there? So notice that this one does not have it, and maybe because before we turned on VM Manager, it wasn't there. So if you have existing ones, then you'd probably have to add that tag for it to take effect. So this one is basically not being tracked. So it's kind of nice that we had that one around because now we know of that edge case. Okay, but I want to actually do something with the VM Manager. It's great that we have it installed. Patching seems kind of boring to me. I would like to apply some configuration if that's possible. I thought that's what we could do with this thing. But give me 1 second. Let's see if I can find it, okay? And I would say I'm not really finding it. Older docs point to the OS config API to turn it on. We obviously just pressed the button. It probably turned on those for us underneath. So really, we just have those two things to work with. But maybe we were doing that through the OS policies. Maybe we should try to do a patch first and see what happens. Let's go ahead and create a patch job. Again, never done this before, but it can't be that hard. Select VM instances for filters or select them manually. We'll go ahead and select it. And obviously, we'll do this one. Other updates available. So there are some statuses here. Notice we don't have any information, but again, OS config is not enabled for that one, so we'll checkbox that one. We just spun it up, so I'm not sure what it would need. You might not have any information here because, at the time of deploying. This will force the patch to run on instances for managed instance groups. We're not worried about that. We'll call this my patch. Okay, we're gonna go over here to Debian. Okay, so my Debian patch. Oh, cool. So like if you need to do an apt-get update, you can do that. So we have patch parameters, and we can select updates. List of updates that will be included in the deployment. Okay, that's cool. List of updates that will not be included. So maybe we want to say don't do these ones or specifically update those ones. But I'm just going to do the standard apt-get update. It's not a bad idea. Oh, we can run it right now? Yeah, let's do that. One zone at a time, sure. There's no percentage of, because we have one. Just going to do that here. Post and batch reboot. The agent will decide if the reboot is necessary. Good. That's good question. Pre and post scripts run before patching starts. Reboot if required. So I guess here we could be attaching from a bucket, probably a bash script, and then a post script. I don't have any interest in doing that here today, but that's cool that you could do it. I guess that if you wanted to do anything, like even if it wasn't specifically just updating something, but you wanted to, like let's say install something, maybe you could do that, eh? Probably, I'm not sure if that'd be the proper use case, but you definitely could do it. So what we're looking for is the job done? Now, it's supposed to happen pretty darn quick. It says duration 1 hour. I'm not sure why it would take that long. We'll give this a nice refresh here. And what I want to see, it did a run. So 20% complete. How's it only 20% complete? But we'll give it a nice hard refresh here. I imagine it must be quick. I guess it's doing the update, right? Oh, it's down here. So we can view the logs. Right, system indicates a reboot is not required. Nice. Beginning, patch, apply tasks. And so we're just waiting. Yeah, we're just waiting for this to complete. So we'll give it about 3-4 minutes. We'll be back in just a moment. It doesn't take long to do an update. All right, so we did have to do a refresh there, but yeah, it applied that patch update. And so that was pretty straightforward. And so maybe in the next video, we'll look at how to add an OS policy, but yeah, very simple. All right, so in this video, we're going to take a look at VM Manager using OS policies. I believe that's what it's called, OS policies, yep. And so the idea is that we're going to set up a policy and that are going to be enforced against our VMs. So let's go over to OS policies and let's see if we can go ahead and create one. So we have create zonal, create global. I guess zonal, since I don't really care if it's global or zonal at this point. So go ahead and we'll see what we can do. Before we do that, I want to make sure if we can see some examples. So some examples here and see what we have. So what do we have that we can do? Well, we have no op. What does that mean? Validate and enforce the shell. So maybe this means that you cannot perform any operations via the shell. It's not really clear because it's not saying exactly what it is. But here it says resource sample, execute, validate, interpreter shell, exit 100, validate, enforce, right? So no ops, like don't touch the machine. Over here, set up repo install package via Linux apt. So an OS policy to set up Google Cloud Monitor repository install stack driver agent for VMs running on Debian. So the idea is that if it doesn't detect it, then it will install that. So that could be something here. We have exec to all. So an OS policy ensures Apache web servers running on Linux OS. I like this one. So let's go ahead and copy this one over. Okay, so this is where our configuration management is, but it's as OS policies. Okay, so we'll go here. I guess we have to make the file, and it needs to be in a bucket. So we already have a bucket from earlier. I'm going to go ahead and open up VS Code here. And what I want to do is I want to make a new text file here. We're going to paste it. I'm going to save this to my desktop. This is in YAML format, so we'll just say save as. And you can't see this, but I'm doing this off screen. This would be OS policy Apache. Okay, so that's saved to my desktop. I'm going to make my way over to a bucket. So we'll go ahead and get a bucket here. And we'll go to this bucket here. And we're going to drop in that script. So again, I'm just trying to find that here anywhere via a Windows Manager here. We'll go ahead and drag that in, drop it in. And what I want to do is I want to, I guess we can navigate it to manually. That's probably a better approach. And, oh, we could have uploaded this entire time? Really? Really? Okay, well, never mind. I didn't need to put it in a bucket. I'm just so used to accessing things from buckets that I assumed that that's how we had to do it. So we have that OS policy. We probably could do more than one. So we'll just call this Apache install. And I guess anywhere where it's Northeast, because I always do everything in Northeast too. Well, hold on. Depends on where we are here. So let's go take a look and see where this VM is running. I still have that virtual machine running from before. So we go over to here, and we have this one. It's in 2B. So we'll go over to here, and we'll switch this over to North America Northeast 2B. 2B, yeah. Okay, so we have that. So we have match OS distribution, include VMs that match this. I mean, it's technically Debian, and we can specify a version, but we'll leave it alone. Select the wave range. Sure, we'll hit start rollup. Do you want to continue this rollout? Yes. Okay, so it's going to roll out those changes. So we're going to wait for this to finish. But yeah, that's your configuration management. Pretty darn simple, but it seems like with patching or this, these are two different ways that we can do it. But we will wait for this to install, okay? All right, so Apache should be installed now. Let's make our way over to VM instances here. And what I want to find out, I mean, I don't know if we opened up the port for this HTTP. Well, it should already actually be open if, because because that's just a general port we have open up on our network here. So maybe if I just go here and take a look at the external IP, maybe it will just show us an Apache server running. Let's take a look here. Fingers crossed that it just works. Even if this page doesn't work, we can always go into the VM and take a look. I don't see anything resolving here, so I'm going to go ahead and log in. Because something should have already shown, right? So we'll go here, and we'll just see if it's installed. Maybe Apache's not started. We can also take a look at the script that we ran and see what's going on here. So here it says, ensures that the server is running. So this only makes sense if Apache's installed. There's nothing here that says it would actually install it, right? Okay, so that makes sense. Let's go and drag this off screen here. And let's go back over to VM. Our OS policies here. One second here. And if we go to our OS policies, we can see that number of VMs that the agent has reported to be compliant with a particular policy. Okay. But how could it be? Here it is. Well, this has no policies, and this one is non-compliant. So it's clearly non-compliant right now based on that current state. So we're going to go here, and I guess we'll just install it. So let's go take a look here. We'll say Google Cloud Startup Scripts, VMs. And there's that one we keep using, which is for installing Apache. So it's lucky that we have that example. So we'll give that a moment to start up, just a moment. Okay, and in here, I'm looking for this. Okay, so we'll do, we'll just install it. Maybe we can just do app install here. We need a sudo in front of that. That's fine. And I don't know if we have to start it. It should just start automatically. I guess we'll find out in just a moment. All right, so let's see if Apache's running. Actually, we just do a curl to localhost, and if it returns something, it does. Then clearly there is a website. We'll go over to here to the actual VM instance. We will copy the external IP address here. And we'll paste it over here. And this should serve up a website. I mean, we got this one, so clearly there is a website, right? Even if that doesn't return that. The question is, how often does it check for these OS policies? Here it's saying it's compliant and then non-compliant. Well, for this, okay, fair enough. One of two. So one is compliant, the other one isn't. So it actually has the agent, but the other one is not compliant. So how do we know? How often does it check? May update the required. Okay, so say, how often does OS VM Manager OS policies check for updates? So between each enforcement is 60 minutes. Wow, that is a long window. So it's going to take 60 minutes for us to find out. We're not going to wait around that long. Obviously, it's going to work, right? Because before it wasn't installed there. But now we know how that works. So I'm satisfied with that. I don't really need these policies to stick around. So if there's a way that we can get rid of our policies, that'd be fine here. This one, where's our other one? Policy, what we call Apache. It's interesting it doesn't even show our policy here. So I'm not sure, again, if where our policy is. It'll probably show up later, I suppose. But anyway, I think that we have met the needs for this video. So I'm going to go ahead and delete this instance. And I still need to get rid of this one. What is this? Oh, I still have a group running. Okay, and so I'll just delete this group. But anyway, I will see you in the next one. And we basically covered VM Manager. So actually, it wasn't that complicated as I thought it was going to be. I thought there'd be more to it, but it's really pretty straightforward. Ciao, ciao. Hey, it's Andrew Brown. In this video, we're going to learn how to deploy a Kubernetes cluster using Kubernetes Engine, also known as GKE. So I made my way over to Kubernetes, but notice that right away it's going to ask me, if I go to Overview, it's going to ask me to enable the Kubernetes Engine API. So we're going to go ahead and activate that and give it a moment. And so now that that's activated, we'll go ahead and start creating ourselves a cluster. So I'm going to go here on the left-hand side. We're going to try to make a really, really simple cluster here because Kubernetes gets very complicated very quickly. I'm not working in it every single day, but it shouldn't be too hard for us to figure out. So let's go ahead and create ourselves a new cluster. Okay, we'll give that a moment. So welcome to the new cluster creator. Oh, they've changed it on me. Cool. They were always doing this here. So with autopilot, GKE provisions and managed clusters underlying infrastructure. If you need more control over your configuration, we'll select switch to standard cluster. For now, we'll stick with autopilot. That's not a bad idea. I kind of don't mind that. And yeah, of course, we know what that is doing. That's fine. So I'm going to go here and launch in Northeast 2, which is Toronto. We'll stick with autopilot cluster here. We'll go down below. Choose a GKE cluster tier based on the complexity of your workload. And for if you need advanced features that improve productivity, reduce software deployment times. Okay, let's go look at our additions. So we have standard tier, run containerized workloads at scale with GKE, includes Kubernetes features available to GKE users. Here we have other stuff. What could be in the enterprise one? Fully automated cluster. Well, they both have those. And this is where it's different. So GitOps-based configuration management, a service mesh, managed policy controller, fleet-based management, multi-cluster ingress, a bunch of useful things, but we'll stick with standard here today. And we will go to our next step, which is fleet registration. So a fleet lets you logically group normalized Kubernetes clusters. And normalized Kubernetes clusters, helping you up-level management from individual clusters to group clusters. We're only going to run a single cluster here today, so we're not going to register this. Then here we have our control plane access. So I would think that we would want DNS-based control access for simple, secure way to access control plane. Maybe we'll leave it alone for now. And then we have authorized network. So safeguard your operations and data. That might be something we might want to do later on. Creating our cluster. So the default network seems fine to me. The node subnet is the default. That seems fine to me. We're not going to be using private nodes here today, but you can imagine they're nodes that are private. We have some advanced networking options. I would probably not touch any of these because I'm not really good at this kind of stuff. Disable VPC firewall auto creation for load balancer services. No, we are fine. We'll go to advanced settings. And here we have rapid, regular, or stable. So use GKE features as soon as they're released. Regular or stable. I guess we'll go with regular. And oh, we have NVIDIA GPU manager. That'd be pretty cool. And so here we have a bunch of options we can enable. This is not too different from, I think, like EKS these days with Amazon, where it'll ask you, like, do you want to turn on any additional features? I'm not sure for this one we want to do anything additional, but it doesn't hurt for us to kind of scroll through here and see what we have. Yeah, I don't need a service mesh. I don't need backups. I don't need automation here today, so that's fine. We'll go review and create. So we have a standard cluster. We're not doing fleet registration. Access using DNS. No, but we will get access via IPv4 addresses, so that's fine. We're not going to bother with authorized networks. We're going to keep it nice and simple. And for the most part, most of these things, like obviously, are disabled, right? So yeah, we don't need a secrets manager. We don't need any of that right now. So we'll go ahead and create ourselves a cluster, and we'll give it a moment to create, okay? Or however long it decides to take, okay? And actually, while we're waiting on that, because I think it's creating, let's go take a look at GKE costs. Because normally you pay, I believe, for the control plane. So we'll go GKE pricing. Right. At one point, I think they were free, but then at some point, I think they started charging for it. So includes automated cluster lifecycle management, pod and cluster auto scaling, priced at 0.10 cents per hour. So that's what we're paying per hour. And so we do this times 730. And we're going to get $73. So we have a base cost, not even running anything, just a base cost for the cluster of $73 an hour because that's what they need. And I think that's pretty standard now for any provider. There might be one like, I can't remember their name off the top of my head, but there's one that has a lower cost that is a third party. Civo might be more cost effective, but running clusters is a lot of work, so that's not that big of a deal to understand that cost is there. But Kubernetes, Google is, I would say, the most seamless, easiest platform to deploy on. It's been a while, but I remember this one was super, super easy. Usually the hardest thing is setting up an ingress controller, getting traffic into the cluster, and I remember this one was like dead simple. So hopefully that'll be the same experience, but they do expose a lot of the Kubernetes components, so it's very easy to figure this out. But we'll wait for that cluster to spin up, okay? All right, so our cluster is up. Let's go click into it. And because it's autopilot, I wonder if it's managing the nodes underneath with something like Cloud Run. Usually when you have these Kubernetes services that are managed by cloud service providers, they'll always have a managed version, and that will be based on their serverless container infrastructure. But I'm looking through here, and I'm just trying to make sense. Okay, where is the nodes being managed here? And so I'm thinking, we have a lot of information here, but I'm thinking that it's probably using Google Cloud Run. I could be wrong, but I'm pretty sure it is. So the idea is that we probably want to deploy something. I wonder if this just takes a deploy script. There's a YAML file that you normally feed into here. And so here, deploy atonement is an app configuration for how to deploy. Yeah, so this looks like it's just a deployment. Okay. And I'm just going to go through this a little bit, and then we'll figure out something we can deploy, right? Because here we're going to get container details right away, and so it's going to want to know some stuff. And if we view the YAML there, we go, yep. So this is our standard configuration file or our deployment file. I actually have an entire Kubernetes course, though. To say I remember it all is a different story, but I'm not sure it's not letting me look at the whole contents here. But here we can kind of see what it's doing. So what do we have? We have here Nginx, so it's going to deploy Nginx, and we have 3 replicas, so I imagine it's going to deploy it 3 times, and then we have a horizontal pod autoscaler, so that's going to allow us to horizontally scale and, I guess, load balance across those 3 instances if we were to go with that standard thing. But let's go to our container details, if we can get there, container details. And so right away, it already has Nginx selected, which is fine. We can do that, but it'd be nicer if we had some kind of hello world application. So I'm going to go over to Claude and just say, like, what is a sample web server container we can deploy to Kubernetes cluster? Like, I'm just trying to give an example of one that already has a web page loaded into it. Maybe there's a sample app. Here it's trying to do Nginx, which is fine. And that's literally basically the same, right? Here it's saying that. It has the load balancer in here, but it's a little bit different. So what I don't know in this example is there actually any actual what do you call it, stuff in like example code in here, but I can't see because if you notice here, this is all buggered up. Oh, here we go. Maybe that might help. Okay, so this is the whole thing. So what do we have? Yeah, horizontal pod scaler, and if we go over to this one, you can see that we have a little bit more information. So they have a config map. Here we're configuring the server, and then we have an index.html page. So we could try that, but we'll go back over to here for a second. Okay, and yeah, I guess we can go to our next option here, next expose. Expose deployment is a new service. So this option creates a Kubernetes service, a service that lets the deployment receive traffic. And so this is something we might want to do and set the ports on here. But for now, let's just go ahead and try to deploy the default here, the Nginx cluster. It's not going to be really useful because if we're not reaching it, it's not going to do a whole lot for us, right? But we'll give it a moment and see how that deploy goes. All right, so looking at our deployment here, we can see deployment 1, pod errors unscheduled, does not have minimum availability. It says that some of these will resolve maybe over time as it deploys. And there we go, we give it a refresh and it's less of an issue because I guess those resources are becoming available. And wow, they've really improved this. Like you have everything you want nearby, logs, events, everything. I cannot tell you how easy and nice this is for us to be able to find information. It's probably, again, one of the best for deploying Kubernetes in terms of being able to manage it. Generally, the way you interact with the server is with kubectl. And so I guess here, maybe they're giving us the commands for kubectl. Let's go up here. Does kubectl, is it already installed here in Cloud Shell? If it is, that'd be really, really nice. Normally you'd have to install that locally. It's not really too hard, but kubectl is a generic CLI command that you use to interact with it. So here, let's take a look here. G-Cloud clusters, auto, etc., etc. So we have a bunch of stuff that gets the credentials, and we'll go ahead and hit enter. And so it says kubectl get deployment, whatever. Okay, so this is getting the deployment information. So if we type in kubectl, is it already available? It is, cool. So I never installed it, it's already here. My kubectl knowledge is a little bit rusty right now, so I will brush up on it in the next video so we can do a little bit more with it. But what can we do with our cluster right now? Probably not a whole lot. The question is like, where is our actual nodes that we're managing, right? And I think again, because we're using autopilot, that it is probably running in Google Cloud Run or something like that. So let's try to figure out where that is. So under workloads, that's the stuff that we just deployed here. I want to figure out what is this running on. Right, so we see 3 pods out of etc. But what are the underlying nodes? Nodes is the servers that it's running on. And so I'm carefully looking through this and trying to figure out where it is deployed to. Details. All right, so I was trying to figure out what is it using underneath, and so I guess it might be using Google Cloud Run underneath, but basically it's fully managed. It's just completely abstracted away. So we're not thinking about the nodes whatsoever. We might want to actually deploy a cluster with nodes just so that we have an idea of what the underlying compute could be if you were managing it yourself. But what might be useful is if we go through this quick start, because I noticed here is that they actually deploy a hello world example for a workload. And that might be really useful for us so that we can actually see something, right? Because right now we have Nginx, and this workload is not exposed. There's no way to actually access it. And we might be able to edit it after the fact. Let's go take a look here. Yeah, but we'd be manually editing the YAML file, which is fine. But if we're not super comfortable with that, I think we might want to go ahead and just deploy a new resource. Okay, so I'm going to go over to my workloads. It doesn't really matter if it's workloads or whatever. We're just going to go ahead and hit deploy. And so this will be hello world. Now they're using the command or Cloud Shell, but we're just going to use the interface here because it'll probably be a bit easier if we do that. We'll go to our container details, which is next over here. And here we are going to select an existing container. Or maybe just give it a path. So I'm going to go here and enter the image path for here. You can also enter the name of a public image on Docker Hub. I like that idea. So we'll go back over to here. And so this is a public image. It's not on Docker Hub, but it is a full address. So it might take it if we do this. Okay, so I'm going to try that. That might not work. And so it says a simple hello world app is packaged with a single container. And then we'll go to the next step for expose. And maybe it is telling us to do this in the actual interface. It just doesn't have screenshots. So we'll go over to the expose option here, next. And we'll expose it. We'll see what ports we have to map. So leave port 80, leave port to 80. And then the target port is going to be 8080. So target port is what it's actually running on, like the actual container. And then port 80 is what you want to map it to. Obviously going to be TCP. And I would assume it'd be load balancers or option. Let's take a look here, 8080. It doesn't say to change it, so I'm going to assume that we're just going to create a load balancer with external IP address. And so this is just different ways that we can expose access to it. I'm going to just tell you, like, this normally is a huge headache, like unbelievably hard. So the fact that it's just going to deploy that load balancer for us and give us ingress into that is going to be super nice if that just works. So we'll give that a moment here, okay? All right, so that new app container is deployed. Again, note that we have 3 up. So the more that we're running, the more that's going to cost us, of course. And so what we're looking for is that external endpoint. And so down below here, it's created a service, and it's a load balancer type, and then we have that endpoint. So if we open this up, hopefully it just works. So fingers crossed. And there we go. So again, I'm just telling you, this is generally super pain in the butt on either Azure or AWS, and I just cannot believe how easy this is because they're just really abstracting away a lot of the functionality. I know we haven't really covered that much here, but I just wanted to show you how you deploy an application, expose that information there. But really, like, this is in itself an entire course. But yeah, I'll look at the exam guide, and if it requires more work for us to do here, we will do it, but we should probably take a look at kubectl separately here. But I'm going to make another video where we're just going to delete this cluster for now. Not the deployment, the entire cluster. Let's see if it'll take everything down if we do that. And let's take a look if we do it standard mode, because I want to see what it looks like to manage nodes, because that's normally the way that we'd normally do it. But I'm going to checkbox this here. We'll say delete. And I'm hoping that it takes the whole thing. There we go. And if we hover over this, the cluster is being deleted. So I'm going to wait for that to delete, just in case it fails to delete, but we're going to wait until that deletes, okay? All right, there we go. The cluster cleaned up, no problem. And again, we'll the next one will not use autopilot. We'll use just the standard way of deploying and seeing what it's like to actually have nodes underneath that we have to manage, okay? Ciao, ciao. All right, in this video, we're going to deploy a Kubernetes cluster, but this time we're going to use standard mode instead of autopilot so we can see what kind of work there is underneath in order to do this the harder way, I would suppose. So in the top right corner, we have switch to standard cluster. And here it's going to just say, hey, you might just want to use autopilot, but no, I want to use standard because I want to manage all that stuff myself. So we'll go ahead here and we have our cluster 1. Notice we have zonal or regional. So if it's zonal, it's obviously in a single zone. If it's regional, it's going to span the entire region. I'm going to pick zonal because that's totally fine for my use case. And I'm looking for North America, Northeast 2, and we'll go with A, that's Toronto. And here we say specify default node location, increase availability by selecting more than one node zone. And I mean, like, I don't need more than one, so this should be fine. So we'll just have that there. That's totally fine. Release channel, so select a release channel for GKE to pick up versions for your cluster with the chosen whatever. So we have a few different options. I'm going to stick with regular as that seems okay to me. Then down below, we can choose our cluster tier. Notice that we do not have enterprise option here. First enable GK enterprise in this project. Okay, so if we wanted that, we'd still have to enable it, which is totally understandable. Let's go over to fleet registration. I do not need to register multiple clusters, so we're going to go with that. Notice the cost here is 128. So obviously it's more, and in fact it's doubled so far, but probably because it might be specifying what kind of nodes we have here. Let's go into the default pool. So this is obviously when we launch up nodes, it's going to go in this pool by default. We can set placement, which is fine. The size of nodes, I'm going to reduce this to 1, and that's probably going to greatly reduce our costs because everything it's spinning up, well, was it really that much? Let's go here. We'll have 1. We'll go to 3. Yeah, so it's not that bad in terms of difference. The thing that's happening here is there's some base cost for the main cluster, and that has to be of a particular size of node instance, and maybe we're not controlling the size of that, and so that's why we're not getting great savings, because the nodes underneath, the other 3 are not that much more. We have enable cluster autoscaler, so automatically creates or deletes nodes based on workload needs. That sounds good, but I don't want to do that here today, and we'll stick with 1 node. Clusters smaller than 3 nodes may experience downtime during upgrades, because that makes sense. There's not backup nodes to work with. I mean, it's going to be here, so it's the only place it can go, but we'll just specify that there specifically. Then we have our surge upgrade, so we can determine how we want upgrades to occur, whether it's blue-green upgrade or short-lived node upgrade. I'm going to leave it with surge. It seems totally fine to me. And let's click into here and see what we have. So here we can choose our base image. And so this, I guess, is the container optimized for container D. Then we got Ubuntu container D. So I guess it just seems like whatever node you have, if you want to have additional things in there, you can have them. I don't know. I would assume it's bad practice to try to even get access to your underlying nodes. At least in other providers it is. I'm going to assume it's the same here as well. Then here we can choose our E2 size. And so, I mean, I don't know if a micro would work. We could do that and see if the cost drops much. It does, but it's barely worth it. And because we are running things that are containerized, you really don't want to go that small. So even a T2 medium or E2 medium seems kind of tiny for what we're utilizing, but that's fine. We're going to do this. We're not going to keep it up for long anyway, right? Because this is 15 cents per hour. Yeah, boot size is fine. That is fine. Yeah, you could do spot VMs, but probably wouldn't want to do that. For networking, these nodes, settings for creating the nodes, the maximum pods per node. I don't have anything that I want to set here. So, I mean, maybe you might want to limit it. Mask for pod address per node. Okay. So I'm not sure what I want to set here. I guess I'll leave it alone, but I would assume this has been numerical value. We have our network tags, so we can say what it has access to. That might be good. Automatically create second ranges. I don't need second ranges. We'll go on to security. I'm hoping that it doesn't come back and say, hey, fill this in, but this is just a maximum number, right? So here we can choose the identity. So compute engine seems fine. That's going to give us good access to things. Default scope, that seems fine as well. It's not like I'm trying to get access to a storage bucket or anything right now. We'll go over to metadata. Okay, so we have basically labels, nothing super interesting here. We'll continue on over to our cluster. So we can enable the maintenance window and set when maintenance can occur. We're not doing maintenance here today, so it does not matter. We can set vertical pod scaling or etc. I don't want to do vertical pod scaling, but it's not a bad idea. If you need your nodes to scale up in size when you're running into issues, or auto provision stuff, it's not a bad idea, but again, I don't want to do that. We have those couple options, balance and optimize. Not exactly sure what they are, but you know, if we have slides and it's important, I will put that in the slides, which you would have already watched at this point. We're not going to have access using DNS, but we do want to have an IPv4 address. It's not a bad idea. Then down below here, yeah, we're going to launch in our default cluster. Enable VPC native traffic routing. That seems fine to me. Okay. We have more options. So I know these are networking things. I cover this in my Kubernetes course. I don't really remember them, but these are all cloud native projects that we can enable. Okay, so everything looks fine down there. Let's go down to security. We have GKE node shield. What is this? Provide strong cryptographic identity for nodes joining cluster. Not a bad idea. So everything else looks fine here. I do not want to have a backup. That's going to be too much of a hassle for what we're doing right now. Let's go to features. And so this is kind of, I guess it's the same thing with autopilot, but you know, when we're using, again, if you're using Amazon EKS, the same thing, you check box on this stuff and you'd get these things enabled. And again, some of these look like, what's this CSI driver and stuff like that? These look like cloud native projects, and some of these are specific offerings from Google. Okay, it'd be really interesting to try their service mesh. Service mesh is always a big pain in the butt, at least on AWS it was. So if Google made it really easy, that'd be really cool, but we're not going to test that here today. And we can look at our code equivalent if we want in the command line. So this, I guess, what it looks like doesn't really help that much. It says gcloud beta container. I don't think this is beta anymore. So services are currently unavailable in Southwest America 1. We're not deploying there. We're deploying Northeast 2. We'll go ahead and create this and see what happens. I thought it would have told us like what kind of compute you wanted to use underneath. I was kind of expecting that. But it makes me think it's just using Compute Engine. So that's something I might want to know. So like, you know, GKE, can you use gcloud or Google Cloud Run? Yes, you can, but I didn't see where you could set it, right? Okay. And I think you have more options than just those two. But that's fine. We're going to go ahead and deploy it. And if it's just virtual machines, that's fine as well. We'll go ahead and create this. And hopefully what we can do is try to deploy the same Hello World application, and we don't run into networking or security issues as working with a custom or standard cluster might be a little bit more of a headache. And does it show us the nodes here on the left-hand side? No, not really. Well, it's over here maybe. So we'll wait for those nodes to, or our node to spin up, right? And I'm curious, once it's deployed, would we see this over in a Compute Engine? We'll be back in a moment, okay? All right, so our cluster is ready. We have below here our node. I'm not sure if we can see exactly, I think in AWS you can see what the control plane is running on, but this one we obviously can't. Let's go take a look. I want to go over to Compute Engine. I want to see if it's running over there and what we can see. There must be some way to use Google Cloud Run because we Googled it, but here it is. Yeah, so this is the default pool. It's interesting. Okay, and so GK cluster. So that is, I guess, one of our nodes. And I'm assuming this is not the control plane, right? It has to be something else, and the control plane must be managed by Google. And so it's just, we don't see it, right? But it's going to work. And that's totally fine. So let's go ahead and see if we can actually deploy something to this. We'll go ahead and hit deploy. Let's see if we can do the exact same thing. So we have that. We'll go to container and we'll go back over to our quick start. This is just the create a cluster quick start. I want to go ahead and grab this application over here. We're going to drop it in here. Okay. Then we'll go all the way down. We'll go to next. Oh, the same thing. Okay. I thought it was going to be something more complicated. So we'll do 8080. And yeah, we'll stick with load balancer. I used to know all those types, but again, right now I don't. It would take me about 15 minutes to reload my brain. But we will start that up and see if it works. If it does, that's, again, super, super nice, like super easy. All right, looks like our workload is deployed. We're going to scroll on down, and I guess we still have an endpoint, just like the other one here. And so basically, a very, very similar experience. So yeah, that's pretty darn easy. I'd be curious, again, I haven't used kubectl in a while, but let's see if I can refresh my memory here. And so I'm going to go ahead and say get YAML. And the trick with kubectl is just establishing a connection. So here we have this information here, and it pipes it over to here. So what happens if we just run that first line here? Because I'm assuming this gets us the credentials, and then we pass it over to here. So one second here. I'm going to copy this here. That seems a bit long. Paste, we'll hit enter. Okay, so now if I do kubectl, right, there should be a bunch of commands here. Okay. So let me go take a look here. Let's go ask Claude. Can I use kubectl to list out services? Again, it's been a while, but once we start seeing it, there'll be a pattern to it. Yeah, there we go, get services. It's very conventional. Everything's super, super conventional. So once you start seeing it, actually a lot like the Google CLI. And that might not be by accident because obviously Kubernetes was originally pioneered by Google. And so that's probably why the CLI mimics it so much. So say get services or SVC. We'll see if we can see that. And so I guess it's already established that connection. So that first line must have authenticated it. And so now we can just basically use kubectl. And so we can see that service there. Let's keep going here. So can we view a service? It's probably that with its name. Okay, yeah, it is. Yeah, so super, super simple. So we'll go back over to here, say kubectl, get SVC, and then we'll get its name. So this will be deploy one service. Whoops, we'll hit up again. Deployment one service, right? So we can see that. Okay, can we, I don't know if there's much else to do. Could we, I don't think we'd be able to get into the container. Could we connect to a container? I remember it's a lot of work to do that, or maybe we need a sidecar for that. Yeah, let's give it a try. So we have pod name, container name. And so if we do, let's say kubectl list, was it list SVC or just get? Maybe it's just get, okay. So the reason I'm doing get first, I just want to see, we'll do pods. Nope, okay, so we'll do this. And let's see if we can figure this out here. So we have kubectl, et cetera. And it really depends on what the container is, but we'll go here. And there's the container itself, and then there's the service, which maybe is the pod name in this case. Let's go ahead and see if we can get their deployment. One service. But the container is going to be the container that's actually deployed, right? Not necessarily, like, because a pod can contain containers, or a service can contain containers, as far as I can remember. So we'll go into here, and what I'm looking for, oh, we're in Compute Engine. So we'll go over to here, sorry. Or we'll actually type in GKE. Because we should be able to see what the name of the container is if we go over into that service. So on the left-hand side, we'll go to workloads. We'll go into here. Right, because there's 3 pods, right? So then you'd have to connect to a very specific pod, right? Yeah, these are the pod names. Okay, so like, let's say we want to connect to this one. That's actually the pod name. Okay, that makes more sense. So we'll go ahead and we'll paste that in there. But now we need the container name. So what is the container name? Hmm, let's see if we go to the YAML here. The YAML might help us see what the name of it is. So what I'm looking for here is where the container is configured. So spec, template, containers, the name is hello app1. So there it is. So we'll go back over to here. Again, I'm just doing this based on my fuzzy memory of Kubernetes. I've done a lot with Kubernetes, but there's just too much in cloud to remember, or tech everything to remember. Let's see if we can connect to that. So it says unable to start the container process, no bin bash. And so the reason that's not working is because maybe the container that is being installed does not have bash installed, right? And that would make sense because if you want to, or at least it's not located there, right? So if you're trying to lock these down and make sure that people aren't abusing them, you would purposely deny certain things here. But we're gonna go here and ask, like, is there another way? So we'll go here and it's like, this bin bash didn't work. Could it be another command or another program, like /bin sh, or yeah, see, right away I thought sh, right? So not everything always comes installed with bash, I think, but sh might have it. Let's go try that. No, that failed. And again, it might not have access to do that. So we'll go ahead and try this. Doesn't exist in the container, right? Often happens with middle containers, exactly, right? But even if that doesn't work, maybe we could try using ls and see what's in there. I'm not sure if that would work. We'll go ahead. Well, I mean, I guess it would because it would have to be in there, right? ls. And we'll try this. Yep, so that's not even in there. Okay, so it's really, really locked down. Let's go ahead and try sh. I don't care if we can get in. I'm just trying to show you what it would look like if you're trying to remotely execute something on it. We could deploy an instance that would allow us to do that. And there is actually a specific container. What container is useful for Kubernetes to launch in order to debug other containers? There's actually a very specific name for that container. I just can't remember what it is, but it'll tell us here in just a moment. It's like something box or, but it's like an intermediate one that is used quite often. BusyBox, there it is. That's the one I was thinking of. So here we could actually end up running it. And I think this one would actually start up within the cluster. Let's go ahead and take a look here. So this will actually download it and I think temporarily run it in the container. Let's go ahead and try that out. Now it's coming back to me because BusyBox, it has a bunch of tools like bash and stuff here. And so now we're actually inside of BusyBox. But it's not super useful for other one. But I guess like if we wanted to ping our other server, because it's on the network here, we could do curl. I don't know what its network name would be. Again, I'm not the best at networking, but we'll go over to here and go back to the, if we just zoom out a bit here, or we'll go back into the actual deployment over here. And it might have like a name. Sometimes the name to network with it is the same name as the container. I'm not sure. So I'll try this, or maybe it's shared on the same network. Again, networking can be set up in a lot of ways, and again, I'm not an expert at this, but we'll try, okay. And I think it's on port 8080, so we'll try this. Oh, curl's not there. Do we have wget? Okay, so that didn't work. What if we try this? Port 80. What if we try 0.0.0/80? Or, okay, what about 8080? Yeah, and again, really bad at networking, but if I spend a little bit of time here, I can figure it out. I just wanted to show you that kubectl was there, that you can interact with it. It's very conventional. But yeah, there's a reason for us to spend more time deploying an actual workload. I'll invest a little bit more energy, and we will build something more substantial. Oh, cool, they have Knative here, so this is for running basically serverless stuff. Do you even need this if you have GKE Autopilot? I don't know, but I guess it does have like smaller functions. Serverless functions, so maybe Knative is useful for that. But I think what we did is we learned that there is nodes, and at the very least, we were seeing them being managed by Compute Engine. How you can get Cloud Run there, I don't know at this point, but it's not really that much of a concern. We'll go ahead and we'll delete this cluster. Okay. All right, and we'll wait for this to delete. I'll be back in a moment. Just make sure that this actually deletes, okay? All right, that cluster is now deleted, and there you go. Let's take a look here at Helm, which is a package manager for Kubernetes that simplifies deploying, managing, and versioning applications and clusters. It also helps automate the deployment management of Kubernetes apps using reusable packages called charts. So charts are Helm package apps, which are pre-configured Kubernetes resources that can be shared and deployed. Helm includes versioning and rollbacks for your app configs. It integrates with GKE. Helm is not specific to GKE. GKE just happens to have integrations with it and simplifies managing complex apps, upgrades, cluster configurations. Helm ensures consistent, repeatable deployments across your environment. Here's an example of a chart file structure with chart.yaml at the top there. You can see that we are deploying a WordPress app as the folder or directory implies. Take a look at the charts directory, which contains charts that it depends on, so its dependencies. Here's a diagram, basically with our Kubernetes cluster and Helm and our repos. The repos are obviously the charts that we are pulling in because, again, it's a package manager, right? So it's bringing in those dependencies. So charts are stored in your repo. Admins download and customize a chart. Helm deploys the chart to Kubernetes cluster. It's a lot harder than the way we're describing it here, but it does look pretty simple though. Anyway, and Helm handles updates and rollbacks. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're taking a look at Kubernetes. This is the reason why we're here for this technology. So it is an open source container orchestration system for automating deployment, scaling, and management of containers. Originally developed by Google and now maintained by the Cloud Native Computing Foundation, the CNCF, as a CNCF project. And we are going to touch on Google Cloud. I'm going to show you how to deploy your cluster there. And you're going to find that Google Cloud is actually the easiest out of all the managed providers because I use them all in this course. Kubernetes is commonly called K8s or K8s. And the 8 represents the letters between the K and the S. Generally, if you see K8s, you can say K8s or Kubernetes. And the advantage of Kubernetes over Docker, because Docker is what people always think when they think of containers, is the ability to run container apps distributed across multiple virtual machines, or as we'll call them in the course, nodes. Now, I have a double asterisk there, and that's just to remind me to tell you that this is a gross simplification. Docker is not as simple as like an it's like an apples to oranges comparison. Docker is a suite of things. It's a runtime. It can have Docker Swarm, which is an orchestration tool. So technically, a better comparison would be between Kubernetes and Docker Swarm. But I'm just trying to keep it simple here for you. All right. A unique component of Kubernetes are pods, and a pod is a group of one or more containers with shared storage, network resources, and other shared settings. So the idea here, I'm just getting my pen out here, is we have a node, which is a virtual machine, and another one here, and you got pods running across them. Now, and pods contain containers in them. That's where the containers are. Now, as we look at pods throughout this course, you're going to find out that basically most components that we run in Kubernetes are pods. So that's why pods are so front and center, because basically everything is a pod. Kubernetes is ideal for microservice architecture, where a company has tens to hundreds of services they need to manage. And so a service would be something like a containerized application. And the thing is that when you have a containerized application, you're very likely going to be running more than one of them, all right? Even like redundant ones. So here we have pods, and a pod would run a specific application. So let's say it's a Ruby on Rails application. And I mean, you could count this all as one service, or you could count each of these as redundant services. And so it's very quick or easy to get into the tens. So Kubernetes can be used quite early on, but it's going to be really dependent on your use case. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Kubernetes component overview. So what I'm going to do is give you a top-level simplification on a lot, but not all of them, but a lot of the Kubernetes components, because there's just too many. It'd be too much to go through all of them, but these are all the ones that we are going to be spending a lot of time with, and you definitely will need to know them all. And you will know them all because we deep dive on a lot of these, and you'll get to see them again and again and again in the course. So at the top of our list is the cluster, and this is a logical grouping of all the components within a cluster. So mostly everything that follows after this is generally inside of a cluster. There are some exceptions. The next is a namespace. So this is a named logical grouping of Kubernetes components within a cluster, and it's used to isolate different workloads on the same cluster. I like to think of it as a slice of pie. So when you look at the icon, and I made all these icons, by the way, because I do not like the ones that are provided right now in the community. So I just made my own, but I made it look like a slice coming out of that cluster so you can remember what that is. Then you have nodes. So this is a virtual machine, or it could be a serverless container, because some providers like Google and AWS let you run it on their serverless container platform. But either way, it's just the underlying compute, the underlying server. And there are two types of nodes. We have control plane and worker nodes. So worker nodes is where your application or workloads run, and the control plane node manages worker nodes. So it does a lot of stuff like that. Then you have pods, and pods are the smallest unit in K8s. It's an abstraction over containers. It generally defines an application workload, but basically lots of these components are just pods. And we'll see that again and again when we list out pods, because I list them all the time to show you under kubectl namespace what is running. They're always pods. So the next is service. So a service is something that we use with a pod to give it a static IP address or a DNS name for a set of pods. So the idea here is that if a pod dies, because pods get dynamic IPs, but we want them to have static IPs, and so that's the purpose of a service. But the service is also utilized as a load balancer. And I'm going to point out that them calling this a service is really confusing, because a lot of times a service, when we're talking about containers, means a workload or application that is continuously running. Right? So if you've ever used AWS ECS, you have the option to run a task or a service, which are just containers and based on how long they run. But for whatever reason, that's what they wanted to name it. The CNCF decided to name it, or Kubernetes project named it. I don't think it's a great name, but that's what it is. Ingress is also not a great name, but that's a name they gave it. But ingress is used to translate HTTPS rules to point to services. But what we'll really see is that it's commonly used, and this is the hardest component that we are going to learn throughout this course, but it's used for getting a load balancer, like an external load balancer on AWS, GCP, Azure, to route traffic to our pods, okay? Then you have the API server. The API server allows users to interact with Kubernetes components using the kubectl, or by sending HTTP or S requests. Probably put an S on there because probably everything is encrypted in transit. I really doubt that they would have it so that it's just HTTP. And I like to think of the API server as the backbone of communication for Kubernetes. And you will see that in a future diagram where it looks literally like the backbone, okay? Then there's kubelet. So kubelet is an agent installed on the nodes. Kubelet allows users to interact with a node via the API server and kubectl. And again, that is a simplification. It actually does more than that, but we will dig deeper into that. We have kubectl. It's a command line interface that allows users to interact with the cluster and components via the API server. So the CTL stands for, I think, controller. And CTL is very, very common to put after a name for some kind of tool that's used for controlling things via CLI. And we spend so much time, tons and tons of time with the kubectl. So you will know kubectl inside and out by the end of this course. You have Cloud Controller Manager. This allows you to link a CSP like AWS, Azure, GCP to leverage cloud services. I never had to provision one throughout this course. I never even noticed one. I think like when you launch a managed service, it's already there for you, and it replaces, I believe, the controller manager. But I'm just saying it's there, but we don't really ever have to think about it. So we have the controller manager, and this is a control loop that watches the state of the cluster and will change the current state back to the desired state. So it's basically state management, but it's also, you could think of it as the brain of Kubernetes because it's doing all the controlling. We have a scheduler, so determines where to place pods on nodes and places them in a scheduling queue. So that's why we have this little crane here, because it's picking them up and putting them where they need to be. You have kube proxy, so an application on worker nodes that provides routing and filtering rules for ingress or incoming traffic to pods. You have a network policy. These act as a virtual firewall. It says as, but at, sorry, at the namespace level or the pod level. So it just puts restrictions around how pods or namespaces, stuff in namespaces, can communicate with each other, because by default, everything just can talk to everything within a cluster. You have config map. So this allows you to decouple environment specific configuration from your container images so that your applications are easily portable. It's used to store non-confidential data in a key value pair. So this is just application configuration details, okay? Then you have, I'm not sure why it's not showing up, there we go. Then you have a secret. So this is a small amount of sensitive data, such as a password, a token, or key. It's basically config map, but with the option to encrypt it. Then you have volumes. So volumes are basically, well, there's some variations here, but they're basically mounting storage. So locally on a node or remote to cloud storage. Then you have stateful sets. We do not do stateful sets in this course because they are just too hard to do, but we definitely talk about them in great detail. So these provide guarantees about the ordering and uniqueness of the pods. So think of databases where you have to determine reads and writes in order or limit the amount of containers. Stateful sets are hard. When you can host, use a database externally from the Kubernetes cluster. So like if you have a relational database, put it on RDS, right? Or put it on Google Cloud Spanner. But stateful sets just basically give you a guarantee that you're going to send traffic to a very particular pod. You have replica sets. So maintain a stable set of replica pods running at a given time. It can provide a guarantee of availability. So this is just saying like take a pod and run copies of it so that we have redundancy there. And we generally do not launch replica sets directly. We do them through a deployment. And this is also how pods are deployed. So deployments deploy a replica set, and the replica set deploys pods. So a deployment is a blueprint of a pod. So think like an EC2 launch template or something that just templates up what should be launched. Hey, this is Andrew Brown from Exam Pro, and we are talking about manifest files in Kubernetes. So when I was studying for the KCNA and I sat it, I was just seeing conflicting terms about what they call their configuration files, because I couldn't understand if there were variants, if they meant different things. But then I kind of settled on the knowledge that they're actually all manifest files, and that's why this slide is here for you, or slides, I should say. So let's describe what a manifest is using non-technical terms. So a manifest file is a document that is commonly used for customs, so like going over the border from Canada to US, to list the contents of cargo or passengers. It's an itemized list of things. So what is that in the context of Kubernetes? Well, a manifest file is a generalized name for any Kubernetes configuration file that defines the configuration of various Kubernetes components. And the name will change. Sometimes they'll call it a pod spec file. Sometimes they'll call it a Kubernetes configuration file, but they're all manifest files, right? If you're listing this YAML stuff in with Kubernetes components, they're all manifest files. And these are all manifest files with specific purposes. Like I was just saying, deployment file, pod spec file, network policy file, and manifest files can be written either in YAML or JSON. Now, I've never seen a JSON manifest file, but taking my Terraform knowledge, I bet the reason why there's JSON is if you are pragmatically creating them. Same thing with AWS, with CloudFormation templates, with their YAML and JSON. You probably would never write a JSON file by hand, but it can take it, and it's being generated by another app. So here's an example of it in YAML, and here's an example of it in JSON. So a manifest file can contain multiple Kubernetes components, which makes sense because we said manifest is an itemized list of things. So it can have definitions, configurations. So here is an example of one, and in YAML they have the syntax, which is the 3 hyphens, which allows you to define basically an array. So like we have 2 different things here, and once we have all of our whichever amount of Kubernetes components we want to define in a manifest file, we're going to be using kubectl and writing apply. And this is something that we use a lot in this course. We're doing kubectl, apply -f, etc. You will absolutely know this by the end of the course, inside and out. And resource configuration files is sometimes used to describe multiple resources in a manifest file, which is confusing because manifest by definition means an itemized list, multiple things. But that's just the terminology throughout the documents, throughout the ecosystem there. I just wanted to clear that up for you, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at control plane nodes versus worker nodes. So control plane nodes were formerly known as master node, and the only reason I'm mentioning this is because a lot of documentation out there, like tutorials and stuff, are completely out of date, and they're not using the new inclusive term. So I'm sorry for mentioning this term here, but I just have to because you need to know what it is when you are looking up information out there. Even the Kubernetes.io website still has some outdated stuff, mostly in the graphics, not so much in the text, so they seem to have fixed that. So, a few years out, and I think we'll all be moved over to the new terminology there. And then you have worker nodes. So control plane node manages processes like scheduling, restarting nodes, and then the worker node does the work, as the name implies. It runs your apps, it runs your jobs, and it's running pods and containers. They're both running pods and containers, but when we think of pods and containers, we're thinking about more of the worker nodes because the other ones, even though they are pods, we're thinking of them as distinct components, okay? And so let's take a look at the components that are involved here. So the first thing is the API server, and notice how I said it was the backbone of communication. Well, look at it. It looks like a big long line here, and everything communicates along it. So that's what I mean by backbone of communication. And the way you're talking to stuff is generally going to be through the kubectl, okay? Or there's the API. I guess I don't have a graphic for the API. I guess it is the API server. So that would be you sending like HTTPS requests directly to it. So I imagine that's like how managed cloud service providers are talking to it. But anyway, so that's the API server. Then we'll have the scheduler. So this determines where to start a pod on worker nodes. We have the control manager. So it detects states changes. So like if the pod crashes it tells it to restart. You have etcd or etcd, however you want to call it. This is a key value store that stores the state of the cluster. So controller manager highly relies on etc. And you have kubelet. So this allows users to interact with the node via the kubectl, because kubelet, no matter if it's a worker node or a control plane node, it's on both of them. And so, generally, all of these are in the kube system. I really should have wrote this in the course, but they're in the kube system namespace. And the components that can be in the control plane node slightly vary. So maybe instead of the controller manager, you'd have the cloud controller manager. If you're using something like K3S, they probably have slightly different control plane components inside of them. But you generally need to know for the exam what is in a control plane. So know what these all are, and know that they are in the control plane and not in the worker nodes. All right. So now onto the worker nodes. The worker nodes will have kubelet. So all nodes will have a kubelet for communication. And that's the way it will talk to container runtime. We'll talk about in a second. And then you'll have a proxy. And so we'll have container runtimes, pods, and containers. So just kind of an illustration there. So Why is there a proxy and why is there a kubelet? Well, the proxy, actually, you know what? I don't think I have it here, but what's missing over here is core DNS. Okay, so generally we'd also have, I can't believe I have it missing, but you'd have core DNS. I have it in another slide, so it's not a big deal. So we should really have that here as well. But I suppose it doesn't talk directly to the API server, but proxy is what is used when you have incoming traffic, right? So I'm a user, I use your website, and how am I reaching that pod? Well, it's going to be through the DNS service, core DNS or kube DNS, and then that's going to go through the proxy. The proxy is going to go through IP tables, which we'll talk about in this course, and it'll reach the application running the container. If we're trying to interact with our container programmatically through kubectl, it's going to go through kubelet, and that's going to go through the container runtime into the container. So again, if it doesn't click right now, it's okay. We're going to cover this in different variations here, and you will know it. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at probably the most important component, pods. So pods are the smallest unit in Kubernetes, and pods abstract away the container layer so you can directly interact with the Kubernetes layer. In my mind, the smallest unit really is containers, but I guess they're talking about like newly defined components that are part of Kubernetes. Okay, and so here is that graphic there. And so a pod is intended to run one application in multiple containers. So notice down below that we have 1, 2, 3, 4 containers. They're all running the same app, like the same app over and over again. Now, so that the idea here is a pod would be a database pod, a job pod, a front app pod, a backend pod. And what we could say is if we use the term service like the way we're supposed to, a service would define a continuously running type of application. So you could say database service, job service, front-end service. We're talking about microservices, that's how we describe it, but that's the idea there. You can run multiple apps in a pod, but those containers will be tightly dependent. I don't even know how to do that, but the idea is if you wanted these all to be slightly different, you could, but I have no idea how to do that. I don't know why you would do that. So each pod gets its own private IP address. So look up here, there's an IP address, and containers will run on different ports. So notice here, 3000, 3001, 8080, 81. Containers can talk to each other via localhost. So if you have a container, we'll just clear on out this eraser stuff. If container 1 wants to talk to container 2, all it has to do is talk to it on its port number, on its own local host. And that is how simple communication is from container-container communication, which we'll talk about because we have a whole section on different types of cluster communication. Each pod can have a shared storage volume attached. All containers will share the same volume. So the idea here is you see this line here drawn to the pod to a persistent volume, a PV. And we talk about persistent volumes and persistent volume claims. We'll get to that later. When the last remaining container dies or maybe crashes in a pod, so does the pod. But when replacement pods is created, the pod will have a new IP address that will be assigned. So IP addresses are ephemeral. I never can say that right. Ephemeral or temporary for pods. So they don't by default persist. And that's why we're going to need Kubernetes services, which we will talk about in this course. So to get pods and show their IP addresses, it's very common. You'll type in get pod, get pods, and then doing this -o wide. Okay. Hey, this is Andrew Brown from Exam Pro, and we're taking a look at the API server. Now, we saw a graphic of it when we were looking at the control plane versus worker nodes, so we don't need another graphic here. And I think a lot of this text I grabbed direct from Kubernetes.io because I'm just trying to get you through the key points of it. So this part's a little bit boring, but let's get to it. So the core of Kubernetes control plane is the API server. The API server exposes HTTP API that lets end users, different parts of your cluster, external components communicate with one another. Kube API lets you query and manipulate the state of API objects in Kubernetes, like pods, namespaces, config maps, events. The API server is a component of Kubernetes control plane that exposes the Kubernetes API. The API server is the front end of the Kubernetes control plane. The main implementation of Kubernetes API is Kube API server. Kube API Server is designed to scale horizontally. That is, it scales by deploying more instances. You can run several instances in Kube API Server and balance traffic between those instances. Everything has to go through the API server. You can interact with the API server in three ways. So the UI, API, and a CLI like kubectl. Now I put an asterisk on UI because I don't know what they're talking about there. The only thing you have is the Kubernetes dashboard, which is something that is optional to launch. And I mean, you can't really launch resources in the Kubernetes dashboard. So I don't know what they're trying to say there. But technically, if you are interacting with Kubernetes via the API server, it's going to go to the API. So I guess in that sense it is. In terms of like how it scales and stuff, I don't really know. I don't know how to observe that directly in there, but apparently it just does it. And hopefully that gives you an idea, a little bit more information about the API server. Hey, this is Andrew Brown from Exam Pro, and we are looking at deployments in Kubernetes. So a deployment provides declarative updates for pods and replica sets. So a deployment controller changes the actual state to the desired state at a controlled rate, and the default deployment controller can be swapped out for other deployment tools like Argo CD, Flux, and Jenkins. So what I'm saying there is that deployment is built in to Kubernetes. So you don't have to install a third-party tool, but generally you want to because the tool there is very limited. It doesn't do Git ops. And so that's why you'll want things like Argo, Flux, and Jenkins, which we will talk about more when we get to our deployment section of this course. Notice at the top here I say pods and replica sets, but in reality, a deployment is always deploying a replica set. And so even if you're just deploying one pod, it's going to be a replica set of one. So here is the actual manifest file of doing a deployment. You're going to be seeing a lot of these manifest files through the course. It's going to be kind and then the type, right? So deployment, and then generally, I think usually, yeah, then, no, I guess spec is just for deployments, but and pods and things like that. And so here spec is our pod spec file, which we'll talk about later. Here it says replicas, so it's going to create a replica set with 3 pods in it. And then down below here, you can see the container that we are going to be deploying for these 3 pods. So we'll end up with 3 containers. So here is a graphical example or architectural diagram of the deployment controller. And so this one in particular is using Flux. Okay, and so the idea here is you have deployment, it goes to the deployment controller, the default one, or whichever one you install, deploys your replica set, and that's how you get your pods. So a deployment defines the desired state of replica sets and pods. A deployment will create and manage a replica set. A replica set will manage replicas of pods. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at networking for the Google Cloud Platform. So the most important service to talk about is the Virtual Private Cloud, VPC. It is a logically isolated section of the Google Cloud Network where you can launch Google Cloud resources. And the idea is, once you have your slice of the network, the amount of resources you can launch is based on how many available IP addresses, and that's determined by CIDR range. So CIDR range or CIDR notation is a format that looks kind of like an IP address. It has this / thing on the end here, and that is what's determining how many available IP addresses are. If you have 65,000, that means you can launch pretty much 65,000 virtual machines. You don't ever just launch something into a VPC. You'll launch it into a subnet of a VPC. A subnet is a subdivision of the virtual private cloud. And the way that works is that you'd actually have to choose a CIDR range as well. That CIDR range is going to be smaller than the VPC one. Interestingly enough, the larger the number is, the smaller the IP range is. That's just how the math works. You don't need to know for the exam, but I like to cover this stuff anyway because it's fundamental information. We have public subnets and private subnets. Public subnets can reach the internet. Private subnets can't reach the internet. Now, there is no hard rule about that. Like, there's no constraint that is just like you don't say create a private subnet. You just create a subnet, and if you don't want, if you want to treat it as a private subnet, just don't give them any external or public IP addresses. So here I have a little diagram I made here for you just to kind of explain some of the components. This is not an exhaustive one. Networking has so many features here. We just got too complicated. So we'll just have a very simple example here. So here we have our VPC. A VPC has to be launched within a region. So here it is in US West 1. We have a public and private subnet. These would be launched in particular zones. That's how you get multi-zone. So you create a subnet across one subnet per zone. So you have 3 zones, and that way you'd be highly available. We have compute engines. These are virtual machines running here. So if we wanted a virtual machine in our public subnet to reach the internet, it has to have an external IP address. It would also communicate through an internet gateway. In Google Cloud, you don't have to create an internet gateway like AWS. It's just there. There's already a route set for it. So that's really nice. You don't have to think about that. For a private subnet, if it has to go out to the internet, not internet coming in, you'd have to use a network address translation. So CloudNet, that's pretty standard across all the cloud service providers. If you're trying to get traffic into a virtual machine sitting in a private subnet, that is where you'd need some kind of hybrid connection. So a cloud VPN or cloud interconnect. You'd probably be using both of these in combination. That's usually how it goes, or just the cloud VPN. But that basically establishes a private connection to this VPC and its private subnet, and that way you could just treat it as the same network. The way you're going to protect your resources is via firewall rules. Firewall rules are at the instance level, and they're also stateful. So you can say allow or deny, which is, again, if you're in AWS, it's totally different, right? You have different controls for that, okay? But yeah, that's generally the main components there, okay? In this video, we're going to learn how to make our own VPC. So we're going to go ahead and type that in the top here, go to VPC Networks, and here we'll create ourselves a new VPC. I'm going to call this my new VPC, and this will be VPC for things. Why would you want to create your own VPC? Well, the default VPC is not recommended for use. You're supposed to create your new one and lock it down to exactly what you need to utilize. But I generally just use the default one because I don't care. Then down below here, we might have to figure our subnets out. It's a lot easier to just use automatic, and so that will set up our subnets for us. Notice that it is single stack, so IPv4. If you want IPv6, go over to here. You might need to set it as dual stack over here. It really depends on what you want to do. But for me, I just want to keep it simple, at least this run through. And so we are going to let it set up our subnets for us, which will be IPv4 single stack. You have our firewall rules. Select any firewall rules below that you would like to apply to this VPC network. And this is if we want to bring them on over. I'm going to leave them alone for now because, maybe if we do use something with this, we'll add them as we go for fun. We can add dynamic routing configuration. I'm going to leave that alone. And then we have best path selection mode. I don't know. I mean, I'd probably just stick with legacy because then I don't have to think. Then down below here, we have DNS configuration. So DNS API needs to be enabled in order to add DNS server policies. Fair enough. We'll go ahead and create our VPC. Okay, and it's creating. We'll give it a moment here to create. Doesn't take that long. I'll pause here, I suppose. There we go. And we have now created our VPC. So here we can go take a look and check its settings. So we go over here and we can see all the subnets. Look at all those beautiful subnets. We didn't have to set up any of those there, but maybe later on we might want to go back and just make exactly what we want. But you can see, we go over here. We have no firewall rules applied, or we shouldn't. So everything is super, super empty. But yeah, we'll work with this and make the changes we need, okay? Ciao, ciao. All right, folks, I'm going to create another VPC here. It's fun creating one with automatic, but I don't think it would hurt for us to set it as a another one. So I'm going to go ahead here and make a new one. This will be my manual VPC. And I'm going to skip over here, and then instead of doing automatic, we'll have custom. And so this will be my subnet 1. And here we'll drop it down. I'm just going to choose Toronto. I'm going to set this to IPv4, IPv6, because this is the only way we'll have IPv6 if we want it. And then here we could associate it. This is with network connectivity. I'm not really worried about that. And then we have our secondary IP address range. Yeah, that seems fine to me. So I can go ahead and hit done. And make sure all fields are filled in. So we do have to put an IPv range here. I'm really bad at this kind of stuff. So we'll just try this, 10.0.0.0/24. So I'm good at it on other providers, but here on GCP, I'm not sure. So we'll go ahead and just create that. And so now we've created a second VPC. We might utilize it to do VPC peering or something, but we will see. I'll let that create and we'll continue on, okay? Hey everyone, it's Andrew. In this video, we're going to see if we can reserve a static IP address. So on the left-hand side under VPC, we'll go to IP addresses. And here we can see right away, reserve an external static IP address or reserve an internal static IP address. So it really depends on what you're doing. I'm going to go here and do an external one. So say my external static IP address. And here we have a couple options. So Google's high quality global backbone. That sounds pretty good. Traffic enters and exits Google network at a peering location. I guess I want to save money here, and it makes it sound like there's some money involved. And also, I don't need IPv6, so we'll do that, and we have regional, so that's fine. And here we're going to say where we're going to get that IP address. So I'm going to utilize Northeast 2 here, and right away it's asking like, do I want to attach this to something? So some of the instances may be disabled due to external IPs of VM. So the question is, can I reserve it right now? It seems like I can. A static IP address not attached to an instance or load balancer are billed at a higher hourly rate. Fair enough. I'm going to go ahead and request that static IP address. That's interesting that it's more money if you don't have it attached as opposed to just costing you money. Other providers do it a little bit different. Notice that it's not in use. Let's put it in use by going over to virtual machines, and we'll figure out how we can attach one. So from here, we'll go ahead and create a new instance, and this will be my Linux machine. I'm going to go here and go to Toronto, as I've been doing everything in Toronto. If you can guess, I live in Canada, so I'm not far. Well, I am far from Toronto, but I wasn't always. Closest major city, only 1,000 kilometers away. Anyway, so we have that probably under networking here. I would think that we could choose our static IP address. I don't see it here. So maybe it's under the network interface. Okay, so here. All right, so I'm looking for where we can attach it. Again, I would assume that it's here. If it's not, let's just click around for a bit. Yeah, it'd have to be. It would have to be on the network interface card. So that's the subnet. That's fine. That's fine. Primary internal IPv4, and then we have the external IPv4. Here it is. Okay, so we can do that. Of course, we can do that for internal as well. We'll go ahead and, so it says 30.04.44.126. So we go ahead and create our instance. Okay, these machines launch really, really fast. I don't know what they're doing underneath the hood, but it's unbelievable how fast these machines spin up. You're like, look, it says it's ready. I just can't believe it when it says that. But here it says 34.0.44.126. So it clearly is attached. We'll go ahead and delete the instance. The question is it going to tear down that static IP address or is it still reserved? That's something I don't know. So we're going to wait for that to be deleted. Okay, it's slower to stop an instance to start one, which is surprising, but we'll give it a moment, okay? All right, let's go take a look at that VPC and, VPC networks and see if that static IP address is still there. So we'll go to our IP addresses, and it is still here. So we're going to go ahead and release that so that we aren't paying for it anymore. And there you go. Ciao, ciao. All right, folks, we're continuing on with VPCs, and I think one thing that Google wants us to know how to do is add a subnet after the fact when we already have a network. So we have the manual one and my new VPC. I'm going to go into my manual one that I created earlier. Let's go over to subnets and add a subnet. So this one's 10.0.0.24. I'm really bad at remembering how this stuff works because I'm not a network engineer, but we'll create my subnet 2. Okay, and it's just our other subnet. This one is in US East 2, and I guess my thought is here is we could create another one in Montreal. So we'll go over to here to this one. And so we can specify its purpose. So it's reverse proxy. No. It's just it's nothing. There's nothing special here. It's just a normal VPC. Maybe you might want it to be dual stack, which is not a bad idea. And we're gonna have to put a range up in here. And I think it's just 10.0.1.0/24. I don't know how I know that. I just know that. If we go over to CIDR XYZ and we were to choose 24 here, you can see there's a count of 256, right? And so see how these are grayed out. This means that this number, this one here, would have to be the one that to be the next one to increment in, if that makes sense. Because coming back over to here, 0 and incrementing this to 1 is the representation of 256, right? When you do that, that makes it 256. So that would be the next address slot as far as I'm aware of. So go down below here, and that's fine. Private Google access. The subnet can access Google services without assigning external IP addresses. I mean, that sounds good, but I don't need to do that. But I guess that'd basically be a private subnet. We have some hybrid stuff down here. No, it seems fine. So we'll go ahead and create that subnet. Okay, it's that simple to create an additional subnet. So we'll just wait for that to create, make sure that it's successful. I can't imagine it wouldn't be. Maybe give this a hard refresh. It shouldn't take too long to create subnets. There we go. And that's how you add an additional subnet. CloudNet is a fully managed network address translation service for secure, scalable, outbound connectivity for Google Cloud resources. CloudNet provides a NAT for the following Google Cloud resources: Compute Engine virtual machines, GKE clusters, Cloud Run instances, Cloud Run functions, App Engine with serverless VPC access, regional network endpoint groups, so NEGs. There are two types of CloudNet. We have public NAT, which provides internet connectivity for resources without public IP addresses, and private NAT. So this enables private-to-private communication across networks. Let's take a look at NAT architecture. So on the left-hand side, we have a traditional NAT, which relies on intermediary proxies to route traffic, adding potential bottlenecks. And then we also have on the right-hand side here with CloudNet, the CloudNet eliminates I shouldn't have chosen such hard words to say, but intermediaries by assigning unique NAT IPs and port ranges directly to the virtual machines. So just be clear that you have one, the typical NAT proxy, or the CloudNet. It's up to you what makes sense for your use case, but there you go. Cloud DNS is a high-performance managed DNS service for publishing domain names globally without managing your own servers. Publish and manage, maintain DNS records by using the same infrastructure Google uses. Supports public zones and private zones. Enables inbound/outbound DNS forwarding for private zones using VPC on-premise networks. Works with managed zones and DNS records through the CLI API and SDK. Use cases here would be managing internal and external DNS records for applications, setting up hybrid cloud with private zones and on-premise networks, enabling custom DNS forwarding policies for cross-network resolutions. There's not a whole lot to say about Cloud DNS. At one point, Google had Google domains, and so these things worked together in tandem. But now Cloud DNS is more similar to Azure DNS, where you can bring in a domain, you can manage it, but you can't buy a domain. But again, pretty straightforward, just a means to manage your domains. All right, let's take a look here at Cloud VPN. This is a service that securely connects your on-premise or other private networks to your VPC using encrypted IPsec tunnels. The VPN connection encrypts traffic traveling between the networks, with one VPN gateway handling encryption and the other handling decryption. Google Cloud offers two types of Cloud VPN gateways. The first being high availability VPNs, which supports IPv4 and IPv6, so that makes it dual stack or single stack, however you want to utilize it. And you have your classic VPN, which does not support IPv6. Use cases here would be to connect to on-premise networks using Google Cloud securely, combined with Cloud Interconnect for high bandwidth hybrid networking, securely connect to VPCs using cloud VPNs, which would be another case here. Let's compare HA VPNs with classic VPNs. So for SLAs, you're going to have a higher SLA with HA VPN because it's highly available. That makes sense. For routing, we're using BGP only, whereas classic VPN, we have static or dynamic. So dynamic for HA VPN only, but BGP only there. For IPv6 support, we just said HA VPN is dual stack or single stack, where classic VPN is not, has no support for IPv6. For external IP assignments, HA VPN is auto-assigned from a pool, where classic VPN, you must manually assign the external IP yourself. For topologies, we got active-active or active-passive. For classic VPN, it's single interface only. Again, this makes sense because HA VPN is highly available, so active-active and active-passive would make more sense there, okay? So firewalls is a security layer that regulates incoming and outgoing network traffic based on defined rules. So for firewall rules, we have firewall rules manage the flow of traffic to and from network resources. These rules are applied at the network level and define which traffic is allowed or denied. Each traffic includes default rules and custom rules, which can be created for specific requirements. Firewall rules control traffic between VMs and a VPC and external sources. We obviously get experience working with firewall rules. You have to know them if you're working with VPCs. But we will look at them more as we go here. All right, let's talk about firewalls and tags. So every firewall rule in Google Cloud must have a target which defines the instance to which it applies. And the default target is all instances of the network. I put an asterisk on that because when you actually look at the form, when you first go through it, it defaults on specified target tags. So maybe if you're doing this programmatically through gCloud, like through the CLI or another way, then it would default to all instances, but you'd have to actually go up and select it there. You have the option to specify based on target tags or specified based on service accounts. When you create a virtual machine, you can apply network tags. So let's say I tag a virtual machine with web server, and then the idea is that on the firewall rules, I can then set a target tag with the same thing, and they'll match against them. The number one thing that makes this confusing, and for me and for everybody, is target tags and network tags, because they're essentially the same thing, because target tags only ever match against network tags. But for whatever reason, I guess like the way it actually works underneath is technically you're making separate tags for both of them, but I don't know why, but Google did not want to abstract that away from their customer. And so it makes it think like maybe target tags can be used for something else and whatever. But essentially, target tags, network tags, same thing. Just think of them the same thing, and then your life will be super easy. And Google, they got to work on their documentation. They got to work on their UI. They got to make this easier for folks because this thing, again, causes a lot of pain for people. But hopefully that helps you to understand. Network tags, target tags, exact same thing, okay? All right, let's take a look at how we configure firewall rules. This is not for policies. I mean, policies is going to have something very similar, but with a few more options. But firewall rules apply directly to a specific VPC, so you'll choose what VPC you want it to apply to. The key thing is setting the priority. What you need to remember is what takes priority, and the lower the number, the higher priority. You should probably work in thousands or hundreds so that you have flexibility when moving around these values. But it always will set as 1,000 as default, so you want to adjust from there whatever you need it to be. You can set whether it's for ingress or egress, so it's either or, and you can say whether if it allows or denies based on the matching option. Then you need to determine how it matches, so you can set by IPv4, IPv6, a bunch of options here. But the thing that I want to highlight is target tags. I think this is basically the biggest headache with firewall rules is that you have tags on your virtual machines or your resources within your VPC to determine who they apply to. You don't have to use target tags, but generally you're going to have to. And so we're going to spend a little bit of time talking about that. When you go over to create firewall rules, you'll notice you'll see two options: create a policy, create a rule. What is the difference? It's really just scope. So the idea is that you have, even though there's only 2 buttons, there's technically 3 levels. You have org firewall policies, folder firewall policies, also known as hierarchical firewall policies, and VPC firewall rules. So the org ones, they apply at the org level. The hierarchical one applies at a folder level and down, and then VPC firewall rules apply to a specific VPC. There's more to firewall policies. There's a lot more options, but what you need to know is these 3 levels, okay? All right, let's talk about Cloud Next Generation Firewalls, or NGFW. It's a fully distributed fire service with advanced protection capabilities, microsegmentation, and pervasive coverage. When you go and type in firewalls, which is how we've always thought about firewalls, at least prior to whenever this was introduced, 2021. Firewalls was a service, and then it got renamed to firewall policies and shoved under NGFW. So when I talk about firewalls, it's really under Cloud Next Generation Firewall, okay? But I'm not going to constantly say Cloud Next Generation Firewall. I'm just going to say firewalls, and that's going to be referred to the firewall policies, okay? But there are different tiers of NGFW. I'm only really familiar with the essential one, as I've never upgraded beyond it, but we have essentials, which allows you to create policies and rules and whatever you normally do with firewalls. For standard, there's a few extra things. Obviously, everything essential is going to be in standard and going up the tree here. But for standard, we have fully qualified domain name objects in firewall policy rules to filter incoming, outgoing traffic from or to specific domains. It also has geolocation object in firewall policy rules to filter external IPv4, IPv6 traffic based on specific geographic locations and regions. You also have Google Threat Intelligence for firewall policy rules. Then for enterprise, you get advanced layer 7 security capabilities and signature-based IPS IDS. Again, very straightforward. Yeah, I'm going to keep saying firewalls, but yeah, technically it's NGFW, okay? VPC network peering enables secure, cost-effective connections between 2 VPC networks for private communication without public IPs or internet. If you've heard of VPC peering, say like AWS, same thing here. Key features: direct traffic between VPCs over Google Private Network, supports peering across regions for global connectivity, maintains separate administration boundaries for VPCs, optimized for fast, high-throughput communication with low latency, avoids egress costs associated with public internet routing. So your use cases here would be to connect on-premise data centers to cloud VPCs for hybrid cloud setups, share resources securely between multiple projects, isolate development, testing, and production environments while enabling controlled data sharing. We got a diagram on the right-hand side so you can have an idea what that peered connection looks like, but that is what VPC networking peering is. So there you go. All right, let's take a look here at the Cloud Foundation Toolkit. So the CFT is a set of Google Cloud infrastructure templates and best practices to help you deploy and manage cloud resources. Some of the key features here are pre-built templates for Terraform and Deployment Manager, enables version repeatable resource management with IAC, includes security, networking, cost optimization best practices, adaptable templates to fit specific project or organizational needs, support collaborative version control and Git for team collaboration and tracking. And so here on the right-hand side, you can see here's a list of links that go out, and they pretty much all go to GitHub. And for the most part, I didn't see much Deployment Manager. I saw mostly Terraform. But we can take a look in a video. I did try multiple times to try to deploy one of these templates, and it did not go well. The other part of it is that these templates are not the latest version of Terraform. So whether you should use them or not is up to you. I guess like if you're closely working with Google and they're helping you deploy it and stuff like that, I can understand it. But I personally did not find these very helpful. But I just want to make sure that you're aware of Cloud Foundation Toolkit. All right, let's take a look here at the Cloud Foundation Toolkit. You can go through the marketing website, but for the most part, it's just on Google. Cloud Deployment Manager has reached end of support December 31st. That's probably why we were not seeing anything for Deployment Manager. Oh, please migrate to Infrastructure Manager, alternative deployment technology. Okay, I'm not even sure what the difference is, as at this point in the course, I've been calling it Deployment Manager. But let's scroll down and take a look. So here's the big list, right? And if you click through to any of these, they're just going to go to GitHub. It's the same place if we go over to here. And, you know, again, I tried multiple times to try to take one of these blueprints and turn it into, like, to show you how to utilize it. But I would just say that it can be a little bit painful to use. So we have DM, Deployment Manager, Templates, Cloud Spanner. So, I mean, that's for Deployment Manager. But let's go take a look here at maybe Terraform. And the ones I saw, it's surprising that this one time I click through, I see Deployment Manager. But I was mostly seeing Terraform, right? So maybe we go down to Cloud Run. Here, Cloud Run. Cloud Run functions. And now all I'm seeing is Deployment Manager, of course. But if we go back over to here, in here, there should be a place for Terraform templates. Maybe we'll go to infrastructure here. Yeah, Terraform, modules. I can't believe it's so hard to find them now. Like I promise you, the only thing I could find before was Terraform templates. So this is under Cloud Deployment Manager. So we'll take this look up again. So we'll go here, and I'm just going to search it again. Maybe just my search results are a little bit different. Maybe because I went to this one here. Maybe that's why. Yeah, okay. So I guess there were separate pages, one for Terraform, one for Deployment Manager, and that's where my confusion came from. And so when I click through these ones, that's why I was always seeing Terraform. But we will go and try to find one. Again, Cloud Functions might be something that might be useful to look at here. Okay, Generation 2 Cloud Functions. And so, yeah, here they are isolate repositories. Okay. And I believe these are organized as modules. I mean, that kind of makes sense. So if you know Terraform, modules are hosted at a GitHub repo and have to follow a very particular pattern. And so they have the usage example, the inputs, things like that. But again, the issue that I had here was that it wasn't using the latest provider. So say this is version 3.0. If we go over to Terraform registry and we go over to the provider here. And we'll go to GCP here. It should tell us the version 6, right? So we have 6 here, and this is talking about 3, right? At least that's how I'm interpreting it. So, you know, this is the challenge, right? Like, there's a huge gap here. It says 0.6, so maybe it is. Well, no, this is the version of this function, right? And so if we go up to here, we should be able to see somewhere in here the Terraform provider. So here we see version greater than 4, less than 7. So in theory, this thing should work on version 6, right? But that wasn't my experience, at least when I was trying to do this. Maybe you'd have better luck than myself. But again, maybe in the future, maybe in the Pro, I'll do this. But for the Ace, I'm just showing you where this is, and just so you have an idea of context, okay? Let's take a look here at Config Connector. It's an open source Kubernetes add-on that allows you to manage Google Cloud resources using Kubernetes. So Config Connector enables Kubernetes managed resources, including RBAC for access control. If you've never heard of RBAC, that's role-based access controls, events for visibility, single source of truth for configuration and state, eventual consistency for loosely coupling dependencies, and its key features are managing existing and new Google Cloud resources, use Kubernetes native APIs for integration, track resources events effortlessly, secure sensitive data using Kubernetes secrets. And the way it works is that you have YAML configuration files that are deployed via your Kubernetes config connector to manage and provision resources like BigQuery, PubSub, and cloud storage. So there you go. What is Terraform? Well, Terraform is an open source and cloud agnostic infrastructure as a code, IAC tool, and Terraform uses declarative configuration files. So here on the right-hand side, we have an example of a Terraform file, which would be named .tf. However, the language underneath is actually called HCL, which is HashiCorp Configuration Language. Notable features of Terraform are installable modules, plan and predict changes, dependency graphing, state management, provision infrastructure in familiar languages via AWS CDK, Terraform registry with 1,000 plus providers. However, in practicality, you're not going to use 1,000 of them. Specific to Google, Google basically had their own means to deploy with Deployment Manager, and Terraform is the main way to deploy infrastructure. So you do want to learn Terraform, and you will see Terraform generated out from the console, examples over the place. So getting familiar with Terraform is a good idea. Okay. Hey, this is Andrew Brown from Exam Pro, and we are looking at Cloud Deployment Manager. So to understand this, we need to know what infrastructure as code is. So IAC is the process of managing and provisioning cloud services through machine-readable definition files, so YAML or JSON files, rather than manual configuration. When you want to have governance in your cloud, you want to use IAC because it means that it will exactly define what there is, and that is a really great way to keep track of exact configuration, okay? So for Google's, it's called Cloud Deployment Manager. So that is their IAC service. You write them as YAML files, and you deploy them via the Cloud CLI. I was a bit surprised to see that they didn't have like an upload, and so I was a bit confused as to how they go do this. If you search for IAC for Google Cloud, you'll see Terraform a lot, which is a third-party provider. For some reason, they just kind of like buried their own IAC solution, but it does exist. And I don't believe there's a JSON format, just the YAML files. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at compute for Google Cloud Platform. And so there's a variety of services, so let's get to it. The first being Compute Engine, and this one is for virtual machines or VMs. And this is generally the primary or traditional type of compute you are going to utilize on a cloud service provider. Then there is bare metal. So bare metal is where you have full control of the hardware. So you can install any kind of hypervisor you want on it or virtualization. It's going to allow you to have very low latency on Google Cloud. Then we have App Engine, which is a platform as a service. Build and deploy apps on a fully managed, highly scalable platform without having to manage the underlying infrastructure. We're going to spend a little bit more time on App Engine because the exam definitely pops up with a few questions that talk about its different core offerings. We have Cloud GPUs, so add GPUs to your workloads for machine learning, scientific computing, and 3D visualization. You have Google Kubernetes Engine, also known as GKE, so reliably, efficiently, and securely deploy and scale containerized applications on Kubernetes. We have sole tenant nodes, and this is known as dedicated virtual machines in all the other different providers. So the reason you'd want to use these is you need to meet compliance. You have your own licenses. You need to keep these instances physically separated with dedicated hardware because maybe you're not allowed to run it with as a multi-tenant. So there's all sorts of reasons for that. You have cloud functions. So these are functions as a service. So you can create serverless single-purpose functions that respond to the events. I guess I could have put Cloud Run on this as well, which is serverless containers, but we have a container section, so it's not a big deal. We'll get to that. Some kind of auxiliary services that are used that are important to know with compute would be Google Cloud VM Engine or VMware Engine. So migrate and run your VM workloads natively on Google Cloud. You have Migrate for Compute Engine. So migrate servers and VMs from on-premise or another cloud to Compute Engine. This was formerly known as Velostrata. Preemptible VMs, so deploy affordable, short-lived compute instances suitable for batch jobs and fault-tolerant workloads. We're going to cover that again when we go to our pricing section. Shielded VMs, so deploy hardened virtual machines on Google Cloud. Hey folks, it's Andrew Brown. In this video, I want to go ahead and create a couple of virtual machines and make sure that we know how to connect to them. We've already done SSH before, but we're going to do it again just to make sure that we know how to do that in a little bit different ways. So we'll go ahead and say my Linux machine, and we'll also launch a Windows machine after this Linux one, but first we'll just do this one. So I'm choosing E2. We're dropping this down to micro. Let's make our way over to security. And in here, this is where we're going to have our VM access. So down below, it says by default, when you connect to a VM using the console or G-Cloud, your SSH key are generated automatically. But you can also add SSH keys here. So I might want to try that for fun and see if that works. So I'm going to do this from my local machine. I'm going to go ahead and open up VS Code. You have to have a local developer environment. If you don't, you can just kind of skip this part and just kind of watch me here. But if you have a Linux machine or something like that, you can go ahead and do that. So I want to generate a new SSH key. I used to do RSA, but these days they suggest to do something better. At least GitHub does. Let's take a look and see what they suggest here. So here we have what? So add SSH keys to instance metadata during VM creation. I mean, I'd rather just do it in the console. It should be really straightforward. Add your public key in the text box. The key must be in the following format. Format of the key without an expiration time or with that date. So your SSH key value, it's not specifying what it has to be. Your username, for example, this. So that's kind of interesting that we were setting it there like that. But anyway, it doesn't say what we have to set it as, so I'll do RSA, but there is a more secure way of doing this now. So go ahead and do SSH keygen. I know it's like TSRSA, but like I need to generate a new SSH key. How do I name the file when naming it? I think it prompts us when we ask. Actually, I'm just going to go for it because I'm pretty sure it asks us. I'm not sure why I'm being so hesitant here. So we'll do SSH keygen, TRSA, and TSRSA is just out of habit. And so it should ask me, but I must have done it wrong. Let's go up here. I don't think anything's wrong. So keygen, SSH. We'll go over to here. Yeah, see, this is the one that they usually have. Use with the example of your GitHub address. If you're using a legacy system that doesn't support this, and this is what I don't know if it does support it, so I'm going to go ahead and grab it here. But it looks like I put the flag in correctly. Maybe I did keygen SSH as opposed to SSH keygen. Enter the file in which you want to name the file. So I want to change the name of this. I'm just going to call this GCP. And I'm not going to put a passphrase on there because that's just a headache. I'm going to do ls hyphen here. And so I should see the key here. But I don't see generated. Oh, enter the file in which to save the thing. So I might have actually just generated it right here in this directory here. Yeah, I did. Remove GCP. Okay, that's silly. So I'll try this again. And maybe I'll make a directory here. We'll just say GCP examples. Okay, and that'll make it less of a mess. So I'm going to try this again. And I don't want it there. I want to save it where I am right now. So I'm just going to go ahead and say IDRSA like this. And now if I do this, there it is. So I have it. And what we're going to copy here is the pub. So we'll cat out the pub. And you notice you get this long thing. If we actually were using the new format, it's a lot shorter. I don't know why. I just don't use it. But I just keep thinking that it's not going to work. So because they don't specify like what format it will take, but maybe the new one does work. And so I'm going to paste this in here. And then I'm supposed to put a space, and then I'll just say Andrew Brown as my username here. And we'll go ahead and don't hit add item. Nope, we'll hit that. But it's not complaining about the format, so this should be fine. And so that should be a way for us to get in. There's also control VM access to IAM permissions. Link VM access to the user and enable OS login. Maybe we'll do that separately in a separate video. But let's just make sure that this thing works with our SSH key. Let's go ahead and create this. Now the SSH port is already open on the firewall for instances. I think that's globally set that for firewalls. As that's spinning up, we'll go take a look just to make sure that we know for certain that that works. So we'll go over to firewalls. Oops, that is not the firewall I want. I wanted this one here. If we look here, we should see 22, right? So allow, allow ingress, right? So we already should be able to do this without issues. And we're going to wait for this machine to be ready. It looks like it's ready. We have different options here. Now, normally I just go with the first option because it's super easy. But this will use the key that is generated and put on the server by Google. I think I would rather, we could use G-Cloud, which is fine, right? See here, it says this, and that's the way to log in. But I want to actually use the SSH key that I generated out. And here it says use another SSH client. So there's different clients you can use. I'm just going to literally use SSH. So now that we have this this key generated out, we're going to SSH in, okay? So it's been a while because I'm so used to using cloud services that kind of do the work for me. I'm going to figure this out. So we need the external IP address. And normally it's SSH, and then it's going to be username. So Andrew Brown at sign, and then the IP address. And then we need to tell it where the key is. So there is a way to specify where the key is, but I don't remember how to do that. So we'll say, if I'm using SSH, how do I tell it where the key is located? There's some kind of flag. I don't know what the flag is anymore. Maybe it's -T? Oh, it's -I. Okay, yeah, that makes sense. So we're going to do -I to tell it where it is. And it's going to go to the private key, of course. So I'm going to do -I, and this will be ID RSA, right? And so I'm hoping that this just works. And so this is normal. You give you fingerprint, we'll say yes. And this is permission denied. So I didn't get in, but I'm not sure as to why. So we'll go back over to here and try to figure out why that is. Okay. So yeah, I'm not exactly sure as to why. Because here it says ingress apply to all IP addresses 22, allow, but allow from where? From the default network, right? So it's not necessarily allowing me for my address to connect. So maybe what we need to do is add a firewall rule. So go ahead here and just say my SSH location. And we have this on default. This is ingress. We can specify specific tags so that it's only applied for very specific things. That wouldn't be a bad idea. But here we can specify our source IP. So I'm going to say, what's my IP? We'll go over to here. I hope I get an IPv4 one. I really can't handle IPv6. And this is my IP address. So I'm going to try and do it this way. And so here it's saying, what are we allowing to come in here? So I do this. And I'm going to do /32. That just means exactly one address, my address. And here we can specify specific tags, but basically we're not. We're just going to say, as long as the IP address is here, then it should be able to come through. It's going to allow the SSH port. So we'll say TCP. This is port 22. Yeah, that's port 22. So, and I don't think it's UDP. Yeah, SSH is TCP. SSH is TCP, right? Yes. Yes. Okay. Again, it's been a while since I've had to open a port, which is surprising because I'm, always doing stuff. But hey, we'll go ahead and create this rule. It says go to issues. What's the problem? Target tags. Oh, all instances in this network. There we go. So we'll go ahead and create it. And so this should allow, my computer from my address to be able to connect, supposedly. The SSH port 25 disallowed. That's fine. I wasn't paying attention, but it did set it to priority of 1,000, so it does take priority over here. And again, we're carefully looking here about where. It says network topology on everything. And I mean, it looks like this one says apply to all. So maybe it's already open, right? We go over to here. Yeah, it's open to the internet. There doesn't seem anything that wouldn't be open here. And down below, we have this external range. So I'm not exactly sure what the problem is. The problem might be that we didn't make this file readable, right? So when you create, maybe it tells us here. When you create an SSH key, do you need to change its permissions? UG chmod. There is something, I just forget what it is, 422 maybe? Oh, 600, okay. So we'll change this to 600. Oh, that was 422. And we'll try this again. So now we'll go ahead and hit up. Permission denied, but it's not telling us to why. I mean, here we're not really specifying the full path. So I might want to go ahead and just grab this. I just want to make sure that we're giving it the right information. And it's still denied. Okay. So that's not working. What we can do... so I don't think this mattered. We figured this out. This doesn't actually matter. The port's already open. Okay, it's because I read it wrong. So we'll go back over to here. I'm just going to spin down this one here. Delete. And I'm going to go... and I'm going to delete this key here. I'm going to try the other format because the other format is a lot more concise. And there's going to be less chance of like a copy-paste kind of issue, which is kind of annoying with the old... RSA algorithm here. So I believe this is spinning down, but we'll go ahead and we'll create a new instance here. And this will be my VM instance number 2. This is fine to be an E2. We're going to switch this over to the E2 micro. We're going to go to security, and we're going to look at managed access. Yeah, so everything's fine. We'll also check the networking here. IP forwarding, we don't have to do that. Yeah, so everything is fine here. The only other thing I can think of is that it could be the machine not allowing it, but I don't think that's the case. So what I'm going to do, we're going to go back over to here, and we're going to add another SSH key here. We'll click onto this and see if there's any details here that was additional here. Add an SSH key. So to disable OS login, clear controls. I don't care about to add manually generated one. If you want to add a public SSH key to the project metadata, clear the block project-wide SSH keys. I don't think that was checkbox. That's off. Add your public key to the text box. SSH key, public key, yeah. But again, here it's not telling us the format that we have to use, right? So, and we can go over here and take a look, and this is, I guess, another way for us to add that metadata. I mean, that's a little bit different, but that's fine. So I'll go back up to here again, to the console. And then the username, right? Okay, so we'll go back over to GitHub, and we'll just say, like, SSH key gen. And it's almost always GitHub that tells you how to do it. And so there is this newer one that's like this format. And so we'll give this one a go instead, okay? So I'm going to go ahead and hit enter here. And I actually just want to, again, do this in place. I'm going to control C that. That did not work out very well. So we'll try this again. And here, I'm just going to do this, and we'll say ID ED25519. ED25519. Okay, and we'll do LS. And I just want to cat this out and show you, like, this is, oh, that's my private key. Doesn't matter, I'm not going to delete it anyway. But if you look at the public key, look how much shorter it is, right? And actually, it follows it on the end with this. So maybe when I copied it, I copied not only the name of that, but that was another issue. So let's take a close look at the format here to make sure we're not making any mistakes. So here, over here, we go back to here. Under SSH keys, add the item. Add your public key into the text box. The key must be in the following format. Format a key without an expiration date. The thing that's not clear is, like, see how there's a space here and we have this part is 1, 2, 3. How would it know? How would it know? Let's go over to gcloud. Let's see what we have. So here it has SSH RSA, right? And then the name. Okay. I wish they would show full examples because it's not clear when they do it that way, right? Your username, for example, is that, or it's this. For the usernames can't be root. Okay. So I don't know, maybe I'm going to copy it like this. I'm going to just see if I'm going to take off the @Del Brown. I'm not going to take that part of it. And I'm going to try to copy it that way. Okay, and we'll try this again. We'll see what happens. So I'm going to go ahead, and now it's technically meeting the format that it wants. We're having no issues here. We'll go ahead and create it. And so now it's just Andrew, and we'll also chmod this to make sure this is correct. So we'll say chmod. And oops, we'll just type in ls, and we'll say chmod. What was it before? It was this. And we're going to wait for this to spin up. These VMs spin up pretty quickly, so it's not that big of a deal. There we go. So we're going to grab that external IP address, and we'll try this again. So this is going to be SSH-I. I'm going to try to do just like that in place. Hopefully that works. And we have our IP address, and this will be Andrew at here. Hopefully that works. It has to be the .pub, so make sure it's the .pub. The .pub. Actually, no, it would be the local one. Say yes. It is required that your private key files are not accessible by others. The private key will be ignored. Bad permissions. Okay, so did we not chmod that? Okay. So I'm not exactly sure because we changed it. Maybe it says they're two open. But we just chmodded it. Okay, so what we can do is do an ls-la and take a look here. And we'll try this one more time. I think it changed, right? Did it change? I don't think it did. What if we do 400? Maybe it doesn't know what it's doing. I usually do like 422. Let's try that again. Okay. We'll copy this. We'll ask Claude. This is the problem. When you use LLMs, your brain starts to rot. But we'll go ahead and try this and see what it says. I did that. Chmod. And we'll try this again. Yeah. Right. So I'll go here. It's crazy. Windows file system doesn't support Unix style mods. Oh, am I not in... I don't know if that's the case. Let's see here. The permission fix should resolve the issue you're having immediately here. The permission didn't change because you're working on a Windows file system. Doesn't support Unix style permission, so chmod has no effect. Copy the key to your Linux home directory. Oh, okay. I did not know that. I mean, maybe that's the case. I don't know if that's true or not, but I guess we'll find out. Because that is a mounted directory. That's kind of a weird edge case, right? So we'll go here, and maybe we can just move this entire directory. So let's just say move GCP. Move GCP to our home directory. GCP examples. And then we'll go into that one. And then we'll chmod that again. So, and now we'll do else. There we go. So now it's starting to change it. Excellent. Okay. So now what we can do is we'll just hit up until we get to here. We'll try that again. And now we're in the machine. Okay, so, obviously some things here, like there is this edge case with WSL. So if you're using WSL, don't do what I did, right? Make sure it's actually on the Linux machine. But we were able to attach it, and we were able to mangle the name there on the end. So I guess that didn't really matter as much. But yeah, there you go. We're connected to that via SSH. Again, I just normally go here and I just connect this way. I find it the easiest way to connect. But if for whatever reason you need to use SSH keys, there you go. We can type in exit, get out of this machine. So we'll go ahead and we'll spin this down. Okay, and I'll see you in the next one. Ciao, ciao. All right, let's go ahead and see if we can spin up a Windows machine and RCP into it. That's remote, or RDP, remote desktop protocol, to get into it. So go here and say my Windows machine, right? Make sure you just go add an instance. And I need to launch something that can run a Windows machine. So Windows requires a lot more resources, maybe at least an E2 medium. And we need to go over to our OS and storage. And we're going to change this over to Windows. So I'm looking for Windows here. We have Windows Server. I think that's the only kind of Windows we're going to get here. I am not a fan of the Windows Data Center server. It always confuses me when I spin it up, but that is our options. It says with desktop experience. Notice where some don't have desktop experience. So make sure you choose one with desktop experience. Yeah, balance disk is fine. 50 is fine. I want to go over to, what is it, security. We'll go down below. So yeah, I'm not exactly sure how we're going to RCP into this. I don't spin up Windows machines very often here, so I kind of forget. I probably would want to choose more resources because, again, it's the Windows machine. It always needs more. This only has 1 to 2. And I might want something standard. So I'm going to choose this. And that might be a lot of money. If you're uncomfortable spinning this up, don't. But notice it's only like 0.32 cents. You could spin something up smaller. I just don't want... Yeah, we could go half, I guess. It's still really small, though. Yeah, it's not going to make a huge difference. If you're not comfortable, don't spin it up. You can just watch me, but we'll go ahead and work our way through here. So we have the Windows server. I don't know if the port is open for RDP, but I don't know if that matters. If it's not, we'll figure it out as we go. So let's go ahead and create our instance here, and we'll see what happens here. Because I'm not sure where we're going to see that option. Maybe RDP will just show up in place of SSH. So we'll just wait for that to... Yeah, exactly. Cool. Okay. So just wait for that to become available, okay? Oh, it's already up. Now, I don't know if it's actually up because it might take a little bit longer for it to get booted. Or if we could look at the logs and see what's happening. Yeah, it's booting. Okay. So we'll go back over to here. And let's see if we can do it. So we have download the RDP file, set the Windows password. That's really nice. View the gcloud command to reset password. So I'm not sure if we need to reset it. We'll go ahead and download the RDP file. I guess if we've never set one, how would we know what it is when we log in? So when you download RDP file, it's here. If you're on a Windows machine, you already have RDP installed. If you're on a Mac, RDP App Store. You go here. It's totally free. You can download it. I don't know if there's one for a Linux RDP client. Apparently there is one, but I've never done it from a Linux machine. But anyway, once you have that installed, you basically double click. It's going to ask you for to confirm. And then we need a username and password normally. So right now it's trying to connect. Normally it pops up and says, hey, whatever. I don't know if the machine is still spinning up though. So notice like how it's hanging and it's taking its time. So I'm not sure. The other question is, oh, here we go. Remote desktop cannot connect to the remote machine. Remote access to the server is not enabled. It's not turned off or it's not available. So there's obviously something more to the story here. That's the problem. So we'll go take a look here and say RDP on GCP and see if there is information because maybe we have to open that port in our firewall rules. I don't know if that port is open by default. So we'll go over to our firewall rules here. We'll type in firewall over to here. And on the left-hand side, under firewall rules, I'm looking for that. So we have 3389. So it looks like it's open by default. So we'll go down here, and it says before you begin, connect to the VM by using RDP. VM without a public IP address, it should have one. Let's go make sure it does have one there with a public IP address and RDP exposed. I mean, should be, right? Connect from anywhere. Yeah, I don't know. So maybe what we'll do while we're waiting here is just reset the password, set the Windows password. So if a Windows account with the following username does not exist, it'll be created for you. So we have the username. If the account already exists, okay, we'll say set. What about the password? And this is our new password, I guess. So I'm going to go ahead and just paste it into a note here off screen so don't lose it. There we go. I saved it. I think it's the same. Looks the same to me. We'll go ahead and hit close and we'll try this again. So we'll say, I don't think we have to download the file again, but just in case we do, I'm going to go ahead and delete it. I don't think it stores anything other than the address. But I'm going to download that file again. I'm double clicking it. We're bringing it on over. We're going to connect and see if it works. So now it pops up. So probably what we had to do is reset that password. So I'm copying that password in here and pasting. Actually, you know what? I can't even do that. I have to write it in manually. So that's 7mmcsq 7mmcsq r6 H B I O D S C. Okay, so 7mmcsq R6H B Oh, it's BIO. Okay, BIO. So we got to go back here. I can't tell if it's correct or not. So BIO. It looks like it's correct. ODSC. So it doesn't look like it's putting any number. Well, like, there are numbers, but I think that O is actually no. We'll go ahead and try that. And hopefully we can connect. Come on, come on, come on. Yes, it looks like it's connecting. And we're now in the machine. So that's all I wanted to show you was how to RDP, because sometimes it's tricky. On AWS, it's very tricky. On Azure, it's very easy. But of course, Microsoft and Azure are the same thing, and they make Windows, so it would be easy. But this wasn't too bad, right? So that's it. There we go. I'm going to go ahead and close that out. And we're going to go ahead and tear down the server. So we'll go ahead and delete it. And I will see you in the next one, okay? Ciao, ciao. OS Login is a feature that links SSH access to IAM, eliminating the need to manage individual SSH keys. You can link your Linux accounts to Google identities for consistent access. You can use IAM to manage precise SSH permissions. Permissions update dynamically with IAM changes. You can sync Linux accounts with AD/LDAP for unified IDs. With two-factor authentication with Google accounts, you require OS Logins users to verify their identity using one of the following methods: Google Authenticator, text message or phone calls, phone prompts, security keys, OTP. Very great feature. I'll show you how to use it in the lab. All right, in this video, what I want to do is show you OS Login. This is a way for you to SSH into a virtual machine without the need of an SSH key, and it's going to be relying on your IAM permissions. My user is quite permissive, so I imagine that I will probably be able to get into it, but if I'm not, then we'll go in and attach the permissions. If it does work, and I didn't have to do it, I'll still show you the permissions so that you're aware of what you need to do. Let's go ahead and create an instance, and here this is to be my VM instance 22. Why not? And I like to launch in Canada because I am in Canada. The closest place to me is Toronto. And we'll go ahead here, do an E2, and we'll say an E2 micro. On the left-hand side, we'll go to security, and there's an option here. Well, we have VM access down below here. If we expand it, we have control VM access through IAM permissions. As far as I understand, that's adding a metadata key for like OS login enabled. So maybe we'll investigate the metadata after that. Notice that you can require two-step verification. So that's probably a really good thing to have on, just to make sure people aren't gaining access to these machines that should not. But anyway, we're going to go ahead and create this instance. There should be some way for us to view the metadata. So we'll go click into this once this instance is ready. Here we go. And I'm looking for metadata information. Metadata, 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 metadata. Should be somewhere here. Down below, see here it says enable OS login true, enable OS config true. It's OS login is what has been enabled. It's unusual that it's lowercase because I've definitely seen in other places it being capitalized, so maybe it's case insensitive. The question will be, can I actually get into this machine? I'd have to create another account to really show you if I wanted a very unpermissive account, but I don't want to do that. Let's go ahead and try this. And so it shouldn't use, it's transferring the SSH key. It shouldn't have to do that though. Let me drop this down, hold on here. So how do I know if it's using OS login? That's the good question. Just a moment, okay? All right, so what's unusual is that I just watched this video here, and what's unusual is that when you actually click this and you're doing this, it still says transfer SSH key, and so that always shows up. So it says allow SSH into the VM, sure. But did it use SSH key or not? Because it's not clear because of the UI. So I'm not sure how we would distinguish that unless we created another account and tested it. But the problem with this right here is that my account's just too permissive. So if we go over to Japanese keyboard, 1 second here. If we go over to IAM and we take a look at our users, right? So I'm Andrew Brown. I'm an organizational administrator, right? So I have a lot of access in terms of what I can do. I could try to remove that and see what happens. If I remove administration owner, can I remove that? I added it for another video, and so I'm just trying to see here. Grant access, remove access. Are you sure you want to remove yourself as the project owner? No, I don't want to do that. I was just trying to get rid of that role there on me. Hold on here. Well, whatever. Yeah, I'm not exactly sure right now how to remove that. I'm not the best at permissions. I don't know. I find permissions within GCP really, really confusing. But anyway, what I want to show you here at the very least is those additional permissions. So if you want to give someone access to OS login, it should be OS login here, right? Once again, OS login. Yeah, so we have compute OS admin login, so access to login to compute engine instance as an administrator, access to login to compute engine instance as a standard non-administrator user. So you have those two options that you can set. But again, because I'm super permissive, I don't really have that problem. And the only way I could really show this is by creating another account, and it's a bit of a headache for me to do that. So I'm not sure if I want to do that here today. But at the very least, you understand how it works, right? And if it doesn't make sense, you could watch this video here. But yeah, they don't really call out as to why that's confusing. That option there, like why does it say it's doing SSH transfer? But I guess they just can't change the UI there. But that's totally fine. So what we'll do is go over to Compute Engine. Okay. And we'll go ahead and just tear that down. Okay. And you generally have an idea of how OS login would work. All right, ciao, ciao. Hey, it's Andrew Brown, and we are going to learn about disks within Compute Engine. So on the left-hand side, we'll go to Compute Engine, over to disks, and we'll create ourselves a new disk. So what I want to do is create a disk, and then we will mount it to a virtual machine. So let's say my alt disk. And you see we have the option for single or regional zone. I'm going to stick with single here today. I'm going to switch over to CA Central North America, Northeast too. And I'm going to switch over to C specifically because when I was launching in A prior, it was saying there was no availability. That is a message that can just happen at any time. So if you are launching an instance of a disk and it doesn't work, just try another place and make sure everything's tied there, or just try in a little bit until one becomes available. So we have quite a few options here. We have blank disk, image, snapshot, instant snapshot, which is basically very similar to a snapshot, and an archive snapshot. We have a bunch of disk options, and you can compare your disk types here if you want to. We can choose a size. I'm going to do a odd size of this size, so maybe we'll do 12. I'll just make it easier for us to identify it when we mount it, and when we resize it, we'll have something that we can change the size to afterwards. So then here we can enable a snapshot schedule. I don't want to do that here today. It's not a bad idea to keep that checkbox so you have incremental backups. We can set a consistency group. We have our encryption key. We'll leave it as the standard Google Managed Encryption key. We can add labels. We can add tags. And we'll go ahead and create that. Okay? So we'll give that a moment to create. Now that our disk is created, what I want to do is go ahead and create a virtual machine and mount this disk. So we'll go ahead and create a new virtual machine. This will just be my instance, whatever you want to call it. So I'm just going to say my instance extra disk. And I'm going to make sure that it's in the same region and also in the same zone so we can mount it. I don't believe we can mount cross zone. We're going to choose an E2. We'll go down below, and I'm going to drop this down into an E2 micro so that we are saving money. Let's take a look at some advanced configurations. Actually, we don't want to do that. I want to stick with this. No, it didn't affect anything. Sometimes, I think it's when you go to custom, it affects it here. Anyway, we'll continue over to the OS and storage. We are utilizing Debian, so that's what it's defaulted to, and that's what I like to use. Notice here that when we're setting the boot disk, because that's what we're doing here, right? We are setting up our boot disk, that we could bring an image, a snapshot, or an archive snapshot, or even an existing disk. But we are technically creating a new disk right here. So in other providers like AWS, they don't make that distinction as clear that you're creating a disk here. But here it is clear that we're making one, and we can even choose the disk type here. So that should be pretty clear. And we're going to go with 10 here. We're going to add our additional disk. We're going to attach that existing one, and we'll drop it down here. We have read and write. I'm going to leave it on read write. We're going to keep the disk. I'll also give it a custom device name. This is just a way that we can reference it for mounting or resizing, though I never seem to ever do that. I just use whatever it's called in Debian or in Linux, and that's fine. I think that's everything that we care about. There is information for doing backups. You probably should have snapshots on schedule, but I'm going to turn that off because, again, this is just for showing things off. And if we go down below, exclude the boot disk. So save costs by only replicating data in non-boot disk. So lots of options for replication that you can set here, but that's everything we want to do. So I'm going to go ahead and create this disk and virtual machine. And once this virtual machine is spun up, we'll go SSH into it and begin the process of mounting. So any provider that you use will have a very prescriptive way in terms of how they want you to mount the disk, because there are some things that are specific to each cloud provider. But let's go take a look and look up GCP mount disk for their instructions. I have done this lab, I think, like 4 times because I have this problem when I reboot the machine. It just stops working because of fstab. But I asked my co-founder, also named Andrew, to fix it, and he pointed out my mistakes. So I'm going to make sure I point that out to you, because if you just blindly follow this stuff, there is a step here where it copies information that you don't expect it to copy. But we'll get to that, and I'll point that out once this virtual machine is spun up, okay? All right, so it is ready. I'm going to go ahead and SSH over here. So we'll go ahead and click that. You can also SSH via G-Cloud within Cloud Shell, but I just click that and open it here this way. I find it super, super easy to do it this way. And we'll get into this machine. So now we're going to follow along here with format and mount. So, I mean, there is this command. There's another command that we can just look at disks. I'm trying to remember what's called FBLSK, I think it is. I don't remember what it is, but let's go take a look and ask Claude. As these are commands I don't normally remember. We'll say common commands to view disks on Linux. There's a couple. I think fdisk is one. Yeah, dh, df, dh, du, but I was thinking about this one here. So let's go take a look at list block devices. All right, so that one should be installed. Right, and so here we can see SDA and SDB. This is a naming convention based on, or by Linux, and I think specifically Debian, where it's going to name it SDA, B, C, D. It's just the order of when these are mounted. And so you'd think that SDA would be the boot disk, but that's not always the case. Sometimes it is, sometimes it isn't, but in this case it actually is. SDA is the boot disk. But if you do this, it might be in a different order, so I wouldn't really worry about it. There's obviously df-h, so that's going to show us how much space is on each one, right? That's actually available. So here you can see the boot disk, and some of it is being utilized, obviously. So there is more information there. But, and also, yeah, these we can see that the boot disk is partitioned into 3 parts. So we have SDA 1, 14, and 15. And you can see we have 1 and 15 for its usage. I don't know where 14 is. I'm not really worried about it. But anyway, we'll continue on here now that we can see using LSBLK our disks and our partitions. Now this one obviously doesn't have any partitions yet. And actually we're probably not going to have more than a single partition here because of the file system we're going to use. But let's continue on and see what instructions we have. So here it says, in the terminal, use symlink created for your attachments to determine which device to format. So we'll go ahead and we'll list this out here. And what they're showing here, or what they want us to see, is if disks have partitions or not, right? And their names, right? So here you can see that these are symlinked over to these. So I guess we can use this as the name, and this would go to the same place, more or less. But anyway, we have SDB, SDA. You can see this one has partitions. This one has no partitions. Okay, so we'll scroll on down, and we're going to use the MKFS tool to format this drive. So here they're suggesting do ext4 because you can use this file system without a partition, and also you can increase the size of your disk later on. I've been using cloud for so long that I've been using file systems where I'm so used to having to create those partitions manually, but this file format or file system is really, really nice, and we're going to use that here. So here they want us to specify the file system type, so we'll go ahead and enter that there. The other thing is the device name. This one is SDB. Okay, but understand that for you, when you're doing this, it could be SDA, it could be something else. So just make sure you pay close attention. We do not want to format our SDA or our boot disk, right? Just the alternate disk that is there. So I'm going to go here and copy this command. We'll go ahead and paste it in. This runs really, really fast. And so now SDB is formatted. We'll scroll on down here and we want to mount the disk. So this is just going to be the directory where we want to create it. The -p flag will make it so it will create all the subfolders. And you can mount it to disks. I normally like to have it on /mount and then the name, but we're going to just follow along here because they have it here and there's nothing wrong with it. But I'm going to call this my alt disk. We're going to copy that command and we're going to hit enter. And so now that directory exists. We will probably want to chmod that directory, give permissions. And here, this is the ability for us to mount it. So we'll go ahead and use the mount command. Okay. And then here they're saying configure read and write permissions, right? If you don't, you'd have to use sudo every time, and that's kind of annoying. So we'll go ahead and chmod. So the process here is pretty darn straightforward. It's not too bad. But yeah, Google Cloud's not bad, except for when they don't document things and then you shoot yourself in the foot. Okay, so we now have that directory and we can go ahead and create a file there. So I'm going to go over there and we're going to go and to this drive. I'm going to just make a new file called touchhello.txt. I'm going to open the contents of that file. You can use Nano or Vi. If you do not know how to use Vi and you're bad at it, use Nano. It'll make your life a lot easier. But because I know how to use Vi, I'm going to go ahead and use Vi. So I'm in Vi, and right now I'm in normal mode. I want to start writing, so I hit I on my keyboard to enter insert mode. If I want to get out of that mode, I hit escape. If I want to enter that mode, I hit I. Okay, so I'm just going to type in hello world, exclamation mark. I'm going to hit escape, colon, to bring up commands, W, Q, write and quit. Okay, and so now I can cat out that file. And we can see that that file is written to disk. So one thing you'll probably want to do is configure automatic mounting. And this is where I run into trouble because I was following through here and there was something that was appended here that I didn't notice. And this happened both times. And so my co-founder had to take the disk, mount it to another machine. That's usually how you debug disks, right? So if you're having a problem with the disk and it's not booting up, you have to launch another virtual machine and then mount that disk to then go and inspect what the problem is. I didn't want to go through that process, so I had him do it. But here you can back up your other ones. Probably not a bad idea, so we'll go ahead and do that. So here is our backup. And here, use the BLI command to list the UID for disks. Okay, so we'll go ahead and do that. And so now we have here, well, this is for SDB. So we have to pay close attention to which one we want to list out. Yeah, it is SDB, okay. For me, right? Again, for you, it could be SDA. So we now have that there. And then the next area, it's asking us to replace the value here. So I'll go ahead and do that. And I think where I was messing this up is the fact that I wasn't adding the mount option. And so that's what my co-founder was telling me. So he was saying like, hey, here's your problem. You keep copying this command and you don't see that mount option there, right? And so what he said here was to just, this we say no fail. So that's what it's supposed to have. Let's give this a careful read here. So specify what operating system does if it can't mount the zonal persist. So for valid values, the fourth field in the fstab documentation. So here it's saying if the disk is unavailable, set it to no fail. So that is something we'll have to set. 4 times. I did this thing 4 times. Not only did I create 4 times, I created other labs and it was quite the pain. So I'm really reshooting a lot of stuff. That's my voice sounds a little bit strained. So we'll go ahead and, well, that's the line we need, right? But it actually has to go into the correct file. So that's going to go into fstab. And here it doesn't say how to edit it, but we're going to use Vi. I'm going to put sudo in front of it because we probably have to because of what it is. And again, you can be sudo nano / etc fstab or Vi. It's up to you. I don't even know what fstab stands for. My co-founder is a lot better at administrating machines. I'm more so a developer, so he knows all this stuff. So, but normally, let's see, what does this stand for? FSTAB, static information about file systems. Okay, not clear with the naming there. It's usually when you open up man, it will tell you as to why, but that's fine, whatever. So I'm going to go ahead and do sudo by / etc. fstab. We're going to open that up. We're going to go all the way down. I'm hitting J and K. I have a Vim course, by the way, on my YouTube if you need to learn it. So I'm going to go ahead and copy this line. I'm going to go ahead and paste in this line. And so this time I made sure that it has no fail, and we'll hit escape. We'll do write and quit. So now what I want to do is just close this, and I want to make sure that this machine is going to reboot. And this is where I would run into a lot of problems. We're going to go ahead and stop this machine. So we're going to hit stop. We could restart, but I want to guarantee that this thing is stopped. Okay, so we're going to stop it. And then once it's stopped, I'm going to start it back up, okay? All right, so the instance is stopped. We're going to go ahead and start that back up there. And what I'm hoping for is that the instance will start back up. If it doesn't, what will happen is when it might start up, but when we try to SSH into it, it will give you a thing about the connection not working, and it'll talk about cloud IAP, but really what's happened is that it didn't boot up because it failed. So that shouldn't happen in this case because we have that no fail flag, but if you do have that issue, the problem is what I just described, and the solution would be to take the disk and mount it to another VM and fix the problem, or just delete the VM and restart over, which is probably a lot easier to do. So that instance is now back up. I'm always surprised how fast these instances spin back up. I'm just used to waiting a bit longer. So it makes me think that they're not ready. But if it establishes a connection, we are in good shape. So let's go ahead and authorize that there. Okay. And so now we're back in there, and that is good. I want to do other things with this disk, and so we can do things like, if we go into my alt disk here, we can create a snapshot, we can create an image, clone a disk, things like that. So I'm going to leave this stuff running. If you don't want this stuff running, you can obviously destroy it. I'm going to do a cleanup video later, but I'm going to continue on in other videos doing other things with disks, okay? See you in a bit. Let's take a look here at snapshots. So snapshots allow you to save incremental backups for your volume data. There are 3 types of snapshots: standard, instant, and archive. And let's compare the functionality across these 3. So if you want snapshot scheduling, it's only available in standard. For the rest, it's not. For hyperdisk support, it is in standard. But for the other ones, it also is. But for instance, for some reason, it's only there for certain types. I don't know why, but it just is. In terms of redundancy, you get that both for standard and archive, but not for instance, because it's instant, right? The idea is that you're trading redundancy for snapshots that are a lot faster, okay? In terms of whether it's deleted with the disk, it's not going to be the case for standard or archive, but for instance, it is. Right, so that's again going to be another trade-off there in terms of recovery. And this was something that I couldn't fully find out. Like, you could ask Gemini and it will kind of give you an answer, but I had to basically do this to test and observe to get an idea, because standard and instance seem so close together. But for standard, you're looking at tens of minutes. For instance, it's like seconds to minutes, and for archive, it's tens of minutes to hours. And again, that was my own research because the Google Docs was lacking there, but there you go. Let's take a look here at snapshot schedules. So snapshots allow you to save incremental backups for your volumes data. When creating a volume, you can turn on schedule snapshots that run on a schedule. You can set the frequency based on hourly, daily, or weekly. You can tell it how many snapshots to retain. So here you can see down below, it says auto delete snapshots after 14 days, okay? But there you go, pretty simple. Let's continue on learning about disks. So on the left-hand side here, we have 2 disks. We have my alt disk and my instance disk. This is the one that is our boot drive, and this one here is our additional disk. So we're going to go over to here, and what I want to do in my alt disk is I want to create a snapshot. So a snapshot is when you have incremental backups. So the idea is that if you change something, you can go back to a prior version. The trick to restoring a snapshot is really you're creating basically another disk and then mounting it. But let's go ahead and create ourselves a snapshot because we have scheduled snapshots off, so we basically are doing them manually. And so we'll have this called hello world because that's the state that it's in that text file, and that's the only thing we're going to change. Notice if we drop it down, we have disk and instant snapshot. I don't know why they do this here because you'll notice here they have the option right there. So I leave it on disk, and then we can switch it from snapshot to instant snapshot. Notice that we have snapshot. This is a standard backup in disaster recovery stored in a separate location from your disk. If you want to restore quickly, then there's instant snapshot where it's stored in the same location as your disk. And then we have archive. So as it says, archive. I want to do an instant snapshot because I'm just going to do this in the same location, and this will make it a lot faster. And if we scroll on down here, we can go ahead and create this instance. And down below here it says your free trial credits will be used for this thing. I didn't even know I had free trial credits, but that's totally fine. I don't care. We'll go ahead and hit create. So we're just going to wait for that snapshot to create. But what I want to do is I want to go into that virtual machine and then update and then take another incremental snapshot. And then we want to restore to a prior version, okay? Actually, I think I just finished creating that snapshot. So let's go back to our VM instance. And I'm going to go and SSH into it. Okay, and we are now SSHing into our instance. Okay, so we'll hit authorize. We'll give it a moment. So now we're back in here. I want to make our way to our mount directory. We actually didn't check that if the directory was still mounted afterwards, but I assumed that it was because it rebooted. And there it is. So I want to update our hello.txt. I'm obviously going to use vi. You can use nano if you want. So I'll do vi hello.txt. And we have hello world. And I'm going to say hello, hello moon. And I'm going to write and quit. I'm going to cat, make sure that's the content of it. There we go. And I'm going to close this out for now. And we're going to go back and make another snapshot. So we'll go over to here and we'll create a snapshot. This will be hello moon. We'll go to instant snapshot. Again, if you go to snapshot here, you could then choose a different region. I don't care about doing that. So we'll have an instant snapshot. That is good. We'll go ahead and create that. And so now we're creating an additional snapshot. So the idea is that now we have two snapshots, and whichever one we want to restore, we can. But notice how fast these snapshots occur. They're really, really fast when they're instant. So let's say I want to restore this one here. Well, actually, our current one has that one. So I might want to restore this one. So the way that we would do that is we would need to create a new disk, right? So I wonder if I click into this, if it, yeah, here we have create disk. You could obviously do it from the create disk thing, but I clicked into it and we will create a new disk from here. And this will be my alt moon disk because that's, actually no, this is like my world disk because currently the current disk is on moon and this is the old one. But let me just make sure that I selected the right one because it's easy to forget. So we'll click into that one. We'll create that one. We'll say my world disk. And then here we're saying, how are we creating this disk? We're going to create it from an instant snapshot. Here is the source instant snapshot. We can also change the size if we want right here. I will do that later on. I'm not that worried about changing that right now. I'm going to just take off the incremental snapshots since I don't need them. We're going to go ahead and create that disk, and we'll wait for it to create, okay? Okay, so we now have that additional disk, and let's go ahead and mount it so that we can see the results. Because the way that you would bring that disk back is you'd have to mount that one and unmount the other one. I'm not going to unmount the other one, but we will at least go through the process of mounting as we have already learned to do that, and it's not too difficult. I still have the tab open here for that information. So we'll give that a moment to connect. Okay, and we're going to go ahead and type in lsblk. Right, and so, well, you know, we actually haven't attached the drive yet, so that's why we don't see it. So we'll go back over to here, and we can actually edit the instances. So if we click into the instance and we click on edit, we can go down below to the actual disk, wherever it is, additional disk, and we're going to say attach existing disk. We could even add a disk here. That's not how I want to do it. So we'll drop down the world disk. We'll checkbox that on so it has its alternate name. Read and write. Deletion rule, if it's deleted, keep the disk, or you can have a delete with it. I don't think I pointed that out before, but that's okay. So now that disk should be attached. I wonder if we have to restart it. I don't think we have to. And yeah, I don't see the disk. Oh, I didn't hit save. That's why. It's the forms. They're misleading. So we'll go ahead and save it. We'll give it a moment here to save. Our disk is now saved. What I want to do here is, what do I want to do? I want to go back over to our SSH that we have open, and let's see if it appears now. And so now we have another disk, and you'll notice here it's SDC. So let's go through that process of getting that ready and mounted. Now we don't need to format it because we've already have a disk file system on there that has data in it, right? So we just need to go ahead and mount the disk. So here, this disk is called, what was it called? What did we call it? We can go ahead and grab this command to find it. That shows the symlinks. And this is going to give us what? My world disk. Okay, so we're going to go down here. Right, this will be my world disk. We'll copy that here. I'm going to go ahead and paste that in here and hit enter. And we have the mount tool now, so we'll go ahead and copy that. And did we change it over to SDC? We got to be careful here that we do that. So this will be SDC now. Okay. We'll copy that. We'll paste this. We'll hit enter. And then we need to chmod that directory so we can work on it. Let's go see if that directory is now there. So we'll go ahead, mount disks. We have my world disk, right? And then we can go to the other one here, which is my alt disk, right? And so there you go. So we now have a disk, and basically we've restored the disk, right? So hopefully that is clear. I'm going to, again, keep these disks attached. I'm going to keep adding to this so we can learn more about disks. And we'll clean up in a later video. See you soon. Okay, so one thing I want to show you that you can do is resize the disk. Now, we're using that ext4 file system format, and they say that if we resize your disk, that we don't have to restart or do anything or resize the partition. So what I'm going to do here is I'm going to resize one of our disks. I think what I'll do is I'll resize the boot disk. And let's go ahead and see if we can do that. So there should be an option here to edit it somewhere. And if it's not in here, then we can probably modify it on the VM itself. So updating the architecture of a disk that is attached to an instance as a boot disk is not supported, which is totally fine as we don't plan to do that. Generally, when you're resizing disk, you probably don't want the server to be running, but I don't care. I'm going to go ahead and do that. I'm going to make the number 14 just so we can keep track. Actually, we'll just make it 11 as I don't want to really make this too large. And we'll go ahead and hit save, right? And so what I'm hoping to see, I'm still SSHing from before, so you know how to SSH into the virtual machine. But once that's updating, we want to check its size. So we'll use df-h, I believe. And so this will help us understand its size. We can also run that other line that we've been running quite a bit. I think it was showing sizes there as well, right? LSBLK. And notice that it's now 11 gigabytes, right? You can't size down a disk, but you can increase its size, especially when you are reattaching or things like that. So just understand that you're increasing it, never decreasing it. There's probably some way to do it, but I don't know how to do it, and it's not that big of a deal. So that is as simple as that. I'm just going to close that tab out. We're going to continue on to learn things about this. So I'm leaving this infrastructure up, okay? All right, let's continue on. So we have create image, clone disk, create secondary disk. If we want to have an additional disk where we have a replication across them, these are these other two options we have here. I do find these options to be confusing. I don't know if one's an extension of another disk that's just somewhere else, and the other one is just a copy of a replica. But maybe if we work our way through these options here, it will make sense. I think it's just the wording is a bit unusual. Let's take a look at clone disk. So we'll go ahead and just say my clone. Well, before we do that, I want to make sure what I'm making a copy of. And I figure maybe we'll do one of these other ones. So maybe we'll do our my alt disk here and make a copy of that one. So we'll clone the disk. We'll say my alt disk cloned. And I suppose we could do that in a single zone, but let's make it regional and send it somewhere else. So I'm going to send it to North America, Northeast B. I'm going to turn off snapshots, but the idea is that this is literally, we're getting an additional disk. This is not a snapshot sent to another region, but there is another disk there. We'll go down below and hit create. So the new disk will copy data from my alt disk and have the following properties, right? So it's going to copy that there. Okay. And we're going to wait for that disk to appear. Notice that we have disks and then we have snapshots down below. So I guess, if you were to move a snapshot to another region, I would expect that it would need a disk, but maybe it doesn't. Maybe it's just the storage of it and it's not necessarily disk. So here you're basically taking the snapshot and then creating the disk. It's basically like two actions, I suppose. And so we are just waiting for that clone to finish, okay? All right, and so we have finished creating our clone disk. Again, it's just a disk that we can use somewhere else. So nothing super exciting there. We're going to continue on and look at something like secondary disks, okay? So we cloned a disk. Now let's take a look at creating a secondary disk. So we have a secondary disk. The new disk will begin replicating from my alt disk to have the following properties. It makes me think that secondary disk is something that is going to replicate data that's being updated. So here we have whichever zone it is. So we have my secondary disk, right? And so we have it within a single zone. I guess it could be cross-regional, but I'm trying to decide what I want to do here. So maybe we'll have something that's regional. Yeah, so we have 1A to C here. I'm going to go ahead and create my secondary disk. So what I want to do is I want to see if actually replication is happening, because that's the only thing I could think of the distinction between the clone disk and the create secondary disk. But once it creates that secondary disk, we'll spin up another virtual machine in that other region, or sorry, that other zone. And then we'll take a look and see if we update one, if it replicates in a particular direction, okay? So it looks like it's created now, the my secondary disk. And this is multi-zone. So look here, we see 1A to 1C, right? It's not just showing one, it's showing two. Same thing here, we have B and C, which is interesting. It's almost like they have a relationship. Let's go ahead and create a new virtual machine. So this will be in, what do we say, B. We have A and C. And, well, these ones are in C. Hold on, let's go back here. This one's in C. This one is A and C. This one's B and C. So I'm going to do A, the A region. I'm going to launch a virtual machine there. So we'll create a new virtual machine. This will be my other VM B, I suppose. And then we'll drop this down, go to Toronto, and choose the B region. We're going to stick with E2. We're going to switch this over to a micro. We're going to go to OS storage. We're going to attach that disk. We are choosing my alt disk cloned. We have read and write. For this, we could probably do read only if we wanted to, but I'm going to leave it as read and write for now. And sure, we'll have a custom name. Why not? So we'll go ahead and we will now go and create this virtual machine, and we'll wait for it to start. All right, so our virtual machine is ready. And I guess the idea is that if we go take a look at this one, let's go take a look at our first one here. We'll look at the contents of what is there, okay? And so what I want to find out is, does the secondary disk create any kind of replication, or is it just literally a secondary disk and there's nothing really exciting? So we're going to go to our mount directory. And, well, actually, this disk is attached, but that doesn't necessarily mean that it's mounted, right? So that's something that we will actually have to do there to get that to work. Let's go ahead and type in lsblk. Right, and so the disk that we attached is the 12 gigabyte ones. It's SDA. Notice this time that the partition is SDB, so it really is just the order that it decides to do here. So let's go over to here. And again, step through this. I know it's really boring, but you got to keep doing it till it works. So here we're going to change this over to SDA. And we don't want to format it actually because it's already a disk, right? So really we're just mounting it. So this one is, what is this disk called? I don't know. So let's go up to here and grab this and find out what we called it. This one here is my alt disk cloned, right? So I'm going to copy that and we'll scroll on down here. We'll go ahead and make this directory mkdir-p/mount/disks, and then we'll paste that in there. Right, we'll grab that name here and we'll go over to here and I'm going to edit this, hit enter, and this is SDA, good, that's correct. So we're going to go ahead and mount this here. And so now if I go into this location, well, before we do that, we should chmod it. Probably already is writable, maybe not, I don't know. We'll go ahead and we'll make sure that it's writable. Put sudo in front of there. Okay, and so we'll go back and make our way there. So we have hello.txt. I'm going to make a new file here. I'm just going to say touch other.txt. And so my expectation is that if there is synchronization, it's one way, or it doesn't sync at all. I don't know. But that's the point, is that we need to test this stuff out, because I can go check the docs. I can go ask LLMs. I don't necessarily trust them. So let's go and figure this out ourselves. So we should have this other.txt file. There's nothing in it. We don't really need to put anything in it. I'm just going to put something in it. You don't have to if you don't want to. Other file. We'll go ahead, save and quit. So that one is now done. We're going to go ahead and close this. And I want to go into our original machine, my other VM. So this is the one with the extra one. So we'll go ahead and SSH into this one. I don't remember which one that we cloned, but I guess we'll figure it out here. I don't remember. I think it was the other one, but we'll see. Like the moon one, but I don't know. So we'll go here and we have two disks. We'll go look into my alt disk. I'm going to do ls-la. There's nothing extra in there. We'll go ahead into my world disk, ls-la. And we don't have anything there. So I'm going to go ahead and just make a new file here, say touch world.txt. And then for this one here, the alt disk, I'm going to say touch moon.txt. Okay, so those have now been both created. I'm going to go ahead and close that out. I'm going to go back over to my other one here. Again, I just want to see, does any replication occur? Why is it called a secondary disk? If it's just a secondary disk, like what? Like why? Why do we have different namings for these things? So we'll go take a look here, and we will cd into our mount directory, into our disks. And nothing. So yeah, I don't understand. What is the difference between my secondary disk and my clone disk? We can ask Gemini. Let's go ask Gemini. What is the difference between my secondary disk, or create secondary disk, and clone disk? Is there even a difference? This option is related to persistent disk asynchronous replication for disaster recovery. It involves creating new disk blank blank disk in a secondary region that will act as a target for replication for primary disk. The data is asynchronously copied from the primary disk to the secondary one, allowing you to maintain a replicated copy of your data in a different region for disaster purposes. Cloning creates an instantly usable duplicate of an existing disk. It's identical, etc., etc. Okay, so for secondary disk, if I mount the secondary disk to another instance, and I go update the original instance, will the replication occur, or the secondary disk has to not be attached to replicate? Okay, let's see if it knows what I'm trying to say here. And we'll give this a moment to see if it can even figure out what we want. A secondary disk created for asynchronous replication cannot be attached to an instance while replication is in progress. Google Cloud blocks this action. The replication process requires the secondary disk to be in a specified state, and attaching to a VM would interfere with the ongoing synchronization. Therefore, it must, if you mount the secondary disk to another disk, replication for the primary disk will not occur. Secondary disk needs to be detached. Okay, so that's fine. I guess what we can do is detach the disk. So let's go ahead and see if we can do that. So we will go over to my instance extra disk, which is in the other region. And let's see if we can detach that disk. I'm not unmounting, I'm just going to detach and see what happens. So here we have the my world disk and the my alt disk. This is my extra instance disk. No, that's not the right instance. Let me go back here. My other VM, this is the one that we want. So go ahead and edit. You got to really pay close attention. I'm going to scroll on down. And we have this additional disk here. So I'm going to go ahead and remove the disk and hit save. And so now the disk should be detached, right? We'll give it a moment here to save, and then we'll go see what the state of the disk is. All right, so that disk should be detached, and yeah, we saved that. So we'll go over to here. Let's take a look here. And we have our clone disk, and notice that it's not in use by anybody. So the idea is that I would think that we update the original disk that it is copying to, then we'll know, right? My alt disk. So I'm assuming it's a, well, hold on. My secondary disk is down here, right? Sorry. So my secondary disk is a secondary of what? I can't remember. It's not like it tells us, does it? No. Let's click into it. It's a secondary disk of my alt disk. Okay, so what we'll do is we will go ahead back over to here, and we're going to go into our original instance here, and we'll SSH into this one. And the idea is that this replication's already, or the disk has already been created. So if we start writing files to it and then it's replicated over, then we're going to know that it worked. I'm not sure how fast replication would be. We'll go over to here to mount disks, my alt disk, that's what they said it was. And we'll just make a new file here. We'll say touch again.txt. And I guess I'll just open it up for fun and just say, we have added a file again. And I'm going to go ahead here, write and quit. I'm also going to, I guess, update the hello.txt for fun. And we'll just put some exclamation marks here. So the idea is that we have now modified this disk. Replication should be occurring. When it occurs, I don't know. It should be, it should happen. So now what we'll do, I guess we could ask Gemini. With a secondary disk, how fast is replication? Again, this is preview, so sometimes I've actually seen it give like AWS answers for GCP, which is terrible. The replication speed is designed to be quite efficient. So it changes blocks per minute. We really changed next to nothing, so it should really update quickly. So what I'm going to do is go back into this this other VM here where, that's being replicated. And we'll go down below to our additional disk. We'll go ahead and add our clone disk. We'll go ahead and we'll save it. While that is saving, I want to start getting into that virtual machine just so that we are being productive with our time here. So we'll go over to here into VM instances. And from this one, I'm going to go ahead and SSH into it. So we'll give that a moment here to connect. Say authorize. And we'll do lsblk. So I want to see if the other disk is there. And so this is our main disk, and this is the other one, SDC. So we're going to have to go ahead and mount that. We're going to go through the whole process again. I believe we already have a directory there. If we go to mount here, disks, and we go here. Yeah, so there's contents there. I don't know if that is good because we never unmounted it. I'm not sure how to unmount. I don't need to unmount that often, but we'll just say like, how do I unmount? And I'm going to copy this command here into Claude. I'm just doing this off screen on Claude here. So I'm just asking like, how do I unmount it? And here it says to do this. I'm going to do sudo mount unmount. Because right now it shouldn't be going to anywhere, right? So we'll go ahead and do that. The target is busy. Well, probably doesn't help that target is busy. Okay, so I'll go ahead and do an ls. We'll see, go into here, into our temp directory, into our mount directory. cd, oh, sorry, not there. We'll go cd mount. Okay, so I don't see the replication. So obviously I'm doing something wrong, but I think that you get the idea that secondary disk is for replication. We could fiddle with this all day, but I don't think it really matters. And what I'm going to do is I'm just going to get rid of our second instance here. We'll go ahead and delete it. And we'll just focus on another task. But now we know what secondary disk is for. It's about creating a secondary disk where we have asynchronous replication. And you don't really want to attach it until you need to work with that disk, I guess. All right, and we'll just continue on learning things about disks, okay? We're continuing on to learn about disks. You can see we have a lot of disks here. I'm not doing anything with the clone disk right now and the secondary disk. So I'd like to get rid of those, as this is making a bit of a mess here for me. It depends if it's in use. If it's not in use, we can delete it. So my secondary disk is not in use, so we'll go ahead and delete that. It's participating in async replication. Replication must be terminated before the disk is deleted. The other disk will not be otherwise affected. Yeah, we'll do that. We'll go ahead and do that. And I guess that's an additional option that we need to do there. So we're getting rid of that disk. And we still have some other ones here. This one is not in use. My alt disk clone, we're not really cloning that, so we'll go ahead and delete that as well. And we'll get a little bit cleaned up here so we can see what we're doing. I was also spinning down another virtual instance, so there should be another disk for me to get rid of. That's probably not in use. Yeah, let me go back over to here. So my world disk. No, yeah, so now we are now cleaned up here. And I guess another thing that we might want to do here, because we've done clone disk, secondary disk, there's create an image. So as far as I understand, create image is kind of like a machine image, except it's not going to replicate everything. It's just going to replicate that single single disk. And I imagine that if you do this, you're going to want to do this on a boot disk, you know, because that just kind of makes sense. So what I'm going to do is go over to disks here, and from here we're going to do my instance extra. I'm going to click into it. I would think that you'd rather do a machine image because that would get everything, but if for whatever reason you don't want all the rest of the disks, you just want that single one, this is the reason why you do that. So go here and we'll just say my image hello, and notice that the source is disk, so we could also choose other things to create the image from. You could use it from a snapshot, an image, even a virtual disk. And here we're going to choose the source. The disk is attached to a running instance. To create an image, you need to stop the instance first. You don't have to, but it's recommended that you do stop. And I'm not going to. I just don't care. We're going to make it multi-regional. This way the image can be utilized in multiple places. Copy this image to a single region or multiple regions. No, we can just have it in Northeast. We don't have to have it everywhere. That's totally fine. We can give it a family name, the family image. So this is the hello family, right? So when creating an instance or disk, specifying a family will cause the latest non-deprecated image in the family to be used. So that's a good idea there. We'll go down below here. We're going to hit create. And we'll give this a moment to create that image. And once that image is created, we will launch a new virtual machine, and we'll just make sure that that new virtual machine works. We wouldn't have that other image attached to it, right? But we'll see what happens here, okay? All right, so our image is now ready. Let's go ahead and click into it. I believe we can create an instance from it, so let's go ahead and do that. And this will be, oh, well, actually, where is this other instance? Where did we set it? This one is in North America, Northeast 2. So I would think that if we want to use this instance, we have to be in that same area. So we'll go back there. It was 2, but 2 what? I already forgot. So we'll go back over to our images here. Is it just 2? Yeah, it's just 2. Okay, so we can put it anywhere in 2. So maybe we'll put it in 2A here. We're going to do a E2. We'll drop this down, choose the E2 micro. We'll go over to here, and we should be able to change this to that instance now. We go over to here. We have my image, hello, right? And it's 11. Everything looks very similar. We'll go ahead and hit deploy. So that's like not all configurations were carried over. Obviously, we have to choose our image type or machine type, name it, things like that. But we'll go ahead and launch this up, and we'll just make sure we can get into it. And if it does, then we're in good shape here. We'll give it a moment, okay? But also remember that we had another disk that was mounted. So, and of course, we're now also in another place, so it should have no fail. We should still be able to get in there, but we'll see what happens, okay? Okay, so this instance is likely ready. Let's go ahead into that machine. I didn't give it a nice name, but we'll go ahead and SSH in, and hopefully it works. As making instances can be a bit finicky, but we'll go ahead and see what happens. Oh, we're in. There we go. Let's go take a look at our mount directory, because that's where we had something mounted before. Yeah, we see those, right? So we have my alt disk. Okay, and they're blank because they should be blank, right? Because there's nothing there. So there we go. We now know how to work with images there. So I'm going to go ahead and delete that there. And yeah, I'm going to leave this up because we're going to try a little bit more here, and I'll see you in the next video, okay? Since we just created an image, we should take a look and see what it's like to create a machine image. And so that will be our next step. So I'm going to make my way over to machine images, and we're going to create ourselves a machine image. This will be my machine image, hello, and we're going to choose our source virtual machine. So this one is spinning down. This is the one that we've been running that has 2 disks attached to it, or yeah, I believe it has 2 disks attached to it. So what I want to see is whether those disks are going to carry over. Like, will it replicate them somewhere else? And so I want this to be in a particular, well, like regional is fine, but can we change it based on source instance location? Can we move this somewhere else? Maybe we can move it to Montreal. So I'm going to scroll on down here. I'm looking for Montreal here. Where are you, Montreal? We have, there it is. There we go. And so I'm going to go ahead and create this machine image. And so, yeah, the question is, do those disks carry over? That's what we don't know. So we'll wait for that machine image to be created, okay? All right, that machine image is ready. We're going to click into that machine image, and we'll create an instance. What I want to, actually, before we do that, let's go back here and notice that we can see the additional disk, and we have network interface information. So we'll go ahead and create it. And the idea is that it should bring along those disks. Now, I would imagine, let's go back here for a second. Did it create additional disks already? No. So those additional disks will get created, I guess, at the time that we launch that machine image. So we'll go ahead here, and this is Northeast 1. So create an instance, and we're going to switch this over to Northeast 1. Now that networking issue resolves. I don't know why they, when you create it, they don't just select the correct thing, but that's fine. We'll choose B here, and we'll go down to E2. We will choose E2 micro, which is fine. We're going to go check out OS and storage here, and we can see we have the 2 additional disks here. So that seems fine here. We'll go ahead and create that. And yeah, I'm just curious to see. Well, I guess we'll have to create those extra disks. Will the data be there? That's what we're going to find out here in just a moment, okay? All right, so our another instance is spun up. Let's go ahead and SSH into it. We'll give it a moment here. Say authorize. There we go. Looks good. And so we'll cd into our mount directory here. Into maybe the world disk, doesn't really matter. So we go to this one and no data, my alt disk. And we do have data. I think it's because one we added to our fstab, so the data is definitely copied. It's just the other one, the directory is there, but it's not mounted, right? So I'm sure the disk is there. We'll close that out here. If we go over to disks, we should now see more disks, right? So yeah, there you go. So, yeah, I think, that's fine. So we saw that. We're going to go clean that up. All right. And yeah, I'm just going to clean up everything now in this video because I'm pretty much done. So I'm going to delete this one and that one, and we'll go and clean up the town here. So I'm going to delete those 2. And once those are deleted, we're going to go ahead and delete all these. So just give a moment for these virtual machines to vanish. 1 second. All right, those VMs are gone. Let's go ahead and tear down those disks. We'll go ahead and do that. So all these disks should not be in use. We'll go ahead and delete those. If there are machine images, let's go ahead and delete that as well if it lets us. If there's any snapshots, I think they should go with the other stuff here, but I got a bunch of snapshots. I don't need any of these snapshots. I'm going to go ahead and delete those. And there we go. That's cleanup. But yeah, ciao, ciao. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at cloud storage. So cloud storage is a serverless object storage service. You do not have to worry about the underlying disks, right sizing, availability, durability, the file system underneath. You only pay based on the storage, so the at-rest storage, and the download, so actually accessing or requesting files. Files are called objects, and folders are called buckets. It has unlimited storage with no minimum object size. Probably there is an upper limit. Most serverless object storages do have a particular limit, but theoretically it's unlimited storage. Worldwide accessibility and worldwide storage locations, low latency, so time to first byte, typically 10 of milliseconds, has a high durability, so it has 9 nines of annual durability. When I say 9 nines, it's because it's 99 and then followed by 9 nines, okay? It has geo-redundancy if the data is stored in multi-region or dual region. It has a uniform experience with cloud storage features, security tools, and APIs. And I want to cover available storage classes because these do show up on the exam. This isn't something that other fundamental certifications would go this deep on, but Google really wants you to know better in detail their core services. So for available storage classes, we have standard. And so here, this is for frequent file use. So if you're building a web application or just general use, you're going to be going with standard storage. Now, this is the least cost-effective solution. It's not expensive, but there's ways to save, okay? You have nearline storage. This is when you're going to be accessing, on average, a file once a month or less, right? It's going to be cheaper than standard storage, but the key thing is once a month or less. Then you have cold line storage. This has a higher access cost than nearline store, but a lower at-rest cost. So that's kind of just a bit of a trade-off there. You have archive storage. This actually has no SLA availability. It's zero availability SLA because it's offline, right? So very slow retrieval, very cost-effective, rarely or never intended to be accessed. You're using these to store like like reports or accounting information that you have an obligation to store for 7 years, that's when you'd be using that. Notice that there's this number here. It says 0, 30, 90, 365. This is the minimum storage duration. It's the minimum days a file needs to remain in a storage before deleting. If deleted prematurely, a charge will occur. So the idea is they want you to hold on to them for a particular time to effectively use them, right? Because if you delete them sooner, then it doesn't make sense for you or for Google Cloud. But yeah, I just want to emphasize that available storage classes will be on the exam, and they showed up more than once for me, so definitely know the difference, okay? All right, let's compare our storage classes for Google Cloud Storage Bucket. We have standard, nearline, codeline, and archive. There's also auto class. We'll talk about that separately. But let's just get a quick summary of these 4 levels. So for standard, it gives you the maximum availability. It's if you don't know what to do, choose standard. Nearline is optimized for data accessed less often. Codeline is cost-effective solution for rarely accessed data. Archive, lowest cost storage for data access annually or less. For the most part, I'm always working with standard, but for different use cases, for larger companies, you might be utilizing this stuff with a lot of data. In terms of duration, for standard, there's no minimum storage duration. For nearline, it's 30 days minimum. For codeline, it's 90 days. For archive, it's 365 days. For standard, we have high performance workloads. For nearline, we have data backups and archival storage. For codeline, it's data backups and archive storage. For archive, it's cold data storage, disaster recovery. Again, if you're coming from AWS, this is looking kind of familiar. AWS obviously has more storage classes, but this is pretty straightforward. In terms of cost, well, the longer you store it, the cheaper it gets, as you can see there across the board, archive being the cheapest, standard being the most expensive, but again, not super expensive. In terms of accessing data, there's no cost for standard, but it's going to get more expensive as you work down from nearline to archive. So you'll have to consider those factors. In terms of availability, you're going to have 99.99% availability, multi-region, dual region for standard, and the rest is going to be 99.95. In terms of regions, for standard, you get 99.99, and the nearline, 99.9, and the rest, 99.9. And we should get an annual durability of 11 nines across the board. Auto class is pretty straightforward. It analyzes and chooses the best storage option over time. Very similar to whatever AWS calls theirs. They have a mode that does this as well. So I assume when AWS added theirs, Google added theirs, or vice versa for that. But there you go. Okay. Some quick cloud storage considerations before we move on. So actions are applied based on object creation date. Deleted objects cannot be recovered. Lifecycle rules may take up to 24 hours to apply. You can test lifecycle rules in development before production. Apply rules carefully to avoid data loss. You can review and update lifecycle policies regularly. And there you go. Let's take a look here at cloud storage buckets. So these are buckets that are scalable containers that store your data in Google Cloud. This is object storage in particular. But anyway, so buckets help organize your data and manage access controls to your data. When you create a bucket, you'll need to input a global unique name, a geographical location, a storage class, access controls, labels, and we have a few different types of geography types. So we have region, dual region, multi-region. For storage classes, we have standard, nearline, codeline, archive. For level of access, we have uniform and fine grain. So you have a general idea there for buckets. There's more to buckets, and we will dive into them in upcoming videos, okay? So objects are individual pieces of data or data chunks stored in a cloud storage bucket. I think we would consider them blobs, but anyway, we'll continue on here. There's no limit to the number of objects you can store in a bucket. Google Cloud Storage uses a flat namespace for object storage. If you've used AWS, same thing. Azure, I don't know if it's flat. I never really noticed if it was or not, but definitely similar to AWS. So when you see that name, see where it says like /notebooks, whatever, that's its actual name, right? Like with the // installs, it's like, imagine it's in a single folder. Folder structures are simulated using naming conventions, but folders themselves do not exist as separate entities. And when we have an object, we have the data itself and then the metadata. So that's other things that can be attached to it. But that's cloud storage objects in a nutshell, okay? All right, in this video, we're going to take a look at Google Cloud Storage buckets. So we're going to make our way over to the top here and type in bucket. Buckets aren't too complicated, but anyway, we'll go ahead and create ourselves a new bucket. Okay, so we can name our bucket whatever we want. Pick a globally unique permanent name as it's globally available. So we'll go ahead here and just say my great bucket, okay? And from here, we'll continue. And see that name is already taken, so we'll go ahead and just say 22, and we'll hit continue. We have a few options here. So we have multi-region, high availability across largest area, dual region, so high availability and low latency across two regions, or down below, lowest latency with a single region. It's really up to you what you want to do. If you want things to be low latency, you can go ahead and do that. So whatever you want. So I'll go here and just choose a single region. But notice the cost over here changes. So here it says 0.0023. And if we go over to here, you can see, again, the price change. So really up to you what you want to do. But I'm going to go ahead and just go with a single region. The next thing we have is the type of storage we want. So auto class, as the name implies, it will automatically transition each object to standard or nearline based on object level activity. That's a pretty good option if you do not know what you plan on using. But then down below we have standard, nearline, cold line, and archive. So standard's best storage, short-term storage and frequently accessed data. Nearline best for backups and data access less than a month. Cold line best for disaster recovery, et cetera, et cetera. You get the idea. It's pretty darn straightforward. We're going to go with standard here. Then let's see, we have optimized storage for data intensive workloads. So enable hierarchy namespaces on this bucket. Don't need it. This makes sense for analytics, but we're not doing that here today. We'll go ahead and hit continue. And we can prevent public access. Of course, you would want this to be off if you are doing something with your buckets where you need public access, then that's going to be a different story, but generally you want to keep that off. For access controls, we have uniform or fine grain. We'll leave it with uniform for now. We'll go ahead and hit continue. We have a soft delete policy. You might want to turn this off if you want objects to be retained for a specific period of time. That way, if you want to recover them, I'm going to turn that off. I don't really want soft delete policy, but that is an option. Object versioning, also another really good option. So the idea is that it will, when you push new versions, it'll just have iterations of those versions. That's really, really good if, let's say, you had an environment and it got compromised and someone tried to delete stuff, that at least you have versions of things like that. Then down below we have retention. So, you can enable a retention policy or tell it to how it should, or like if it should retain objects. But we'll go ahead and hit create. It says public access will be prevented. This bucket is set to prevent exposures of data from the public internet, enforce public access. Absolutely. Notice how they pop that up because it's such a big issue. Having your things compromised that, you got to have that on there. Let's go ahead and upload a file. It doesn't really matter what it is. I guess we could generate out an image. So I'm going to go over to ChatGPT and I'm going to generate an image. So we'll say a cloud engineer working on GCP and their seat is a race car. Why not? Because we can have fun. Why not generate stuff out? So we'll hold on. Okay, create an image, right? And we'll be back here when it's done. Okay. All right, there we go. And there is our image, which is not too bad, I would say. And it even got Google Cloud logo, pretty good. I'm gonna go ahead and drag this onto my desktop and just rename this to Cloud Engineer. Right, and I'm going to go ahead. I think we can drag it into place. Yeah, we can. We'll drop it in there, and so now our image, okay, is there. All right, so there's obviously a lot of other options that we can do here, but I think this is a good start. We'll just separate out these videos. I'm going to leave this bucket up here, and we will explore the other features of buckets, okay? Let's take a look here at object lifecycle management. This automates actions on objects based on predefined conditions, optimizing storage and retention. The idea here is that you set a time to live to automatically delete objects of a specified duration. It can manage storage by removing or archiving outdated object versions, or it can transition objects to lower cost storage based on access frequency. So this is basically like the manual way of doing auto class. Auto class being a storage class where it decides on its own. So here you are setting specific rules on how you want things to move, transition, delete, expire, whatever you want. Use cases would be move objects older than 180 days to cold line storage to cut costs, delete objects created before June 1st, 2023 to free up space, keep only the 4 latest versions of objects in version buckets. So those are a bunch of examples. And it says 2023, it's, I'm recording this, it's like 2025, almost 2026. Yeah, sometimes we have dates there and I just don't decide to update them. But anyway, let's go on and continue on and take a look here to understand how the actions are based on rules and conditions. So rules are any set of conditions for any action. A condition, you can have one or multiples on a bunch of different, I guess, metadata or information about those objects. And then your action would be something like delete, set storage class or archive. So an example could be you have managed versions. You keep only the 5 most recent versions of each object. You delete older versions. Another one could be archiving objects. So files older than 180 days, you move to archive storage. We already said this prior. There's probably like a wait hold in terms of how long a file has to stay in certain locations. And we talked about that earlier in storage classes where we compared about how long an object has to live in different classes. So there is that factor as well when doing object lifecycle management. So there. All right, so let's continue on with buckets, and probably we would like to set up a lifecycle policy. Lifecycle policies allow for buckets to take actions based on certain conditions, and that may be really useful if you, let's say, have an object that hasn't been used in a while, you want to move it into the archive or things like that. Notice here it says after you add a rule, it may take up to 24 hours for it to take effect. So we're not going to be able to see the results of our actions here, but at least we can go through and start setting up one here. So we have set storage class to nearline. So best for backups and data access less than a month. So the idea is that if something hasn't been used in a while, it's going to move it over to there. It could also be delete objects. So objects cannot be restored after deletion, which is totally fine. So the point is that we want to see what are the conditions to be met if we delete an object. So we'll go ahead and hit continue. And so here it says use prefix, suffix, rule, scopes for to filter objects by their paths. So it could be that it's the age of the file, it's the prefix of the name, all sorts of things. But maybe what I would like to do, a number of newer versions. So applies actions only to versioned objects within at least many new versions. This might be useful if, like, let's say you don't want to retain X amount of versions. That'd actually probably be a really, really useful one. But let's say object names matches prefix. And I'm just going to put something in here. And so maybe the prefix is temporary, like maybe it's that. And so if anything is in that is in there, it will probably just get deleted. So that might be interesting to try out. So we'll go ahead and I'll hit continue. And the idea is that anything with that prefix, it's going to get deleted, right? So we'll go ahead and do that. I'm going to go over to objects. I'm going to create a new folder. And again, it says that it can take 24 hours. So this might not even take effect. So I'm going to create that folder. We now have temp. And so I'm going to go ahead and just rename my Cloud Engineer file to Cloud Engineer 2. It's still on my desktop. And we'll go into here and we'll move this over to here and see what happens. Okay, so that is now in here. And we'll go over our lifecycle policy. So present over changes in storage class, et cetera, et cetera. So we'll go back over to here and we'll give us a nice hard refresh. So my question is, like, when would this take effect? So we might have to wait 24 hours, but we'll ask if it'll let us. Nope, not today. I thought we could ask Gemini, like, hey, Gemini, when do you think, when do you think we'll see this propagation, right? But it's hard to say. 1 second. Anyway, I think we were going to basically have to wait to see if this takes effect. So I'm going to keep it around, and if I happen to have this bucket tomorrow or in 2 days, then I will roll up this video. If there's nothing on the end of this video, then you know that I couldn't be bothered because it was taking too long. But lifecycle policies are very straightforward, as you can tell. This is really, again, useful if, let's say, you have something and you want to move into long-term storage. That's not a bad idea. Okay, ciao, ciao. Hey, this is Andrew, and in this video, we want to figure out how to use signed URLs. That is a way for you to access a non-public file temporarily via a URL that expires. If you've ever used Amazon S3 and you've heard of pre-signed URLs, it's a very similar concept, but I'm pretty sure we have to do it programmatically. Over here on the right-hand side, if we were to click here, we have URLs like the public URL and things like that, but this is not going to get us access because this bucket is not public, right? So you're not going to get access this way. Now, we could open up permissions in order to be able to access that file, but that's not going to be safe. You also have the option for GSUtil. GSUtil is not really recommended anymore. You should use gcloud, but that was the one of the older ways that you could go ahead and get access or download files via the CLI, but gcloud is obviously better. I'm pretty sure we have to use gcloud to generate one out, and we could try to hunt it down here in the instructions, but it's somewhere here. So we go over to, let's say, create signatures. Here it's saying this shows how to use Google Cloud sign blob method to create a signature from a string to sign policy document to create a sign URL. So we'll go ahead and click this. And so we have sign blob. Okay, and that makes sense because our storage is blob storage, right? And you are signing something that you can utilize. So here, have gcloud installed. That makes sense. Create a JSON file that contains information. Use a curl. Okay, so here we say what data we want to download, I suppose. And I mean, I would probably use the gcloud to create the sign URL. So that looks a little bit too involved. We are looking for the easiest way to do it, right? Command line. Here we go. This is what I'm looking for. So here we have Google Cloud Storage, sign URL, the bucket name, the object, impersonate service account, and service account email. So here that should provide us the information we want. I guess the real question is like, what should we set as the service account? That's probably the most important thing because we only want access to, I'll do that here. I'll just scroll up here. We'll take a look here. So enable the API, so enable the service account credentials. I mean, that should already be activated in my account, but if it's not, let's go ahead and do that. So you're going to make changes to the GCP. If not, this is your project intended. Okay, we'll go ahead and hit next. You're about to enable the IAM service account credentials. Yes, let's go ahead and do that. But I'm pretty sure I already have that activated. But if I don't, let's just activate it again. And we will continue to step through here. So we'll go back over to here. So that's now enabled. Create a service account. If you already have a service account that you want to use, you can skip this step. It's not a bad idea for us to create a new one for practice. So let's make our way over to service accounts. Okay. And we made one for Terraform before. I always find this form a bit confusing, but we'll work our way through it. So we need our service account name. So this should be bucket access. And then down below, we'll just say this provides us bucket access for signed URLs. Or maybe just like signed bucket access. Okay, and then we'll go ahead and hit next. And so this is where we need to add our permissions. Let's go back over to here and take a look at what permissions we need. So here it's suggesting ask your administrator to grant one of the following IAM roles. Just one of them. Okay, so object user, object viewer, object creator. If you only want to create sign URLs for downloading objects, use the role if you want to create sign URLs for both uploading and downloading objects. So I guess it depends on the direction that you want to do this in. I just want to do this for downloading here today, but obviously it can go both ways. So we'll go ahead and type in object viewer. And sometimes it's a pain. I'm never really good at searching for this stuff, so maybe it's storage first. As much as I use Google, like I never can figure out. I think it's because it's trying to use human names. That's why. So it's storage object viewer is what we need to type in here. Sorry. I don't know. I find that confusing. I don't know why they do it that way. We'll go ahead and hit continue. And here, grant users the permission to deploy jobs, VMs in the service account. No, we don't need that. I don't think we do. The prerequisite contains the permissions required. You might also be able to get permissions for custom roles. Yeah, we don't need this last step here. Okay, so now we have our service account, right? And so we'll go back over to here, and here it wants us to probably fill in that service account name or email, I guess. And so we'll go here and we'll copy this here. We'll go back over to here and we'll paste it in. So now we have that there. We'll scroll to our left. What is their bucket name? I don't remember what it is. So we will make our way over to our buckets. We'll type in buckets. And we will, get that name. I'll click into it to try to get the name. It might make that a little bit easier. There we go. We copied that. And we'll go here to our bucket name. We have this item in our bucket, so I'm going to grab that there. Hopefully it doesn't give me the whole address. I just want some of it. It did, but that's fine. We'll go ahead and do that. And so now we have this to create a signed URL. So I need to do this somewhere, and I've been using GitHub for that. And so we have a repo. Just for the cloud GitHub code spaces. You can do this locally if you want, but this is the way I'm doing it. I already have an environment here before. We set that up way earlier in the course, so look out for that video. But it's not that hard. But we'll go ahead and open the browser here and get this environment spun up. And then I need to log in. So this thing already has the GCP or G-Cloud installed. I did that via going to my command palette. I always just show this. I'm not going to show you all the steps, but we'll show you some of it. And so inside my dev container here, I was able to modify it. And then I added G-Cloud. So if you type in G-Cloud here, there it is. If I go over to here, you can just see it. This is what it updated. Just update this file to have G-Cloud in here. But even if you do that, you have to rebuild. So you'd have to go here and just say rebuild and then rebuild the container. I don't think I need to do that here today, but let's type in G-Cloud, make sure that it's there. And it's thinking. I'm not sure why it's thinking so hard, but that's usually a good indicator, right? Yeah, of course. So we'll type in G-Cloud auth login. It's probably going to complain saying, hey, if you have no device, do this. But I'm going to go ahead and hold control on my keyboard. I'm a Windows machine, so I'm holding control. And I need to log in here. I'll hit continue. I'll say allow. It's going to say, you should have done this. I go, oh, yeah, I never do that. And I did copy that. I go back over to here, and we will right-click. We'll just, right-click, and it puts it in there. And so now I'm logged in. It's probably a good idea to set the project. So say config set project. I'll go back over to here and grab my project ID. So we go here, and I will grab that here. And we'll go back over to here, and we will paste that in. And that should set our project. There we go. And so now what we can do is go ahead and use this URL that we generated out. I think we just have the same one open twice. And so the idea is that we're going to copy this link, go over to here, back over to this one. It's confusing because they both have the GitHub logo. We'll paste this in here and we'll see what happens. And here it says permission denied. So fail to impersonate. Make sure that the account that's trying to impersonate, the account that's trying to impersonate has access to service account self. Denied on resources may exist. This command is authenticated by that one. So I guess I'm having this issue here. So I need this service account token creator. Which I'm confused that it didn't work because it seemed like I had. Like I'm an organizational administrator, but whatever. We'll go ahead here and update our permissions. So we'll say grant access. What did it want us to give? It said service accounts. So we'll go down here. Why does it not, why don't we have our principal here already selected? It's really interesting. It opens it up, but it doesn't select the person, but that's fine. We'll go ahead and do that. And this is for service accounts. So we'll type in service accounts. But is that creating tokens? I'm not sure. We'll go back over to here. That's like for creating service accounts. We're talking about for tokens, right? So here it says service account token creator. Permission, get access token. So I'm going to clear that out. I really don't like how they do this. We'll say, we'll take that off there. And Yeah, okay. Access token. Mm-hmm. Uh-huh. Okay, so we'll go to roles. Maybe it shows. No, that's not going to really help. So I'm going to go back over to here. Well, I mean, like, these are roles, right? And then there's permissions. So I guess we could go here and just make the role that we want for the permission that we need. Yeah, here we go. Access token. Storage. Oh, it wasn't storage, it was service accounts, wasn't it? Service. Okay, so we'll go back over to here. Roles IAM service. Yeah, so there is one. It's called IAM. Okay, so maybe I was thinking like, okay, we'll just make it, we'll add it. But if there's already a role, I'd rather just use the role, right? So we'll go back here. Yeah, you can tell I'm awesome. I don't know why. This is like, for me, this is the hardest. GCP out of all the providers is the hardest to figure out permissions. So we'll go ahead here and we'll do Andrew at exampro.co because that is the principal. We'll go here. What if we try IAM? Okay, so now we're starting to see stuff. Service account. Nope. Get token. Nope. Okay, so I'm going to go over to here and I'm going to go and ask Claude. Let's go ask Claude. What is the name of the role? Yeah, the friendly name. Like, I never understood why don't they just use the programmatic name, because then you'd find things so much easier. Service account token creator. Okay. Sure. We'll try that one more time. There it is. Isn't that ridiculous that in order to figure out the name, I would have to go and do it that way? Like, just use the programmatic name. It's just so much easier. We'll go ahead and we'll add that. And so now I should have permissions to do that. It should propagate instantly. We'll go ahead and try this again. Permission denied. So make sure that you're trying to impersonate has access to the service account itself. Permission, get access token denied. This command is authenticated as Andrew Exampro Co, which is the active account specified. Impersonation is used to impersonate the signed bucket. I mean, I added it. We can try this again. Just a moment. All right, so there are some suggestions that Claude is giving me, which is verify that's correct, wait a little bit longer, right? Wait a little bit longer, wait a few minutes. You could, I guess it's saying, attach it to not at the project level, but up a layer here, add it to the service account user role. But re-authenticate, this actually sounds like a good idea. So maybe we will just try revoking and relogging. Well, before we do that, because it's been maybe a few minutes, let's try this again and see what happens. Wait, did it work? The service account is using service account impersonation. All API calls will be executed as this. Failed to auto-detect the region for migrate bucket. Please ensure you have the storage flag there. So I didn't do anything. I just waited a little bit. So maybe I was impatient. I thought it would really be instantaneous. I don't know why. Again, I guess it's Google. But I guess we need to specify the region here. So we'll go ahead and do that. What region is it in? I don't even know. I know it's a singular region, and maybe that's the reason it's having a hard time finding it. It's not everywhere. But let's go back here and figure out what region did we set it in. I would have set it in Toronto. Oh, I did. Okay, perfect. So we'll go ahead and copy that. We'll go back over to here. And I'm going to paste this in here and hit enter. And now we'll see what happens. Hooray, we have a URL. So now we should be able to take this URL, go anywhere, give it to your friends, and they now have that signed URL. I would imagine you could probably adjust this to set the expiry on it. That's usually a pretty common feature on this stuff. You could also use this as an upload link where someone would send a payload to it to get it into the bucket. Again, the ideas here, they can be temporary. You could set maybe the limits of how many times it can be used. I'm not sure if that's actually an option, but definitely setting the time to live would absolutely be an option. But yeah, there you go. So, you know, again, just have confidence, and some of this takes fiddling, but we got it to work. I'll see you in the next one. So for storage buckets, we have 4 different options of access controls. The first being IAM with standard IAM permissions. Permissions are inherited hierarchical. This is a hard word for me to say. Hierarchically. There we go. Then you have ACLs. This defines who can access a specific bucket and object, specify the level of access for individual users and groups. Pretty sure ACLs is the old way to do it. There are some cases where you would want to use ACLs, but for the most part, you probably don't want to use ACLs. You have sign URLs. This provides time-limited read-write access to objects. It grants temporary access without requiring user authentication. If you know what these are in AWS, you know what they are here. We have signed policy documents, enable fine-grained controls over uploads, specifies conditions like file size, content type, or expiration. We should probably compare IAM and ACLs, and we'll do that in the next video. In this video, we're going to learn how to make our bucket publicly accessible. So here I'm on the permissions tab in my bucket. I'm going to remove the public access prevention. This is set at the organizational level to ensure all your buckets don't have public access. It's just kind of an additional thing. And it makes sense because one of the biggest problems is people leaving their bucket permissions open. Now that's set, we can grant access, and we'll need a new principal. We're going to type in all users because we want everyone from the internet to be able to do this. Now is the tricky part, typing the human readable name here. If we go to cloud storage, actually it is a little bit okay. We have storage bucket viewer. I believe it's storage object viewer. Yeah, we go up here. Grant permissions to view buckets and their metadata. No. We want grant access to view objects and their metadata. Metadata excluding ACLs. And we have this one here, access to create, read, update, delete objects and multi-part uploads. So we want this one here. And we'll go ahead and save that. And we'll say allow public access. And so now it says open to the internet, right? So if we go back over to here and we were to grab the public URL here, and we open up a new incognito tab just so it knows we're not logged in. Now anyone can access that, okay? So it's as simple as that in order to put those permissions. But here it says this bucket is public accessible. You might want to change that. We'll go ahead and edit it and go down below. And we might want to adjust this, okay? So how could we adjust it? We might want to put a conditional here to say a very specific object. I'm really bad with this, so give me a moment to figure out what we need to do to set it for a specific object. So it's really hard to find, but what I did is and I don't know if this will work, but I just say, hey, tell me what it is via the CLI, because it's going to generate out a condition, which is this expression, right? And so maybe what we can do is just copy this over here and make it work. So we'll go ahead and copy it. And here we have our condition editor. If we go here, there's the builder. I guess we could try to use it, but it just seems so hard. We'll go over to here and try this. And so maybe with this, we can figure it out. And so I think what we can do is just make it, if a file is not necessarily starts with public. I'm going to try this. Let's say starts with public. Starts with, I'm just guessing here. Thinks there's an error still here. Oh, try this again. Run linter. Maybe because we don't need the expression part in here in the front. 1 second here. And we don't need the title because that would be here, right? Okay, and so now that makes more sense. So only public prefix. So we have ends with. I'm going to try to change this to starts with. So that's kind of how you're going to have to use. Yeah, it's really confusing to learn the CL expressions. At least it is for me. And so here, and we could even say like there might be like a public folder. And so anything in the public folder should be accessible, right? So only public folder maybe. Try that. Only files in the public folder are public, right? And we'll see if that actually works. We'll go ahead and save that. And we'll save that. Conditions are not allowed on public principal, all users or authenticated users. Okay, so I suppose that's not going to work there, which is unfortunate. So, okay, 1 second. I thought that was going to work. Okay, and so I've been asking like, hey, how do we work around this? And ChatGPT is like, what you would do is you use object level access control list. because there are reasons as to why it can't do it. But at least we tested it out and found out there. But that's a bummer. So what we'll do is we'll go ahead here, and I'm pretty much done showing what I wanted to show here, as all I wanted to see was showing you how to do public access, and we tried to take it a little bit farther. We'll go ahead and remove access here and bring our bucket back into its original state. We'll turn this back on, and yeah, we're back to here, okay? Ciao, ciao. All right, let's take a look at versioning. So versioning is the ability to retain multiple iterations of an object, with each replacement creating a new immutable version. So the idea is that you have a bucket and you have your current version, and then you have revisions. The idea is that it generates a specific version of an object, and we have meta generation, which tracks changes to the object's metadata. Objects are immutable, meaning they can't be changed or edited in place. Each update creates a new version. New versions mark the end of the old life cycle. And this is something that we will do a lab on, so it'll be very clear on how this works. All right, let's go ahead and work with object versioning. I think that's probably a good thing to test out. So we'll go ahead and turn on object versioning. And so it says, with object versioning, live and non-current versions will be stored in the same bucket and stored class by default. Save on versions costs by adding lifecycle rules. So object lifecycle rules keep versioning costs under control. Without any lifecycle rules, versioning will be unlimited. Basically, you can have as many as you want. And I think we looked at earlier with the lifecycle rules, specifically saying like deleting older versions. So here it says add recommended lifecycle rules to manage version costs. Not a bad idea. And so that's literally what it's doing, saying, you know, how many max versions of numbers per object. And I mean, one is basically next to nothing. Expire non-current versions after 7 days. So we'll go ahead and maybe we'll just increase this to like 3. Of number of versions per object, we'll go ahead and hit confirm. And so now we have object versioning turned on. Let's go over to here. And so we have this here. I guess the question is, if we have more than one version, how can we go to previous versions? But what we'll do is we'll go ahead and we'll generate out a new image. We're using ChatGPT. And earlier here we had this image here. Let's generate a version. Can you generate me out a new image, but this time they are in a plane? And change them to a woman. Okay, let's have representation for everybody here, okay? So we'll go ahead and have that generate out and give it a moment. All right, so we have another image here. We'll go ahead and download this to our desktop. And I need to name it, I believe, exactly the same for this to work. So we're going to go ahead, grab that name here. And I might already have something on my desktop, so let me just delete the other one first. All right, and so I have the file renamed here. As you can see here, it's just renamed. So I'm going to go ahead and drag this on over here. And here we get an object. So resolve object conflict. So Cloud Engineer already exists. How would you like to resolve it? Overwrite it, exclude the object from the upload. Okay. So my question is, if this is versioned, is it not versioned? How do we know if a file is versioned or not? So that could be an issue that we're having here. So we'll go ahead and cancel all uploads. And that's what we'll need to figure out next. So can we go into here and check if it's versioned or not? So I'm checking here the metadata to see if there's any information that might suggest that it is what it is. And even if it's not, one second here, I still have the old image, so it's not really a big deal if we lose it. So I'm going to go ahead here. I'm going to drag this here and drop it in, and we'll go ahead and overwrite the object. Okay, so we'll go ahead and do that. All right, and so we have the new one here. And over here it says version history. Version history displays the total number of non-current versions stored. If an object has more than 100,000 non-currents, then it will be considered that. And over here we have 1. And there's this and there's this. So if we go here, you see 1.7 megabytes. I believe that's the original size of our original image. Just check here off screen here. Yes, the original one was 1.7 megabytes, and our new one is 2.1 megabytes. And you can see over here that we could restore the other one. I'm going to generate just another image here, one second. And we'll just say, now generate me another image with a person on a boat. Okay. And let's see if it will go ahead and do that. All right, so we can just give that a moment. All right, so we have another image. I'm going to go ahead and download that. I'm going to just have to rename the other one here is some other one. So I'll go ahead and drag that down here and rename it off screen, of course. Engineer, just make sure I spell it right. Cloud Engineer. Good. We'll go back over to our bucket. We'll go and upload another one into that directory there. And we'll overwrite the object. And we'll go over to here. I have two non-current versions. And so here we can see our other versions. And if we want to restore to any of those, we can obviously, well, we can download previous ones if we want. We could also restore it to make it, I guess, the top level one. So if we wanted to go ahead and restore it here, confirm that you want this version to become the live version. If there's already a live version, then this action will do the pre-existing one. We'll go ahead and do that. And so now it is now the latest one, and our history has changed again. So hopefully that is pretty clear on how object versioning works. But yeah, that's pretty straightforward there, and I'll see you in the next one. Ciao. Hey, this is Andrew Brown from Exam Pro, and we are looking at Storage Transfer Service, which allows you to quickly import online data into cloud storage, set up a repeating schedule for transferring data as well as transfer data within cloud storage from one bucket to another. It's going to enable you to move or back up data to a cloud storage bucket, either from other cloud storage providers or from your on-premise storage, move data from one cloud storage bucket to another so that it is available to different groups of users and applications, periodically move data as part of data processing pipeline or analytical workflow. You can schedule one-time transfer operations or recurring transfer operations, delete existing objects in the destination bucket if they don't have a corresponding object in the source, delete data source objects after transferring them, schedule periodic synchronization from a data source to data sync with advanced filters based on file creation dates, file names, and the times of day you prefer to import data. So what I want you to understand here is that you can use it for cross-region replication. So because you can move it on a schedule from bucket to bucket, that you can get data from other cloud storage providers like AWS, or you can get it from on-premise, okay? So cloud monitoring collects metrics and performance data to help you monitor and improve your systems and applications. It collects metrics to provide actionable insights. We can visualize data with dashboards and charts, requires workspaces to organize monitoring data. It uses agents for VM monitoring. It integrates with cloud logging for comprehensive monitoring. It supports GKA for Kubernetes clusters of monitoring, sends alert for issues or failures. So this is basically like an umbrella for a bunch of services underneath cloud monitoring, but this is the high level view of its offering, okay? Hey, this is Andrew Brown. In this video, we're going to take a look at cloud monitoring. So cloud monitoring will allow us to set up alerts that will react to things within our account. So at the top here, I'm just going to type in cloud monitoring, and we'll make our way over to monitoring. And so over here, down below here on the left-hand side, there are options that we can set. So if we go over to alerts, what we can do is we can go ahead and create ourselves a new policy. And so here we can set something that might trigger something when something happens. So here on the left-hand side, we have a lot of pre-made filters. And so maybe we go into VM instances, into instances. And over here, we might want to have something when our CPU usage is triggered over a certain amount. Let's see, there's utilization and usage. I would probably say utilization, as that is probably the amount of, let me see here, delta v CPU usage for all VPCs in seconds. Yeah, I think we want utilization. I'm trying to think of like percentage of it being utilized, and so I believe it's that one there, so we'll go ahead and do that. Another thing we could do actually might be better would be storage. No, we'll do utilization. I think that's fine. Okay, so here we have this one. The idea is that I want this to trigger after a particular time frame, so maybe within each 1 minute time series. And here we have different rules in terms of when this triggers. So maybe the sum happens over function applies for the rolling window, the sum of it, the mean. No, we'll stick with mean, because I was thinking that maybe like in total it would be that, but it's actually adding it over time, and so that might not make a whole lot of sense. But anyway, we're going to go ahead and do that. There are additional filters that we can apply. So we could say it's for a very specific instance. And so that would probably be a good idea for us to do. So we'll go over here and we're going to launch up a new instance, a virtual machine. We'll give it a moment here. I want to see what we can put on as our filters. So here we have metadata. So we might want a metadata label as the name. So we'll go here. I'm going to choose Northeast Toronto. I'm going to use an E2. I'm going to use something a little bit larger than a micro. We'll actually stick with a medium. That seems fine to me. And then the name here is going to be my Linux, or just my server. We'll keep it nice and simple. And I think that's good enough. Let's go ahead and create that. And so we're going to provision this instance. And these virtual machines spin up very quickly, so we won't be waiting very long. Okay, so here our server is ready, and I'm going to click into here. I'm not sure if the name would apply as metadata here. Of course, we can apply our own custom metadata down below. But I'm going to guess that when they say system metadata, they're talking about literally the name of it. So here, I'm just going to take a guess here. It's going to be my server. There's other ways that we could filter that label, so it's not that big of a deal. And so I'm going to paste that in here. And we don't see any information here because there is no CPU utilization that is happening. And also, this is data that's happened within the last hour, so we might want to consider that. I just don't know if there's something else I might want to do here. We could make it a little bit easier by just choosing the region. So this way we would have a guarantee that this would work as expected. So I'm going to do that instead and say North America, Northeast 2, right? And so again, we're set it on CPU utilization. We have 1 minute and the mean. I'm going to go ahead and hit next. And so we have our trigger. So when it meets the threshold, metric absent, or forecast, threshold is what we want. And so any time series that violates above the threshold, and so maybe we'll just say 50% as we are looking for anything for it to trigger. We'll go next. And then we have our notification channel. So we want to send this to somewhere. So if the data is absent, send a thing. I don't care about if it's absent, but we recommend that you create multiple notification channels. That makes sense. There are no notification channels here. So we need, I guess, a notification channel. Let's go over here and see if we can find one. Notification channel. There we go. And I'm just carefully looking here. Why do I not see? How did we get to it? Where is it? Why don't I see it? But anyway, I guess what we can do is we can add one. So maybe it goes to SMS or PubSub or something. I don't really want to get an email, but I'll add an email, I guess, for this case. I'm just carefully looking here. We'll add this one. So just say Andrew at exampro.co, and Andrew Brown email channel. We'll go ahead and save that. And hopefully I can just refresh that on that other page. Refresh. There we go. So I'll checkbox that. We'll just say CPU utilization exceeds 50%. Okay. And again, I'll checkbox that, hit OK. Notify on incident closure. No, I don't care about that. But I mean, it'd be nice if you want that. Linking alert policies to App Hub. No, I don't want to do that. Policy user labels. I don't need that. Policy severity. We'll say critical. Again, this is just for test. Editor documentation would like to be included with a notification. This is a notification to tell you your instance is over 50% utilization. Okay. And then we'll go to review alert. This seems fine to me. We'll go ahead and create the policy. And there is a little bit of a problem here. It doesn't like something. Oh, the name of the policy. So this would be 50 CPU over. Okay. We'll try that again. Hopefully it likes that name. I don't think it should be an issue. So we'll give it a moment there. There's a spelling mistake there in my description, but it doesn't matter. And already we have some data here. And we see utilization over here. But again, that's when the server was starting up. And so I was hoping that since we made that to prior, that's less of an issue. So let's go over into our machine. So if we go over to our VM instance, I want to SSH into it. So we'll click that there. And we'll give that a moment to start up. I'm going to just drag this up a little bit so I can see what I'm doing. And we'll click authorize. Okay, we'll give that a moment here to start up. And what I want to do is I want to get that stress software installed. So we'll do sudo app install stress -y. There's another one called stress ng. It's newer. I just haven't used it yet. I just know how to use this one, but they're both totally fine. So what we're going to do here is we're going to wait for that to install, and then we will do our stress test. Now, just installing this alone could trigger that, but we'd have to watch that here for that, but that's fine. So what we'll do now is we'll go over to here, and I believe it's stress, the number of CPUs. So I think it's vCPU, and there's probably at least 2 there. And then we have timeout, and so I'll say 60. So hopefully that works. So maybe it's just CPU. Let me go ahead and try that instead, CPU. And so now it is utilizing the 2 CPUs. I think that's how many there are. Okay, and that will happen for 60 seconds. So that should be enough for that to capture it. I might even want to do that longer. Actually, I'm going to stop that for a second. And I'm going to run this for 120. That way, we'll be sure to go over that 1 minute mark and absolutely capture something. So I'm going to pause here and wait for this to finish, okay? All right, so that ran for a couple minutes, and I've been waiting a couple minutes. Let's go over here and take a look and see if there's any new information. We'll give this a refresh and see if it picked up what was in the region. I'm thinking that it did. There we go. So it definitely went over that spike. So that's perfect. That's exactly what I wanted. And I'm going to go over to my mail, and I'm going to take a look and see if we have a mail, if it sent one over. And we do. We have an email. That was an easy one. Okay. Folks, half the time when I do these Google Labs, they don't go as expected, but this one turned out perfectly. So here we can see the start time, the policy, the project, the condition, and a bunch of the metadata. And so the instance name is my server. And so I'm assuming instance name, probably the same. We'd have to play around with that. There might be some inconsistencies there. But there you go. We set up our own alert. And I'll see you the next one. Ciao. Let's take a look here at cloud logging. So when I talk about this, I'm talking about the service in general, cloud logging, though I do have another one specifically about cloud logs. So I'll try to put those close together so it's less confusing. But anyway, so cloud logging is a centralized service for collecting, analyzing, and managing log data in real time, collects logs from multiple sources in a central repository, enables real-time log analysis and tight integration with monitoring, supports platform system and application logs, allows exporting logs to external destinations. In terms of concepts, we have log viewer, which displays logs for specific projects, a log entry, which records events or statuses, logs, which are a group of collection of entries with defined retention periods. Do we have types of logs? So we have audit logs, which track who did what, where, and when. We have access transparency logs, so record of action taken by Google staff. And we have agent logs, so provide system level logging. So this is a high level talking about cloud logging. But when we talk about the cloud log service, I'll be a little bit more detailed. Okay. Let's take a look here at Cloud Audit Logs, which lets you know who did what by logging API calls performed within your GCP account. And there are different types of audit log types. So you have admin activity, which is when you have direct user-driven API calls or actions. So if you are using gCloud, you're clicking around, launching stuff, that's what it's going to be tracked under. Then you have the data access logs. These are API calls specific to data services. You have to turn on data access because it does cost money. This is no different than, let's say, AWS, where they actually have like data logs for S3 buckets and things like that. Because if you were to track every data change and you have a lot of data, that adds up really quickly. So there's going to be obviously a charge for that. You have system events. These are API calls that are indirectly called by systems. So let's say you launch a virtual machine. So that would be the admin activity, but the virtual machine indirectly has to do something and call an API itself. Then those will get logged there. Then you have policy deny. So these are when you have denied access to a user or service because of a security policy or violation. I do need to point out that log entries are written by Cloud Logs are immutable. So for the most part, you're going to be able to keep that data, which is a good idea. I don't know if you can like hide it or whatever, but the point is that the data will still be there, which is I think a pretty good policy there. There's things we can talk about like retention of logs and permissions, but if we need to, I will make additional videos for that. But the question is like, where do you see your logs? Well, this is going to be in the Log Explorer. So it has a whole interface here. You can choose the time range. It has a query language. It's pretty complex, but the point is that this is what we're using. So when you think about logs, you should immediately think of Log Explorer. There is another service that I believe is like called Log Analytics. Again, this is probably to kind of match against AWS's offering, as they have an analytics tools. I can't remember the names off the top of my head, but yeah, so Log Explorer or Cloud Audit Logs is basically like CloudTrail in AWS, but there you go. Hey, this is Andrew Brown. This video, let's take a look at creating a log bucket. So if we go over to here to the top and type in log bucket, or or bucket logs, maybe bucket logs, it should bring us to, maybe if we go to storage logs, we'll find it there. There we go, log storage. And so here we can create a log bucket. You can see I actually just created one here, and this one's just pending for deletion. So it will take a little bit of time to delete, but they're pretty straightforward to create. You go here, you say my log bucket. The only trick here is that I don't have any data, so I can't expect any data to be pulled into here. Probably you'd want to do is upgrade it to Log Analytics, and here you can create a BigQuery data set that links to this bucket if you want to. If we work with BigQuery, I have a feeling we would end up doing this. I'm going to go ahead here and just put like 1 day. Again, I don't want this to stick around for very long. I just want to show you how to create it. And that's where you create a log bucket. But again, this would be a lot more useful if I had some data flowing in here. If I go here, I could view the logs. And so notice there is no information here. If I go to the left-hand side, it's showing us that information. I could try to trigger something for this, but it depends on what it's doing. We could go over to Log Analytics and take a look here and see what we can see. So here we're in Log Analytics. I'm not the best at Log Analytics, but we could try our best here. So what I'm looking for is a means to run a query, and this is probably gonna be more useful. Yeah, I think this is gonna be more useful when we actually use BigQuery. So there's not much to show here, but at least you know how we can create a log bucket. And once you do that, we can turn on Log Analytics for later use, okay? So error reporting is a real-time service that identifies, counts, and aggregates errors to help you quickly detect and fix issues. It aggregates and analyzes errors across your Google Cloud environment, alerts you instantly when new apps errors occur, integrates seamlessly with Cloud Functions, App Engine Standard, and issue tracking tools, supports major platforms like Compute Engine, Kubernetes Engine, App Engine Flexible, and AWS EC2. I haven't verified the last one. If it does work on AWS EC2, that'd be really good, but I haven't used it. And it supports Go, Java, Node.js, .NET, PHP, Python, and my favorite language, PHP, okay? All right, let's take a look at error reporting. So I'm gonna go up here in the top here and type that in there. I notice there's like 2 of them. So I just want to make sure that they're going to the same place. But if you notice here, and you might have something or you might not have something, but earlier on, I guess I was running base a month ago, I was running a Kubernetes cluster, and we're getting some error occurrences. So here you can see an example where I think it looks like it was trying to get ready, or the pod didn't scale. And so we can see that there are these issues. I can acknowledge, resolve, or mute them. Now this cluster is gone, so I can just go ahead and check these however I want. I think we can click through and take a look at the error. Let's take a look here, right? So very useful service because it's collecting errors in a single place. So it's just basically error handling. Maybe something that might be similar would be like something like Rollbar. Okay, so Rollbar error handling or Sentry. All right, but I personally have not used, and maybe I will, but I have not used this for like an application workload, like a Rails app or a Django app. So it'd be very interesting to see what information it collects out, but it's okay for, Google offering this, okay? Let's take a look here at log configurations. And so we have 3 things I want to talk about: log buckets, log router, and log analytics. So log buckets, this allows you to store, manage, and query logs in Google Cloud Logging. It supports regional and multi-regional storage, control logs, retention, organization, and access. And I feel like log buckets are very often used with BigQuery, and same thing with log analytics. But anyway, we'll continue on here. So provide insights through advanced querying, visualization, and filtering, integrate with BigQuery for complex queries and large data sets, aids troubleshooting, monitoring, and auditing. Then we have log router, so routes logs to destinations based on filters, export logs to cloud storage, BigQuery, PubSub, manage log flows to ensure proper processing. But anyway, the idea here is that, logs are there to manage logging specifically from data services. So there you go. Hey, this is Andrew Brown. In this video, I want to take a look at cloud audit logs. Now, we've been using, or you should be have been using Google Cloud through labs through here and generating out log data. So what I want to do is go over and type in audit logs. There's actually two ones I want to show you. One is under IAM. This one is just where you would configure what you want to see. Notice here it says data access log configuration. So again, enabling data logs is going to cost money. So like if we wanted to do one, maybe BigQuery would be an example of something we would want to turn on. That might be something in particular. So here you can configure what types of operations you want to record. So you might say admin, read, write, and etc. And so that would be the easiest way to turn that on. I'm going to turn that back off because I really don't actually want to store that right now. If there's a case where we need to look at that data, we can do that. An easy example, if you really want to test it, would probably be buckets, I would think. If they even have that, they do not. Maybe it's called cloud storage. And yeah, so maybe under here, if we turn these on, maybe if we put things in a bucket, we could observe that. But I'm not really worried about it right now. Then we have the defaults here, which I would think, does this turn on all of them? I think it turns on all of them. So you can do that. But you can see it's very easy to turn on data services. But where the magic is really going to happen is Logs Explorer. Let's make our way over to Logs Explorer here. And from here, we can choose a date range. So I'm going to click up to here. And I've been using this, for the last few months. So you might want to increase your range and go here and go back a month or two, like whatever you started using it, and you'll start to see data here. I want to filter this out. Maybe because we've been launching a lot of virtual machines, we should take a look and see if we can see some virtual machine data. So what I'm going to do here is go up to resources, and it says VM instances because I obviously pulled it up earlier. We type in instance and click there. We'll get more information. Now I'm not going to click any of these. I'm just going to hit apply, so it's across all of them. And then we can see that it already started to fill out this query. So that's really nice. And so we can see that we are seeing data. Now I personally cannot really distinguish between the different types. But maybe there is a way together that we can take a look here and see. If we go down below and type. Yeah, I'm not exactly sure, but let's just open up the data and take a look here. So what do we have? We even have a trace, it looks like. We'll go all the way back to the top here. I can't even see what I'm looking at. Oh, I think, are we still getting data coming in? Is that why I'm getting confused here? But anyway, we'll go all the way to the top here. I do find this a little bit hard to see, but here we can see that we have an instance that is starting up. So these are system logs of an instance that is booting. Okay. I'm trying to see if there's anything useful that I could expand here to show. If not, it's not that big of a deal. Here we have an error. Okay, so we have logs, etc. Again, I don't think this is very valuable, the way I've set this up. Again, I'm not the best at looking at logs. I just know that they exist. And when I have to go in here, I kind of struggle. But what I'm just trying to do here is I'm just trying to find anything that I may have done. Just give me a second. All right, so I was looking through examples, and I saw this one here, and I was pretty certain that that's what it would be. And so here they have an example. So I'm going to see if I can grab this here. I'm not sure if this is going to work. But we're going to paste it in, and I'll just change this over to be my email, as that is my account. You'd obviously have to do this for you. Let's see if that produces any results for us. I do remember seeing here on the right-hand side, it would show if it was performed, yeah, like by this person or etc. So here you can see like instance insert, delete, things like that. So here I'm deleting an instance. And if we scroll on down here, we can take a look at the data. So let's see what we can see. Yeah, we can see the method that was called. Okay. The service, sure, the resource. All right, so you get an idea of how this works. Again, if we need to spend more time here, I will invest more time to be better at this and show it to you. But to be honest, it's not too hard, okay? But there you go, okay? Let's take a look here at Google's Operations Suite, which allows you to monitor, log, trace, and profile your apps and services. It's available for GCP and AWS. I've never used it for AWS. I'm not sure if I would use it for AWS because AWS has really good monitoring and logging tools there. But I guess if you are primarily on GCP and you have just some EC2, AWS EC2 virtual machines, and maybe you might want to keep everything in one place. We have VM monitoring with agents available for on-premise environments. It has Google Cloud native integrations. There is a ton of stuff underneath. So within Operations Suite, we have, it's an umbrella, like umbrella term or umbrella service, and underneath they have their own umbrellas. But we have cloud monitoring. So it provides visibility into performance, availability, overall health of cloud-powered applications. We have service level monitoring. So this defines and measures availability, performance, and other service levels of cloud-powered applications. There's way more than just those two, but for cloud logging and reporting, we have cloud logging, which can store, search, analyze, monitor, and alert on log data and events from Google Cloud and AWS. We have error reporting. So this identifies and understands application errors. It's basically bug tracking. We have application performance management, so an APM. We have Cloud Trace, which finds performance bottlenecks in production. We have Cloud Profiler, which continuously gathers. It's interesting we say APM at the top there because they specifically have an APM service, though I don't see it in here. I think it's newer. I can't remember if it's beta or not, but they literally have one specifically for tracking application monitoring. But anyway, Cloud Profiler, or we just call it Profiler, which continuously gathers performance information using low-impact CPU. So basically, it's for a heap profiling service. And then you have Cloud Debugger, which is deprecated. But I feel like, yeah, I think there's like one that's missing here. But again, it's beta, so I would probably add it in the future when it's actually important to learn, okay? Let's take a look here at Ops Agent. So this is Google Cloud's unified agent for logging and monitoring. I think before they used to have one for logging and for monitoring, but now they have a single agent. This approach is very similar to how AWS does it. Either Google did it first or AWS did it first, I'm not really sure. But it's designed to enhance observability across virtual machines. Key features, it combines logging and monitoring into a one lightweight agent, reducing complexity resource usage, optimized for high throughput environments with minimal impact on performance, compatible with multiple OS application standard log formats, simplifies deployments, updates via Google Cloud Console, customizable metrics and logs, improves visibility for critical applications. Ops Agent replaces older agents, is recommended for new VMs for better performance features. There's really no reason never to really install this. But I guess it's stacking logs, so maybe that's one reason. It has lots of installation methods. The easiest is like when you launch it, if you do not, you'd have to uncheckbox it to not have it installed when you launch a virtual machine. If you forget to install it, there's a one-click button to install it. Those two methods to me are new. I used to have to install this manually via a bash curl script, or then they added a policy agent, or you do it via Terraform. But honestly, when I went to do the lab, I was so surprised how easy it was. And really, we just have a checkbox on there, and it's that easy. Things that you get when you utilize it is being able to see processes in memory. Now, other providers like AWS, in order to get application logging collected, you normally would use the CloudWatch agent installed. And so I thought maybe Ops Agent would do the same thing. But logs are already being collected. So again, Google just makes observability or monitoring within your, observability monitoring of VMs super, super easy. But there you go. Hey, this is Andrew Brown. In this video, we're going to take a look at Ops Agents. So Ops Agents is a unified logging agent that you can install within your virtual machine. AWS has something very similar. I can't remember what it's called, maybe CloudWatch Log Agent. But it's interesting because it looks like Google also unified their agents into a single one. So what I'm going to do is I'm going to make my way over to Compute Engine, and we're going to launch a new instance. Okay, so we'll go over to here, and we'll create a new instance. And I don't know if we use the default one, if it already has the logging already pre-installed, but I guess we'll launch it, and if it doesn't, then we'll try to get one where it doesn't have it. So I'm just going to rename this one to my instance for logging, whatever we want to call it. I like to use Toronto because I'm in Canada, so I'm going to go ahead and do that. I'm going to stick with E2. I'm going to drop this down, go to E2 Micro. We're going to go ahead, and I'm just looking here for observability. Now, notice that we can install it this way. So if this is checkboxed on, it will already be installed, but I'm going to purposely not have it on there right? So that we can get that going there. I'm going to go ahead and just enable another one, just like my instance with ops agent, right? And what we'll do is we'll take a look and see what that looks like. So we'll go ahead and drop that down. I'll go over to here and we'll go to E2 Micro. And this one will have the ops agent installed. So we'll go ahead and create that. And so now we have 2 instances that are being created. We're going to wait and see them spin up, okay? All right, so we are back. So we have one where it's installed and one's not. So let's see if we can observe like if there's a difference in information that's being collected, because the idea behind the agent is that we're going to get some information that we normally wouldn't get in other places. And so I'm going to go here. I'm just going to go to observability. And so as far as I understand, I should have named this a little bit easier for logging. I think this one's not going to have process information. Right, so see here, we don't have it, and it's showing that it's not installed. In fact, it looks like a single click. There is a way to install this through the command line, but I mean, considering that it's literally a button click away and it can be pre-installed, I don't even see a point in showing you the other methods. But here right away, you can see that we can actually get a list of processes, which is really nice. If we go down over to our memory area and go back over to here, so notice we do not get fine detailed memory, but we do get memory utilization there. Probably, let's see, take a look with disk, right? Okay, so we are getting disk information. It looks like same information, but clearly processes and memory are definitely 2 things that we were capturing. Now, I'm not sure if that also includes additional logs. Let's go over to here and take a look. I mean, they both seem to be collecting logs, so it seems like that's good in both cases. But I guess the key thing to just make note of is the fact that when you have ops agent installed, you're going to get those at least those 2 key things, which is processes, and we'll go back to metrics, processes and memory, right? I'm not sure in terms of CPU. Let's take a look here for CPU. But yeah, I was going to show you how to install it manually and stuff like that, but man, they've made it super easy. Like, what's the point, right? I would like to see how easy it is to install this way. So here, we'll click a button. It's that easy now. Wow. Okay, so that's the way we're going to learn how to do it. That is great UI. I would just say that GCP's done a really, really good job. I complain a lot about GCP, but that is smooth. That is nice. So I'm not going to really wait to see that install. I don't really care. But like I have confidence it's going to work. So we'll go ahead and delete those. And there you go. That is Ops Agent. Let's take a look at Profiler under the Operations Suite. Okay, so Profiler is a low overhead service that analyzes CPU and memory usage to optimize resource consumption in applications. It identifies resource usage patterns for performance optimization. Lightweight with minimal overhead, requires a profiling agent, supports GCE, so Google Cloud Engine, GKE, GAE, and non-GCP environments, compatible with Go, Java, Node.js, and Python, no Ruby. So this is the reason you don't ever see me utilizing it. But you know, this would be really, like if this had Ruby, what I would be looking for is memory leaks or things that are making things take very, very long. So, you know, again, it's a profiler. It's really easy and nice to use. So for those target languages, but there you go. All right, let's talk about Trace. So Trace helps you monitor and analyze latency in your apps, providing insights in request handling, time, performance, and bottlenecks. It collects latency data from cloud resources, apps, and HTTPS load balancers. It's integrated with GAE standard for seamless tracing, supports GCE, GKE, GAE for deployment of cloud environments, works on non-GCP environments for broader compatibility, supports multiple languages, even Ruby, my favorite, provides insights into app engine performance and application latency. It's not easy for me to set up a use case to use Trace. There's also a Trace Explorer, which is obviously a way to explore your traces. Tracing is really good for apps or workloads that are basically microservices or bumping around between a lot of stuff. Would you need to know how to use it in detail for at least the Ace or the Pro? I don't think so, but you should know what traces are and that this is the Trace service and you can use Trace Explorer. Hey, this is Andrew Brown from Exam Pro, and we are looking at cloud identity. And this is identity as a service by Google Cloud that centrally manages users and groups. So you get a bunch of stuff in here like user lifecycle management, account security, single sign-on, cloud directory, device management, reporting and analytics, app management, extensible through APIs. Does a bunch of stuff. And the idea here is to confederate things between Google Cloud, Active Directory, Azure AD, and many more directory services. You can manage access and compliance across all users in your domain. You can create a cloud identity account for each of your users and groups. Then you can use identity access management, so IAM, to manage access to Google Cloud resources for cloud identity account. If you want to give someone access to your Google Cloud without having a Google Workspace account, so not having a Gmail and the G Suite, this is what you would use cloud identity so that it could just get access to just Google Cloud. So there are two versions of Cloud Identity. We have free and premium, and there is a lot of features here, but let's just run through it so you get the idea or the scope of what Cloud Identity can do. So it can handle device management, and in the free version, we have basic mobile management, directory or device inventory, basic passcode enforcement, remote account wipe, Android, Apple iOS. In the premium, you get advanced mobile management, advanced passcode enforcement, security policies, application management, network management, remote device wipe, reporting, application auditing, company-owned devices, mobile audit, MDM rules. So that would be mobile device management rules. Okay. Then for directories, you have in the free basic directory management, organizational units and groups, and they're unlimited. That's pretty standard in all directory services. Admin managed groups, groups for business, Google Cloud Directory Sync, which we'll give closer attention to later on. Admin rules and privileges, Google Admin app for Android, Google Admin app for iOS, just showing you works on both. Admin SDK API, so you can pragmatically work with the directory. Secure LDAP. For the premium, we have user lifecycle management, and there's no user cap on this. Secure LDAP. I guess it's in both, so maybe we don't have to list it in both there. Single sign-on and automated provisioning. So for free, we have set up SSO using Google as identity provider to access pre-integrated list of third-party SAML apps. Set up SSO using Google as an IPD to access custom SAML apps. Set up SSO using a third-party IPD with Google as a service provider. For premium, we have automated user provisioning. For security, we get user security management, self-service password recovery, which is a great feature. Azure AD also has this, so I really like this. Two-step verification, so I guess that's multi-factor, including security key management. We have enforcement control, so with security key enforcement and management, password management and strength alert. For premium, first-party session management, Google Security Center. For reporting, we get admin, login, SAML, groups, token, audit logs, security reports, SAML audit logs, app reports, account activity reports. For premium here, we get device audit logs, auto export audit logs to BigQuery, and you get an SLA of 99.9% of premium. So here you can see it does a lot. You don't need to remember all this stuff for the exam, but if you're going to take anything away from here, just understand that Google Cloud Directory Sync is a subservice of Cloud Identity, okay? Hey, let's take a look here at Cloud Identity Device Management, which lets employees work securely from any device, protecting sensitive data, keeping organizations in control. We're taking a look specifically at mobile device management, so MDM, so phones, right? Phones or tablets. Orgs can allow employees to access work apps on personal devices while keeping corporate data safe. Enables policies like creating a whitelist of secure and approved apps for accessing corporate data, enforcing work profiles on Android devices, requiring managed apps on iOS devices. It also provides inventory tracking for devices with corporate data, password enforcement, remote wipe capabilities for stolen or retired devices, auditing for security compliance. But there you go. Let's take a look here at security for Cloud Identity, specifically two-step verification, which is a security feature that requires users to verify their identity through something they know, like a password, plus something they have, like a physical key or an access code. So here you could use a security key, Google prompt, authenticator app, backup codes. So Cloud Identity streamlines the deployment of Two-step verification across the orgs, enforces password policies and ensures compliance with security requirements automatically. You have self-service password recovery, password management. So there you go. There are some common gcloud IAM commands that you should absolutely know. So we're going to quickly go over them, and then we'll all know them together, right? So gcloud IAM role commands manage IAM roles, enabling you to create, update, copy, delete, inspect custom roles. Key commands for managing IAM roles across projects and organizations. So here we might have one, which is the gcloud IAM role copy. So copies a role from a source to a destination. We have updating existing role. So as you can see here, we're updating a role. We're providing a JSON file with the structure that we need. We can create a custom role. So that's pretty straightforward. We can list projects and we can delete a role. Okay, so there you go. All right, let's compare IAM and ACLs. So in terms of granularity, that's a hard word for me to say. IAMs is project level and bucket based, whereas ACLs are object level. In terms of ease of management, IAMs are centralized and easier to manage. ACLs are decentralized and complex for large data sets. IAMs are recommended for most use cases, where ACLs are around for legacy support and not recommended. It's the same story if you're on AWS, the same thing they say, okay? Permissions, role-based, basic, predefined, custom, and for ACLs, entry-based permissions plus scope. In terms of inheritance, permissions inherit hierarchically, I can't say that word. With ACLs, there is no inheritance. So again, the key thing is ACLs, not recommended. Sometimes they crop up in old projects.